गुड इवनिंग टू ऑल। सब कैसे हो? मैं बहुत बढ़िया हूँ यार। शिफू, क्लास ड्यूरेशन आप लोग ही डिसाइड करेंगे। जब तक आप हो मैं भी हूँ, राइट। और कल भी सेशन है तो बीच में थोड़ा गैप रख देते, बट ऐसे नहीं बोल रहे 2 दिन पढ़ाओ यार, ठीक है। कोशिश करेंगे मैक्सिमम जितना होगा उतना, और सारे कॉन्सेप्ट्स रिवीजन चाहिए तो उतना पूरा रिवीजन करेंगे, राइट। लास्ट टाइम टीओसी में तो एक क्वेश्चन भी नहीं छोड़ा, ऑलमोस्ट प्रैक्टिस कर दिया ना। तो इस बार कोशिश करेंगे मैक्सिमम कॉन्सेप्ट्स को रिवाइज करने हैं, राइट। राइट। आप लोग को दिक्कत होगा कंपाइलर में यार, फिर कंपाइलर इस बार बहुत अच्छा रिवाइज करना है कल भी, ठीक है। कोशिश करेंगे जो होगा। आप बताओ यार कितना टाइम चाहिए? या गुड इवनिंग, गुड इवनिंग जोन्स, या सेफ, गुड इवनिंग पवन, चंद, गुरुजी, सही है। आठ घंटे मिनिमम 12 AM तक तो हो सत्यम, वो तो रहेगा यार। जस्ट करंट, ठीक है। फुल रिवाइज चाहिए ना? सबको हो जाता अनुराग, वहाँ पर आपको नहीं, बहुत लोग को हो जाता। वॉइस क्लियर है सबके लिए? कम तो नहीं है? शिवम बढ़ा दो यार, आपका वॉल्यूम, आपका रिवाइज का वॉल्यूम बढ़ा दूँ। ऑल गुड। हाँ, न्यू क्वेश्चंस दिमाग से होता है ना। गेट के लिए जितना इंपॉर्टेंट है वो सारे कवर करेंगे। नया क्वेश्चन, पुराना क्वेश्चन, ये नहीं होता। रिवीजन मतलब सब्जेक्ट पूरा क्लैरिटी होना चाहिए। राइट, एवरीथिंग इज फाइन, राइट। चलो, ओके। सो स्टार्ट करेंगे एज जो सब्जेक्ट है, बेसिक्स ऑफ टीओसी से स्टार्ट करेंगे। पूरा सिलेबस तो आपको मालूम होगा, टारगेट कहाँ से होता, कैसे होता, राइट। तो गेट में मेन जो टॉपिक होता है, रेगुलर लैंग्वेजेस में 3 to 4 मार्क्स की मार्क्स होता मोस्टली। उसमें आपको पता है रेगुलर लैंग्वेजेस में रेगुलर एक्सप्रेशन भी होता। कितने मार्क की होता पता है सबको? वेटेज, फाइनाइट ऑटोमेटा और रेगुलर ग्रामर। वेटेज की भी बात कर लेते। यू शुड नो द वेटेज ऑल्सो, राइट। देन आइडेंटिफाइंग, वो बहुत इंपॉर्टेंट टॉपिक है। आइडेंटिफिकेशन ऑफ रेगुलर्स एंड नॉन रेगुलर्स, दोनों रेगुलर्स एंड नॉन रेगुलर्स। और क्या होता? क्लोजर प्रॉपर्टीज। अगर एक टॉपिक भी मिस हो गया ना, रिमाइंड कर लो मुझे, ठीक है। जो इंपॉर्टेंट कम होता वहां पर हम कम टाइम डिस्कस करेंगे, वैसे भी ज़्यादा टाइम स्पेंड करना जरूरत नहीं है। और एक पंपिंग लेमा छोटा कॉन्सेप्ट है, ठीक है। इसमें बहुत इंपॉर्टेंट वेटेज है यहाँ पर होता। यहाँ पर 2 मार्क्स एक्सपेक्टेड है, यहाँ पर 1 to 2 मार्क्स एक्सपेक्टेड है, और आइडेंटिफिकेशन 1 mark to 2 marks एक्सपेक्टेड है। Expected, remaining depends, right? Closure property sometimes they ask, sometimes may not. They combine with other chapters like CFL, DCFL and so on. वो है। तो रेगुलर लैंग्वेज फर्स्ट चैप्टर है रेगुलर लैंग्वेजेस, वहाँ पर जो शुरू करने से पहले हम बेसिक से स्टार्ट करेंगे, कि डायरेक्टली तो वो समझने आता है ना, तो बेसिक्स ऑफ टीओसी से स्टार्ट करेंगे। इसके बाद सेकंड चैप्टर भी देखते हैं इंपॉर्टेंट कितना है, राइट। यहाँ पर आप एक्सपेक्ट कर सकते हैं मिनिमम 4 मार्क, तो फर्स्ट चैप्टर से आपको टोटल वेटेज पता होगा 8 से 10 मार्क होता है टीओसी की, तो मिनिमम वर्स्ट केस में 7 भी पॉसिबल है, वर्स्ट केस में व्हेन कंपाइलर इंक्रीजेस मार्क्स टीओसी में कम हो सकता मार्क्स, ठीक है, राइट। शुरू करें। एक 2 मिनट इंतजार कर लेते लोग के लिए अभी। ओह थैंक यू ऋषिकेश। सब ठीक है ना? सब लोग का अच्छा रिवीजन चल रहा है ना? यहाँ पर मैं देखा यार बहुत अच्छा रिस्पांस है हर सब्जेक्ट में, राइट। और क्या चाहिए पीडब्ल्यू में, राइट। बहुत बच्चे को फ़ायदा हो रहा है और लाइव भी 100 तक जा रहा है मिनिमम कभी कभी, राइट। तो और सुबह तक आप लोग पढ़ रहा है और मैं ही कोशिश करूँगा, मेरा भी वो है ना, हर कॉन्सेप्ट भी रिवाइज करने के लिए, और आप लोग का मेहनत वैसे तो भी है, तो यू आर डूइंग द फैंटास्टिक जॉब, राइट। सो कीप इट डूइंग फॉर ऑल द सब्जेक्ट्स, लेट्स सी यू नो, लेट्स होप फॉर द बेस्ट, यू गिव योर बेस्ट and I want you to attempt the best in the exam, right सौरभ? यहाँ कितने लोग हैं यार, इन लोग का फर्स्ट अटेम्प्ट है? ये बताना guys before starting the subject, right? So how many of you are attempting the first time GATE exam? देखो जो फर्स्ट टाइम अटेम्प्ट कर रहा है, इन लोग का जो प्रिंसिपल है सबके लिए अप्लीकेबल है, जो गाइडेंस फर्स्ट अटेम्प्ट लोग को मिलता है ना, ये सबके लिए वैलिड है, राइट। बट सेकंड टाइम जो अटेम्प्ट कर रहे हैं उनको थोड़ा नॉलेज होता है यार क्या मिस्टेक किया नहीं किया। जो फर्स्ट टाइम अटेम्प्ट कर रहा है ना, उनको समझने आता है यार गेट एग्जाम एक्चुअल फील कैसे होता, क्योंकि वो कभी नहीं गया होगा ना, राइट। जो ऑलरेडी सेकंड टाइम अटेम्प्ट कर रहा है तो उनको पता है यार 3 घंटे बार कैसे वेस्ट होता है और कैसे यूज़ करते हैं हम, और कैसे यूटिलाइज करना पड़ेगा, और क्या मिस्टेक करते हैं हम, राइट। व्हाट आर द मिस्टेक्स दैट वी डिड, राइट। यू सबको पता है ये चीज़। सेकंड टाइम ठीक है, थर्ड टाइम बहुत सही है। याद रखना गाइस, द फर्स्ट टाइम दोज पीपल आर अटेम्प्टिंग एंड ऑल्सो अलॉन्ग विथ अदर पीपल। सो मेन जो चीज़ है, जो बाकी कितने भी मॉक टेस्ट अटेम्प्ट करो बाहर, बट अंदर जो 3 घंटे होता है ना, उसी टाइम में उसी 3 घंटे में आपका दिमाग जो बताएगा वही करके आओगे। मतलब जितनी भी प्रैक्टिस करो, 100 मॉक टेस्ट भी प्रैक्टिस करो, बट उस समय में आपका दिमाग, ऑफ कोर्स हार्ड वर्क विल ऑलवेज हेल्प यू, दैट इज ऑलवेज यू नो आई रिकमेंड टू डू द हार्ड वर्क विल नेवर गोइंग टू वेन, राइट। इट विल गिव यू ऑलवेज बूस्ट इनटू योर एनर्जी। तो जो पीपल हार्ड वर्क करके जा रहा है ना, उनका कॉन्फिडेंस कुछ अलग लेवल में होता, राइट। सो जिनके पास नॉलेज होगा, इनके पास प्रैक्टिस होगा, वो वैसे कंफ्यूजन नहीं होता। जितना फियर तो सबके लिए होता, राइट। सब लोग को फियर तो होता, बट फियर को कम करना पड़ेगा। तो उस दिन बहुत इंपॉर्टेंट होता, जो फर्स्ट टाइम सेकंड टाइम थर्ड टाइम जितने भी अटेम्प्ट, अब 10 बार भी अटेम्प्ट करो, वो 3 घंटे वैसे ही होता, आप नहीं रुक सकते उसको। जो बॉडी शेक होता होगा और दिमाग यहाँ वहाँ सोचता होगा, बट जो कंट्रोल करके अटेंड करेंगे ना, उनका ही रैंक निकलता। और सबको आता होगा क्वेश्चंस, बट उसी समय में आपका जो प्रैक्टिस है वही बताएगा आप कैसे अटेम्प्ट करोगे। तो मैं ही कह रहा हूं, सोच क्लैरिटी होना चाहिए, और जो प्रैक्टिस कर रहा है ना वो मीनिंगफुल होना चाहिए, तभी वो 3 घंटे सही होता। एवरीबॉडी, नर्वसनेस सबको होता, बट ऑलवेज यू नो रिमेंबर दैट यू आर द बेस्ट इन द वर्ल्ड। आपका यू नो किसी से कंपेरेबल नहीं है, यू आर द यूनिक इन द वर्ल्ड, राइट। व्हाट यू डू दैट इज डिपेंड्स ऑन व्हाट यू हैव द नॉलेज, राइट। आपका जो नॉलेज है वही करके आओगे, राइट। वहां जाके तो कुछ नया तो करना पड़ेगा नहीं। आप जो सीखा था इस साल में और 1-2 साल में जो प्रिपेयर करके गया वही करके आओगे, राइट। तो वो कैसे करके आओगे, वो इंपॉर्टेंट है। जो आप पढ़ोगे ना, सही सोच से पढ़ लेना। यही होता है यार, एक क्वेश्चन आप प्रैक्टिस में देखो, सेम क्वेश्चन बार बार कभी कभी आते हैं ना, कभी कभी सही करते, कभी कभी सही नहीं करते। प्रॉब्लम कहां पर है? तो आपका प्रैक्टिस में, आपको कॉन्सेप्ट्स में, राइट। ये जो महा रिवीजन है, जो प्रैक्टिस सेशन है, बाकी सब लोग, मैं इतना बोल रहा हूँ यार, 100 से 200 बीच में लाइव आ रहा है ना, मैं ये वादा करूंगा यार, आप लोग को अच्छा रैंक आना चाहिए, कि मैं आपका डेडिकेशन देख रहा हूं, आपका वो जो अटेम्प्ट देख रहा हूं हर सब्जेक्ट में, आप लोग सही कर रहा है। ऑफकोर्स एक दो लोग कुछ गलती करेंगे, बट वो लोग भी सही कर रहा है बाद में, ठीक है। यही चाहिए गेट में, बस आपका जो कॉन्फिडेंस है वही रख लेना। अब इतना हार्डवर्क कर रहा है, 10 घंटे 12 घंटे, सिर्फ वो 3 घंटे हार्डवर्क करना है यार अटेम्प्ट करने के लिए, क्यों नहीं करोगे बताओ? पूरा रात तक इतना मेहनत किया, वो 3 घंटे आपका एनर्जी रख लेना, इतना चाहिए उतना कर लेना। जिंदगी में एक ही बार आता है यार, इतना एक साल में इतने घंटे पढ़ लिए हर दिन, आपको भी पता है 10 घंटे 12 घंटे पढ़ना वो मुश्किल नहीं होता। मैं भी पढ़ लिया ना, मैं भी कहा था यार 12-14 घंटा एक दिन में पढ़ता था मैं आप लोग को देख के मुझे वो पूरा वो है ना, मुझे याद आ रहा है बीटेक में मैं क्या किया था। सेम आप लोग जैसे कर रहा है ना, बट मैं खुद ही कर रहा था उस टाइम में। मुझे वो उसी टाइम में कोई पढ़ाने वाला नहीं था यार, मैं खुद ही पढ़ रहा था वो 12 घंटे 14 घंटे, मैं वो लड़ रहा था गेट एग्जाम के लिए, राइट। मैं तो सेल्फ प्रिपेयर्ड बंदा था, मैं आप लोग जैसे नहीं है। और मैं इतना गलती पढ़ा था, और अभी उसको देख के ही पढ़ा रहा हूँ, क्या गलती हो सकता बच्चे का, राइट। मैं उसी क्वेश्चन को ला रहा हूँ आपको ठीक करने के लिए हमेशा, राइट। आपको पता है यार सुपर 30 में कैसे क्वेश्चंस लाया मैं, और रिवीजन थ्रो क्वेश्चंस में कैसे क्वेश्चंस लाया। कुछ क्वेश्चन में कोई भी सही नहीं किया आंसर, क्यों? वो कॉन्सेप्ट आप लोग गलत अप्लाई करते हैं, राइट। उसको सही कर लिया मैं, ठीक। या थैंक यू सो मच। राइट, चलो बीच बीच में हम इंटरेक्ट करते रहो, बट कभी भी डिमोटिवेट नहीं करना। इस जो लास्ट मिनट में है ना, तो खुद ही आप यूनिक है, ये सोचो यार आप जो कर रहे हैं वो सही है, राइट। वो गलत है नहीं, वो बाद में पता चलेगा, बट तो आपका कॉन्फिडेंस 100% रखना है, कोई कम नहीं करना है यार। एक सब्जेक्ट में एक टॉपिक में थोड़ा गलती हो रहा है, ठीक है, उसको थोड़ा प्रैक्टिस करते रहो। इस समय में टाइम कम है और आप ज्यादा भी प्रैक्टिस नहीं कर सकते, बट आइडेंटिफाई करके उसको सही कर लो, राइट। चलो स्टार्ट करें। या दुर्गेश, आई रिमेंबर योर नेम। हर टॉपिक में ये बताता हूं एक्चुअली इसमें क्या पढ़ना चाहिए आपको। ये बेसिक्स में आपको ये पढ़ना चाहिए, टारगेट एक ही होना चाहिए इसमें, जो ऑपरेशंस होता है ना स्ट्रिंग्स की, ऑपरेशंस ऑन स्ट्रिंग्स। मैं टॉपिक का नेम भी बताता हूं, ऑपरेशंस ऑन स्ट्रिंग्स। इसमें भी ये चारों पता होना चाहिए आपको। प्रीफिक्स का कॉन्सेप्ट क्लैरिटी होना चाहिए, सफिक्स, सबस्ट्रिंग और सब्सिक्वेंस। वैसे भी गेट एग्जाम के लिए तो नहीं आता होगा, राइट। ये तीनों कॉन्सेप्ट्स बहुत इंपॉर्टेंट है। ऑपरेशंस बहुत होंगे, बट ये तीनों कॉन्सेप्ट्स एग्जाम के लिए इंपॉर्टेंट है। कभी कभी प्रीफिक्स, कभी कभी सबस्ट्रिंग आया, कभी कभी सफिक्स भी आएगा फ्यूचर में, ठीक है। राइट, सबको पता है ना, बट हर कॉन्सेप्ट को हम रिवाइज करेंगे यहां पर। चलो स्टार्ट कर लेते फटाफट। ये बेसिक्स में ज्यादा टाइम स्पेंड नहीं करना है, क्यों? हमको पता है यार, जो इस सब्जेक्ट में आप ये देखो, मिनिमम मैं बता रहा हूं, रेगुलर एक्सप्रेशंस आया, मिनिमम 50 क्वेश्चन से, इंपॉर्टेंट क्वेश्चन से रिवाइज करूंगा, वो खुद ही बना के वैसे भी, राइट। रेगुलर लैंग्वेज मिनिमम ये होना चाहिए 50, राइट। रेगुलर और नॉन रेगुलर मिनिमम, ऑफकोर्स ज्यादा ही होंगे, वैसे ही बोल रहा हूं, राइट। रेगुलर ग्रामर्स आएगा, मिनिमम 50 होना चाहिए रेगुलर ग्रामर्स। इसमें फर्स्ट चैप्टर बहुत क्लैरिटी बनना चाहिए एक्चुअली रेगुलर लैंग्वेजेस क्या होता और उसके लिए क्या इंपॉर्टेंट है, यहां से समझ में आता। और डीएफए है वो भी 50 होना चाहिए, मेरा टारगेट ये है। मतलब यही से आपको क्लैरिटी होना चाहिए, ये 200 क्वेश्चन से आपको फर्स्ट चैप्टर कंप्लीट होना चाहिए, राइट। सेकंड चैप्टर में वही बात करेंगे, वो क्या करने वाला है हम, ठीक है। स्वराज, रेगुलर एक्सप्रेशन, बुलियन एक्सप्रेशन रूल्स, मतलब समझ नहीं आ रहा है ना। प्लस मतलब वहां आ रहे, यहां आ रहे, वहां डाट मतलब एंड है, यहाँ डाट मतलब कनकैटेनेशन है। वो डिफरेंस जब तक आपको डेफिनेशन नहीं आता तो प्रॉपर्टीज कंफ्यूजन होता। आप रट रहा है ना, समझ में आया तो बहुत अच्छे से क्लैरिटी होगा। यही है, मैं बहुत बार बोला, डाट मतलब क्या होता, डाट मीनिंग अलग अलग सब्जेक्ट में अलग अलग मीनिंग होता। कुछ मैथमेटिक्स में क्या है, अलजेब्रा में मल्टीप्लिकेशन होता, और डिजिटल लॉजिक में आइंड होता। डिस्टर्ब क्यों कर रहा है अभी, यहाँ डाट मतलब कंकैटिनेशन होता। क्लैरिटी होना चाहिए यार, ठीक है। चलो बेसिक्स, सिंबल, अरे सिंबल मतलब एनीथिंग इन द वर्ल्ड, यहां कोई डेफिनेशन नहीं है, वो स्मॉलेस्ट होना चाहिए, बेसिक होना चाहिए, राइट। जो भी है आप कुछ भी रख सकते हैं, यहां कोई रूल नहीं है कैसे बनाते सिंबल, बट अल्फाबेट है, क्या है अल्फाबेट, सेट ऑफ सिंबल्स होता, यहां डिसाइड करना पड़ता अल्फाबेट। अल्फाबेट आप देख सकते ये कामा भी सही है, मोस्टली हम ये यूज करते, बट कभी कभी एक सिंबल भी यूज करते, कभी कभी कुछ वर्ड्स भी यूज कर सकते हैं आप, गेट, एग्जाम, मतलब कुछ भी, ऐसे कोई रूल नहीं है कैसे यूज करना है इसको। अब यहां मीनिंग क्या होता, बेसिकली ये गेट है, यहां पर जो गेट दिया ना, इसको बोलते हैं हम वन लेंथ। क्या बोलते हैं हम, वन लेंथ। वन लेंथ हो सकता सिग्मा के अंदर एप्सिलॉन होगा, लैम्डा होगा, बीटा होगा, जो भी है। अब एप्सिलॉन क्या होता है, यहां पर वन लेंथ होता, जीरो लेंथ नहीं होता। इस सिग्मा में जो भी स्ट्रिंग बना लो, एप्सिलॉन मतलब एम्प्टी स्ट्रिंग नहीं होता, क्योंकि एप्सिलॉन यहां सिंबल होता। तो सेट ऑफ सिंबल्स मतलब ये सिंबल क्या होता है, बेसिकली जो सिंबल है ना, इसको बोलते हैं हम हमेशा वन लेंथ स्ट्रिंग बोलते हैं हम। तो जो भी यहां लिखा उसको मानना है पड़ेगा आपको वन लेंथ, वन लेंथ मानना पड़ेगा जो भी लिखा सिंबल। बट सिंबल का डेफिनेशन यही होता, ये बेसिक बिल्डिंग है, और इसको लेकर हम स्ट्रिंग बनाएंगे, इसको लेकर हम लैंग्वेज बनाएंगे, राइट। ओके गुड साथिया, एवरीबॉडी यही है, इससे ज्यादा डेफिनेशन जरूरत नहीं, इसको देख के ही समझ में आना चाहिए यार वन लेंथ क्या होता। वन लेंथ जो दिया है वही वन लेंथ है, राइट। सिग्मा में जो दिख रहा है ना, कामा के बीच में दिख रहा है ना, वो अलग अलग मेंबर दिख रहा है, एवरी मेंबर इज अ वन लेंथ। आपको दिख रहा होगा जैसे चार लेंथ, चार लेंथ नहीं माना, इंग्लिश अल्फाबेट नहीं है, ये नया अल्फाबेट है, ठीक है, ये आपको पता है। स्ट्रिंग मतलब क्या है, स्ट्रिंग मतलब सीक्वेंस ऑफ सिंबल्स। कितने सीक्वेंस ऑफ सिंबल्स है, ये नया स्ट्रिंग है। ये जो आप इंग्लिश लैंग्वेज में पढ़ता है वो स्ट्रिंग, यहां स्ट्रिंग मैच होता होगा, बट यहां एक स्पेशल स्ट्रिंग होता, एम्प्टी स्ट्रिंग। वो किसी लैंग्वेज में नहीं दिखता, वो टीओसी प्रॉब्लम्स में दिखता होगा, और बाकी सारे दुनिया में एप्सिलॉन को मीनिंग होता है बट लोग को समझ नहीं आता, वो भी स्ट्रिंग है, राइट। बट आपको ये टीओसी में मीनिंग होता है जब स्ट्रिंग नहीं दिया बट काम कर रहा है कोई, तो मतलब एम्प्टी स्ट्रिंग लिया है, उसको कहते हैं हम एम्प्टी स्ट्रिंग। तो सीक्वेंस ऑफ सिंबल्स में अगर मान लो सिग्मा इक्वल ए कामा बी है, तो अब बताओ यहां पर एम्प्टी स्ट्रिंग क्या होता। हम यहां मान लेते एप्सिलॉन इज एम्प्टी स्ट्रिंग, और वन लेंथ क्या होता, ए बी। टू लेंथ क्या होता, डबल ए बी, बी ए बी बी, ऐसे होता है ना। तो वही है स्ट्रिंग्स। लैंग्वेज क्या होता, ऐसे बहुत सारे स्ट्रिंग्स होते हैं ना, थ्री लेंथ, फोर लेंथ, जो भी है। लैंग्वेज क्या होता, सेट ऑफ स्ट्रिंग्स। कितने स्ट्रिंग्स होंगे हमको भी मालूम नहीं है। जीरो स्ट्रिंग्स मतलब एम्प्टी लैंग्वेज आएगा, वन स्ट्रिंग मतलब कुछ भी हो सकता है, एप्सिलॉन हो सकता, ए हो सकता, डबल ए हो सकता। टू स्ट्रिंग्स होगा तो एप्सिलॉन कामा ए होगा, ऐसे इन्फिनिट लैंग्वेजेस है, राइट। साइज 3 हो सकता, साइज 4 हो सकता, साइज इन्फिनिट भी हो सकता। बट देखो यहां पर क्या डिफरेंस है, स्ट्रिंग्स और लैंग्वेजेस के क्या डिफरेंस है। स्ट्रिंग मतलब फाइनाइट लेंथ होगा, लैंग्वेज मतलब आइदर फाइनाइट नंबर ऑफ स्ट्रिंग्स और इनफाइनाइट नंबर ऑफ स्ट्रिंग्स। यहां पर एक डेफिनेशन होता, स्ट्रिंग हमेशा फाइनाइट लेंथ होता, ये याद रखना पड़ेगा, फाइनाइट लेंथ होता। जो भी स्ट्रिंग लेना इसमें फाइनाइट लेंथ ही होंगे। लैंग्वेज मतलब आइदर फाइनाइट लैंग्वेज होगा और इनफाइनाइट लैंग्वेज होगा, आइदर फाइनाइट सेट और इनफाइनाइट सेट होगा, इधर इनफाइनाइट सेट और फाइनाइट सेट। इसमें कोई डाउट है तो जल्दी बोलना। If you have any doubt, right, please let me know quickly. The basic है, just revise कर रहा हूं what you know. Just I'm trying to remind what is, या PDF हम कोशिश करेंगे ऐप में अपलोड करने के लिए, या बट रिमाइंड करो और we will share it. सिंपल एग्जाम्पल है, सिग्मा गेट एग्जाम दिया, राइट। ये दो है ना, ये क्या है अभी, स्ट्रिंग नहीं है, इसको बोलते हैं हम सिंबल, इसको बोलते हैं हम सिंबल। अब अल्फाबेट, ये तो अल्फाबेट है, राइट, जो सेट दिख रहा है अल्फाबेट है। स्ट्रिंग अब कैसे लिखोगे, एप्सिलॉन, गेट इज द वन लेंथ, एग्जाम इज वन लेंथ, और टू लेंथ कैसे लिखोगे, इसको रिपीट करना पड़ेगा, गेट गेट, गेट एग्जाम, एग्जाम गेट, होता है ना, एग्जाम 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 गेट। ये लिखना आना चाहिए आपको, क्यों एग्जाम में ऐसे वाली क्वेश्चंस पूछा जाएगी। ये जीरो लेंथ है, इसका लेंथ जीरो है, इसका लेंथ वन है, इसका लेंथ टू है, राइट। चलो अब ये बात आता, सर सिंबल तो समझ में आया, कुछ भी अल्फाबेट क्या है। अल्फाबेट मतलब सिग्मा है ना, सिग्मा इज ऑल्सो ए सेट, बट दिस सेट इज व्हाट, फाइनाइट सेट। इसमें क्या होता, सेट ऑफ वन लेंथ स्ट्रिंग्स होता। देखिए इसका डेफिनेशन अलग अलग है, एग्जाम में पता नहीं यार अल्फाबेट के डेफिनेशन क्या पूछेंगे लोग, सेट ऑफ वन लेंथ स्ट्रिंग्स, सेट ऑफ सिंबल्स, सेट ऑफ फाइनाइट लेंथ स्ट्रिंग्स, सब सेम है। ऑफ कोर्स फाइनाइट लेंथ मतलब वन लेंथ है, सेट ऑफ सिंबल्स, सेट ऑफ वन लेंथ स्ट्रिंग्स, ये फाइनाइट सेट है। सिग्मा ये स्पेशल लैंग्वेज है, ये भी एक लैंग्वेज है। क्यों लैंग्वेज है, इसमें वन लेंथ स्ट्रिंग्स होगा, तो मतलब लैंग्वेज अगर कोई ए कामा बी लिखा और सिग्मा भी ए कामा बी है तो एग्जैक्टली मैच होता। देखो लैंग्वेज भी ए कामा बी है, सिग्मा भी ए कामा बी है, मतलब अल्फाबेट इज ऑल्सो ए लैंग्वेज इन द वर्ल्ड, but this is also a language over the language. Fine, everyone. I'll try to provide, I think I don't know whether I have shared it or not, Satya. Yeah, thank you for reminding. Today I'll check. लैंग्वेज एंड अल्फाबेट में क्या डिफरेंस है, लिखो। अल्फाबेट इज ए स्पेशल लैंग्वेज, बट कैसे टाइप की लैंग्वेज है, व्हाट काइंड ऑफ लैंग्वेज इट इज, व्हेन ऑल वन लेंथ स्ट्रिंग्स आर इंक्लूडेड इन द लैंग्वेज, only one length strings and all one length strings are there in the language, then that language is actually looks like alphabet. That's why alphabet is a special language. But language, any language need not be alphabet, defined over alphabet, but language need not be alphabet. ऐसा कोई रूल नहीं है लैंग्वेज जस्ट अल्फाबेट जैसे दिखना है, नहीं है। लैंग्वेज कुछ भी हो सकता, एम्प्टी भी हो सकता, वन स्ट्रिंग भी हो सकता, दो स्ट्रिंग्स भी हो सकता, लेंथ कितने भी हो सकता, राइट। तो डिफरेंस ये होता, अल्फाबेट इज अ स्पेशल लैंग्वेज, बट ऑफ कोर्स दिस अल्फाबेट इज यूज्ड टू डिफाइन द लैंग्वेजेस, to define the strings, but language is the special which is defined over the strings and over the given alphabet. Everybody, so ये difference पता होना चाहिए। और string, देखो string मतलब defined over sigma, अगर sigma ही नहीं पता, ये special language ही नहीं पता, string भी नहीं पता होगा आपको। defined over special language, that is a sigma, and language क्या है, language भी डिफाइंड ओवर सिग्मा। अगर सिग्मा ही नहीं पता कैसे फॉर्म करोगे उसको, राइट। सेट ऑफ स्ट्रिंग्स चाहिए, स्ट्रिंग्स तो डिफाइंड ओवर सिग्मा है, ये भी डिफाइंड ओवर सिग्मा है, राइट। तो याद रखना अल्फाबेट इज द बिगिनिंग फॉर द स्ट्रिंग्स एंड लैंग्वेजेस, बट लैंग्वेज का डेफिनेशन एक और भी होगा, लैंग्वेज इट इज ए सबसेट ऑफ द सिग्मा स्टार। कितने लोग को पता है डेफिनेशन, L is the language, L is the language, let's say L is the language, और इसका डेफिनेशन है सबसेट ऑफ द सिग्मा स्टार। कोई भी लैंग्वेज लेना वो हमेशा सबसेट ऑफ सिग्मा स्टार होता, ओवर डिफाइंड ओवर द सिग्मा। कितने लोग को पता डेफिनेशन ऑफ द सिग्मा, सॉरी लैंग्वेज, ये तो पता है हमको, कलेक्शन ऑफ द स्ट्रिंग्स, वो तो सिंपल डेफिनेशन यार। कितने स्ट्रिंग्स होंगे आप डिसाइड करो, ये प्रॉब्लम के ऊपर डिपेंड होता। डिपेंड्स ऑन द प्रॉब्लम, डिपेंड्स ऑन प्रॉब्लम हाउ वी डिफाइन प्रॉब्लम, लैंग्वेज will be decided how many strings are present। आपको पता है ना यार, आप पूछते यार कितने स्ट्रिंग्स होना चाहिए, वो तो प्रॉब्लम डिसाइड करेंगे ना, प्रॉब्लम डिसाइड करेगा। अगर मेरे प्रॉब्लम में सपोज लेट्स से आई वांट टू रिप्रेजेंट प्राइम कॉन्सेप्ट, तो आपको डिफाइन करना पड़ेगा यार प्राइम कॉन्सेप्ट कहां से लाना है मुझे, राइट। यहां तो 1 2 3 लिखना है, नहीं तो एक कॉमा भी लिखना है, आप डिसाइड करोगे। लेट्स से आई वांट टू डिफाइन ओवर वन सिंबल, तो कैसे डिसाइड करेंगे, डिसाइड करेंगे लैंग्वेज, लैंग्वेज ऐसे डिसाइड करेंगे यार नंबर ऑफ एस विल बी रिप्रेजेंटेड बाय द प्राइम। मतलब मेरा लैंग्वेज में 2a से मतलब नंबर 2 से बराबर है मैथमेटिक्स में, और 3a से मतलब नंबर 3 से बराबर है इन मैथमेटिक्स में। ये है डेफिनेशन ऑफ ए प्राइम लैंग्वेज कॉन्सेप्ट, राइट। तो आप डिसाइड करोगे प्राइम लैंग्वेज कितने सिंबल्स लेना है, 1 सिंबल लिया, क्यों, मुझे प्राइम वो ना 2 मतलब 2a रिप्रेजेंट करूंगा, नंबर 3 के लिए 3a रिप्रेजेंट करूंगा। तो ये है लैंग्वेज इज डिफाइंड ओवर द सिंबल। गुड इवनिंग, गुड इवनिंग चंद्र प्रकाश, गुड इवनिंग दुर्गेश, गुड इवनिंग, राइट। ये बेस्ट एग्जांपल है, किसी को प्राइम कॉन्सेप्ट को रिप्रेजेंट करना है, इवन कॉन्सेप्ट को रिप्रेजेंट करना है, किसी को इवन नंबर की लॉजिक लिखना है, तो इवन कॉन्सेप्ट मतलब लिख सकते होंगे, वो लेंथ के ऊपर डिपेंड होता, कभी कभी नंबर ऑफ सिंबल्स आप डिसाइड करोगे पहले। वो कि लेट्स से आई वांट टू डिफाइन ओवर 1 सिंबल ओनली, तो आप लिखोगे ए पावर इवन कॉन्सेप्ट। ये क्या है, ऐसा होता है टीओसी में डबल ए होल स्टार, आप इसको ए पावर 2n सच दैट n ग्रेटर देन और इक्वल 0, मतलब नंबर ऑफ एस रिप्रेजेंट करेगा इवन नंबर इक्विवेलेंट इन मैथमेटिक्स, यही होता है ना। ये रेगुलर लैंग्वेज नहीं है, बाद में देखेंगे, मैं रेगुलर लैंग्वेज नहीं पढ़ा रहा हूं ना, बेसिक्स पढ़ा रहा हूं लैंग्वेज क्या है, राइट। रेगुलर लैंग्वेज नहीं पढ़ा रहा हूं ना, वहां पूछो रेगुलर लैंग्वेज है नहीं। वैसे भी ये तो रेगुलर लैंग्वेज नहीं है, ये तो रेगुलर लैंग्वेज है, वहां है ना, इसके लिए डीएफ है, इसके लिए रेगुलर एक्सप्रेशन है, बट इसके लिए डीएफ नहीं है। हमारे पास कॉन्सेप्ट भी है, ये अर्थमेटिक प्रोग्रेशन फॉर्म नहीं होता ओवर 1 सिंबल, इसलिए ये रेगुलर लैंग्वेज नहीं है, राइट। लैंग्वेज का समझ में आया सबको, कोई डाउट है? गुड क्वेश्चन, गुड क्वेश्चन। पहले सिग्मा स्टार कितने लोग को पता? सिग्मा स्टार मतलब क्या है, सिग्मा पावर 1 यूनियन सिग्मा पावर 0 से स्टार्ट होता है ना। गुड क्वेश्चन, ये सबको मालूम है ना। इसका मतलब कोई छोड़ेंगे नहीं, लेट्स से सिग्मा इज इक्वल टू ए कामा बी अगर लिया, तो यहां पर क्या होता है, एप्सिलॉन भी होगा, ए भी होगा, 1 लेंथ होगा, 2 लेंथ होगा, 3 लेंथ होगा, सब होंगे ना, राइट। अगर मैं कोई भी लैंग्वेज लिखा, देखो L1 एम्प्टी लिखा, L2 कुछ ऐसे रैंडमली एप्सिलॉन कामा ए भी लिखा, L3 ऐसे लिखा, लेट्स से ए पावर n सच दैट n ग्रेटर देन और इक्वल 0 लिखा, L4 हो सकता ए पावर m b पावर n सच दैट n ग्रेटर देन और इक्वल सॉरी m कामा n ग्रेटर देन और इक्वल 0, L5 जो भी है a पावर n b पावर n सच दैट n ग्रेटर देन और इक्वल 0, जो भी लिखा, ये सारे किसकी है, सबसेट। ये एम्प्टी लैंग्वेज लिया, सबसेट ऑफ सिग्मा स्टार है नहीं है, ऑफ कोर्स सबसेट और इक्वल, समटाइम इक्वल भी होता, सबसेट ऑफ सिग्मा स्टार है, यस और नो। इसी से लेना पड़ेगा ना स्ट्रिंग्स, कहीं से तो नहीं उड़ाएंगे, यही से उड़ाएंगे ना। यू हैव टू टेक द स्ट्रिंग्स फ्रॉम द सिग्मा स्टार टू फॉर्म एनी लैंग्वेज ओवर द सिग्मा, है ना। इट इज अ कलेक्शन ऑफ द स्ट्रिंग्स नो डाउट, बट जो स्ट्रिंग्स है वो सिग्मा स्टार के अंदर जो है उसी से उठाना पड़ेगा आपको, इसी से सेलेक्ट करके इसमें डालना पड़ेगा। अगर सारे डाल दिया वो लैंग्वेज सिग्मा स्टार से बराबर होगा, कम डाल दिया तो सबसेट, स्ट्रिक्टली सबसेट बनेगा, आइदर सबसेट और इक्वल होगा। क्लियर? तो कोई भी लैंग्वेज लिखो यार, कोई भी लिखो, L6 लिखा, सपोज L6 लिखा, ये पावर लेट्स से क्या है, ए बी होल स्टार लिखा, ये भी सबसेट ऑफ क्या है, सिग्मा स्टार है। और जो भी लिखो यार ओवर ये कामा भी वही होता आंसर, और कोई तो नहीं होता। सबसेट, सबसेट का डेफिनेशन मालूम है, वो तो कंफ्यूजन नहीं है ना। सबसेट का डेफिनेशन है तो मुझे बता दो यार, वो भी डिफाइन कर दूंगा आपके लिए। So if you don't know the subset definition, first learn it, then you will understand, oh, every language is a subset of sigma star only. Okay? Oh, thank you, Govind Soni. निशु, डिसाइड तो आप लोग करेंगे, राइट? आप लोग करेंगे। तो यहाँ ऑपरेशंस क्या क्या होता? यूनियन नहीं होता, कनकैटिनेशन होगा, और क्या हो सकता? वो जो बोला था ना, प्रीफिक्स, और क्या, सफिक्स, सबस्ट्रिंग। सो प्रीफिक्स को इनिट भी बोल सकते हैं, सबस्ट्रिंग को सबवर्ड भी बोल सकते हैं आप, सिनोनिम्स है, राइट? और बहुत सारे हैं, वो हम लैंग्वेजेस में चेक करेंगे, जैसे होमोमॉर्फिज्म, राइट? यहाँ भी होमोमॉर्फिज्म कर सकते हैं हम, बट इतना जरूरत नहीं है, यहाँ तक सीख लेंगे हम, ठीक है? क्वेश्चन भी यहाँ पर है, बहुत कुछ है यहाँ पर, बट मेन जो ऑपरेशन है यहाँ पढ़ेंगे, रिमेनिंग ऑपरेशंस लैंग्वेजेस में करेंगे हम। यस शेफू, द प्राइम विदाउट एनी रिस्ट्रिक्शन इट्स अ नॉन रेगुलर। वो तो यार वहाँ पूछो ना यार, जितने भी डाउट है उसी कॉन्सेप्ट में पूछा, रेगुलर रेगुलर नॉन रेगुलर नहीं आया, हम सिर्फ बेसिक कॉन्सेप्ट में है, राइट? कनकैटिनेशन ऑफ टू स्ट्रिंग्स, इसमें क्या याद रखना है आपको? बस इतना याद रखना है यार, अगर कोई स्ट्रिंग दिया कुछ लेंथ, लेट्स से के, लेट्स से एम लेंथ, लेंथ ऑफ W2 दिया एन लेंथ, क्या होता है यार? W1 W2 का लेंथ क्या होगा? और W2 फॉलोड बाय W1, एक कनकैटिनेशन है बीच में, क्या होता लेंथ? बस इतना याद रखना, रिमेनिंग तो आपको पता है। क्या होता लेंथ? मतलब W1 जो भी स्ट्रिंग है एज इट इज रख के उसके बाद W2 लिखेंगे ना, तो लेंथ m लेंथ फॉलोड बाय n लेंथ क्या होता? m प्लस n लेंथ होता। यहां भी n लेंथ फॉलोड बाय m लेंथ, n प्लस m, मतलब ये दोनों हमेशा सेम होता। W1 W2 may or may not be same as, right? Not equal or not, that depends on the string, but length of W1 W2 is always equal to length of W2 followed by W1। ये सबको पता है ना? बस इतना ही कॉन्सेप्ट आपको पता है, पता होना चाहिए कंकैटिनेशन में। एग्जाम्पल्स तो आपको पता है यार, बेसिक कॉन्सेप्ट है। लाइक अगर नाम है निशु कुमार है, निशु W1 है, कुमार W2 है, निशु फॉलोड बाय कुमार, निशु कुमार, W1 लेंथ फॉलोड बाय W2 लेंथ। लेंथ होगा जो लेटर्स है, नंबर ऑफ लेटर्स है निशु में, फॉलोड बाय नंबर ऑफ लेटर्स इन कुमार है, तो बस ऐड कर लो, वही लेंथ होंगी। यूनियन, व्हाई नॉट? गुड क्वेश्चन, गुड क्वेश्चन। देखो L1 सपोज एक लैंग्वेज है, लेट्स से एक L1 है, L2 में लेट्स से एप्सिलॉन है, तो आप लैंग्वेज को यूनियन कर सकते हैं ना? क्या होता है? एप्सिलॉन A कामा डबल B, तो लैंग्वेज का यूनियन लैंग्वेज आया। अगर स्ट्रिंग्स लेट्स से A B है, W2 ये B A है, तो अगर W1 प्लस और यूनियन कहा ना, यूनियन कहा ना, वो प्लस मान सकते यूनियन। W2 किया, ये सेट्स नहीं है, स्ट्रिंग्स है, तो अगर मान लिया AB AB प्लस डबल B है, दिस इज नॉट ए स्ट्रिंग, इट इज गोइंग टू बी ए सेट ऑफ स्ट्रिंग्स। एक स्ट्रिंग, देयर इज नो गारंटी, राइट? तो W1 union W2, you will get a set of the strings, not a string. Need not be a string. A single string नहीं है, more than one string. You'll get multiple strings. Multiple strings आएगा, वो language बनेगा, string नहीं बनेगा। But इसमें देखो concatenation, वो concatenate करने के बाद भी string आएगा। AB W2 let's say ABB, क्या होगा? W1 W2 एक string बनेगा, result। मल्टीपल स्ट्रिंग्स नहीं बनेगा, राइट? वन स्ट्रिंग बनेगा। बट वही तो है, यूनियन हम अप्लाई नहीं कर सकते टू गेट द स्ट्रिंग बैक। अगर यूनियन ऑफ टू स्ट्रिंग्स किया ना, लैंग्वेज आएगा, वो स्ट्रिंग नहीं आएगा, राइट? वो मल्टीपल स्ट्रिंग्स आएगा, इसलिए हम वो ये ऑपरेशन अप्लाई नहीं करेंगे स्ट्रिंग्स के ऊपर। पता होना चाहिए, राइट? कहाँ अप्लाई करना, कहाँ अप्लाई नहीं करना, ठीक है? ऑफ कोर्स यू कैन अप्लाई इट, बट यू डोंट गेट ए बैक द स्ट्रिंग, ओके? हम यूज नहीं करेंगे, ये यूनियन यहां पर अगर कोई भी यूज किया ना उसका पर्पस अलग होगा, इट विल गेट द डिफरेंट मीनिंग. यूनियन ऑफ टू स्ट्रिंग्स विल गेट ए सेट, यू मे नॉट गेट ए स्ट्रिंग बैक, बट प्रीफिक्स ऑफ ए स्ट्रिंग वन स्ट्रिंग बनेगा. यहां भी सारे प्रीफिक्स चाहिए तो सेट बनेगा, तो प्रीफिक्स चाहिए तो वन प्रीफिक्स, सेट ऑफ प्रीफिक्सेस लैंग्वेज बनेगा, या यूनियन किया एक सेट बनेगा. अगर किसी को यूनियन करना है कर लो, क्या होता है यार, आपका मीनिंग है तो कर लो. यूनियन क्या बनेगा, यूनियन अप्लाई किया तो यू विल गेट ए लैंग्वेज लाइक लेट्स से W1 यूनियन W2. एक्चुअली यूनियन स्ट्रिंग के लिए अप्लाई नहीं करते हम बेसिकली, अगर अप्लाई किया तो भी एक लैंग्वेज आएगा, ये इट्स गोइंग टू बी ए सेट नॉट ए स्ट्रिंग. ओके, we won't get a string or not, that I can't tell you, right? That's what I'm saying. AB plus AB किया वो ठीक है, AB आएगा ना. AB को यूनियन किया, एक ही स्ट्रिंग है तो उसको सेट की जरूरत नहीं है. जब when you have one string, right, when you have one string in the set, you don't need to represent a set. Like we write epsilon, इसको आप equivalent epsilon भी बोल सकते हैं ना. Only one element है, उसको equivalent कह सकते हैं one string से बराबर. जब एक से ज्यादा है, अगर एक से कम है, सेट की जरूरत पक्का पड़ेगा. यस, तो वन स्ट्रिंग है तो आप बोल सकते हैं यार लैंग्वेज की जरूरत नहीं पड़ता वन स्ट्रिंग के लिए. मोर देन वन स्ट्रिंग है और जीरो स्ट्रिंग से लैंग्वेज की रिप्रेजेंटेशन जरूरत है, राइट, कलेक्शन ऑफ द स्ट्रिंग्स के लिए. बट वन स्ट्रिंग के लिए यू डोंट नीड ए लैंग्वेज बेसिकली. ठीक है, वो रेगुलर एक्सप्रेशन में भी हम रिप्रेजेंट करते हैं. वो ज्यादा कंफ्यूज्ड है, दैट्स व्हाई वी नेवर टॉक अबाउट वन स्ट्रिंग ऑलवेज. ठीक है, अब चलते प्रीफिक्स ऑफ ए स्ट्रिंग. सबको मालूम है ना, एक एग्जांपल लेके कर लेता. ए बी ए, राइट, ए बी ए. प्रीफिक्स का डेफिनेशन क्या होता, प्रीफिक्स ऑफ ए स्ट्रिंग डेफिनेशन क्या होता, प्रीफिक्स ऑफ डब्ल्यू का डेफिनेशन क्या होता, यानी बिगिनिंग सीक्वेंस. एनी बिगिनिंग सीक्वेंस ऑफ W. इसका मतलब क्या है, अगर W को दो पार्ट्स डिवाइड किया तो ये U हम बोलते प्रीफिक्स. अब देखो W जो है ये बी ए, इसको दो पार्ट्स डिवाइड कर लो, जो बिगिनिंग वाला लेना है तो मैं डिवाइड करूंगा देखो टू पार्ट्स में, बट दो कंकैटिनेशन W आना चाहिए. एप्सिलॉन ए बी ए, इसकी कंकैटिनेशन क्या आया, W आया. ए बी ए, ए बी ए और ए बी ए एप्सिलॉन. देखो ये यू वी है, ये यू है, वी है, राइट. ये जो पोर्शन है ना, इसी को बोलते हैं हम सारे प्रीफिक्सेस ऑफ डब्ल्यू, ऑल प्रीफिक्सेस ऑफ डब्ल्यू, राइट. तो अगर कोई पूछा प्रीफिक्सेस क्या क्या है तो आपको लिखना पड़ेगा एप्सिलॉन ए बी ए. इसका फॉर्मूला भी है, राइट. क्या है फॉर्मूला एग्जाम में, नंबर ऑफ प्रीफिक्सेस ऑफ W ऑफ एन लेंथ कितने होंगे, n+1. एक टाइप की क्वेश्चन है. दूसरी टाइप की, नंबर ऑफ नॉन एम्प्टी प्रीफिक्सेस कितना होना चाहिए, नॉन एम्प्टी प्रीफिक्सेस ऑफ W ऑफ एन लेंथ कितना होना चाहिए, एक्सेप्ट एप्सिलॉन कितना होगा, n होगा, राइट. अगर नंबर ऑफ डिफरेंट लेंथ प्रीफिक्सेस कितने होगा, ऑफ W ऑफ n लेंथ कितने होगा, n+1. अगर यहां भी जीरो लेंथ जरूरत नहीं है, n होगा. डिफरेंट लेंथ है ना, चारों तो 4 होगा, 3 होगा. यस, काउंट करना होगा, वो डायरेक्ट फॉर्मूला यूज कर सकते हैं. अगर आपको पता है प्रीफिक्सेस काउंट करना जरूरत नहीं मैनुअली, एक दो स्ट्रिंग लेके आप फॉर्मूला बना सकते हैं. यू कैन मेक ए फॉर्मूला ऑन योर ओन, राइट. यस गाइस, ये ऑलरेडी वन ऑफ द टाइम गेट क्वेश्चन आल्सो, राइट. तो अगर प्रीफिक्स कॉन्सेप्ट समझ में आया तो सफिक्स क्या होगा, सफिक्सेस क्या होता बेसिकली यहां पर, द एंडिंग सीक्वेंस. एंडिंग सीक्वेंस क्या होता, एप्सिलॉन होगा, सी होगा, बी सी, ABC, मतलब एंडिंग यहां पे होंगे, एंड इज हियर, तो बिगिनिंग आप कहीं पर भी कर सकते हैं. बिगिनिंग इज एनीवेयर, यू कैन बिगिन एनीवेयर. यहां पर इसमें यू कैन बिगिन एनीवेयर. सेम नंबर ऑफ सफिक्सेस कितने होंगे? मान लो लेंथ ऑफ W इज गिवन n, लेट नंबर ऑफ सफिक्सेस कितने होंगे? n+1. और नंबर ऑफ नॉन एम्प्टी सफिक्सेस कितना होंगे? नॉन एम्प्टी मतलब अदर देन द एप्सिलॉन, अदर देन द एप्सिलॉन कितना होंगे? राइट, n होंगे. बहुत बार लिखा होगा इस फॉर्मूला को, राइट. और नंबर ऑफ, यहां पर देखो डिफरेंट लेंथ, कभी कभी सेम लेंथ होगा ना, उसको एक ही काउंट करना पड़ेगा आपको. नंबर ऑफ डिफरेंट लेंथ सफिक्सेस कितना होंगे? वो भी n+1. क्यों? सारे डिफरेंट लेंथ है, तो डिफरेंट लेंथ पूछा, टोटल नंबर ऑफ सफिक्सेस पूछा, सेम आंसर है इस कॉन्सेप्ट में, राइट. प्रीफिक्सेस सफिक्स में कोई दिक्कत नहीं इसमें. नंबर ऑफ डिफरेंट नॉन जीरो लेंथ सफिक्सेस, क्या होता आंसर? n. तो ये एक्सेप्ट एप्सिलॉन कितने नॉन जीरो लेंथ है? 3 है, राइट. यहां तक कोई दिक्कत नहीं होता क्योंकि प्रीफिक्सेस सफिक्सेस बहुत इजी कॉन्सेप्ट है. सो देख के ही आपको समझ में आता है यार सफिक्स का डेफिनेशन क्या है. एंडिंग सीक्वेंस. सो W को 2 पार्ट्स बांटना है, तो V को बोलते हैं हम सफिक्स, U को बोलते हैं हम प्रीफिक्स. कोई डिफरेंस, कोई डिफिकल्ट नहीं होता. लास्ट में लिया तो सफिक्स, बिगिनिंग में लिया तो प्रीफिक्स. सो कोई बिगिनिंग कितना लेंथ है वो आपको डिपेंड्स ऑन आपको कितना चाहिए. 0 लेंथ, 1 लेंथ, 2 लेंथ, 3 लेंथ, राइट. मैक्सिमम जो W लेंथ है उतना ही ले सकते हैं आप, आइदर U और V. करेक्ट. ओके, यहां पर होता सबस्ट्रिंग. सबस्ट्रिंग में प्रॉब्लम क्या है बेसिकली? वो ये भी चाहिए क्या? ट्रिवियल नॉन ट्रिवियल भी चाहिए. बेसिकली ट्रिवियल कब बोलते हैं हम? ट्रिवियल, नॉन ट्रिवियल. प्रीफिक्स में एंड सफिक्स में देखेंगे. सफिक्स, मान लो W कुछ दिया, W इज इक्वल लेट से ABC दिया, ABC ले रहा हूं, ठीक है, ABC. ट्रिवियल क्या बनेगा? ट्रिवियल प्रीफिक्सेस लाइक एप्सिलॉन एंड ABC. मतलब इन जनरल क्या होता? एप्सिलॉन एंड W. यहां भी एप्सिलॉन ABC. बाकी सारे वो ट्रिवियल नहीं है. क्यों? एप्सिलॉन ABC सारे, मतलब एप्सिलॉन एंड जो गिवन W है, एप्सिलॉन एंड गिवन W, ये दोनों बाय डिफॉल्ट सबके लिए, दुनिया में सबके लिए ये ट्रिवियल है. बिना देख के, स्ट्रिंग को देख के ये लिख सकते हैं आप कॉपी पेस्ट करके. बट नॉन ट्रिवियल उसके अंदर देखना पड़ेगा. यार अगर ABC है तो प्रीफिक्सेस मतलब आपको 1 लेंथ और 2 लेंथ और 3 लेंथ. 3 लेंथ तो वो हो गया, राइट. और यहां भी ऐसे है 1 लेंथ, ये भी है. क्या हो रहा है? यहां देखो C है, BC है, तो ये है नॉन ट्रिवियल. कि ABC तो वैसे ही बाय डिफॉल्ट ट्रिवियल में आ गया. यहां 1 लेंथ 2 लेंथ बनेगा नॉन ट्रिवियल. उसको देखना पड़ेगा, किसको इग्नोर करना, उसको अंदर देखना पड़ेगा, राइट. नॉन ट्रिवियल मतलब कॉपी पेस्ट नहीं कर सकते आप. तो दुनिया में ये एप्सिलॉन W प्रीफिक्स ऑफ एवरी स्ट्रिंग. अगर W स्ट्रिंग है तो एप्सिलॉन भी प्रीफिक्स होगा और WB इटसेल्फ भी प्रीफिक्स होगा. W मतलब इटसेल्फ, ठीक है. अगर एग्जाम में दिया नंबर ऑफ नॉन ट्रिवियल प्रीफिक्सेस, नंबर ऑफ नॉन ट्रिवियल प्रीफिक्सेस फॉर लार्ज एंड लेंथ स्ट्रिंग. लार्ज मतलब स्मॉलर में तो ये कंफ्यूजन करेगा आंसर, इसलिए फॉर लार्ज एंड लेंथ स्ट्रिंग. मोस्टली n value is let's say greater than 1. n is equal 2 से स्टार्ट होता बेसिकली. तो तो कितना होगा आंसर n, नॉर्मली तो आंसर n+1 है ना, तो अभी n-1 बनेगा, क्यों एप्सिलॉन को हटाना है आपको, w को भी हटाना है, तो n-1 होगा आंसर। ठीक है, ये क्वेश्चन अब तक नहीं आया, फ्यूचर में हो सकता गेट में, नॉन ट्रिवियल कॉन्सेप्ट। सिमिलरली नॉन ट्रिवियल सफिक्सेस तो होगा -1, n-1, n+1 टोटल, उसमें से माइनस, आपको आंसर चाहिए n+1 एक्चुअल टोटल है, -2 हटा लो, ये तो टोटल है, ये तो ट्रिवियल है, तो ट्रिवियल हटा दिया तो नॉन ट्रिवियल आ गया आंसर। एग्जैक्टली मिर्जा, दैट इज ट्रू, नॉन ट्रिवियल में एप्सिलॉन एंड डब्ल्यू नहीं आएगा। ओके, लेट्स गो टू द सबस्ट्रिंग। आप बताना क्वेश्चंस, डेफिनेशन भी नहीं दे रहा हूं मैं पहले। हाउ मेनी सबस्ट्रिंग्स, यही क्वेश्चन है, बहुत लोगों को कंफ्यूजन होता, हाउ मेनी सबस्ट्रिंग्स पॉसिबल फॉर एंड लेंथ स्ट्रिंग। बस एक ही क्वेश्चन है, वो बहुत इंपॉर्टेंट है एग्जाम के लिए। या इस आंसर देख के मैं फटाफट कर लेता हूं। पावर सेट क्या यार, सबसेट्स नहीं पूछा, आई आस्क्ड द सबस्ट्रिंग्स, नंबर ऑफ सबस्ट्रिंग्स, या ये तो याद रखना पड़ेगा, सबसेट अलग वर्ड है, सबस्ट्रिंग अलग वर्ड है। सबसेट लैंग्वेजेस के लिए होता, सबस्ट्रिंग स्ट्रिंग्स के लिए होता। n इंटू n+1/2, या श्रीतम सही है, एक बिल्कुल आंसर गलत है। कोई बताए ना n इंटू n+1/2 +1, गलत है। क्यों, गारंटी नहीं होता, ये मैक्सिमम आंसर होता, एग्जैक्टली नहीं बता सकते आप। स्ट्रिंग को देख के लिख सकते हैं एग्जैक्टली, बट एग्जैक्टली ये आंसर नहीं आएगा, एक रेंज बनेगा, तो डिपेंड्स ऑन द स्ट्रिंग, आंसर विल वैरी, बट आंसर लाइज इन बिटवीन, आंसर इज इन बिटवीन two things. One is n+1, maximum is sigma n+1. ये मैक्सिमम आंसर होता, ये मिनिमम आंसर होता, बट एक्चुअली जो गिवन स्ट्रिंग है वो कहीं पर भी हो सकता है, इसको दोनों का बीच में आंसर ये हो सकता है, ये हो सकता है, नहीं तो बीच में भी हो सकता, राइट। बट ये कब होगा? अच्छा, सबस्ट्रिंग डेफिनेशन क्या है? सबस्ट्रिंग डेफिनेशन क्या है? देखो, अगर W इज इक्वल 4 ये है और W इज इक्वल, देखो दोनों 4 लेंथ तो है, बाकी सारे मैं नहीं लिख रहा हूं, आप बाद में लिखो, कोशिश करो। ऐसे होता ना, A B A A, W इज इक्वल A B B B, W इज इक्वल A B A B, ये अलग अलग होता है, W इज इक्वल, राइट, अलग अलग होता, बट ये मिनिमम केस है, ये मैक्सिमम केस है, और बाकी सारे बीच में रहेगा आंसर्स। इसका जो रिमेनिंग स्ट्रिंग्स, राइट, दिस आर द स्ट्रिंग्स, दे गिव द नंबर ऑफ सबस्ट्रिंग्स इन बिटवीन दिस टू आंसर्स। ओके, तो मिनिमम केस यहां पर कितने सबस्ट्रिंग्स होंगे? पहले सबस्ट्रिंग का डेफिनेशन क्या है? W को 3 पार्ट्स डिवाइड करना, X Y Z, एंड Y को बोलते हैं हम सबस्ट्रिंग। हो सकता है X एप्सिलॉन Z एप्सिलॉन, बट Y जो मिडिल पोर्शन है, पार्ट ऑफ द स्ट्रिंग, इट इज द पार्ट ऑफ द स्ट्रिंग, बट ये पार्ट X नहीं है तो ये पहले होगा, Z नहीं है तो लास्ट में होगा, अगर दोनों है तो बीच में कहीं पर भी हो सकता, पार्ट ऑफ द स्ट्रिंग। X को आप मान सकते प्रीफिक्स, Z को मान सकते सफिक्स, और इस 4 years को जो भी करो, द सबस्ट्रिंग्स सिर्फ 5 पॉसिबल होगा। क्या क्या होगा? Y एप्सिलॉन हो सकता, नहीं तो 1A हो सकता, 2A हो सकता, 3A हो सकता, 4A होगा मैक्स। तो कितने सबस्ट्रिंग्स पॉसिबल है? यहां पर 4 लेंथ के लिए 5 पॉसिबल है। टोटल कितने सबस्ट्रिंग्स है? 5 सबस्ट्रिंग्स है। ये मिनिमम केस है, इससे कम कभी नहीं होगा नंबर ऑफ सबस्ट्रिंग्स। अगर 4 लेंथ दिया 5 नंबर ऑफ सबस्ट्रिंग्स, राइट, इससे कम कभी नहीं होगा। मिनिमम ये होना चाहिए कब ऑल द सिंबल्स आर सेम इन द स्ट्रिंग, ये कंडीशन है। और मैक्सिमम कब होगा, ऑल द कैरेक्टर्स और ऑल द सिंबल्स आर डिस्टिंक्ट, डिस्टिंक्ट तभी होगा मैक्सिमम। मैक्सिमम क्या हो सकता है यहां पर देखो, सबस्ट्रिंग्स लिखना पार्ट ऑफ द स्ट्रिंग, बट 0 लेंथ से स्टार्ट कर लो, एप्सिलॉन। 1 लेंथ क्या क्या होगा, ए हो सकता, बी हो सकता, सी हो सकता, डी हो सकता। 2 लेंथ क्या क्या होगा, ए बी हो सकता, बी सी होगा और सी डी होगा। बट क्या नहीं होगा, कुछ लोग लिखते सर ए सी, ये सी नहीं होता, क्यों, ए सी इज द नॉट पार्ट, नॉट देयर इन द मिडिल। व्हाई, दैट इज नॉट नेवर बी ए सी, राइट? इफ आई राइट ए सी, how can you make this total is equal to ABCD? Impossible, right? You can't write in the middle AC. That AC should be together. Remember that. You can't skip the sequence of the, you can't skip the symbols. तो AB, BC, CD और 3 लेंथ क्या क्या होगा, ABC, BCD। 4 लेंथ क्या होगा, ABCD। यार इसका फॉर्मूला देख लिया ना, तो यहां पर ये तो अलग है, स्पेशल है, ये तो स्पेशल, ये 1 है, ठीक है। देखो ये 4 है, ये 3 है, ये कितना 2 है, ये 1 है, मतलब 1 + 2 + 3 + 4 क्या बन रहा है, सम ऑफ द फर्स्ट 4 नेचुरल नंबर्स। इसको कहते हैं हम 1 + 2 + 3 टिल n लेंथ, टिल n, राइट? n लेंथ स्ट्रिंग मतलब टिल n, तो सिग्मा n कहते हैं हम इसको, बोलते हैं हम आंसर सिग्मा n। ये +1 टोटल, ये 1 है, तो इसलिए सिग्मा n +1 इन द वर्स्ट केस। वर्स्ट केस अगर एग्जैक्ट स्ट्रिंग दिया ना तो ऐसे रैंडम फॉर्मूला यूज नहीं कर सकते आप, ठीक है। रिमेंबर दैट। यस निशु, शुरुआत में लिखा ना, प्रीफिक्स इज आल्सो कॉल्ड एज इनिट। तो इन जनरल क्या होता है आंसर, तो द आंसर लाइज इन बिटवीन दिस टू। अगर कोई पर्टिकुलर स्ट्रिंग दिया तो यूज द कॉम्बिनेशंस टू फाइंड द राइट आंसर, राइट? ये नहीं बोलना, ये नहीं बोलना, ठीक है। अगर यहां दिया ना हाउ मेनी सबस्ट्रिंग्स, ये भी लिख लेते आंसर। लेट length of the string is n, right? How many substrings of w, okay? ये first question, okay? Next question, how many substrings of w if all symbols in W are same? How many substrings of W if all symbols in W are distinct, or that means different? How many different length substrings? No need to ask that, distinct, all these things. How many substrings, how many different length substrings of W? आंसर देना फटाफट। 1 2 3 4। बस ये चारों कॉन्सेप्ट आ गए ना, बस सबस्ट्रिंग का कॉन्सेप्ट पूरा समझ में आया आपको। फर्स्ट आंसर तो 2 होता, मिनिमम होता, मतलब एटलीस्ट, आंसर ऐसे होता एटलीस्ट n +1, एट मोस्ट 2 आंसर्स होता है इसका, सिग्मा n +1, मतलब n × n + 1/2 +1। परफेक्ट, ये तो ऑलरेडी पता है आपको। हाउ मेनी सबस्ट्रिंग्स, यहाँ क्वेश्चन क्लैरिटी नहीं है, ऑल द सिंबल्स आर सेम और डिस्टिंक्ट, क्लैरिटी नहीं है, तो आपको बताना पड़ेगा एटलीस्ट क्या है, एटमोस्ट क्या है। सेकंड, हाउ मेनी सबस्ट्रिंग्स ऑफ W इफ ऑल द सिंबल्स आर सेम, ये बनेगा n +1। अगर नॉन एम्प्टी सबस्ट्रिंग्स कहा, यहां पर एक और क्वेश्चन होता, मैंने लिखा, अगर नॉन एम्प्टी सबस्ट्रिंग्स कहा n, बस 1 को माइनस कर दो एक्स्ट्रा। या बिल्कुल सही है वो निशु, यू कैन राइट दैट वे। डिस्टिंक्ट कितने होंगे, डिस्टिंक्ट नहीं, व्हेन द ऑल द सिंबल्स आर डिस्टिंक्ट तो नंबर ऑफ सबस्ट्रिंग्स कितना होंगे, सिग्मा n +1, n × n + 1/2 +1, सही है, राइट। तो ये है पुराना गेट क्वेश्चन, ये गेट क्वेश्चन भी है, लोग कंफ्यूज्ड है, आंसर यहां पर गेट PYQ है। ये नंबर ऑफ डिफरेंट लेंथ ये भूल गया, आंसर दे रहा है हाउ मेनी सबस्ट्रिंग्स, वो भी ये दे रहा है सिग्मा n+1। यार कैसे होता सिग्मा n+1, डिफरेंट लेंथ्स पूछा ना, कितने डिफरेंट लेंथ्स है देखो, कितने डिफरेंट लेंथ्स, कहा गया सबस्ट्रिंग्स, एग्जाम्पल कहा गया इसमें क्या, ठीक है, डिफरेंट लेंथ्स कितने हैं यहां पर, ये है 0 लेंथ, ये 0 लेंथ है, ये 1 लेंथ है, ये 2 लेंथ है, ये 3 लेंथ है, ये 4 लेंथ, कितने डिफरेंट लेंथ है 1 2 3 4 5 डिफरेंट लेंथ्स है, राइट। यहां पर क्या आंसर आएगा 5 डिफरेंट लेंथ्स, 5 डिफरेंट लेंथ्स, ये आंसर मिलना चाहिए इनको। टोटल नंबर ऑफ सबस्ट्रिंग्स नहीं पूछा, हाउ मेनी डिफरेंट लेंथ्स है, 0 1 2 3 4 5 डिफरेंट लेंथ्स है, तो ये आंसर होगा, क्या होगा n होगा, n+1 होगा, 0 लेंथ भी है ना। पुराना क्वेश्चन था हाउ मेनी डिफरेंट नॉन 0 लेंथ सबस्ट्रिंग्स, वहां n है, क्वेश्चन थोड़ा बदल दिया गेट एग्जाम में, क्या बदल दिया, हाउ मेनी डिफरेंट नॉन 0 लेंथ, नॉन 0 लेंथ मतलब 0 का हटा दो, नॉन 0 लेंथ सबस्ट्रिंग्स शुड रिमूव n होगा आंसर। This was one of the time taking question for many people. They were just assuming n into n+1 by 2+1, but that was wrong answer, right? Done? So basics में इससे ज़्यादा तो जरूरत नहीं पड़ेगा आपको। So ये basics है, strings में क्या पढ़ना है और languages में क्या पढ़ना है आपको। Any doubt? अगर डेफिनेशन से याद रखना है तो किसी से मैप कर लेना। सो ये TOC में ये होता बेसिकली, इन TOC क्या होता, हम ऐसे फॉर्म करेंगे, क्या फॉर्म करेंगे, सिंबल, अल्फाबेट, स्ट्रिंग, लैंग्वेज, फाइनली यही पर फोकस करेंगे हम, लैंग्वेज लैंग्वेज लैंग्वेज, हमेशा यही पर फोकस करते हैं हम, राइट। बट अगर सी लैंग्वेज में देखा, रियल वर्ल्ड, इन रियल वर्ल्ड प्रोग्रामिंग वर्ल्ड, सी लैंग्वेज है, तो पहले हम बोलते कैरेक्टर, सारे कैरेक्टर्स मिला के कैरेक्टर सेट बनाते, इसी को बोलते हैं हम सिग्मा, इसी को बोलते हैं हम सिंबल। और ये जो ग्रुप ऑफ कैरेक्टर्स को हम लेक्सिकल एनालिसिस में आता है ना कंपाइलर, देयर वी विल कॉल इट इज टोकन, ये तो स्ट्रिंग से बराबर है। और ये जो टोकन सीक्वेंस में लिखेंगे ना, एक प्रोग्राम बनेगा, उस प्रोग्राम को बोलते हैं हम सी लैंग्वेज, राइट। सेट ऑफ प्रोग्राम्स को बोलते हैं हम सी लैंग्वेज, राइट। सी लैंग्वेज के लिए क्या क्या चाहिए होता, सिंबल वो कैरेक्टर है, और अल्फाबेट मतलब कैरेक्टर सेट है, और स्ट्रिंग मतलब इन TOC में यहां पर टोकन है, तो और टोकन्स को पढ़ना पड़ेगा आपको, प्रोग्राम लिखना है तो। कैरेक्टर को लेक्सिम नहीं बोलते, टोकन को लेक्सिम बोलते हैं हम, टोकन का दूसरा नाम है लेक्सिम होता, कैरेक्टर को लेक्सिम नहीं बोलेंगे हम, ठीक है। पता है ना, टोकन एंड लेक्सिम बोथ आर सेम फॉर द प्रोग्रामर, कंपाइलर के लिए अलग मीनिंग होता होगा, बट प्रोग्रामर के लिए लेक्सिम टोकन में कोई डिफरेंस नहीं होता, राइट, करेक्ट। अब देखो इंग्लिश लैंग्वेज में कैसे यूज करते हैं हम, तो ये तो सी लैंग्वेज में हो गया, तो इंग्लिश लैंग्वेज में क्या फॉर्म करेंगे हम इसमें, इंग्लिश में, तो इंग्लिश के लिए वो जो इंग्लिश हिंदी जो भी है, राइट, तो यहां पर क्या होता है, हमको लेटर बोलते हैं हम, इंग्लिश लेटर, हिंदी लेटर, राइट, लेटर्स कलेक्ट करके हम इंग्लिश अल्फाबेट बोलते हैं हम उसको, अल्फाबेट, अल्फाबेट अलग है, लेटर अलग है, अल्फाबेट मतलब सेट ऑफ लेटर्स होता, और इसको लेके हम डिक्शनरी वर्ड्स फॉर्म करेंगे, इसको, ये वर्ड सारे डिक्शनरी में होता, राइट, हर वर्ड डिक्शनरी में होता, यू कैन फाइंड, तो उसको लेकर हम इंग्लिश लैंग्वेज को फॉर्म करेंगे यूजिंग सेंटेंसेस, और सेंटेंस फ्रेम करने के लिए ग्रामर होता, बहुत सारे होता, इंग्लिश लैंग्वेज फ्रेम करेंगे, जो भी सेंटेंस बात करेंगे उसको बोलते हैं हम इंग्लिश लैंग्वेज, राइट। ऐसे बहुत सारे लैंग्वेजेस बना सकते हैं दुनिया में, आपका लैंग्वेज भी बना सकते हैं। कल अगर आपको नया प्रोग्रामिंग इंट्रोड्यूस करना है तो यही रूल्स फॉलो करेगा ना, आपकी प्रोग्रामिंग में, लाइक रिसेंटली पाइथन इंट्रोड्यूस किया, कैसे इंट्रोड्यूस किया, उनका वो ओन कैरेक्टर सेट है, वो एक नया अल्फाबेट बनाया, उसके बाद इनका अलग कीवर्ड्स है, अलग ऑपरेटर्स है, तो टोकन फॉर्म किया, उसके बाद उसका रूल्स है, सिंटैक्स है, सिमेंटिक जो भी है, राइट। ये टीओसी मदद करेगा दुनिया में अगर किसी से कम्युनिकेट करना है, कुछ नया इन्वेंट करना है लैंग्वेजेस, तो ये टीओसी बताएगा ये कैसे करना है, राइट। कंपाइलर एक बेस्ट एग्जांपल है कैसे फ्रेम किया टीओसी को हेल्प लेकर। राइट, ये है पूरा टीओसी में जो हम पढ़ने वाला है। ओके, क्या पढ़ने वाला है टीओसी में, किसी को पता? क्या यार, पूरा टीओसी में क्या पढ़ने वाला है हम? कितने सर्कल्स है, कितने बॉक्सेस है यहां पर? किसी को पता कितने बॉक्सेस है? मुझे भी नहीं पता एग्जैक्टली कितने चाहिए उतना फ्रेम कर सकते हैं आप। चाम्स के एरर में क्या किया, एक ऐसे लैंग्वेज है उसको बोलते हैं हम टाइप 3 क्लास है। टाइप 3 क्लास क्या है? टाइप 3 क्लास। और एक और क्लास को आइडेंटिफाई किया, वो है टाइप 2 क्लास है। एक और है टाइप 1, एक और है टाइप 0, और इसके बाहर भी है बहुत। मतलब ये जो दिख रहा है ना आपको, ये पूरा टाइप 3 है। इसमें क्या लैंग्वेजेस है, इसमें क्या लैंग्वेजेस है, यहां पर क्या लैंग्वेजेस है, यहां पर क्या लैंग्वेजेस है, रेगुलर लैंग्वेजेस है। तो यहां से यहां तक पूरा रेगुलर लैंग्वेजेस है, बट इंक्लूडिंग द इनर बॉक्स। ये क्या होता है? फाइनाइट लैंग्वेजेस। रेगुलर लैंग्वेजेस है यहां पर। कितने रेगुलर लैंग्वेजेस है? इनफाइनाइट रेगुलर लैंग्वेजेस है, इनफाइनाइट। अब ये देखो, टाइप 1 छोड़ो, ये सॉरी टाइप 2 के बीच में एक और लैंग्वेजेस है DCFL, वो नहीं करेंगे अभी। ये देखो, यहां से यहां तक जितने भी लैंग्वेजेस है, यहां तक, इस लैंग्वेज को क्या बोलते हैं हम? कॉन्टेक्स्ट फ्री लैंग्वेजेस। क्या लैंग्वेजेस है वो? कॉन्टेक्स्ट फ्री लैंग्वेजेस। कितने यहां पर? इंक्लूडिंग रेगुलर लैंग्वेजेस। और एक और टाइप 1 है, देखो वो टाइप 1। टाइप 1 क्या है? ये यहां से पूरा यहां तक, वो क्या है? कॉन्टेक्स्ट सेंसिटिव लैंग्वेजेस। और जो इंपॉर्टेंट क्लास है वो है टाइप 0 क्लास। वो बहुत इंपॉर्टेंट है, मतलब यहां से लेकर पूरा यहां तक, वो है रिकर्सिवली एन्यूमरेबल क्लास लैंग्वेजेस। रिकर्सिवली एन्यूमरेबल। प्रॉब्लम ये है, ये चॉम्स्की एरर की क्लास की प्रॉब्लम, मतलब ये जो क्लास डायग्राम है, क्लास डायग्राम और लैंग्वेजेस की रिलेशनशिप मालूम नहीं होता बहुत लोग को। यार क्लास मतलब सारे लैंग्वेजेस उसके अंदर है। यह जो टाइप 3 क्लास है ना, इसके अंदर सारे रेगुलर लैंग्वेजेस अंदर है। तो रेगुलर लैंग्वेज एंड सेट ऑफ रेगुलर लैंग्वेजेस, दोनों वर्ड अलग है। ये पूरा बॉक्स है सेट ऑफ रेगुलर्स। एक अगर लैंग्वेज लिया इसी के अंदर, वो बोलते हैं हम रेगुलर लैंग्वेज। तो ये याद रखना चाहिए, रेगुलर लैंग्वेज क्या होता? सेट ऑफ रेगुलर लैंग्वेजेस। तो पहली वर्ड है, ये दोनों डिफरेंस होना चाहिए। लैंग्वेज, सेट ऑफ लैंग्वेजेस, दोनों डिफरेंट है नहीं? ऑब्वियसली। अगर लैंग्वेज, अगर मान रहे हैं हम रेगुलर लैंग्वेज, तो मान लो यहां पर रेगुलर लैंग्वेज है, ये वर्ड बहुत इंपॉर्टेंट है हमारे लिए। रेगुलर लैंग्वेज, फाइनाइट लैंग्वेज, ऐसे ही बोलते हैं ना, फाइनाइट लैंग्वेज। और ये अलग वर्ड है, सेट ऑफ फाइनाइट लैंग्वेजेस। ये दोनों अलग है। क्या अलग है? ये भी याद रखना, अभी याद रख लो। क्यों अनडिसाइडेबल में आपको कंफ्यूज इसलिए होता, ये दोनों का सेंटेंस समझने आता। लैंग्वेज, फाइनाइट लैंग्वेज मतलब ये लैंग्वेज के अंदर लेट्स से एप्सिलॉन ए बी ये की लैंग्वेज है। यहां पर क्या होता, ये लैंग्वेज के अंदर एक फाइनाइट लैंग्वेज होगा। क्या लैंग्वेज होगा, लेट्स से F1, F2, F3, कितने फाइनाइट लैंग्वेजेस है, इनफाइनाइट। ये F1 का मीनिंग होता लेट्स से एप्सिलॉन ए, क्या है ए बी एक हो सकता, ये इसमें कुछ और एप्सिलॉन होगा, इसमें कुछ एम्प्टी लैंग्वेज होगा। ऐसे कितने सारे फाइनाइट लैंग्वेजेस है, इनफाइनाइट नंबर ऑफ फाइनाइट लैंग्वेजेस। ये दोनों में डिफरेंस नहीं पता है लोग को, तो इसके मतलब डिसाइडेबल क्या है, अनडिसाइडेबल क्या है नहीं बताएंगे हम। पहले फाइनाइट लैंग्वेज, सेट ऑफ फाइनाइट लैंग्वेज, डिफरेंस नहीं आता, प्रॉब्लम ये अलग है वो अलग है। फाइनाइट लैंग्वेज मतलब ये सिंपल प्रॉब्लम है, इसमें फाइनाइट नंबर ऑफ स्ट्रिंग्स है। सेट ऑफ फाइनाइट लैंग्वेज मतलब इस सेट के अंदर फाइनाइट लैंग्वेजेस है, तो इसके लिए लॉजिक लिखना पड़ेगा, राइट। इस एल के लिए ट्यूरिंग मशीन है क्या, इस एल के लिए ट्यूरिंग मशीन है क्या, ऐसे सोचना पड़ेगा आप, राइट। तो ये दोनों का डिफरेंस समझ में आया तो लोग को समझ में आने लगेगी, वो रेगुलर लैंग्वेज अलग है, मतलब रेगुलर सेट अलग है, सेट ऑफ रेगुलर्स अलग है। ये प्रॉब्लम अलग है, ये प्रॉब्लम अलग है। सेट ऑफ रेगुलर सेट्स को हम बोलते हैं टाइप 3 क्लास। क्या बोलते हैं हम, टाइप 3 क्लास। बट इसको बोल सकते हैं आप ए लैंग्वेज प्रेजेंट दिस बिलोंग्स टू टाइप 3 क्लास। बिलोंग्स टू टाइप 3 क्लास, वो पूरा नाम, ये इसका नाम है टाइप 3 क्लास। दोनों डिफरेंट है, तो लोग को समझ में आया क्लियरली। या इज इट क्लियर। लैंग्वेज क्या होता, लैंग्वेज बेसिकली सेट ऑफ स्ट्रिंग्स है, यहां पर सेट ऑफ स्ट्रिंग्स, बट ये सेट ऑफ स्ट्रिंग्स नहीं है, सेट ऑफ लैंग्वेजेस। ये जो लैंग्वेज बेसिकली बाय डेफिनेशन सेट ऑफ स्ट्रिंग्स है। ये क्या है, सेट ऑफ स्ट्रिंग्स ऐसा होता है बेसिकली। इसका मीनिंग क्या है, सेट ऑफ स्ट्रिंग्स, मतलब सेट के अंदर सेट है, उस सेट के अंदर स्ट्रिंग्स है। मतलब अगर क्लियरली लिख दिया ना तो F1 की जगह में ए डाल दो, सेट के अंदर एक और सेट दिखेगा, उसके अंदर स्ट्रिंग दिखेगा, राइट। थोड़ा इंटरप्रेट करना पड़ेगा, उस सेंटेंस को समझना पड़ेगा। तो रेगुलर देख लिया, उसको गलती से डीएफए नहीं बताना है, तो यहां पर सेट ऑफ रेगुलर सेट्स, इसके लिए डीएफए नहीं होता, इसके लिए डीएफए होता। ये दोनों का डिफरेंस समझ में आया। हम डीएफए किसके लिए डिजाइन करेंगे, इस बॉक्स के लिए नहीं है, इसमें एक लैंग्वेज के लिए डीएफए डिजाइन करेंगे, इस बॉक्स के लिए डीएफए नहीं होता। इज दैट क्लियर, बात सबको समझ में आया। हम टीओसी में इस बॉक्स के लिए ट्यूरिंग मशीन होगा बट डीएफए नहीं होगा, बट इस बॉक्स में हर लैंग्वेज के लिए डीएफए होगा। इज दैट क्लियर, कोई डाउट है यहां पर, अभी बोलना, क्यों बाद में ये नहीं बोलना है सर लास्ट चैप्टर में ये समझने आया, क्यों, इसलिए मैं पहले ही इंट्रोड्यूस करके जा रहा हूं। रेगुलर लैंग्वेज क्लास, सॉरी डीएफए क्लास के लिए नहीं होता, राइट। क्लास में हर लैंग्वेज के लिए डीएफए है, राइट। आप देखो, अगर टाइप 3 लैंग्वेज को रिप्रेजेंट करना है, राइट, उसको क्या बोलते हैं हम, रेगुलर लैंग्वेज। क्या बोलते हैं हम, रेगुलर लैंग्वेज। टाइप 2 लैंग्वेज के लिए कॉन्टेक्स्ट फ्री लैंग्वेज बोलते हैं हम। टाइप 1 लैंग्वेज का नाम क्या है, कॉन्टेक्स्ट सेंसिटिव। टाइप 0 लैंग्वेज का नाम क्या है, रिकर्सिवली एन्यूमरेबल। एंड टाइप 3 लैंग्वेज के लिए क्या मशीन यूज करते हैं हम, फाइनाइट ऑटोमेटा। टाइप 2 लैंग्वेज के लिए क्या ऑटोमेटा यूज करते हैं, पीडीए। सो सिमिलरली टाइप 1 टाइप 0 लैंग्वेज के लिए लीनियर बाउंड ऑटोमेटा एंड ट्यूरिंग मशीन। तो ये जो सिलेबस में नहीं है, फिर भी आपको फॉलो अप करना पड़ेगा, डिफरेंस क्या होता है बेसिकली। ग्रामर में रेगुलर ग्रामर, कॉन्टेक्स्ट फ्री ग्रामर, कॉन्टेक्स्ट सेंसिटिव एंड अनरिस्ट्रिक्टेड ग्रामर। अब देख लेते हैं यहां पर हम क्या बोलते हैं, रेगुलर implies CFL implies CSL implies REL। इसका मतलब क्या है, is, what is the meaning, एग्जाम में पता होना चाहिए। रेगुलर is CFL, CFL is CSL, CSL is REL, but converse need not be। CFL no need to be regular, CSL no need to be CFL, REL no need to be CSL। बट आप देखो एक और क्लास है, वो क्या है, सेट ऑफ रेगुलर्स। सेट ऑफ रेगुलर्स इज इनसाइड set of CFLs inside the subset, set of CSLs inside set of RELs. ये क्लियर है? वो बॉक्स है, this is smaller box inside the another bigger box. This box is smaller than this box, right? Class diagram. This is a class relationship basically. Okay, a class relationship. ये simple language relationship. अब ऑटोमेटा रिलेशनशिप, ऑटोमेटा में कैसे रिलेट करेंगे? इस लैंग्वेज के लिए जो मशीन है ना, हर लैंग्वेज के लिए बता रहा हूं मैं, हर लैंग्वेज के लिए वो रिलेशनशिप है ना, तो इस लैंग्वेज के लिए फाइनाइट ऑटोमेटा है। ये जो फाइनाइट ऑटोमेटा यूज करके हम इतना सारे लैंग्वेज के लिए अलग अलग फाइनाइट ऑटोमेटा डिजाइन कर सकते हैं हम। इसके लिए पीडीए है, इसमें अंदर लैंग्वेजेस के लिए लीनियर बाउंड ऑटोमेटा है, इसमें ट्यूरिंग मशीन है। इसकी पावर, इस सेट की रिकॉर्डिंग, इस सेट स्मॉलर देन इस सेट, मतलब इस मशीन का पावर इससे कम है, राइट? जितने भी फाइनाइट ऑटोमेटा बना लो, पीडीए से पावर कम ही होंगे, क्यों? पीडीए रिप्रेजेंटेशन ज्यादा होंगे, मतलब इससे ज्यादा लैंग्वेज रिप्रेजेंट कर सकते हैं आप, राइट? सिमिलरली लेस देन बोलते हैं हम, इसको बोलते हैं हम एक्सप्रेसिव पावर बोलते हैं हम। इस सिंबल क्या बोलते हैं हम? एक्सप्रेसिव पावर। इसको यूज करके हम जितने लैंग्वेजेस है उससे कम ही है। पीडीए कैन रिप्रेजेंट द बिगर सेट देन द फाइनाइट ऑटोमेटा सेट। नॉट डिफरेंट मेजर, इसलिए हम रिकर्सिव बेसिक्स में नहीं पढ़ेंगे हम, राइट? यहां पर रिकर्सिव आया, डीसीएफएल्स आया नहीं है ना, चार्म्स के हायरार्की में हम हटा दिया उसको, बट बाद में इंट्रोड्यूस करेंगे। वो कहाँ आता? बीच में आपको क्या दिक्कत हुआ? इस जो छोड़ दिया ना, इसको बोलते हैं हम रिकर्सिव सेट ऑफ रिकर्सिव लैंग्वेजेस। ये बॉक्स का नाम है, इसके लिए कुछ टाइप का नाम नहीं दिया हम। एक और छोड़ दिया ना, इसको बोलते हैं हम सेट ऑफ डीसीएफएल्स। उसका हम छोड़ दिया ना, उसका नहीं लेके हम बिल्कुल, राइट? ये दो क्लासेस, ये छोटा बॉक्स भी फाइनाइट लैंग्वेजेस क्लास है, वो उसका नाम नहीं है, इसलिए हम छोड़ दिए, राइट? यू डोंट नीड टू वरी अबाउट इट राइट नाउ, सिर्फ इस लैंग्वेजेस की बात कर लेना। और ग्रामर्स के डिफरेंस क्या है? सेम ग्रामर्स की बात आता तो कैसे रिलेट करोगे? ग्रामर्स, रेगुलर ग्रामर implies context free grammar, is मतलब implies, context sensitive grammar implies unrestricted grammar। ये है रिलेशन। every regular grammar is context free, every context free is context sensitive, every context sensitive is unrestricted grammar, right? इसमें कोई डिफरेंस दिक्कत है? रिलेशनशिप क्यों डायरेक्टली एग्जाम में ये पूछा जाएगी, तो आपको रिलेशन एग्जैक्टली पता होना चाहिए। जब सेट ऑफ रेगुलर लैंग्वेज आता, सबसेट रिलेशन यूज करो। इक्वल भी यूज कर सकते, कोई दिक्कत नहीं है, क्योंकि स्ट्रिक्टली सबसेट है ना, वो सबसेट और इक्वल भी लगा सकते हैं, कोई दिक्कत नहीं है। जब रेगुलर लैंग्वेज आता है ना, इज इंप्लाइज की मीनिंग आता है यहां पर। मशीन्स एक्सप्रेसिव पावर और ग्रामर्स सेम इंप्लाइज रिलेशनशिप। बहुत इजी क्वेश्चन है, बट यही पे रिप्रेजेंटेशन क्लैरिटी होना चाहिए कि बेसिक्स है ना, और बेसिक्स क्लैरिटी नहीं है तो आगे अनडिसर्वेल्ड में हम अटक जाएंगे। आप जो भी लगाना यार, आपको कितने लोग को पता, कितने लोग को पता, अगर एक सबसेट y है, आप हमेशा एक सबसेट और इक्वल y लगा सकते हैं, इज करेक्ट, कोई दिक्कत नहीं यार, ये तो बात है। बट ये रिप्रेजेंट करना जरूरत नहीं, इसको हमेशा ऐसे रिप्रेजेंट कर सकते, कभी भी इक्वल तो नहीं होता हमको पता है, फिर भी इसको ऐसे लिख सकते। इसलिए टेक्स्ट बुक में कभी कभी सबसेट और इक्वल लिखते, कभी कभी सबसेट लिखते, कोई दिक्कत नहीं है, ये तो हमको आंसर पता है, ये तो एग्जैक्ट, बट ये लेना जरूरत नहीं है, हम हमेशा ये रिप्रेजेंट कर सकते, ये भी करेक्ट है। हम उस तरफ नहीं जा रहे हैं ना, हम इस तरफ आ रहा है। क्लियर? एक्स इज इक्वल वाई कभी नहीं होता, हमको पता है। इक्वल, अरे दुनिया यार, दुनिया में ये फिक्स्ड आंसर है, इसमें बदलते नहीं आंसर, ये बदलते नहीं। सबसेट ऑफ रेगुलर्स ऑलरेडी, ये बॉक्सेस बदलते नहीं कभी, ये तो ये फिक्स है। ये सेट ऑफ रेगुलर से, ये सेट ऑफ सीएफएल्स, ये बदलते नहीं, ये फिक्स है। आप स्ट्रिक्टली सबसेट लिखना, आप सबसेट और इक्वल लिखना आपका इच्छा है, क्यों? हमको पता है स्ट्रिक्टली सबसेट को हम सबसेट और इक्वल कभी भी लिख सकते हैं, ये तो फिक्स है, दुनिया में कभी चेंज नहीं होता है बॉक्सेस, है ना, सेट ऑफ रेगुलर्स इसी में रहेंगे, सेट ऑफ सीएफएल्स इसी में रहेंगे, ये कभी बदलते नहीं बॉक्सेस, ये हमेशा छोटा ही रहेंगे, ये हमेशा बड़ा ही रहेंगे, तो आपका इच्छा है। इक्वल तो कभी नहीं होता, इक्वल तो कभी नहीं होता, तो सबसेट लिखना, प्रॉपर सबसेट लिखना, इट्स योर चॉइस, बट हमको क्लियरली पता है ये प्रॉपर सबसेट, ये तो क्लियरली पता है एग्जैक्ट। कभी कभी चेंज होता, कंफ्यूज होता, चेंज कभी नहीं होता है ना, फिक्स्ड है आंसर। एग्जाम में ये भी इंपॉर्टेंट है यार, एग्जाम में आपको आंसर आया एक सबसेट बाई प्रॉपर सबसेट, बट वो ऑप्शन में नहीं देखा तो ये सिलेक्ट करना ही पड़ेगा आपको, क्यों वन वे है ना, क्वेश्चन से आंसर लेना, इक्वलेंट नहीं बोलेंगे वहां पर, इज डैश, तो ये रिलेशन नहीं मिला तो ये लेना ही पड़ेगा आपको। इज मतलब इंप्लाइज, याद रखना ये वर्ड्स लोग को बहुत कंफ्यूज होता, इज दिया, डैश दिया, इक्वलेंट वर्ड आया, इक्वलेंट टू डैश, ये दोनों अलग है। इज मतलब implication, the question is dash, question equivalent to what, the question equivalent to let's say is answer, इसका मीनिंग है Q implies A, मतलब A implies Q होना जरूरत नहीं, बट ये है Q equivalent होना चाहिए आंसर, मतलब यहां दो मीनिंग होता, क्वेश्चन इक्वलेंट आंसर इंप्लाइज आंसर होना चाहिए, आंसर इंप्लाइज क्वेश्चन भी होना चाहिए, तभी हम इक्वलेंट चूज करेंगे। यहां क्वेश्चन इंप्लाइज आंसर है, बट आंसर नो नीड टू बी, नो नीड इंप्लाइज क्वेश्चन, वो जरूरत नहीं पड़ता वहां पर। ये गेट एग्जाम में 65 क्वेश्चन में 30 क्वेश्चन इसी फॉर्मेट में होता, कभी कभी इक्वलेंट पूछता, कभी कभी इज पूछता, लोग को ये कन्वर्जन भी समझने आता, यार क्वेश्चन से आंसर निकालना है, आंसर से क्वेश्चन निकालना है, तो ये क्वेश्चन में ही क्लैरिटी होता, राइट। तो ये वर्ड्स याद रखना, इज इक्वलेंट टू, ये दोनों अलग वर्ड है बिल्कुल। इज इक्वलेंट, तो इक्वलेंट को इज लिख सकते, बट इज को इक्वलेंट कभी कभी होता, कभी कभी नहीं होता, क्लियर। Oh, great. Yes, good evening. Welcome to the class. राइट, ये गेट एग्जाम की बात कर रहा हूं मैं, टीओसी का बात नहीं कर रहा हूं। तो ये वर्ड समझना, इज इक्वलेंट, दे आर टेक्निकली साउंड, यू शुड नो हाउ द मीनिंग इज एम्प्लॉयड। राइट, चलो एक बार रिपीट कर लेते लैंग्वेज का डेफिनेशन, इसमें कोई दिक्कत है? लैंग्वेज, या मैं भी पीछे देख रहा हूं वीडियो को, 1 घंटा हो गया ना, थोड़ा पानी पी लेते। कोई डाउट है तो बताना, आगे चलते, नेक्स्ट चैप्टर स्टार्ट कर लेते। ये देख लेते, टाइप्स ऑफ लैंग्वेजेस कितने पढ़ने वाले हैं हम। टाइप्स ऑफ लैंग्वेजेस, ये तो सबको पता है ना, फाइनाइट लैंग्वेज, इनफाइनाइट लैंग्वेज, वो डेफिनेशन अभी जरूरत नहीं है, बट टाइप्स फाइनाइट, इनफाइनाइट, रेगुलर, डीसीएफएल, सीएफएल, सीएसएल, रिकर्सिव, आरएल, बट और कितने होंगे यार, ये तो मैं कम लिख के आया, किसी को पता है? गुड इवनिंग राजा, अब लिख देना, आपको जितने लैंग्वेजेस पता है टीओसी में फटाफट लिख देना, कितना, ये छोड़ के, ये छोड़ के बहुत सारे क्लासेस है, उसमें से एक लैंग्वेज उठाना। यू हैव बहुत लैंग्वेजेस है, नाम बता रहा हूं, नाम, नॉट आरियल, परफेक्ट, ऑल राइट, नॉट आरियल, और है यार, और बहुत है, और बहुत है, मैं तो कितने लिखे देख लेते, 1 2 3 4 5, बहुत सारे लैंग्वेजेस है, और भी है लैंग्वेजेस, देखते हैं। यस, नॉट रिकर्सिव भी है, 11 नॉट फाइनाइट तो हो गया, नॉट रेगुलर भी है, मीनिंग अलग है बिल्कुल। नॉट DCFL भी है, नॉट CFL भी है, नॉट CSL भी है, नॉट रिकर्सिव तो लिख दिया, नॉट REL तो लिख दिया, और बहुत है, और बहुत है यार। चार्म्स के आर्क में इतने हैं, बहुत अच्छा लिखा शिवा। CSL नॉट CFL, देखो CSL है बट वो नॉट CFL है, बिल्कुल सही है यार। आप ऐसे भी लिख सकते, कुछ और लैंग्वेज है CSL है बट वो नॉट रेगुलर है, वो CSL है वो नॉट CFL है, वो रेगुलर है बट फाइनेट नहीं है, वो DCFL है बट नॉट रेगुलर है, वो DCFL है बट फाइनेट नहीं है। फाइनेट नहीं है मतलब इनफाइनाइट है। मतलब ऐसे कितने लैंग्वेजेस है यार, चार्म्स की हायरार्की मतलब हंड्रेड्स ऑफ लैंग्वेजेस आप डिफाइन कर सकते हैं। इज दैट क्लियर गाइस? मतलब इस लैंग्वेज में इतना इतना टाइप्स ऑफ आंसर्स है, एग्जैक्टली आपको पता होना चाहिए क्या लैंग्वेज बात कर रहा है आप, राइट? या काउंटेबल भी है, ठीक है। तो हम सोचते हैं चार्म्स के हायरार्की मतलब 4 क्लासेस, ये 4 क्लासेस इसलिए देखते हैं हम क्यों पूरा हम जो जितने भी दुनिया है इस 4 लैंग्वेज में फिट करेंगे, बट फाइनली हमको अनडिसरेबिलिटी चैप्टर है, डिसरेबल अनडिसरेबल, वहीं पर पता क्लियरली पता होना चाहिए हम क्या बात कर रहे हैं। बट इतने सारे लैंग्वेज है, मैं बता रहा हूँ 100 लैंग्वेज होंगे ऐसे लिखेंगे तो हम, राइट? काउंटेबल अनकाउंटेबल यहां बात नहीं करेंगे, सिर्फ चार्म्स के हायरार्की में यस काउंटेबल अनकाउंटेबल भी है, क्यों नहीं है, वो भी है, राइट? बट वो रिलेटेड विथ अदर कॉन्सेप्ट्स, राइट? थोड़ा लिख लेते 21 क्या होगा, DCFL तक आया ना, CFL बट नॉट DCFL, 22 CFL बट नॉट रेगुलर, ये सारे अलग अलग है मीनिंग, यू हैव अ डिफरेंट मीनिंग फॉर डिफरेंट लैंग्वेज, राइट? बट नॉट फाइनेट, 24 CSL तो लिख दिया ना, रिकर्सिव बट नॉट फाइनेट, वैसे 25 रिकर्सिव आप लिख लेना, बहुत सारे लिख सकते हैं। एक और काउंटेबल सेट भी है, बट या वो चार्म्स के हायरार्की बाहर है, वो बिगर क्लास है, अंदर भी है, काउंटेबल लैंग्वेज है। चार्म्स के हायरार्की में जितने भी है ना उसकी सुपर सेट है, वो बाहर नहीं बोलेंगे, सुपर सेट बोलेंगे, उस क्लास के अंदर ये काउंटेबल लैंग्वेज दिखेगा। और क्या अनकाउंटेबल लैंग्वेज है, अनकाउंटेबल सेट है, मैथमेटिकल रिलेटेड डेफिनेशन है यहाँ पर, ठीक है। हाँ वो तो निश्चय फाइनाइट होंगे यार कि दुनिया में वर्ड्स भी फाइनाइट है यार, जो वर्ड्स हम मीनिंगफुल वर्ड्स होता है ना वो भी काउंटेबल, ये CFL DCFL नाम्स भी फाइनाइट है, हम तक आज तक इन्वेंट किया वो फाइनाइट नंबर ऑफ टाइप्स ऑफ प्रॉब्लम्स है। डिफरेंट टाइप्स फाइनाइट ही बनेगा यार, इनफाइनाइट कहाँ, कितने लिखोगे, एक दिन लिख सकते होगा पूरा वर्ल्ड में कितने भी मीनिंग्स है इस क्लास के अंदर, ठीक है। चलो आगे चलते हैं, ये है टाइप्स ऑफ ऑटोमेटा जो TOC में हम रिवाइज करेंगे ना। फर्स्ट फाइनाइट ऑटोमेटा रिवाइज करेंगे, इसके अंदर DFA NFA पहले टारगेट है, उसके बाद मोर एंड मिली मोशन, राइट? उसके बाद पुश डाउन ऑटोमेटा है, DPDA एंड NPDA, ये आउटसाइड ऑफ द गेट सिलेबस बट इसको भी पढ़ना पड़ेगा, हाल्टिंग ट्यूरिंग मोशन एंड ट्यूरिंग मोशन। अब देखो ये जो DFA NFA दोनों इक्वलेंट है, मोर मोशन एंड मिली मोशन दोनों इक्वलेंट है, और DPDA NPDA नॉट इक्वलेंट बट रिलेशन है लेस देन, मतलब DPDA लेस पावरफुल देन NPDA आर डेफिनेटली नॉट इक्वलेंट, और LBA एंड NLBA रिलेशन मालूम नहीं है, ओके? प्रूव नहीं किया अब तक इक्वलेंट है नॉट इक्वलेंट है, बट लोग मानते हैं यार डिटरमिनिस्टिक इज लेस पावरफुल देन नॉन डिटरमिनिस्टिक, बट प्रूव नहीं किया कोई। DTM NTM दोनों इक्वलेंट है, ठीक है। ये एग्जाम में बहुत बार आया ये क्वेश्चन, मतलब ये क्वेश्चन इंपॉर्टेंट है, विच ऑफ द फॉलोइंग इज फॉल्स, वहां लिखते हैं DPDA is equivalent to NPDA or every NPDA is convertible to DPDA. There exists an algorithm that converts PDA to DPDA. वो गलत स्टेटमेंट्स है, ठीक है? निश्चय ऐसा नहीं कह सकते यार ना. Countable, uncountable is the last chapter. Finite is a countable but infinite may or may not be countable. उसके लिए आपको मैथमेटिकल बाइजेक्टिव फंक्शन डेफिनेशन मालूम होना चाहिए. अरे वो माइक क्लोजर है यार. हेलो हेलो, आई कैन सी दैट यार. इज दैट वॉइस क्लियर टू एवरीवन? प्रभाकर, ये आपके लिए है सबके लिए? वेरी सॉरी यार इफ वॉइस इज नॉट ऑडिबल. वॉइस इज क्लियर ना फॉर एवरीवन? अरे सबको क्लियर है तो प्रभाकर आपको क्यों क्लियर नहीं है? तो चेक कर लो, ऑडियो डिवाइस चेंज कर लो, नहीं है तो आप रीलोड कर दो, रिफ्रेश कर दो, जो करना कर लो. ठीक है, अब तक हम फाइनल बेटा पीडीए कर रहा हूँ. डीपीडीए बीच में आएगा पावर और अल्टरनेटिव ट्यूरिंग मशीन है, ये दोनों का बीच में रहेगा. जो क्लास डायग्राम में देखा ना, जो सेट ऑफ रिकर्सिव लैंग्वेजेस में हर लैंग्वेज के लिए एचटीएम है, वो सेट ऑफ डीसीएफएल्स में हर डीसीएफएल के लिए डीपीडीए है, राइट? ओके यार, लेस पावर मतलब इट रिप्रेजेंट्स लेस नंबर ऑफ लैंग्वेजेस, मोर पावर मतलब रिप्रेजेंट्स मोर लैंग्वेजेस. बट लेस मतलब इन्फिनिट है, मोर भी इन्फिनिट है, बट ये भी रिप्रेजेंट करेगा इन्फिनिट लैंग्वेजेस के लिए. ओके तो हम आगे चलते हैं. यहाँ कोई नहीं, कुछ ऐसे डिफरेंसेस है, ये आप तो क्लैरिटी नहीं मिलेगा जब तक हम स्टार्ट करें. तो बेसिक्स में ये बताना, डू यू हैव एनी प्रॉब्लम इन बेसिक्स? किसी को कुछ भी एक वर्ड भी प्रॉब्लम है बताना यार, क्लैरिटी करके जाएंगे हम. यहाँ फाइनाइट ऑटोमेटा के बाद रेगुलर एक्सप्रेशन स्टार्ट करेंगे आज. नॉर्मल मेरा क्लासेस में रेगुलर एक्सप्रेशन पहले होता, बट आज ऐसे ही फाइनाइट ऑटोमेटा पहले कर रहा हूँ. लास्ट टाइम सिवा को चाहिए लैंग्वेज, कोई डिफरेंस नहीं यार. पहले मैथमेटिकल सेट है, सेट ऑफ सेट्स है, डिफरेंस है नहीं. इन जनरल सेट किसी के लिए भी यूज कर सकते हैं, बट हम सिंपल लैंग्वेज मतलब कलेक्शन ऑफ स्ट्रिंग्स. यहां पर ये सेट इज डिफरेंट. सेट मतलब ये भी सेट है. देखो सेट ऑफ सेट्स आप समझ लो. पहले सेट ऑफ सिंबल्स, सारे सेट्स है यार, कोई दिक्कत नहीं है. सेट ऑफ स्ट्रिंग्स, सेट ऑफ सेट्स, किस टाइप की सेट है पहले ये समझ लो. मैथमेटिक्स समझ लो, फॉरगेट अबाउट दिस लैंग्वेज वर्ड. सारे तो लैंग्वेजेस है, हम इसी को मेनली मानते हैं लैंग्वेज की डेफिनेशन, राइट? इसी को हम कहते हैं लैंग्वेज. जनरली डेफिनेशन लैंग्वेज ओवर द सिग्मा, लैंग्वेज ओवर सिग्मा हम ये मानते हैं. इसको मानते हैं हम अल्फाबेट मानते हैं टीओसी में. ये है स्पेशल लैंग्वेज, सेट ऑफ सेट्स. ये अब नहीं पढ़ेंगे हम, लास्ट चैप्टर में पढ़ेंगे सेट ऑफ सेट्स. अब इसके लिए हम कुछ नहीं करेंगे, सेट ऑफ सेट्स के लिए हम कुछ नहीं करेंगे. सिर्फ ट्यूरिंग मशीन कर सकता, हम किसी से नहीं लड़ेंगे, राइट? डीएफए से, पीडीए से ये प्रॉब्लम डिजाइन नहीं करेंगे हम. ट्यूरिंग मशीन को समझ में आता सेट ऑफ सेट्स क्या होता, राइट? पहले दिन जाके यार पहले वन प्रोग्राम ही नहीं आता, सेट ऑफ प्रोग्राम्स कहाँ से बनाओगे, प्रोजेक्ट कैसे बनाओगे? ये सेट ऑफ सेट्स दिखेगा प्रोजेक्ट, ये दिखेगा वन प्रोग्राम, ये दिखेगा वो सिंबल से. यार प्रोग्राम लिखने से पहले सिंबल्स पढ़ के आ जाओ, उसके बाद ही आप प्रोग्राम लिखो ना. ये वन प्रोग्राम जैसे है. सेट ऑफ स्ट्रिंग्स मतलब सेट ऑफ स्टेटमेंट जैसे है. ये सेट ऑफ सेट्स मतलब सेट ऑफ प्रोग्राम्स जैसे है. इज इट क्लियर? सूर्या स्टार्ट नहीं हुआ यार. हाउ टू कंस्ट्रक्ट रेगुलर एक्सप्रेशन फॉर अ डीएफए? दब होगा कर लो ना, बत पूछो यार डाउट. एक एक प्रोजेक्ट है यार, एक एक करके आ रहा है. ये प्रोजेक्ट जैसे दिख रहा है, राइट? एक सिंगल प्रोग्राम जैसे दिख रहा है. प्रोग्राम लिखने से पहले बेसिक्स है, पढ़ के आओ बेसिक्स. ठीक है। अब क्लियर है? इसको कहते हैं बेसिकली, हम ये कहते हैं, इसको कहते हैं सेट ऑफ लैंग्वेजेस। बट बाहर से देखे यार, सारे तो लैंग्वेजेस है, ये स्पेशल लैंग्वेज है। ये जो लैंग्वेज हम लड़ेंगे यार 5-6 घंटे तक लैंग्वेज समझने के लिए। उसके बाद अनडिसेबिलिटी डिसेबिलिटी में ये सेट ऑफ सेट्स के लिए भी लड़ेंगे। सेट ऑफ सेट्स नहीं, देखो इस टीओसी में क्या क्या पढ़ेंगे यार, मुझे तो मालूम नहीं यार। सेट ऑफ सिंबल्स तो दुनिया को पता है यार, अल्फाबेट है। सेट ऑफ स्ट्रिंग्स, इसको क्या कहते हैं? सिग्मा। इसको क्या कहते हैं? सिग्मा स्टार। ऑफ कोर्स कोई भी आपको ये तो ऑल के लिए कह रहा हूं, अगर सम लिखना है वो सबसेट बनेगा, राइट। सेट ऑफ सेट्स, ऑल सेट्स, तो इसको लिखेंगे हम 2 पावर सिग्मा स्टार। और सेट ऑफ होता बाद में ग्रामर्स, वो अलग है, उसके लिए कुछ और नहीं लिखेंगे हम। सेट ऑफ डीएफएस हो सकता, सेट ऑफ ट्यूरिंग मशीन्स हो सकता, सेट ऑफ क्या कुछ भी हो सकता। एक पेयर होगा और पेयर में एक डीएफए होगा, दूसरा कुछ ट्यूरिंग मशीन भी हो सकता, कुछ भी। सेट के लिए कोई डेफिनेशन नहीं है, इंडियनली कलेक्शन ऑफ द मेंबर्स। बट हम पढ़ेंगे कलेक्शन ऑफ द स्ट्रिंग्स। उसको समझने के बाद, ये समझने के बाद हम यहीं पर है, इस सिग्मा स्टार में जितने भी लैंग्वेजेस है उसके लिए कोशिश करेंगे, उसके बाद ये बाद में अप्लाई करेंगे। नो क्लियर? या सौरभ कोशिश करेंगे। और कोई डाउट है? हम जो भी कर रहे हैं सेट ऑफ ऑल स्ट्रिंग्स के लिए, अब ऑल भी नहीं, सम स्ट्रिंग्स के लिए करेंगे अभी। ऑल मतलब सिग्मा स्टार बहुत इजी मशीन बनेगा बाद में। स्टार्ट हो गया यार। स्टार्ट होने के बाद पूछो नंबर ऑफ स्टेट्स क्या होता। पहले फाइनाइट ऑटोमेटा क्या है? जल्दी आंसर देके बताओ, आपको ऑलरेडी पता है तो वो भी बताओ चलेगा। व्हाट इज द फाइनाइट ऑटोमेटा? शुभजीत स्टार्ट करे। प्रोग्राम नहीं लिखा इनको, सर नंबर ऑफ फंक्शंस मिनिमम कैसे लिखना है? पहले प्रॉब्लम ले लो, प्रॉब्लम के लिए पूछो यार। शुभजीत नेवर आस्क एनीबॉडी हाउ मेनी स्टेट्स, कैसे कंप्यूट करना है, पहले प्रॉब्लम ले लो, उस प्रॉब्लम के लिए कोशिश करो, एफर्ट उसके ऊपर डालो। प्रॉब्लम टू प्रॉब्लम आपका आप कॉन्सेप्ट अलग होता और अप्लाइंग इंटरप्रिटेशन अलग होता। ओके सत्या, ऑलराइट ऑलराइट। यस, व्हाट इज फाइनाइट ऑटोमेटा? ये तो बाद में करेंगे यार। व्हाट इज फाइनाइट ऑटोमेटा? व्हाट इज फाइनाइट ऑटोमेटा? इट इज गोइंग टू रिप्रेजेंट, क्या लैंग्वेज है? It represents a regular language. Do you know this point? That's why we say finite automata is equivalent to regular language. Finite automata regular language nahi hai. It is not a regular language. Remember that. Finite automata is not a regular language. It represents a regular language. Okay? श्योर सत्यम। अब टाइम क्या हुआ? 8:40 राइट? ओके, आफ्टर द बेसिक्स राइट, बिफोर कंस्ट्रक्शन ऑफ द फाइनाइट ऑटोमेटा, we'll take the break. Is that clear everyone? After basics, before starting the construction of the FA, we'll take a break. Wait for the time. Sigma star को हम दिखाएंगे ना, you will know it. Why are you worried sigma star is regular now? Anybody knows what is the regular? No, right? How do we know language is regular? Anybody? Let me write the question. यार इनको समझ में आना चाहिए. You should know what I am asking, right? How do we know L is regular? How many of you know this point? How do you know L is regular or not? To understand this point, is it regular or not, to understand this point, first study, first learn DFA, NFA, regular expression, regular grammar, and equivalence classes. Then you will get to know what do you mean by a regular. Why? When you have the language is regular, definitely all exist. What exist? FA exist, regular expression exist, definitely. If you don't know them, then how will you know that it is exist or not? Regular grammar exist. If it is a regular, finite number of equivalence classes exist. How do you know these points without studying the chapter? यार चैप्टर स्टार्ट नहीं हुआ, इनको रेगुलर है नॉन रेगुलर समझ में आना चाहिए. कैसे आएगा? सीख लिया क्या? पढ़ के आया क्या? तो बताना आंसर. If you have a DFA, or if you have expression, if you have a grammar, if you know that number of equivalence classes are finite, then you can believe the language is regular, right? Pumping lemma से नहीं होता. Everyone, pumping lemma cannot help you. Pumping lemma cannot help you to answer regular or not. Pumping lemma useless. Pumping lemma will not help you. Is useless. That is only to prove. If you already know it is regular, you can prove with the pumping lemma. If you already know it is non-regular, then you can prove with the pumping lemma. If you don't know L is regular or not, pumping lemma cannot be used. Everybody, very, very important point. If I already know you are the ranker, then I will prove you are the ranker. Then pumping lemma will help you. If I already know you are not the ranker, then I will use a pumping lemma to prove you are not a ranker. That means known thing will be proved as a known one with the systematic proof. Everybody, so don't use pumping lemma to prove L is regular or not. Only what pumping lemma uses, that we will learn later, right? That's why I did not write here pumping lemma, okay? When you don't know what language it is, you should know these things. For that, I told you, right, at least we will design 50 finite meta, at least we will write 50 regular expression, at least we will write 50 regular grammars. Oh, then you will get to know what is a regular language. You will be confident what is it. Okay. What is finite automata? Oh, it represents a regular set. Any other point that you know? Anybody else? It represents a regular set. It is equivalent to what? Regular set. Matlab every regular language you can design a finite automata. Every finite automata represents a regular language only. So in general, what we say, language represented by finite automata is regular. You can also write somehow different way. This is a different point. Finite automata is equivalent to regular set, because every finite automata is representing regular set, and every regular set you can design a finite automata, every regular set. So in general you can write this way, in general. If DFA exists for a language, then you can always write regular expression. Satyam, whoa, cannot be used. Pumping lemma cannot be used to prove given language is regular or not. No, cannot be used. That's what I'm saying, right? Everybody got the point? Yeah, ask me in pumping lemma, right? Do you want to learn pumping lemma or not? Because you are discussing right now only. Anybody is interrupting the concept, or I'm discussing fundamental, you are talking about pumping lemma, something else, please do not interrupt. I may discuss because you want to know the answer, right? I'll skip the topic. Straight away I'm saying I'll skip the topic then. Okay. So I hope you got the answer right. Pumping lemma आएगा वहाँ पूछना doubts वहाँ clear करना. So first finite automata. Focus on the finite automata. What are the doubts you have? How do you want to learn the finite automata? You decide right now. Okay, you can ask as many questions, thousands of questions you ask. I have the patience to answer today. Okay, believe me or not, you ask me any question, I'll answer with the patience. But of course, sometimes when you ask easy, silly questions, I will leave to you. Finite automata can be designed two ways. Acceptor and transducer. Mainly we'll focus right now at acceptor. Acceptor in the sense it is a recognizer. It will try to recognize your input string, right? Because every finite automata is used to represent a language. If you design a machine to represent a language, you can give one string at a time. So if it is able to say valid string, then that is present in the language. If it is not valid string, it will say it is not belongs to a language. So acceptors are going to inform you either by halting at final or halting at non-final, right? We'll discuss that point later. Transducer is, this is what acceptor. You give an input, it will understand what is that input. Is it belongs to L or not belongs to L? Is W belongs to L or not? It will understand. Because this finite automata designed to accept the L. So it represents L. If you give any input, it will tell you whether W is there in the L or not. If W belongs to L, it will be called as a valid string. If W not in L, it is called as invalid string. Everybody knows valid and invalid, right? I don't need to discuss now. Valid and invalid, everybody knows, right? There is some machine, don't worry what machine it is, okay? So every automata is a machine basically. If this machine is accepting some regular language L, accept some L, that L is called as a regular basically. So this machine, if it is recognizer, then it will try to recognize the W, whether that is belongs to L or not. If it is belongs to L, called as a valid string. If it is not belongs to L, called as invalid string. This is called as invalid W, means invalid string. This is called as a valid W, means valid string. If the string is valid, this finite automata halts at final. But how it halts at final? Using one path or more paths, the type of the machine will decide. Okay, this will halt at non-final. How it halts at non-final? With no path or with more paths, the type of the machine will decide. Again, this finite automata, two types. How many types? Deterministic finite automata and non-deterministic finite automata. And again, this machine is two types. Without epsilon, with epsilon transitions. So with epsilon moves. But you know that, right? These all machines are equivalent. DFA, NFA equivalent, and these two machines are also equivalent. You can convert any machine to anybody here. So in this chapter, we are going to learn first mainly focus on these three, and mainly we'll first focus on DFA, then NFA, two types. Exactly. Mathematically, it is denoted by set of 5 tuples, right? Correct. Perfectly right. Okay. Let's start. This is the mathematical notation of the finite automata. Every finite automata is represented with the 5 parameters, and these 5 parameters are there for every machine, every automata almost, like who are accepting to the finals, Q, sigma, delta, Q naught. These are all like a finite automata, PDA, Turing machine, everybody will have these 4 parameters. But sometimes like a PDA can accept the string without final states also. So there you will be having a different criteria. So anyhow, assume that these 5 parameters will help you for every machine. Like for PDA, for Turing machine, these definitions are there. So you should know what is Q. Q nothing but number of Q nothing but set of states. Sigma matlab alphabet input symbols you have. Delta that we are going to learn, what is delta? And Q naught is initial state, and F is not a final state. Remember, F is set of final states. One final state is different, set of final state. This is what we missed. We do the mistake. Even I did the same mistake even in PhD. In PhD, I just written as F is a final state. He cut 2 marks straight away. Do you know the difference between final state and set of final states? Both are different sentences. Okay. Okay, some of the points you are writing, right? By looking at this 3, right, you can have a meaning here. What meaning? All DFAs, you can call them as, these are all DFAs. You can call them as all NFAs without epsilon moves. You can call them, no doubt. But there are some NFAs, they are not DFAs here. And there is another one, that NFA, all NFAs with epsilon transitions, with epsilon moves. Of course, this diagram you will never find anywhere. Okay. Fine. Only for 3 years I did, because I left later on at ISC Bangalore. Okay, now what is the meaning of this? How many of you know the meaning of this? Every DFA is what? I'm writing the point here. Every DFA is what? NFA. Which NFA it is? Are you talking about NFA without epsilon moves, NFA with epsilon moves? You decide. Both are correct only. DFA, you can call it as NFA without epsilon moves, you can call NFA with epsilon moves. You decide it. But NFA need not be DFA, because this NFAs, these are both are NFAs only, right? They are not DFAs. Okay. So, but NFA need not be DFA. NFA need not be DFA. Fine. Here we have a fun fact. What is that? Even though these classes are there, right, these are not having a relation with the Chomsky hierarchy at all. Chomsky hierarchy completely different. These classes are completely different. Even though these 3 are having different classes, of course you see that there are more NFAs you can design compared to DFAs, right? Because we can convert one to other. Yeah, can't you understand how equivalent? I should tell that 2 plus 3. Okay, let me say 5, and I'll write just a program, right? Void main. I'll just write printf for 5. Are they same or are they equivalent? This is a program, this is a number. These 2 are equivalent. That means I can convert this to this, this to this. They're not same, yaar, but they are equivalent. Are you able to understand? DFA, NFA, they need not be same. Sometimes they may be same, that's okay. But here you understand equivalent meaning is, right? Here DFA, NFA means every DFA is NFA, but NFA need not be DFA. That's a different relationship completely. Okay? Equivalent, understand, you can convert one to other, that is the meaning. They have conversion algorithms. If you give me any machine here, I can convert, I can put here. Because same language I can represent with the DFA, I have an algorithm to convert this machine into this machine. These 2 machines might be equivalent. They might be represent, yeah, you want to represent the language. See that. This is NFA, and this is, let's say, over A comma B, DFA. I can convert this machine to this machine here, and this machine I can convert. This is already called as NFA. Already called as NFA. Then what is the use? This is already called as NFA, and this NFA I can convert to this DFA. That means I have an algorithm to convert NFA to DFA, DFA to NFA. Then I can say every NFA is equivalent to DFA. Understand why we use this word. This DFA we will keep here, and another NFA will keep here. You can see that NFA is here and other DFA is here. You can see that, right? But that machine you can't keep here. Even though both are representing the same language, you can't keep in the same place, because that is NFA. Even of course that is NFA without epsilon moves, right? I can keep here, and maybe let's do something like I can keep that machine there. See, this is NFA with epsilon moves. This is NFA without epsilon moves. This is a DFA. All the 3 representing the same language. This is a DFA already called as NFA, and this is NFA but not called as a DFA. This is another NFA with epsilon moves, and it is not called as without epsilon moves. It is not called as a DFA. But all the 3 are actually equivalent, even though they are not same, because they are representing the same language. You can convert one to other. Okay? It is already there in this bigger circle. That means it is already called an NFA. Only these two you need to know how to convert into DFA. Fine. But when you look at them, that's what I'm saying. So you should know all DFAs. I'm saying that this is a big set actually. Set of all DFAs here, and set of, let's say, all NFAs. Forget about with epsilon, without epsilon moves, okay? Look at what's going to be relation. This is, okay, let's try different way, not this way, like this way. This is set of all regulars. Now if you look at these motions are also representing the same. Even not only this, even this one is also representing the same. Even though that is a bigger one, there is no difference between this machines and that machines. All must represent this class only. Either you take the DFAs to represent these languages, or you take NFAs to represent the same. Only what you have, the same language, you have different machines and more machines. But here, here you will be having few machines, you will be having more machines, that's it. But even though these two are different classes, but they're actually representing the same class of the languages. Okay, look at that, very important relation for you. Whether you take DFA, NFA, I don't care. That is going to represent the language only. This language, let's say this language is Pi. I have infinite DFAs here, I have infinite NFAs here. Okay, getting the point? Here I have, let's say, A star, here I have B star, here I have epsilon. These are all regular languages. For every regular language, you have infinite DFAs, infinite NFAs. You decide what you want to design. But this class or this class will represent only one class. It is the regular class. Okay? Everybody clear? Yeah, good, Varmaji. I'm already taking the questions, right? I will definitely take the questions in each topic, and at the end, did I leave any time the questions? You no need to ask, sir, you clear my doubts. You come up with the questions. I was always there all the time, right? Even I'm there today also for you. I hope you got the point. DFAs, NFAs relation. We'll take the break here. We'll take the break here. After the break, so we'll meet, it's now 9, right? So 9 p.m. to 9, how much time you want a break? You have to cook, Satyam. Cook parallel then. Okay, 15 minutes. Let's take 15 minutes. Average of all the times. Okay. So then see, 20 minutes or 15 minutes. I'll come back by 15 minutes. I'll take up some doubts. Then we'll start. Yeah. Okay. Bye. I'll be back. Okay. So everybody able to see the audio and video, right? Everybody able to see the video and audio video clear to everyone? मैं आ गया ना, तो कुछ लोग पूछ रहे हैं कब आएगा सर. Okay, perfect. So epsilon belongs to L. So what must be the final in DFA? Right. So this kind of concept we need to design, like initial state is a final. It means that epsilon definitely there belongs to L. Okay. So that in that language definitely you will see epsilon as one of the string. Remaining they are not depends on the remaining transition sign states. Right. Is that statement clear to everyone? Anytime you see the initial state is a final, the first focus should be on epsilon. Why epsilon is there in the language? Is that language demanding? Then only you keep initial as a final. Otherwise, don't keep it. Okay. Anyhow, representations, I'm not going for it. I hope you are clear, right? How do you represent finite automata? Anyhow, next dead state. See, many people design the dead state like this, right? It is a non-final on every transition. Let's say sigma is equal 0, 1. Then you always keep something like this, right? Self loop on 0, self loop on 1. There you ask, right? I'm saying again, when you have the doubts, keep the doubts with you. When the topic comes, put one by one in the chart. Okay, but give me time to clear it. Everybody clear? Don't interrupt the class. If you have the doubt in closure properties, wait till there and ask me the doubts. Right? And now many people do not aware that this, when you have two non-finals, let's say on 0, 1 you are going there, on 0, 1 you are coming back. And let's say from these two states you will never go to any final, because you might come here but you will never go to any other, right? So these two states are also actually dead states. Dead state no need to be like self loop 0, 1. It could be like this also. These two are also called as dead state, because on 0, 1 it goes to another non-final, and this non-final also comes here, and these two will never have a path to any final. So these two are also actually called as dead. This is also dead state. This is also dead state. And of course you may also design a dead state like this. But if you want to design the best DFA, always you take this approach. But if you don't want a minimum DFA, you can also design a dead state like this. Is that clear? You can design dead state many ways, but we will always design a minimum DFA. That's why we approach this kind of structure. If you really want a dead state, you always approach this structure. What is the meaning of dead state? It is a non-final. Whenever you don't want to accept anything from now onwards, then come here and stay here. Like example, my problem is starting with A. I want to accept all the string starts with A. Or let's say starts with 0 here, 0 and 1, right? Starts with 0, strings are there in my language. Then your language never contains starts with 1. Whenever any string starts with 1, come here and stay there only, because you don't want to accept. Trap state, you can also call dead state is a trap state. Yes, you are trapping, right? You want to stay there always. Any other names you have? You can say reject, but a reject state is special reject state. It is called a special non-final state. Okay. These are only theoretical points. It's not the DFA. Okay, it's the theoretical points. Another concept is, when all the states are final, if it is suppose DFA, what is the language accepted by this DFA? What is the language accepted by that DFA? It could be possible direct gate question. I have 100 final states, and every state is the final, and that machine is the DFA. Then what is the language accepted by that DFA? What is it? Universal, complete language. It's a universal set, total language. Okay, you can call universal language, total language, complete language. Okay, no string left, right? Every string is accepted. So this is a special machine. Of course, I have given only 3 states. In the exam, they might ask theoretically. You have the 100 states, and all the states are final in DFA. Then what is the language accepted by that DFA is sigma star. right? What is the sigma star definition? Set of all strings, you know, right? Set of all strings. It is also called as universal language because every string is there. Another one, if suppose it is a DFA and every state is a non-final, then what is the meaning of this? I have 100 states in a DFA, all the states are non-final. What is the language accepted by that DFA? Come on, quick. Empty language. So these 4 points you remember: when all the states are final, sigma star; when all the states are non-final, empty language; when epsilon you want to accept, keep initial as a final; when something you don't want to accept, from there onwards we need dead state. We'll see that examples also. Okay, are we ready now? In the exam pattern you will be seeing number of states in minimum DFA. We are going to see many languages, but for that, first you should know what exactly representation is. Everybody clear about the representation? Let's say sigma is A comma B. First, is this DFA? First question. Is it DFA? Is this motion DFA? Let me ask the questions one by one. First question, is it DFA? If anybody says no, right, give me a reason. Why are you saying no? Okay, let's say 1, 2, 3 and state number 4. Why it is not a DFA? First answer, it is a DFA. That means you don't know what is the definition of DFA. You are saying something else which is not at all, having a meaning what you are saying. Why it is not DFA? It is a DFA. What is the definition of DFA? How many of you know definition of DFA? DFA definition is every transition you should have satisfied this definition. From every state, for every input symbol, you should go to exactly one state. It will not look at how many final states, it will not look at how many non-finals, it will not look at is there every state reachable. It will only look at if you have a state, let's say you have sigma is equal to A comma B, then you should have on A one transition only, you should not have more. On B only one, that's it. This definition should satisfy. For every state this definition should satisfy. On A exactly one, on B exactly one. That might be self loop or that might go to other state, doesn't matter. Okay, this is only the definition. How many finals, how many non-finals, no worries at all. No, don't look at ever how many finals, don't look at ever how many non-finals. Only look at you should have one initial state and this definition should satisfy in the machine. Is that clear? Set of finals means 0 finals also correct. How many of you know set could be empty, right? Never look at number of finals, number of non-finals. Never look at. Already I have given you definition, right? All are non-finals, the language is empty. All are finals, the language is sigma star. What is the problem with the finals and non-finals? 0 to any number of finals. No final is a fine. Only one final is a fine. Both can be final, or 3 can be final, all can be final. Anything is fine. Okay, so this is a DFA, no doubt. This is a DFA. But the problem is this complete DFA? There is a definition called as complete DFA. Is that every state reachable from initial state? In this, every state, is it reachable from initial state? Oh, this 4 is not reachable from initial, so this is not a complete DFA. It is not a complete DFA. Why it is not complete? Because some states are not reachable from initial. Who is the complete DFA? Complete DFA means every state must be reachable from initial state. Every state is reachable from initial. That motion is called as complete motion. Okay. Okay, third question. Is this minimum DFA? Is this minimum DFA? Of course, you can make a complete DFA by deleting this. You can make it, that's not an issue. Oh, I'm very sorry. Nobody I recognized. Thank you so much. I thought it was there. So just put a self loop. I did miss it. Yeah, thank you. Who was that? Sugandh Kumar, you're right. I was not observing at all, third has a transition or not. Okay, you're correct. My intention was to make a DFA just to give the difference between complete and DFA. Yes, you're correct. It was not DFA if you don't have that. And actually everybody should say it is not a DFA, but only some are correct, looks like. Okay, good, Anjali. Some people said no, that was actually right answer. It was not DFA because this transition was missing. It was my mistake. While creating, I missed it. Okay. Yeah. Those people who said no, that time they were correct. Okay. They also did not observe that third is not having the transitions. Were actually answering like me. Yes, good point. Good point. Very sorry that I did not see it properly or I did not construct it properly. Okay, good. Good identification. Is it minimum DFA? Is this minimum DFA? This is not minimum DFA. This is not minimum DFA. So how do you know it is not a minimum DFA? Is there any other DFA who can accept the same language with less number of states? आपके पास कोई और DFA है वो इस सेम लैंग्वेज को रिप्रेजेंट करेगा और इससे कम स्टेट से, ऐसा कोई DFA है क्या? See this. Are these two machines are accepting same language? Are these two machines are accepting same language? So this is called as a minimum DFA, but that is, even though DFA, it is not a minimum. Right? When you design, you must be careful about it should be DFA. That means that like that I missed a transition. That means I was not creating a DFA. First I should create a DFA, then try to make it complete and then try to make it minimum. Is that clear? All the things you should observe when you design a single machine. What is Anjali, at least 2 length but not accept in this machine? Nothing, right? No final state means what is the language? Yeah, empty. Shivam, that is what the language, right? Language is empty. It is also a language, right? You have written a program that's producing nothing. It is also a program, right? It is also a program. But you write recursive program. It is also a program that might not stop or that might stop with a runtime error. It is also a program, right? So understand, yeah. If you don't have a final, still it is representing a language that's called as empty language. Okay? Correct? Good. Any other doubts? अंकित सर भी आ गया. अंकित सर का एनर्जी नेक्स्ट लेवल होता हमेशा. मेरा तो बच्चे का ऊपर डिपेंड होता है क्लास में. ऑलराइट, ओके, चलो शुरू कर लेते. फर्स्ट प्रॉब्लम, लैंग्वेज इज, मान लेना हमेशा सिग्मा इज ए कामा बी. ओके, अगर सिग्मा चेंज किया तभी बोल देना सिग्मा अलग है, आंसर भी अलग होता. L इज इक्वल पाई, L इज इक्वल सिग्मा स्टार. थर्ड, L इज इक्वल ओनली एप्सिलॉन. फोर्थ, L is equal to what else? Sigma plus. Tell me how many states? Very simple questions in the exam. How many finals, how many non-finals, how many total states, all the things will come into the exam pattern. No need to say number of dead states, that can be ignored right now. Tell me the total number of states. Okay, that one state itself dead state, that is fine. Number of states in minimum DFA. Do you want me to design both at a time, minimum DFA and minimum NFA, so that we can save the time for the remaining topics? Everyone? Do you want me to design both at a time, so we can save a lot of time? So if you don't understand anything, I'll take specifically that question itself and ask me the doubts especially. If you don't ask, I assume that you're understanding. Okay? So I'll show the machine, you tell me the number of states. Here the machine, the first column, let's take minimum DFA. The second column, take minimum NFA. Okay, what is the answer for the first one? Pi, right? A comma B. Or you can also design the same machine. A you take separate edge, B you take separate edge, but both are same. Remember that? Both are same. A comma B or A separately, B separately, there is no difference. Minimum NFA, there are many machines. It's the only one, right? It's both are exactly same, there is no difference. Okay? No need to design separately like this. Okay? Here minimum NFA, you can design this way, or you can design only A, or you can design only B, or you can design both A comma B. 4 minimum NFAs are there, but you always have only one minimum NFA, one minimum DFA. So total number of states, how many? Here how many states? 1 state. We will only worry about how many states. Here how many states? 1 state. Okay. So this is what final answer should be. 1 state, 1 state. Here you may have many NFAs, take 1 NFA is fine. You don't need to take these 4 NFAs. Okay. Take any 1 NFA and all are having same number of states. Okay. Next one, sigma star. What is a sigma star? Oh, everything should be accepted, right? Epsilon is accepted and everybody else is accepted. A as well as B. So A plus B whole star, that means. And here, is there any other way that you can design? Only one way, that is also the same. You cannot design any other way, only one way, that too. Only one minimum NFA for this language. Okay, but number of states, how many? Here also 1 state, here also 1 state. And epsilon you want to accept. How do you design epsilon? Epsilon is in the language, so initial should be final. Everything else should be accepted, then now dead state is needed. A comma B should go to dead state and reject everybody else. Why do you need dead state? Because in DFA, for every string you will have exactly one path. So if you miss the transition, you will miss the strings, so that will not become DFA. Okay, should never miss any transition here. From every state, you should cover the transitions for both A and B, exactly one, that two. And this one, and here that would be sufficient. That's only the one machine and that can accept epsilon, that's the minimum NFA. You don't have any other minimum NFA here. How many states here? 2 states. How many states here? 1 state. So if I use the minimum NFA, I will have one state. If I use the minimum DFA, I will have two states. Formula is depends on the problem. Formula cannot be written directly, right? If you go to any subject, any problem will decide the formula, right? Pi, these are different languages. How many empty languages are there? Only one. This one, do you need any formula? Sigma stars, how many sigma stars are there? Only one. How do you need any formula for this? And epsilon is only one language, right? If you have the similar properties, we can have like starts with A, starts with AB, starts with triple A. For there, you can create a formula. If you have a same concept but different problems, then you can create a formula. Okay? Don't create a formula for same formula for all the machines. Never works. Okay? Like if you want to write a program for prime numbers, different, right? Factorial, different program. For everybody, don't expect the same number of states and same number of functions here. Okay? Sigma plus means except epsilon everybody else. So this machine only, this one make a non-final, this one make a final, because both are complement to each other, these languages. Okay? So what I am going to do here, non-final, epsilon should not be accepted now. Everything else is accepted. So you know this point. And how many states here? 2. But here, except epsilon everybody else you need to accept. So how do you do that? So many machines are there. Now I want to design, right? So many machines are there. Okay, one way is this A comma B, and of course this is a final A comma B. You can also design other way. This can be A comma B and this can be A comma B again. So like this, there are so many machines. I am not designing all, but do anything, you will be having 2 states only. Here also 2 states. Design any NFA that is accepting sigma plus will also have the 2 states. For that, you should know the definition. Why only one state? Because invalid strings, you no need to have the path. You no need to have the, okay, let me give the definition too. So I hope DFA you understood, right? NFA, delta definition is Q cross sigma, NFA definition without epsilon transitions, 2 power Q. It means if I have a state, I know it on A, how many transitions? Oh, may or may not, you don't know. May or may not have a transition, that depends on your requirement. May not have a transitions. Same concept for B. We don't know whether you have a transitions or not. If you don't want, don't cover. If you really want to accept any string, then cover the transition, otherwise not needed. That's why you have only one state. Why one state here? On A, I don't have a path, it means I am rejecting that string. On B, I don't have a path, means I am rejecting that string. That's why any string starts with A or B, I don't have a path because I don't have the valid strings. I have only valid string epsilon, that I have a path. And what is that path? How many paths? The NFA definition is at least one path is enough. That means if I have 1000 paths, only one path going to final, that's enough. Remaining paths, let them go in on final, I don't care. If at least one path is there, that is halting at final, then that string is valid. So these machines are very dangerous. If I am designing for you, it may be difficult to understand, but you should know how to construct the NFAs. How do you construct? If the string is valid, show at least one path is there. If the string is invalid, no need to have a path. If you have the path, everybody should halt at non-final for the invalid strings. Okay? Meaning of 2 power Q. Okay, what is that? 2 power Q. This is DFA, right? Of course, every DFA is NFA. Every DFA is NFA. Remember that too. Okay, now look at. You will understand what I am going to do. Let's take this is Q naught Q1. Let's take this is P naught and P1. And this is definitely not DFA, it is just NFA. But this is also NFA, okay? Don't say this is not NFA, it is also NFA. Now look at what do you mean by delta Q cross sigma that maps to Q. It means you can see the delta table you can see. This is a delta table and these are the Q's. Initial state is Q0 and final state is Q1. On A, on B, what is happening? Q0 on A, it goes to exactly one state. Q0 on B, exactly, oh, this is a Q0 only, no? Q0 on B, it's a Q1, and Q1 on A is a Q1, Q1 on B, it is Q0. So if you see that result, that codomain element is exactly one state, the Q is actually, see, either Q0 or Q1. So this is going to have a codomain. So Q0 belongs to Q, Q1 belongs to Q, Q1 belongs to Q, Q0 belongs to Q. Is there one state enough? That's why the belongs to comes here. So here also one state that belongs to Q, an input symbol belongs to Q. So Q0 comma A Q0. So you can also write something like this, delta of Q0 comma A is equal to Q0. So how do you understand? Q0 belongs to Q, A belongs to sigma, Q0 belongs to Q. So it's just like a function, right? Domain and codomain. But here this function is not valid here. Why? See here, see, I'm just building delta table, right? So Q P0 is there initial and P1, of course, let's take this is a final P1, fine. Now P0 on A, you can't write only P0 like DFA. DFA means exactly one transition. Now we have two transitions. How do you write that? Either P0 or P1. So you need to put a set. So where is this belongs to? It's not belongs to Q. It is belongs to 2 power Q. When we say delta Q cross sigma, this set is a subset of the Q. That's why it is belongs to 2 power Q. And P0 on B, oh, no transition. But here it's exactly one. But here it is no. Then empty comes empty set. Where is it? It is belongs to 2 power Q. And P1 on A, no transition. It belongs to 2 power Q. P1 on B, exactly 1, that's fine. This is also belongs to 2 power Q. Are you clear? So what is the meaning of 2 power Q? In the NFA, to understand the transitions, you need a subset of the Q. Subset of the Q as a mapping or as to find the number of transitions. For one input symbol, how many transitions are there? Here 2 are there, here no, 1. To represent that, you need a 2 power Q. It's just like a subset of the Q. So every mapping is just subset of the Q. But here it is not just subset, it is equal, it belongs to Q. It is a belongs to Q. Everybody understood why we need a codomain as a Q? Here why we need codomain as a 2 power Q. The mapping is actually P0 on A is having multiple transitions. To represent that, you need element in 2 power Q. So this is the belongs to 2 power Q. This is a belongs to 2 power Q. But this is belongs to Q, that codomain. We are talking about this. Here we are talking about this one. Okay. That's why always you see exactly one transition. DFA, D, deterministic, came from this meaning only, right? You will never have a confusion. You ask anything, I will go to exactly one state. Here, non-deterministic, I don't know, I have a 0 transitions or I have 1 or 2, I really don't know, depends on the problem that will be considered, right? Fine. Fifth one. Okay, language is having, okay, I am just writing a short form, A W such that W belongs to A comma B whole star. L is equal to W A such that, or let me write a formula directly, A B W. If you understood, please let me know what is the language. Don't construct in the exam at least A power 100 W. How will you design? So now you ask me the shortcut. This all problems have the same concept. Now you have a shortcut for this. In the exam, no need to design. In the exam, you just answer it by knowing this concept. How many states are there in minimum DFA? How many states are there in minimum NFA? You can create a single formula for this. What is the answer? I don't know what is n. You should tell me what is n. What is the length of the prefix? No, what is the prefix here? Never use the word prefix. Quick. So now you have the concept. The key point here is those people who know the minimum string, they will get the answer correctly. What is the minimum string? Is A. What is the minimum string? Is AB, not the prefix here. Take the minimum string concept. Here, what is the minimum string? It is AAA. What is the minimum string here? A power 100. 100 consecutive ways. So if you want a minimum DFA, so what do you answer it? The minimum string for all of them, same concept. The answer is, I'm writing above, that is length of a minimum string plus 2. Here the answer is length of minimum string plus 1. So here minimum string length is 1, 1 plus 2 is 3, and here 2 plus 2 4, and here 3 plus 2 5, and 100 plus 2 is 102. But one less compared here because you don't have a dead state. So 2 3 4 101. But really, do you want to construct the machine? Definitely takes time, right? If anybody want to design any machine, let me know. I will design for you. But if you are okay with this formula, I will go further. If anybody want to design any, but don't ask me the 8th one. I can't show you with the 8th. 100 states I can't show, right? I don't make the fun here. So you need an explanation. Then you take this 6th example. Okay, 6th example, starting with AB, right? Look at minimum DFA, how you design. Minimum DFA or minimum NFA, first you start with the minimum string. What is the minimum string? A followed by B. This is the first string you should accept, right? So this is only the way you should start beginning it. Randomly you should never design. The minimum string is AB. First know how to accept the AB. Don't accept anybody else. Here and here the same concept. You want to design minimum NFA, then focus on what you want. I want the minimum string is AB, right? In NFA, any string starts with AB, you will accept by taking the self loop, and you don't need anybody else, because if I don't start with AB, I don't have a path. If I don't have a path, means I am not accepting. So NFA is very clear. All the valid strings, I will show a path, at least one path. Invalid string, I will never show a path to the final. That means I may not have a path. Even I have a path, I will alt it non-final. So NFA is so clear, I am representing valid strings correctly. Invalid strings, I may not have a path. I don't have an issue. But DFA, you should show path, exactly one path for every string. That means here you need to worry what happens on a B, what happens on A, what happens on A, what happens on B. This is how you design a DFA. But NFA you don't design. NFA you design what you want. I want starts with AB. I started with AB. After that everything is accepting. So you give me any string starting with AB, I will go to this path and I'll accept here because I will alt here. But here I need to look at, even I don't start with AB, I should have exactly one path, somewhere I should halt. So now if I start with B, oh, my string never start with B, so I will go to a dead state. I'll stay there, but I should show a path exactly. If I start with AA, oh, I never start with AA, that's why I go to dead state. Once I start with AB, I have no issue, I will halt at final all the time. So this is how you design a DFA. You need extra one sets. Look at, to understand the minimum string is what for both of them? AB. And to understand AB, you need 3 states. That's why length of AB plus 1 plus 1. So length of AB plus 2. Here length of AB plus 1 is enough. To understand AB, you need a 3 states. So 3, 4, 3, 4. That is what I did here. Length of the string plus 2 and length of the minimum string plus 1. So if you understood this concept, that all of them the same approach, you need a dead state for them, you don't need a dead state. Clear? But don't ask me for all the problems. That's not my intention in the revision. Okay? Clear? Okay. In the exam, please don't try to construct the DFA if you already know the concept. Right? If you don't know, you are looking at the first time this problem, then you should construct it. You need to have the confidence to and then answer it properly. These are all well known problems, right? Well known problems we don't, we just practice before the exam only. In the exam we don't have the time to practice. Okay. 9. Ends with A. 10. Ends with AB. If you have any issue in construction, that you will face the difficulty in this ending only, because this ending problems makes a lot of time. If you have this shortcut, then you can easily answer it within seconds in the exam. Let's take L is equal W, A power 100, B power 123. Then let's see how will you answer it. Keep answering if you already know it, that's all right. Just hardly takes 5 seconds to answer this question. But if those people who are designing it, they may take even 5 minutes. Sometimes they come up with the wrong answer also. Don't try to design if you know the concept. How many states in minimum DFA? How many states in minimum NFA? Once you got the concept, I will ask the random questions. I don't go with this frequency because it is not regular class, right? Revision class. Once you are in the frequency, same frequency, we'll go to random questions. Good, good. 2, 3, 4, perfect. Who is that 2 to 4? Do you require a dead state for any of these 4 problems? Do you require a dead state any of these 4 problems? Anybody? You will never require a dead state for these problems. So minimum string is the key. For both of them, same formula is applicable, that is length of minimum string plus 1. Here also same formula, because you don't need a dead state for both of them. Here minimum string is A. Here minimum string is AB. Here minimum string is ABA. Don't apply the start formula to the end formula, right? If the string is ending with a particular condition, formula is going to change. That's why don't try to create the formulas for every model. You try to understand the concept, that's going to be enough. You can create at that time, is it plus 1 or plus 2? You can understand. Only remember, oh, this is the ends with condition, so you do not need a dead state. For all these problems, no dead state required. Dead state not compulsory. Dead state is not required. Is not required. Why it is not required? If you go to the dead state, how will you conclude? If it is ending with ABA, how will you come to the final? Dead state says that you will never go to final. But after going dead state, ABA may come. How will you come out of the dead state? Impossible. right? Nobody should go to dead state, because this don't know when will happen. Okay, after going to dead state, this condition might come, then you should come to final state, but impossible. Okay, here how many states you will have? 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, and 223 is the minimum length, so 224. And the same answer here also, 2 3 4 224. Right, everyone? But anybody want to design a DFA or NFA, let me know quickly. I'll do it. I told you that every doubt will be taken care, and if you are not asking the doubt, that means I assume that you are understanding. You know, teaching whole DOC will take 100 hours or 60 hours or 50 hours, but here we are going to do the revision. Okay, first one you want to understand ends with A, right? Just look at ends with A, ends with A. How do you do minimum DFA? Ends with A, minimum string is A, right? First accept A, that's done, right? How do you do minimum NFA? Ends with A, right? So first design how to accept A. Beginning, you know, both look same. Now here approach is different, here approach is different, right? Anyhow, this is already NFA satisfies. Now look at B. Oh, I want to end with A, so B I will wait. After A, I should guarantee even it should end with A, because don't accept everything here. Oh, after A, if A comes, then only ends with A. If B comes, oh, that's not end with A, because A, B, oh, it's not ending with A, right? You should come back. See, from every state you should think about what should I do on A or B. So if I assume this is end, then before that anything can come, I can write A comma B here. That's enough. Even though this is the minimum NFA, you can design another way minimum NFA. See, both are having two states. This is the only minimum DFA, but both are minimum NFAs. But this is an easy minimum NFA, ends with A. So that's all. The minimum string is concluding both the answers, right? You don't need a dead state ever, because you will never go to dead state. You will wait for happening that ending with A. You will wait always. This state, you look at ends with A, you are coming to final. Oh, whenever B comes, you are going to non-final, because you are guaranteeing whenever ends with A, I will be there in final. Whenever ends with B, I will be there in non-final. So I will guarantee moving here and there. Whenever the string is ending with A, I will be there in the final. That's what the conclusion here, right? Clear? Both anyhow two states. But you can design a lot of NFAs. No need to be this way. There are many other ways to design. So I can help you. There are many other NFAs, but I am not designing. Like ends with A, right? This ends with A. I can keep here A comma B, still I can keep here A, still it does the same job. It will not change the language, but you will have multiple paths for the same string. But that's fine, that is also another NFA, and this is also NFA. You can also design this way as an NFA. So these are the three minimum NFAs. Okay, if you want many, you can try on your own. Okay, fine. How many are over? 12. W1 AB. Okay, let me ask. Now you got my point, right? So for every problem there is way to answer the question. So we will focus on the formulas and shortcuts. Okay, so I'm writing my random questions, but you should know how to answer it. Okay, now onwards you will be facing random questions. Some questions will have the formulas, some questions you need to design right now, okay? So when I write a k, remember that k is a constant. You can put any constant to understand the formula. try with k is equal to 2 and 3, then conclude the formula. Yeah. This was a previous gate question. The 15th is a previous gate. They asked with the regular expression. So this you may assume as a short notes. That's why I am making the table. You can create in one page all the problems. Maybe when I am taking different slides, you can put all in one page. Mostly happening gate questions. So you may see the gate questions directly from these slides. We don't know exactly what will happen in the exam, right? Yeah, good. You can use a formula if you have it, because other people will get to know that, right? If you have any formula for that, you can put here. Good. Who was answer? 47. Excellent. 13th problem is 47. How did you get that 47? So for this problem different, and everybody will have a different formula now. Don't assume that they are all having same formula, wrong. Now everybody has a different formula. So here the 46, right, the minimum string, here minimum string is AB power 23. It means 46 length it is, because AB 23 times you write 46 length. So it's containing problem. Containing and end will have the same formula. Containing, remember that both, you don't have a dead state here. So till that happens you will wait. Once it happens you will accept everything. So this 46 length should happen, then you will go to final state. So now this 46 lengths, to understand 46 length you need 47 states, and in both of them you need the same answer. No confusion at all, because both of them you don't need a dead state. Okay, 46 plus 1, 46 plus 1, and dead state is not needed. That's why you don't get a 46 plus 2, you get 46 plus 1. And this one, how you design that? You should now practice it. How to design. So you make a practice. Quick, you practice. Minimum string is AB. So minimum is AB. So can I focus with the 3 states? No, because dead state is needed. I should not start with the B. So first focus on AB. Oh, understand this, rough notes. Oh, AB accepted. Now try to create from every state a missing transition. Oh, B, I can't have the start with B, so I should go to dead. Rough notes, that's enough. And after A never comes, second A never comes, so again dead. After AB, A never comes, dead. After AB, any number of B's can come. So with 4 states enough, right? So now 4, you make don't make a formula. Here 4 states needed. How many states? 4 states. Here 4 states needed, 4. And here, look at this motion only. You don't need a dead state. Minimum is AB. So definitely this path is enough to understand AB power n, where n is at least 1. So 3 states fine. So here only the answer is there. Okay. So when you design this, NFA also accept dead state, you can look at, oh, this path is sufficient to accept all the AB power n strings. Okay. And this one, oh, exactly k length. So understand exactly 2 length. What happens? 3 states, 1 dead. So here k plus 2. Here dead state is not needed. So this one you require little bit practice. So how do you practice it? Oh, 13. What is happening? Anjali, please practice not this problem. Practice a different problem containing A. Just take one here. Don't take this one. This is a very big problem, right? It's a very big problem, yeah. Don't understand that way. So take this problem and understand how to design it. Never look at the bigger problem. You will never get the answer directly, quickly. Okay. So minimum string is A, containing A. So focus on how to contain A. So now before A, you have to wait for the A. So you should stay in this state, because you should not go to dead. If you go to dead, on A you can't come back, because containing A means A might be there anywhere. So B you will wait. Once A comes, everything is accepted. That's why 2 states is enough. This is a DFA. And in NFA, what you can do in NFA? So containing A is a very simple answer is there. This is A, and before A, after A, anything could happen. A comma B, A comma B. This is also, easy way to design, but that's the minimum NFA. Easy motion it is. Whenever A happens, I'll take this path, I'll go to final. If A is not happening, I will wait here. If there are 100 A's, I can go to this final on any A, right? But this one, first A, remaining A's you will be taking here. So understand there are many multiple ways to design the NFA. But anyhow, this is a simple machine. Both have the same number of states, right? That's why. So for one length, I took 2 states, and for 46 length, I took 47 states. So AB power 23, understand the AB power 23 means, what is AB power 23? It means AB, AB. AB power 2, that is the meaning. Power 23 means, you should write AB 23 times, you will get a 46 length. Okay. Fine. Language recognition start. What do you mean by that, Harshit? When will language recognition start? What do you mean by that? Please let me know. Come on, quick. Who is that? Harshit. Okay. So when you have at most k, same concept. Copy exactly k, at most k, same number of states. But for that, you just take any k value to understand it. K is equal to, take 2 length strings, take at most 2 length, then you will see the same answer here. But this is minimum k, you don't need a dead state, both will have the same answer. So mostly minimum string is the key. So for both of them, you require a dead state. Dead state is needed. Dead state is present. Here, no dead state. Here, of course, dead is there, because you are restricting. First symbol is A and second symbol is B. You are restricting. That's why you need a dead state. Here, we don't know after W. W1 is also don't know. Is it 0 length, 1 length, 2 length? That's why you have to wait. Okay. K can be any constant. K can be any constant. It might be 2. If it is 2, 2 plus 2, 2 plus 1. If it is 3, 3 plus 2, 3 plus 1. So k value should be a constant. In the exam, they will say 100 length. So let me frame the question here. If you are really confused with the k, sorry. So in the exam, you will be seeing like this: set of all 1000 length strings. Binary strings, let's say. Tell me number of states in DFA. Now tell me how many states in DFA. This is enough. Now you need to interpret exactly how you need to design. Set of all 100 length strings. Oh, actually, how do you write in our format? Our format is like this: W such that W belongs to binary 0, 1 whole star. Length of W is equal 1000. This is our format, but in the exam they will ask in a sentence, English line. All exactly 1000 means, to understand 1000 you need to have 1001 states plus extra dead. Why dead required? Because 1001 length you should not accept, right? You should go to dead state. You should get, understand, Just take one example. Why do you want a bigger one? Just take length of W is equal to exactly 2. How do you do? 0, 1, this is a 1 length, this is the 2 length. Exactly 2, 3 states, 1 extra dead state needed, because after 2 length everybody should be rejected. This is exactly the machine For 2, you need 3 plus 1, total 4, 2 plus 2. For 1000, you need 1002 states in DFA. How many states? 1002 states in DFA, but 1001 states in NFA. In the exam, how do you answer it? How you apply the formula for a different examples, k value. They may not ask in our language format, I represent in set notation, they may ask in English, they may ask in regular expression, they may ask in regular grammar, we do not know, right? Anything they will give, you should have the conclusion with the meaning. They may give you NFA, they may ask you about DFA, but never use any algorithm, understand the problem and design, answer it directly. No need to design DFA. Is it clear? How to answer these questions? Concept is important, not the formula. Once you have the concept right, this is the concept. This is the concept k. Just take the smaller number to understand the concept, then apply to any bigger one. 2 can be 1000, 2 can be 1 lakh, 2 can be anything. Just apply the same concept there. Okay. So, anybody did not understand this formula, right? Just go in the same way. K, take the smaller number and practice both of them. I already given the clearly dead state is needed. So, for both of them dead you need, but last one you do not need a dead, because after k you put a self loop at final, you do not go to dead. So, that is why you have the same answer here. Okay. What is this now? Okay. Straightforward gate questions they are. You do not need to worry much. Okay. K is fixed. Remember, it is a fixed constant. So, remember, whenever the length is given, you know the formula, then apply the same formula here, no confusion at all. These 3 problems also use the same formula. May take much time if you want to design. Okay. How many states you need? Same formula, just copy paste, because I want you to keep just after that, so that you will remember these 3 formulas easily. What is it? Dead state is needed, so k plus 2, dead state is not needed, and again at most dead state is needed, not needed, and dead state is not needed, so both will have the same answer. Okay. Just copy paste from the below, but question is different. Here is about number of A's exactly 100, then you will have 102 states. Number of A's is at most 100, then you will have 100 plus 2 states in DFA, 100 plus 1 in NFA. Number of A's is at least 100, so you do not need a dead state, because after 100 everything you want to accept. Here after 100 nobody is there, that is why you need to go dead state. Okay. Just repeat the same length problem here. Yeah. Whenever k is given, remember, just take any k value to understand, as Nishu told, right? Just take any k and understand. K is the fixed, that is what I am saying. Why I am not writing k? Why should I take 2, 3, 4? Takes much time, right? Instead of that, k I took, that is it. You put k is equal to 1, understand what is happening. That is what I explained there. K is known constant, fixed constant. In the exam, k will be given. If k is not given, you should also answer the same way. Remember that. K is constant from any natural number, then you should answer the same way. Generalized formula, and when the k value is known, just substitute. Okay, now let's go to the designing part. Now onwards we'll design. No formula, no formula. Now onwards we will design. Okay, let's see who will design. Okay, so anyhow regular expression I'll start later, but this is a very special. You can also write another way, 1 power 2, 1 power 5 and whole star. Oh, this can be also written as set. Any other way that I can write? 1 power 2 comma 1 power 5 power star, something like that. With many ways to represent that. So how many states required in DFA? Of course NFA will be same. And now the sigma is having only one symbol, that is 1. Remember that. Okay, let's see who will answer it. Very, very famous question. It was one of the gate model too. You should know how to design this. One of the gate model too. Oh, sorry, good point. 1 power, take 2 only. No, I did not count. You know, many good people are there. They are able to identify mistakes also. Just take 2 ones only. So many ones are there to confuse. Okay. Take 1 power 2. I think it was the exact gate question now. 1 power 3 is not asked in the gate. 1 power 2 plus 1 power 5 asked in the gate. Take 1 power 2 only. One power 2 plus 1 power 5. Just change the question if you have done with the 1 power 3. Also practice, like you take random, right? I'll just help you later on, but let's conclude this. What is the answer? First, are you able to understand the language? Oh, that you have epsilon and minimum 2 ones, then 3 ones impossible, 4 ones and 5 ones, 6 ones, 7 ones possible, and 8, and everything else is thereafter, right? Then you should understand, oh, the key is here the 4. Why 4? Because after 4 everybody is there, 5, 6, 7, 8, 9th one, right? But here single one is not there, 1 power 3 is not there, that you should reject. So how do you do that? You need to design like this: epsilon not accepted, and single one no, that's why non-final. Double one accepted. Oh, 3 ones should not, so don't make cycle here. And 4 ones should accept, 1, 2, 3, 4th one accepted. But after that every one, that's every one next string is going to come. So you put a self loop on 1. So once you have the 4 ones followed by any number of ones, it is accepted. And definitely this is NFA, DFA, it's over 1 symbol, right? It's over 1 symbol, so no issue with the NFA. It is also having same states. So 1, 2, 3, 4, 5. So how many states you have here? 5 states. 5 states. And what about this 2 ones whole star, right? What is the language? Epsilon, 2 ones if you come once. If you go twice, double one followed by double one, it's a 4 ones. If you go 3 times inside, 6 ones. If you go 4 times inside, you'll get 8 ones, and so on. So what is the meaning of this? Even number of ones. Even number of ones means 2 states you take, and when odd comes, go to odd state. When another one comes, come to even state. This is the even state, this is the odd state. So even number of ones, epsilon is accepted, and 2 ones, then again 2 ones 4, again 2 ones 6 ones. So whenever you halt here, this will represent double one whole star. Whenever you halt here, it will represent odd number of ones. So just 2 states enough. 2 states enough here. So here you need 2 states. Okay. So these are the special languages over 1 symbol. When you have the 1 symbol, just you need to look at, are they forming arithmetic progression or not. You see the distance is just one single one. So they are forming AP. Here also you see 2 ones, 2 ones, 2 ones. So the distance is going to be 2 ones. That's why after every 2 ones you are coming back to final. Here after every one it's going to the final. That's why self loop is needed. So how many ones is the distance? That will tell you what is the cycle length. Is it 1 length or 2 length? Everyone? You have only 5 states, right? It's very clearly shown, right? Yeah. (22). Here there is no 0, right? If you have a 0, you need a dead state. Here 0 is not mentioned. So never take the 0 path, because if I mention 0, answer is different. Sigma is equal to 1. How many states you have? 5 states. The same question, if they ask for sigma is equal to 0 comma 1, the answer will be 6 states. Why 6? Because on 0 you will go to dead, and in minimum DFA this is the concept. In minimum NFA both of them will have the 5 states, but minimum DFA you will be having 5 states. If it is sigma is 1, sigma is 0 comma 1. For 0 you need to go dead state, so you will get extra 1 state. That's all, Anjali, right? So here sigma is given mentioned only 1. If not mentioned, still you should take only 1, because you don't know about other symbols. Clear? So you are getting the 6 because you are considering five ones is accepted by this self loop, right? Oh, you don't know self loop? 1, 2, 3, 4. Fifth one you need a self loop, because 4 is the minimum. 5, 1, 6, 7, 8, 9, you can put a self loop and you can stay there only. You don't need additional final state, because that both will be combined. No need extra 1 state here, no need extra 1 state. If 4 ones comes, you will halt here. Even 5 1 comes, you will halt here, but you will take extra 1 transition, that's all. That is what the meaning, right? After 4 ones only everything will be accepted, not after 5 ones. After 4, that sequence is saying that 4 ones valid, 5 ones valid, 6, 7, 8, 9, all are valid, right? After 4 ones. Then why do you want extra states here? If you take extra states, right, what happens? 1, 1, how long you go, yaar? When will you stop? Right? Is that DFA will be having infinite number of states? No, right? Ever? You should stop somewhere. That's why DFA is possible. Okay? Any other doubts? Can I reach 50? Okay. Practice the same one. 111 plus 5 ones whole star. 25. 1 followed by 11 whole star. 26. Just practice this. 1 power n such that n not equal to 1. 27. 1 plus. Plus means at least 1. You can also write an expression is like 1 plus. Never apply your mathematical knowledge. 1 power 2 is equal to 1 in maths, okay? But in TOC never write that. 1 power 2 means 1 followed by 1, which is double 1 in TOC. Here we only do concatenation, we don't do multiplication. Remember that too. Strings we concatenate, we don't do multiplication like numbers. Okay? So 1 power 2 never write as a 1, it's just 1 repeated twice. Okay? Some people still applying that kind of concept, I see. Just answer now DFA only. NFA we just ignore. You understood, right, how NFA should be designed. Just focus on minimum DFA only. Minimum NFA you can just do later. Do you need additional states or not? Minimum DFA will do, not NFA. Yeah, Sugandh. Plus means at least 1. You have a sigma plus right there. You didn't ask that time. In regular expressions, we represent that 1 plus means you will be having at least single 1, like 1 power 1, 1 power 2, 1 power 3 and so on. So plus basically represents, is called as a positive closure, Kleene plus. So it's a Kleene plus. In regular expression I will discuss anyhow. That means 1 is having at least 1 time repetition. So this is minimum 1 time. If you write 1 star, that means this star represent at least 0 time. That means 1 power 0, 1 power 1 and 1 power 2. So this star represent at least what? 0 times. So the star means minimum 0 and plus means take at least 1 time. So in the concatenation, how many times that 1 should be repeated, that decided by your requirement. If I want 5 length string, you have 6 length, you have 0 length, you don't have, because 1 power 0 is not there, that's why epsilon is not there. Okay, but difference when you look at the 1 time, here repeated at least 1 time, here you can repeat 0 time, you can get even epsilon. 1 power 0 represent epsilon here. Okay. Anybody answer? Yeah, any, what is it? 24. Almost all questions are answered, looks like. 9, 2, 3, 2. How many? So, what is the set of strings? Epsilon, 1 power 3, 1 power 4 you can't get. Either this or this, right? 1 power 4 you don't get. 1 power 5 you can get here. 1 power 6 how do you get? You can repeat this 111 twice, you get this one. 1 power 7 you don't get, right? 1 power 7 you don't get. 1 power 8 how do you get? Take 3 ones first, then 5 ones later, because you can come twice. You can understand power star means you can take power 2, but you can go inside twice. First time when you go, you have 2 choices. Which one you want to consider? Take 3 ones first, and you have 2 choices. You can take 5 ones here. So 1 power 3, 1 power 5 you will get 111 followed by 5 ones. You will get 8 ones. 8 ones. So how do you get 8 ones? I am writing. Similarly, you can get every string that you want that is there in this language, you can generate. If it is not there, you can't generate. Here 1 power 7 you can't, because you take anything, any number of times, 1 power 7 you can't get. Either you get more or less. And so on. 1 power 9 you can get by taking 3 ones 3 times. 1 power 10 you can get 5 2 times. 1 power 11 you can see 5 6 is there, so you can get 11, and so on, everything after. So now what is the key here? Key is just shortcut. See, 8 ones is the key. When you have the 8 ones, after that what is the length? Just after every one you are getting the next string. That means you can put a self loop. So 8 ones is the key. Directly you can say 9 states, 8 plus 1. In the exam that might be the key for you. Till 8 ones you should know which state is a final, which state is a non-final. Initial state is a final, then first second states are not final, then again you go to the third state is a final. You can say first means assume from Q0, Q1 that way. So understand which state is the final, which state is a non-final. Single 1, 2 ones, 1 power 4, 1 power 7 should not be accepted. So that you can put a sequence. In the 9 states is very easy to design. And this one just 2 states. How did you get 2 states? Previous one. When even number of ones is there, another state represent odd number of ones. And this one is except a single one, except a single one. That means how do you do that? Epsilon accepted and single one no, 1 power 2, 1 power 3 and so on. So this 2 is the key. And to understand the 2 ones you need a 3 states. So this one directly 3 states. And 1 plus, oh, epsilon should not be accepted. So you will just say 1 and followed by everything 1. Everything, right? Every one you should accept. So how many states? 2 states. So how many of you answered correctly? 9, 2, 3, 2. Most of you? Yeah. Any simple doubts are there? In the chart you can discuss and clear it. Because many people are helping each other, right? So keep doing that. In 25, just you need a single one, right? Minimum one. So keep it final, other one you go there. So these two states would be sufficient to understand 25, right? After 2 ones, no need to go another state, just this state can help you. So every 2 ones, see single one followed by any number of ones is going to accept odd number of ones. This state is odd, this state is even. So this is odd number of ones. So just 2 only enough, 25. Of course 3 also you can design, but that is not a minimum DFA. Should aware that. Some people design this way, see, oh single one, then after that what they do is other 2 ones they will come back. Oh, this is not a minimum DFA, this is just DFA only. Okay, some people do that mistake, but it's fine. W such that W belongs to A comma B whole star, length of the string is divisible by 100. I don't know how you design, just see. I want you to generalize rather than putting. This is a very famous question in the exam again. Okay. Are you going to construct? How many people are started constructing? So that is the key. Why these 100 states are needed? Why these 100 states are needed? Because divisible by 100 has 100 remainders, 0 to 99 remainders are there. You need to track everything, so 100 remainders are there. That is why you need 100 states. Whether you design DFA or NFA doesn't matter, 100 states needed. And here also you need 100 states. To understand this problem, just take divisible by 2, then do it. Divisible by 2 and then do it. 0 and 1, there are 2 states, 0 remainder, 1 remainder. Just maintain the cycle, that's it. Sometimes the question slightly changes, I'm just changing it. Look at the 30, only I'm writing for this. W such that you should be very careful now. A comma B whole plus, small change, you can see that, whole star whole plus means other than the epsilon. Epsilon should not be accepted now. This is a possible gate question in the future years. Then you should be very careful. There is a small difference in both of them. Don't assume they are the same problems. Concept is almost same except one string. Here epsilon is accepted, 0 length is accepted, but here epsilon should not be accepted. They are demanding don't accept epsilon here. When they don't mention accept it, not an issue, but when they mention it, don't accept. So then how many states? I'll show you random machine, like how do you design. Q naught here is the final state here, and on A comma B will go to Q1 and remainder, that is Q2. Likewise you go to till Q99, right? Then from here you came back to Q naught, but now you can't come back to Q naught and this is not a final. So you need another one to represent remainder 0. So don't keep this is accepted now. So this is initial state, Q naught will represent here somewhere. So extra state comes here, and from Q naught you should go to Q1. So keep the same machine, but don't keep the final, and this line should come to another Q0, and from there you go to Q1. So extra one state is needed. Here you should mention 101 states. So always understand these formulas by looking at the concept. Here epsilon is accepted, here epsilon is not accepted. That's all the difference. But divisible by 100, it's always 100 states only, unless they mention some other concept, other restrictions. Correct? Everybody got the point? So in the exam, remember, if they ask length of the string is divisible by n, how many states? N states. Keep this concept, but always look at your W. Obviously that is only the question asked all the time, but in future they might change slightly, then you should be very careful. Length of the string and number of symbols, both will have the same answer. Okay, now new concept is coming. Divisible by 100, you know, right? Now I will go for 31. 31. Length of W is equal to 100n plus 5, where n is greater than or equal to 0. Let us see who will answer it. Same concept, slight change, but how many can understand this concept? Not divisible by 100. Those people who want to design, please don't take the 100, take the 2 or 3, then solve yourself. In both of them, it is also you are dividing with 100, but here remainder should be 5. So Q5 will be the final, that's all. Here only final will be different. Q5 is final, but number of states will be 100 only here also. Previous question was 100n plus 0, that's a Q0 was the final. So here 100n plus 1, that's all. Previous one was multiple of 100, this one is 100n plus 5. When you divide with 100, you will get a 5 remainder. This one, except 0, everybody else is a final. What is the meaning of this? Except Q0, every one other except Q0, all states are final. Which states? Q1, Q2, all of them till Q99. So, but number of states again same. Everyone? Who is 105? Shifu, why 101? Oh, first understand why are you going for 105? What is the minimum string? Minimum string, take the minimum string, you will have the answer there itself. What is the minimum string? That is a file length, right? When you put n is equal 0, you will get file length, yeah, not 105. Minimum string is file length string. First you need to go for file length, then after under length you should come back. So you put a cycle like this. You will get, but waste of time, right? I'll tell you there. You want 31, right? Look at 31 how it looks like. 31 I am designing. Q0. Minimum length is what? File length. Yeah, why are you wasting your time unnecessarily to make extra states? Once 100 states there, 101 states you can design, 102, 103, 105, 1000 states also you can design. But best DFA you should design. That's always important. Now here, this is the final. Who is that? Q1, Q2, Q3, Q4, Q5 is the final. Then later on, you don't make anybody as the final. Go till Q99. From there, just come back to Q0. Now look at, from here you focus. Here Q5, right? After 100, that means after 100 you come back. Again after 100 you come back. So n is equal 1 means first one time. N is equal 2 means 2 times you take like this. Okay. So minimum file length. File length will decide the answer. Oh, you want 105? I'll take that too. We have that question also if you really wanted it. Okay. 33. Look at this question. So length of W is equal to 33n plus 104, where n is greater than or equal to 0 you take. Okay, now you answer it. Oh, this 104 will never act as a remainder. Previously 5 was acting like a remainder. Here there is no remainder 104. Here remainders are 0 to 32 only. Because 33 multiplicity means it is the remainders are 0 to 32 only. Now what will be the answer? The key is here 104. No, minimum length is 104. How will you take 104 states? No, how will you take 33? Our minimum string is 104. How can you understand with the 33 states? Sakshi was right, 105. Minimum length is a key, minimum length is always a key. Minimum string is going to be 104 length here. Is 104 length. How will you understand 104 length? To understand this, you need 105 states. Dead state anyhow was not required because we are going to put the cycle there. That always focus on what is your minimum string. If minimum string is 100, 101 states. Do you need a dead set? Think separately. Okay. Always all the questions, this is a very important point. What is your minimum string? What was the length of that? Here previously minimum string was less than the divisible by concept. Like 33 you are dividing, if it is let's say 5, 33n plus 5. Then this is the remainder, this is the multiplicity. Now you need to maintain 0 to 32 states. Of course, here also you should maintain 0 to 32, but it is after accepting 105 length. There you will make in the last, from the final state, you will try to look at 33 length cycle from the final state, but not from the initial state. Okay. So here it is very important, after accepting 104 length, from the final state, you will take the previous 33 states to make a 34 length or 33 length cycle. Okay. Everyone? Yeah, that's what somebody was saying 105, 105. So I made the 105. So what is the shortcut here? The shortcut is very simple. So remember, this shortcut is very important. I am making a shortcut, but consider as a problem. Length of W is equal to, I am keeping two constants, K1n plus K2. Okay, look at that. The conditions carefully look at, n definitely given as greater than or equal to 0. Otherwise you convert it. You convert to n greater than or equal to 0. And the K1 is greater than K2. Then the answer is K1 only. That means K1 acts like divisible by concept and K2 acts like a remainder. So look at this. If 33n plus 10, then 10 will be remainder. So states will be 33. If the second question is, this is case 1. Case 2, if that K1 either equal or less than, doesn't matter, then K2 will not be a remainder. Suppose I write 33n plus 33, then 33 never be a remainder, right? Remainder maximum is 32. So 33 is the focus. Then this K2 is the key for you. K2 plus 1 you should write, like 104 plus 1. So is it K2 plus 1 or is it K1? That you decide. The two kinds of questions. One is depending on K1, other is depending on K2 plus 1. So here remember that either K1 or K2 plus 1. Only two answers are there here. Is it K1 or K2 plus 1? Don't say K2. K2 is not an answer. 104 plus 1, 105. So two examples are there in front of you only. Okay, if you look at the previous two questions and this question, you have the both kinds of cases. Either answer is K1 or k2 plus 1. k1 and k2 are constants and n is greater than or equal 0. So it's not only length of the string, it can be number of a's also, same concept. Number of a's also, same concept. Okay. So should I write a list of problems? Can you do it on your own quickly? So I'll make it 50. So remaining I'll do less explanation, just answer if you know it. Okay, I'll keep writing the problems. 35. Model gate questions again. Are you able to understand this pattern? Don't ask me to design, it takes much time. आएंगे. Just let me cover the concepts, then we'll go to there. Anyone? You don't need pen and paper also for these 3 questions. Only should know what do you mean by length. What is the first problem? 35. This problem is third symbol third symbol from begin is A. So you will get the answer quickly. And this one, third symbol, is a very famous question in the gate. But they ask 10th symbol. You can't go for 10th to design. You should understand the concept. Third symbol from end is A. How many observe that? And this one is a very simple question. 2 plus 3, 5. So it's a length of W is greater than or equal 5. The overall length will be minimum 5. 2 length, 3 length and anything. So minimum 5 length. So those people who can analyze this concept right, then directly you can answer this. Third symbol is A. That means minimum 3 length comes. So 4 states, extra dead, because third, if it is not A, you should go to dead. So total you will have the 5 states. Here you will be having 5 states in the minimum DFA and 4 states in the minimum NFA. Remember, here you will be having 4 states in minimum NFA. You don't need a dead state. But the next one, third symbol from end, is a very, very important concept. 2 power 3 is equal 8 states required in minimum DFA. It's a very lengthy motion going to be. We need some kind of tree approach to design this problem. Okay. And if you want to design NFA, it's so easy. It takes just the same n plus 1. If you are looking for third, 3 plus 1, 4 states only it takes. So if you really want to design NFA, just 4 states. So this kind of problems you need a NFA help, because NFA just takes 4 states. How that takes third, right? How do you design that? W1 is A comma B, you put a self loop A comma B, and you are looking for the third, right? So this is A, and the second last is anything, and last is anything. So easy to design NFA, just 4 states. Okay, third symbol from the last. So you design that same fashion. So second is anything, first is anything, before that anything. But DFA you can't design this way. You need to have a exactly one transition in DFA. That's why you require a lot of states to track the last 3 symbols. So here in DFA you have to track last 3 symbols. That's why 2 power 3 takes. And in NFA you no need to track the last 3 symbols. Just third last is enough. Okay. This one, minimum file length. Minimum file length means 6 states, right? In both minimum DFA and minimum NFA. So only it might take time if they ask number of states in minimum DFA for that kind of problems, because there is already one model gate question. This is already one model gate question. So I am just going to begin the regular expressions. So there you may approach again back the minimum DFA. Okay, let's conclude that. Can we move to NFA a little bit, because now we have another topic, NFA with and without epsilon moves too. So let's change the topic. As you know, it takes really, it's just like writing a program. If you want to think about DFA, there's a lot to think about how you need to cover every transition. Let's change this concept. It's okay, Kadir. So only difference is, like, if you are watching recording, that you need to follow the same thing explained. In case if you are live, you can ask more doubts. That's all the only difference, right? Same content will be there in the video. So everybody knows the DFA and NFA both are equivalent, and without epsilon moves, with epsilon moves, both are equivalent. So now if you want to talk about the minimum DFA and minimum NFA, for every regular language, how many minimum DFAs? Only one. How many minimum NFAs? One or more. Is this point clear to everyone? You take any regular language. If L is regular, how many minimum NFAs or minimum DFAs? For this L, you will have only one. How many minimum NFAs? Greater than or equal to 1. Either 1 or more, that depends on the what problem that you have taken. But always remember, you will be having finite number of machines. Don't ever say minimum NFAs infinite, never say. We will be having infinite. If I ask how many DFAs, oh, that's a different question. How many minimum DFAs is 1, but how many DFAs? Should say infinity, infinite you can say. How many NFAs? Oh, NFAs again infinite, because every DFA NFA, there only you got the answer, same answer. But when it comes to minimum DFA, minimum NFA, right, you will be always having finite number of machines, but either 1 or more, maybe 10 or 100 or 1000, but minimum DFAs exactly 1, minimum NFAs depends on the problem. Never say minimum NFAs infinite, never. Minimum NFAs you will be having only few, but either 1 or more. Right. So this is another concept where the future gate questions might be predictable from here. Clear this concept? We just take 5 minutes break. Meanwhile, as I said before starting anything, right, comparison of DFA, NFA, just take care of this. I have few slides. Whenever I share these slides, right, you just read them. Whatever we have discussed, these things are already covered. You just fill up this. You got the answers right already. Where n is the constant you take, you got the answers already. So just fill up them. It's the same slides, but I have given for homework to understand. Okay, the theoretical questions are there, don't worry about them. So I'll share the PDF, then complete it. Okay, just assignment questions are there, you just complete it. So now we'll move to a regular expression, and as well as after this we'll come back to NFA with and without epsilon moves to understand. So this is actually first topic where I always discuss, but today I discuss DFA first, just to know some of the important questions are coming from DFA, like second symbol from end, a length of the string is exactly n, and the last pattern W1x W2 pattern. These are very famous question and important questions for the GATE exam. Okay, we'll, just after 5 minutes break we'll start regular expression. So take the break. Now it's I think 11:03 to 11, let's say 10. It's a break time. We'll meet after around 6 to 7 minutes. So meanwhile I'll take some of the questions if you have. Previous X slide, what was that? This one? Just look at it. This NFA to DFA conversion will just come later after regular expression. Regular language, it's not regular language, okay. What was it? Are you talking about regular language? Where is the regular language slide? Yeah, this one? Oh, number of DFAs. Ask me clearly, number of DFAs. This one? Okay, those people who wanted a break, please take it and then come back by 11:10. For every regular language we can design infinite equivalent DFAs. That is the answer, right? The same thing. This is only written this side. The same theory I explained here, yaar. Why are you reading separately? For every regular language, how many DFAs? Infinite equivalent DFAs, infinite equivalent NFAs. The same point I have just explained there. This point I explained this side. Okay, don't look at much in detail. The same thing is covered already here. Yes, Rohit. We will discuss that, right? In closure property, if you want to understand the complement, this is needed. Okay, just take 5 minutes break. We'll be discussing. If you have any doubt, please note down that. From video you can get the slides right. From video you can catch, and if you have any doubts you can ask me back. Okay, so we'll meet at 11:10. Bye. This video is fine? Yeah, I think I can see. Are we ready? 11:15. So after DFA, the next important topic is regular expression, right? Everybody knows this point. Just give me a second. Yeah, perfect. Let's move to the next important topic. Good to go. Still some people are not back. Okay, anybody want to know about regular expression definition? Yes, regular expression has the operators where you have total 4 operators, 2 unary and 2 binary operators. 2 unary operators, 2 binary operators. So these 4 operators will help us to represent a regular language. Like in finite automata we have 5 parameters, right? Q, sigma, delta, Q naught, F. Those 5 parameters will help us to represent a finite automata. Here the 4 operators will help us to represent a regular expression, okay, which is similar definition of course. So if you want to write any regular expression, you can use any of these 4 operators to write a regular expression, okay. And obviously the operands again are the sub expressions. If you want to represent any expression, right, operators, operands are 2 types. Operands again they are expressions only, but only operators if you have to learn properly. The 4 operators, they are unary and binary. Okay, let's start with, I don't refer the slides, guys. So you can refer the slides. So how many total operators we have? 4. For that, let's discuss one by one clearly. One is R, other one is concatenation, other one is clinistar and cliniplus. Of course, you can also use 3 operators. Clinistar, cliniplus, not having much difference. Okay. So we have R. Oh, this plus is different from other subject a plus. Don't call it as addition. Of course, it looks like addition. Don't call it as logical R, because logical R in digital logic R is different. This R is between 2 regular expressions. Is that clear? This R is between 2 regular expressions. This R is between 2 regular expressions. It is not between 2 digital expressions. It is not between 2 mathematical expressions. Remember that too. Okay, many people I have seen they used to study like addition, multiplication. They are not addition, multiplication. Okay, so don't do that. This is not a multiplication. Concatenation. Maybe you can call it as a product, but it is not a multiplication. Okay, but it is a dot. Concatenation. Other one is not a multiplication. It is a clinistar, or you can call clinic closure, the star. This is a unary operator. Another one, cliniplus. Use the plus. See, in both of them we have the plus, but they don't have the same name, they don't have the same meaning. This is a binary operator and that is a unary operator. Is that clear? So mainly we have 3 operators, and these 2 operators almost same except one small difference. Okay, both of them are just like repetition only. So this looks like the similar to the for loop in programming languages, for loop, because star means you need to repeat multiple times. Here plus also you need to repeat at least 1 time. Star means at least 0 times. So this just looks like a for loop, and this one looks like if condition. You know if condition, right? If else. If true, go to this side. If false, go to this side. This is similar to if else condition, but of course there is no condition here. You can take any choice. This one just looks like 2 statements, one after other. If I have the program, right, 2 statements like x is equal 10, then y is equal 5. Just one after other you need to execute compulsorily without any restriction. So concatenation is also same. This followed by that. This followed by that. These 2 are binary. I'm going to write. I did not write it, right? I'm just speaking. Okay. So this one R1 plus 2. You see that the plus, how do we use 2 operands required? Concatenation R1 R2. I did not write anything, means there is a dot in between. Okay. So you have 2 operands to represent, and clinistar just one expression whole star, and cliniplus R plus. You see that there are 2 binary operators and there are 2 unary operators. Okay. Why it's is it buffering? Is it fine? The video, is it running? Any issue here? Is that video clear? Because I can see the video is buffering now. Any issue with the internet? Okay, I'll just check. Let's see what's going to happen. I think it's set. Strength is clear, excellent. Let me refresh once. Now okay? Right. Yeah, just let me see. Now good. Okay, maybe glitch in internet. Let me know. Please type if you are facing an issue. Okay. Just refresh. Those people are still facing an issue. Now see here. This is like either this or this. Never assume that both are executed, right? It's just like two statements. Either you can take this or this. So you cannot take both. So here you have R1 and you have R2. You can take any one of them only, but you can't take both together, R1, R2. No, you can't take R2, R1. Is that clear? So if anybody writing the plus, that means go this side or this side, take any one, right? You cannot take both simultaneously. You have R1 strings or you have R2 strings, but you can't have R1 dot R2 strings. You cannot take together. Suppose anybody writing A plus B, it means in the language you have only two strings. If anybody writing pi plus A, that means in the language you have only A, because pi can't generate even single string. If anybody writes epsilon plus A, oh, epsilon is different string. So in the language you will have epsilon separately, A separately. In the language, if suppose you have any other like AB plus triple A, then language will have two strings, either AB or triple A. But you will not have something like AB triple A. Can you see that? No. Everybody? So are you able to understand? So left side and right side. If you have really bigger expression, because they are only strings, right? Sometimes you will have a very big expressions. Then how do you understand? You should say that, oh, language is L of R1, means whatever R1 generates, union, and whatever R2 generates. But never take R1, R2 together. Done? So how do you speak this? You speak something like either R1 or R2, but don't take both. Now this one, oh, both are must. You can't have only R1. You can't take only R2. The expression will decide if the result is R1 or R2, but you should never take only R1. You should take both. The result may be R1, but that after taking both of them. If R2 really epsilon, the result might be R1. That expression decides, but you should not. You should consider both of them only. R1, R2. But you cannot take reverse. R2, R1 also you cannot take. So how do you speak this? Here R1 followed by, it's not either, R1 followed by R2. That means sequence is very important. You need to follow this sequence only. But here there is no sequence. You can go to this side or this side. So there is no kind of sequence there. Everybody, any doubt in the R1, R2? Example, suppose you have A dot B. It means language has only one string AB. In case if I have something like A dot, then Oh, I can't take any string from pi. That means you can't get any string. Your language is pi, nothing. You can't get even one string when a dot pi is there, because from the pi you can't get anything. At least if you have epsilon, right? Oh, that means I can get a at least, because a followed by epsilon means 0 symbols. I can get a from here. I can get this is equal to just a, but this is equal to pi. This is equal to ab. Right? No doubt so far. So mostly people confuses here, but I have a clarity. Dot pi means pi acts like a dominator, annihilator. So pi is going to be dominate whole concatenation operation. Okay. Yeah. So remaining examples we'll see later. In case if you see any bigger expressions like r1 dot r2, then you should write a language like language of r1, means language, all the strings generated by r1 you can take as a set, put a concatenation language represented by r2. Okay. Sometimes we have bigger expressions, right? Like a plus b dot, like ab plus epsilon. How do you write it? You should write something like this. The language is, oh, here ab is there, that means here a comma b is there, a comma b dot, that is epsilon comma ab. You need to concatenate. How do you concatenate? One after other. A dot epsilon. Look at carefully here. How do you concatenate? A dot epsilon. That is just like a dot epsilon. That is a. And a dot another one. A dot ab. So this is a dot ab. That is aab. Aab. And this one b dot epsilon. B dot epsilon is a b only. You can write a b. And b dot ab is bab. If any string is repeated, don't take twice, take only once. So how do you do concatenation of two expressions? Remember that here you have two choices. You can take any one of them. Here you have two choices. You take any one of them, but dot is must. So take one of them, then you will get concatenation of two strings, 1, 1. But anyone. That's why AAB, A epsilon, BAB, B epsilon. So look at how do you apply that concatenation. Any doubt? We need to practice, of course. Definition I am explaining. Is that clear so far? R concatenation. Now this is the cleanest star. What do you mean by cleanest star? Cleanest star means R can be repeated in the concatenation any number of times. So this R star means you can write R power 0, you can write R power 1 means R, you can write R dot R means that is R square, basically R square. R power 3 means you can repeat R 3 times in the concatenation. You can write R power 4, you can write R power 5. You decide how many powers you want to take, because all powers are there. Here, how do you speak? This one is cleanest star or clinic closure of R. Clinic closure or cleanest star of R. Here clinic plus of R. So how do you write here? Oh, here R power 0 is not there. Okay, you should take minimum one time. You decide how many times you want to repeat that R. You have all the times, but except 0 time. Then to understand this too, we need one more slide. If anybody writes something like A star, what do you mean by it? Well, in that language, you have epsilon, you have 1A, you have 2A, you have 3A, and so on. If anybody writes AB whole star, then in that language, you have epsilon, you have 1 time AB, you have 2 times AB, you have 3 times AB, you have 4 times AB, and so on. If anybody writes A plus, it means that language is not having epsilon, but it is having 1A, 2A's, 3A's, and so on. If anybody writes AB whole plus, then language is having minimum 1 AB, epsilon is not there, 2 AB's, means AB followed by AB, and so on. Now the problem is, any doubt so far? I'm coming, Ranjan. I'm coming for that. Not practiced it, right? Just definition I'm introducing. Now if anybody writes a plus b square, it means a plus b dot a plus b. 2 times you have to take. But each time you can take a or b, because 2 times you are going inside. That is the meaning. Loop you are executing 2 times. In that loop there are 2 optional statements are there. Either this statement or this statement you can execute, like if else, but there is no condition. Okay, but if else is depends on condition, you know, right? So you can take a or b first time, second time also you can take a or b. So this will convert as a or a b. You have 4 strings coming here. b a, b b. It means it is going to give you set of all 2 length strings over a comma b. This can be written as sigma square. It is going to give you set of all 2 length strings. Everybody clear? That's why sigma star will give you all strings. Sigma power 3 will give you set of all 3 length. Sigma power k will give you set of all k length. So you decide if you want 100 length, sigma power 100. That means a plus b power 100, you will get every 100 length. Because 100 times you go inside, each time you can pick either a or b, is your decision. Right? Now let me help you to understand how you can I have written something, right? I have written something. I want you to understand. Okay, let me write one more. Very sorry. Just me write one more here. Plus, just to make you, understand what is it. Not AB, something else. B star whole plus. Okay. Now I have given something. I just want to find what is the minimum string that is generated from here. So I want to look at first any 0 length. I'll just try like this. Epsilon AB. Who is going to generate? Can you help me? 3 length also I'm writing here. Which strings are generated? Can you help me? Because in the exam they will ask how many 3 length strings are generated, how many 2 length strings are generated, how many 4 length strings are generated. Then you should know exactly how to look at here. How many strings up to 3 length? So this could be a numerical type gate question for you. Can you tell me 0 length, is it possible? Total how many strings? How many of this? I'm asking the question. How many strings generated up to 3 length? I want to know the count. Let's see. Up to 3 length. Here 8, 4 plus 12, 16, 17 strings are given to you. Out of 17, how many are generated? Let's check. Somebody saying no. Very dangerous statement. How many of you know that epsilon is there? Not from out, but in B star, B power 0. AB is minimum chanchal. Can't you see B power 0 here? How do you get epsilon? How do you get power 1? But here you have a B power 0. See that angle. I have 2 choices. I can go this side. I can get a B power 0. This plus is very important. You have the choices. Both sides you can go. You can find out where is the minimum. Okay. Epsilon helped. Remaining you need to try on your own. Can you get single A? No. I'll just write on my answers. You try your answers. B possible. Double A no. AB yes. B A no. BB yes. Triple A no. And AB no. AB A no. ABB yes. B double A no. BAB yes. BB A no. B, 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 S. 1, 2, 3, 4, 5, 6, 7. How many answered? 7. So now ask me the question, which one you are not able to understand from here? So those people who are able to understand why that is generating, why that is not generating, that means you know exactly how to look at this expression. Right? Most of the people in the beginning really struggles to understand what is this means, how to read this. See, this one says greater than or equal to 1. This one says greater than or equal to 0. This one says R. This one says greater than or equal to 1. And this one is something is there here. So now how do you look at? Oh, this demands go inside. When you go inside, you have two options. Any one you can take, any side you can go. But how many times? First time I go here, this demands go inside at least once. You can, if you go twice, right? First time I can go this side, second time I can go this side, is my choice. Now look at A, I can't generate because if I go this, single A cannot come, AB comes, but single A cannot come. B, oh this side I can go B power 1 I can take because I have a choice. And this one, how I go at least once, and of course 2 times also you can go, 2 times also you can get. First time I take epsilon, second times I can take a B. I have a choice, not only one. So here I will go for B power 1. This one, no, not possible anyhow. This one, how? You have AB, right? So this time you can go, anyhow this is not possible, okay. Next one, you take here AB power 1 and here 1. And BA, BB, how can you go? You can go twice. Of course others are also having options. Here you can take B power 2. This side don't go at all. 2 times, oh sorry, 1 time only. 1 time enough. No need to go twice because B power 2 option is there. If you go twice, every time you take a B. And ABB, how do you get? Oh, you need to go twice. But first time you take AB, second time you take a B. Remember that. You can't get both at a time. You can repeat. The first time you can AB, dot is there, second time you take a B. So you have 2 choices. You go this side and later you go that side. Right? And last triple B, every time you take a B only. So 3 times you go, you take 1 B, or at least go one time you take a B power 3. That is also fine. 3 times no need to go. You have a lot of choices here. How epsilon possible? That is what I have clearly mentioned, right? I have clearly mentioned here. Go at least once. I am going at least once. Inside you have 2 options. Take a B power 0. What is a B power 0? Means epsilon only, right? Here epsilon is there. Oh, do you want to see some other way? Let me help you. The meaning of this one, okay? The meaning of this one. This means AB, AB square, and so on. Union. This means epsilon, 1B, B square, and so on. Now you see, you go inside, can you get epsilon or not? You have it, right? What is this? You can get it, right? Here at least once I go inside, I got epsilon. Why can't I get? Come on, Lokesh, you can see that epsilon, right? So when you look at this union, right, indirectly what we are saying, you have epsilon, you have AB, you have a B, AB square, B square. You can get any one of them, right? Third last, ABB. Oh, very simple, ABB. How do you get? Because of this place, I can go twice. But first time, I pick AB. Second time, I pick this B. So ABB, what is that? Third last, BAB, no? I'm very sorry. BAB, how do you get? Reverse. I explained reversely. Okay, let me go another side, another time. So go twice. The first time, take B. How do you take? This B you take. The second time, take this AB. You got it, right? BAB. You want BAB, right? You need to look at, that's why, you know, those people who are good at for loops in programming, recursion in programming, for them it is so easy. Only those people who are not able to understand the looping, because every time you don't execute the same statement, here there are infinite statements are there in the loop, but you have the option anybody to execute. So now when I go inside the loop, Oh, so many are there. Which one you will pick? That depends on which order you are looking for. Triple A. So I need to look at A first. Oh, I have A, but second A I can't get from there. So that sequence will help you which one to pick. The first one I need epsilon. That means I look for, here do I have epsilon, here do I have epsilon. I look inside, where is my epsilon? Okay. What order? This plus means anything is fine. That's what I told. Did you forget the definition of plus, yaar? Did you forget the definition of the plus? R1 plus R2 means I can take R1, I can take R2, but R1, R2 I can't take. I can take any one, any order, right? Only R2 I can pick if I want it. Only R1 I can pick. There is no order. There is no order, yaar. Why are you looking order? The plus means any one only, not both. There is no order here. Only this side or this side. Here there is order, here there is order, here there is order. Here pick R1 or pick R2. Where is the order matters? Which one you pick, you decide, no? There is no order concept at all. There is no order. Here you see, I can pick A, I can pick A, that's why double A. For this one what I did, I pick A, I pick B, it's my choice. Okay. So any doubts so far? Come on, come on. Any doubts so far? This is one of the important expression for you to understand concatenation or clinic closure, positive closure. All the four I kept in one place to look at how the strings are generated. In the exam, they may ask many kinds of questions. How many 3 length strings? Then answer is 3 only, because 3 length this much only. How many 2 length? Look at this, 2 only. How many 1 length? 1. This is how you should answer. How many length? How many strings up to 3 length? Then 7. Just now we answered. Everybody clear? So this kind of questions you face, but expression might be very simple, but I have taken, a little bit lengthy and complex. Good. So are we ready to write expressions? Before that, let me solve some questions for you. Okay. So many people may not aware, right? Okay, it's indirectly I am trying to say what is R plus R. Okay, so just tell me what is the simplified expression. Will it be same or different? Will it be same or different? R plus R means R union R. Is it same or different? It should be same. It should be same. Okay. No confusion here? Because indirectly what you are saying, the same strings union same strings, right? Both sides same strings are only there. When you do the union, so this one you can write something like, whenever you see A plus B, you can write many ways, like A union B, A bar B, or simply A or B. All are same. The indirectly you are getting the set A comma B. That's the meaning. Okay, you don't get AB here, you don't get BA. So this is the meaning. In the exam, we don't know how do they speak. So you should know the concept of this one. Okay, this R is a regular expression keyword. Okay, use that, not English language like A or B means both might happen. That's a different one. Okay, so this avoid if you really don't want. Just say A comma B. Any other? So keep this in mind. So they can use any operator, all are same. Comma in the set, bar between two expressions, union and plus. All means same regular expression or operation. Next. Pi dot pi, epsilon dot epsilon, A dot A, R dot R. Is it same or not? I'll come to that. Pi plus epsilon, I'll come to that. Let's focus on what I am asking right now, okay? So somebody asked, right, it's a digital expression, I'm getting a doubt, right? So because in the digital expression, x dot x means it's and, it will be x in digital logic. in digital. Here dot means and. Here in TOC, x dot x means x square. How many times x is repeated? Here dot means concatenation in TOC. So first let's know what is that in TOC, what is the name of the dot. It is not the same as digital logic. Digital logic, it is AND operation. It's a bitwise operation. It's not a bit, it is a string here, concatenation. X dot x, you will get x square. Whether it is equal to x or not, R will decide. No, you can't say it. R dot R, that R will decide, but we know only R square, that R square is equal to R or not. What R has will decide. You can't decide without looking at R. Right? Remember that. Is it equal to R or not? That R will decide. If R has epsilon, epsilon square will be epsilon. If R has A, then A square will not be equal to A. So R will decide whether it is R square is R or not, but never say equal to R directly. So A dot A is not equal to A, it's just A square, that's it. Epsilon epsilon, see, that is equal to epsilon, that's fine. Pi dot pi, it's anyhow nothing generated, pi only. So this is what the meaning of same expression when it repeats. Look at what that expression has, that will decide. Everybody, if I write AB dot AB, well, you can only write AB whole square, nothing else. Everybody, if I write AB dot pi, oh, then answer will become pi, because from pi you can't get anything, so you can't concatenate it all. Any doubts here? Of course, we'll mix it. We'll mix it. Just I'm waiting for the understanding of that plus sign dot. Everybody got? The same expression comes twice, how you decide it. Okay, let's mix up all the expressions like pi plus epsilon. Somebody was asking pi dot epsilon, pi plus A, pi dot A. With pi, all meanings I am writing here with pi. Okay, epsilon, some of them are covered. Now let's go for epsilon. Epsilon plus A, epsilon dot A. Okay, that's fine, I guess. Yeah, quickly complete it, then we'll move to the writing expressions. Yeah, that's a property. You can use the domination if you know that. Otherwise, understand the meaning of the expression. Because you can't map with the properties, right? Just look at and understand quickly. I'll write the properties here if you want it after this. Pi comma epsilon never be there. Pi means what? Nothing. Pi is not a string. Never write pi comma epsilon. Never, never. Please don't write. This is not a string. Oh, please don't do that ever. That is an empty expression, this is an empty string. Both are completely different. Empty expression means it generates no string. Epsilon means it generates one string. So this is just epsilon. Oh, this is nothing, because from here, from empty set and epsilon, here if you want to concatenate, right, you have no string here. At least somebody should be there like epsilon. If you have A dot epsilon, right, so you can take A, you can take epsilon, A dot epsilon, you can get A. So that you can write in the result. But here you get nothing, no string, dot epsilon, no string at all. Pi plus A, union. Union means, oh, pi gives nothing, A gives A. So you will get A. And pi dot A, from pi you can't get even single string, so result is pi. So pi dot anything, remember always pi. Pi dot, in the concatenation, you see the pi, whole result will be pi. That means while you are executing the program, operating system stuck at one place, then whole program cannot execute. The same way, that meaning. So here, epsilon is one string, A is another string, you can't reduce. This is the same, you can't reduce at all. Epsilon dot A. So 0 symbols followed by 1 symbol will be 1 symbol, that will become A. is that? Star? Why are you going for Saurabh Ranjan? Just wait for the clean star clinic closure, right? Wait for some time. There you ask, please. Stars, just wait for that. No, it's not 0. Behaves, but that's fine. 0 multiply with anything is 0, right? Same way. But 0 is a different language, mathematical language, and multiplication is mathematics, not here. Don't use that. Now epsilon comes, you will confuse what to assume. Okay? Epsilon just you assume like a 1 here only. But for multiplication, for dot only you assume that way. But plus is a different concept. You can't assume like a 1, you can't assume like a 0. Yeah, pi if you assume like a 0, 0 plus epsilon, for this it may work, but the whole thing concept is different. Mathematics and TOC, please don't combine. These are the strings. Unnecessarily you confuse 0 and 1. Okay, don't change your mind. Keep complete focus on the TOC. Because you can't apply these properties everywhere. Fine. So let's move to little bit clean closure and positive closure. A star plus A star and A plus plus A plus. Did I give any numbering? No, right? Yeah, that's good. Let's number here. 3. A star plus A plus. 4. Concatenation. A star dot A star. 5th. A plus dot A plus. 6th. A star dot A plus. Okay. Can someone give correct answers? Very, very simple questions, but just based on definition only you should answer. Don't think they are very big, very small and just basics. Same expression putting 2 times union. So 2 times we are taking the same operand in the union. So what happens? I'll explain the meaning, but you can't do that every time. If anybody not understood, I will give you clear meaning, but do not use the same kind of steps every time. Okay, for understanding, I'm going to write in detail. Anybody has a confusion, they can get a clarity from this slide. But in the next coming slides, I don't do that way. Okay, A star union A star. That means you have epsilon A square. Just you are doing the union twice. The same thing, right? When you do the same thing twice, what do you get? You get A star only, right? A star union A star, it is A star. And A plus union A plus, what is it? It is A plus. So convert this plus to union, but dot you can't convert into anything else. A star union A plus. Oh. Here A star is a superset of A plus. So A star union A plus. So A plus already there. How many of you know the relation? A star is actually the A plus union epsilon. So when you combine these two, you will get A star. So that means when I do A star union A plus, you can always write A star only. Why? This A plus strings already covered in A star. So which is equal to A star. Now another one, A star dot A star. So this is going to be simply equal to A star dot epsilon. How is that? So how can be? This is where the people confuses a lot. A star dot A star. What is the meaning of A star? Epsilon A square and so on. Dot another A star. Epsilon A square and so on. The result we have to look at, what do we get here? Here, do you have everything? Look at here. Epsilon, you take concatenation with epsilon. A a square. That means you got every string. These are not required at all. Not required concatenation because they are already covered by this epsilon. See, a dot epsilon. That a is covered already by epsilon dot a. So this is epsilon dot a is same as that a dot, a dot epsilon. This was already covered. Now a dot a, that a square is already covered by epsilon dot a square. You can see that. That means this simply you will get epsilon a square everything which is equal to a star. So understand, get the meaning of this one. Don't blindly say r dot r is r. Not happens all the time. Okay. So here that epsilon can help you. One epsilon can help you whole concatenation. Here a plus, but this one don't say a plus. Why you don't say a plus? A plus dot a plus. Here the minimum is 1a. There's one more mistake. We may do it by saying a plus is wrong. Why? The minimum string when you do concatenation, you will get minimum is a power 2. The next you will get a power 3. Here impossible. Here a power 1 is not belongs to here. So single a is not there. So this one will give you minimum 2 a's. Then after that any number of a's you can. So this one, after that you can put a star if you want, or you can write this a star, you can combine as a plus, or you can write a plus a, all going to be the same. So this is one of the important concept for you, that minimum 2 a's you can write so many ways. So I'm just writing here minimum 2 a's, that I can write double a, then followed by any number of a's, that I can write a star. Of course a star you don't need to put at the end, you can put anywhere of course. Just you can also write a plus, you can also write a plus a. Because 1a can do, in this 1a, we just concatenate, the same thing happened with the remaining all, it dominates. Here a star, put epsilon, that epsilon dot a plus can dominate remaining all choices. So many of you did that. But understanding is important. There is no shortcut for this, except your definition and understanding. Those people who don't know the definition, they don't get the right answer. Remember that? Here there is no shortcut why a star dot a plus is a plus. Only by understanding what a star and what a plus has, the result what you get. Result you get at least 1a. Why not epsilon? Because this is a dot and both must, and here minimum is a, here minimum is epsilon. The result is minimum is a. This is a trick. That's how you can ignore the epsilon, because epsilon never comes from here. Everybody? So those people who are assuming epsilon is there, they are wrong. Epsilon is there only one side. In the concatenation, that epsilon is identity. That is going to be ignored. Everyone? Minimum string is always the key for all these concepts. For all this concept, minimum string you understand, the remaining strings automatically will get idea. So how do you get the minimum string? Epsilon both sides is there, 1a both sides is there, 1a is the minimum. Here epsilon is one side, so epsilon is the minimum. Epsilon dot epsilon, epsilon is the minimum. 1a, 2a is the minimum, 2a is the key for this. And here epsilon dot a, 1a is the minimum. So when you get the minimum, then you will get the right option also most of the times. So how many of you got this point? A star dot a star is actually called as a star whole square, right? A plus means a plus 2 times you have written. Everybody, so remember this point, a star you have written twice, a plus you have written twice means a plus square. Done? I'm going for the most important, the combination a star whole star. Don't know how many can interpret properly. A plus whole plus 9, a star whole plus 2. It's called as nested loops, one outer loop, one inner loop. So just like loops exactly. You know the nested loop concept, right? Same way. Once you understand this, I write whatever you can easily explain. This side I'll write. So once you understand, then only you come to this side. Okay, otherwise don't. This answer? Good. A star, A plus, mostly. So how many got the right answer? Just cross check. Those people who don't get, please ask me. A star, A plus, and then here you will have A star. Here you will have A star. Here you will have A star, A plus, and A star. Only the one question that how many of you see the epsilon, that is very important. How many of you can see the epsilon? Here can you see the epsilon? Outside you can take 1, but inside you can take a power 0. There's epsilon power 1, you have epsilon. So whether you have epsilon or not is the key, right? If you don't know how to get epsilon, that you should try first. That you should try. Minimum string is the key here. Minimum string is the key here. How many of you got the minimum string? The minimum, how did you get minimum here? Oh, you get a power 0 is epsilon. How do you get a minimum here? A power 1, that is A. How do you get a minimum here? Minimum is a power 0 power 1, that is epsilon power 1 is the epsilon. And this one, how do you get a minimum? Minimum is a power 1 power star. Oh, a plus only you take, but minimum take a power 0, that's enough. This power 0 means epsilon. Anything power 0 is epsilon, remember that. And minimum is so easy, all power zeros, even not required, just take it outside power 0. This power, even here you can take a star, not a problem, right? I took the 0, but 0 is also not required. This one, you just take outside, you have a 0, right? Something power 0 is epsilon all the time. Here, oh, everything is the minimum 1, that's why you got A. This one, outside you take a power 0. Outside only you take a power 0, it's epsilon. 10th one, I'm explaining, right? 10th one only I'm explaining. What is the meaning of this one? Meaning of this one is A plus power 0, union A plus power 1, union A plus power 2, union, and so on. This is epsilon, union, this is A plus, union, this is A plus whole square, and you see these two only enough. Epsilon, union, A plus, you got A star. These all are redundant terms. Everyone? Yeah, happy Republic Day to everyone. I hope this new year, this Republic Day brings you smile after the GATE exam. Okay? You're very near to your GATE exam too, right? Yeah, happy Republic Day once again to all. So you got the Anjali right, 10th one. So you got a meaning A star, but not by simplifying. It's not a mathematical expression to simplify them. Never look like this as simple expressions, okay? Don't try to answer just by ignoring the meaning. You need to look at the meaning. So any question that you have a problem, please ask me. I'll explain the meaning, how you conclude it. Apply simply definition. Power star means power 0, power 1, power 2. In that I understood power 0 union power 1 only, you got every string. Then why do you want a power 2? Power 2 is already inside power 1 and 0. But this A2 length, right? Minimum 2 is already covered in the minimum 1A. So understand it. Anything power 0, those people who don't know, oh, let me write that. Pi power 0, epsilon, A power 0, epsilon, AB power 0, epsilon, and epsilon power 0, epsilon. This is TOC, right? It means take the 0 number of symbols in this expression when you take epsilon. So it doesn't matter, you are just looking at R. R could be anything, just it is epsilon. Oh, that could be anything in the world. Okay, here power 0 means take 0 symbols from that expression which will give you epsilon. Right? It's, don't look at it all. Don't look inside ever, because if you look inside, you will get confusion what to take. You no need to look at inside, right? So take 0 symbols from whatever I give, it means epsilon. Whether I give 5 or a, it doesn't matter, it is just epsilon. Okay. But power 1, it's different completely. You need to look at now, you will get a pi. You will need to look at, you will get a. You will need to look at, you will get exactly same, right? R power 1 is actually R. Okay. Power 2 something different. When you say power 2, you need to repeat that. Pi dot pi is actually pi, and a power 2 is a dot a. AB power 2 is AB AB. Epsilon power 2 is epsilon, epsilon is epsilon, right? R power 2 is RR. Okay, you got my point, I guess. Everyone, can we write regular expressions now? Before this, any other important regular expression? Let me see. Okay, good. 14, right? So just, conclude the meaning later. 14 done. Let me go to the last slide. Yeah, before this. So can you fill up this? I have given this is already with the meaning. Can you cross check that later? I don't want to read the slides. That's why I just kept here. You can just cross check later, and all the equivalent expressions you can write later. So you have a plus b. You can't simplify. A plus a is a plus pi is a. So now I'm going to give you some properties. Right, you have all the definitions clearly, no doubt with this positive closure and cleanly plus, yeah, this one. So what is the meaning of identity? So let me write these points clearly. R plus pi is that pi plus r equal to r. It means pi acts as an identity for r operator. Is that clear? What is this means? This is the first one. This is the first one. So I am writing the meaning of the first one. Why pi is called as an identity for r operation? Because the r plus pi, pi plus r is always r. The second one, concatenation identity. What is that concatenation identity? R dot epsilon, epsilon dot r, you will get r. So that's why we call epsilon is identity. It will not have an importance when the concatenation is present, right? Pi has no importance when you are doing r with some expression. So that's why pi is deleted simply, because pi can't generate any string. Even epsilon generates epsilon, but epsilon meaning is 0 symbols. R followed by 0, you will get r only. R followed by 0 symbols, you will get r only. Okay, third. Any doubt so far? No, right? Associative means very simple. Third one. Anybody knows associative? R1 plus R2 plus R3. There are 2 plus, there are 2 R. Which R you evaluate first? Let's say this is a left associative, means left plus. This is a right associative, means right plus. Do whatever, the final result will be R1 union R2 union R3. So this, any of this associativity will give you same answer. So in the regular expression, whether you write left associative or right associative over the R, you will get the same answer. So whenever I give A plus B plus C, you do whatever. You do this first or this first, the answer will be finally, the set will have the 3 strings. Clear this point? Because this answer will never change when you change the parenthesis. The fourth one. For concatenation also, R1, R2, R3. So you have 2 dots inside. So which dot you do first? Left one or right one? Doesn't matter. Always they are same. The string will be, let's say, if I take ABC, do this first or do this first, the final result will be ABC only. So the result will never change. That's why the associativity is satisfied for concatenation as well as OR operation, right? This 4 you understood, right? The fifth one, sorry. Fifth one. What is the fifth one? Commutative. Commutative means operand switching, like R1 plus R2. Is it same as R2 plus R1? Always. Doesn't matter, right? That's why, here R1, R2 string is not there. It's not the order, right? Any one, R1 or R2. So you can speak in any order, doesn't matter, because result contains union only. Right? In the set, the order of the elements doesn't matter in the set. The same way, the strings, how do you generate? R1 do you generate first, or R2 you generate first? Doesn't matter at all. Sixth. So this is where it is important. Why? Because R1, R2 need not be same as R2, R1. It may be or may not be. That's why this operation, concatenation operation, is not going to hold commutative property. So never write R1, R2 is same as R2, R1. Only sometimes equal happens, not all the time. Is that clear? R1, R2 need not be same as R2, R1. Sometimes equal, sometimes not equal. That's why this property is not going to hold. R1, R2 equal to R2, R1 does not hold. Is that clear? This property is not going to hold. Oh, annihilator, the seventh. The 7. R union sigma star. Union means plus here. Union means plus. R plus sigma star plus R. What will happen? The result will be dominated by sigma star. So you can call this as a dominator, annihilator or dominator. So this sigma star is called as dominator for R, and concatenation, I was talking about that. R dot pi is same as pi dot R. What is it? Pi. So this pi is the dominator for concatenation. So earlier somebody was asking about the properties, right? You were confusing between digital and the T-Boost regular expression. So please consider this. Now we are ready to write regular expressions. Are you ready? So far I was only talking about what is regular expression, guys. I did not explain what is actually, how do you write regular expressions. Right? So far we did not consider the problems at all. So now you got an idea, what do you mean by operation? What are these 4 operators, how we deal in expressions? Ready? Okay, let's start writing regular expressions now. Okay, you only write, I'll just write the problem. If you understood the answer, please write yourself, okay? I want regular expression. Also, if you want, you can answer number of states in DFA. Both you can mention. So they are very simple problems for both DFA and regular expressions. Main focus is on regular expressions, but also you can focus on DFA if you really need it. So write regular expressions for this 4. Anybody answered? Perfectly. Okay, pi. Okay, so I'm writing regular expression, right? So what is the regular expression for this one? Is there any string which is having less than 0 length? Do you have anything? No, right? So here regular expression will be pi, but in the exam you may not see the pi. So they may give you pi dot a or pi dot ab, anything, doesn't matter. Pi dot is there, answer is pi, or a dot pi, doesn't matter. So pi square, pi power 100, anything that gives you meaning of pi is the answer. Is that clear? If you don't see the pi, you may see some other form like this. How many answers, how many regular expressions are there? Infinite. In the exam they could ask anything. Is that clear, everyone? Okay, they can ask any, because we don't know how do they make the options, right? Based on their instance at that time, what do they think, based on that they will decide the options. Okay, next one. Oh, 0 length strings. I want all 0 length strings. What are there in the world? Only epsilon is there here. But do you think they will ask epsilon in the options? No. They may say pi star. They may say, what else? Epsilon star. What else I can say? I can say AB power 0. Doesn't matter. That gives you some epsilon. Clear? MSQ, yes, exactly. These days MSQs were very popular, right? They may ask all the options in exam. So MSQ type is very dangerous these days. You believe only one is the answer, but others are also possible answer sometimes. And now minimum 0 means everything comes in that, right? It means equal to sigma star, right? You know, right? R is equal, you can represent now sigma star, everything comes including 0 length. What else? The same as a comma b, of course. Expression you want to write, right? Expression you just write like this, a plus b whole star. Now there is an issue. This is a very, very famous expression for the GATE exam. I am putting 3 stars and don't know how many infinite answers are there. Correct? So TOC is the one subject where it helps you to analyze how you should think about for the questions. It looks like you know it, but unless you know the concept, you can't answer it. Everybody got? Sometimes you are getting answer, sometimes you are not getting answer, means you are not focusing on the concepts. That is a true. Believe in your concepts, that will help you to come up with the right answer. But first time it will take time. The second time, once you know the concept, it comes very quickly. How I remember this many concepts here? Am I looking at any textbook? No, right? But every time I teach, I never teach the same way, because only concepts are there in the brain I was delivering. Okay, this one, I am coming to this one next. What does this means? Other than 0, everybody. How many of you know length of the W greater than 0 is same as anybody? Length of W not equal to 0 is same as length of W, what else? Greater than or equal to 1. Everybody know that point? Is that everybody know that point? You want all the strings more than 0 length is same as other than 0 everybody. In mathematics this is not the same, because negative numbers are also there, but in TOC there is no negative length. That's why the greater than 0 is same as not equal to 0, not equal to 0 same as greater than or equal to 1. Everybody able to understand this point? That means minimum 1 length. How do you represent minimum 1 length? Sigma plus a plus b whole plus. Correct? Now the question is, this is so important, and I don't know how much time you spend to revise this, but this one you need to focus a lot. Okay, any doubt here before going to the third one? Third, you need to go very deeper to understand how many important equivalent expressions are there. I'll write all of them, just you need to check later. So here a plus b whole star. Okay, how many you want to write? Which are so important, like r star is equal to r plus epsilon, like r star is equal to r plus epsilon. Correct? And that epsilon no need to write outside, you can also keep inside to generate. Without this I can generate everything, but when I put this I can generate even epsilon that was not there earlier. So except epsilon you can generate everything when you don't have epsilon. Any other? So these two are very simple expressions. Okay. So do not worry about these forms, only you need to focus on will you get every string or not? Will you get every string or not? Whatever I write here, they're all equivalent, only the way I am writing is might look different. Equal to, I can write lot of things like this: a star, b star, a star, whole star, or b star. I don't know how many ways I can write, infinite ways. Sometimes we write a plus b, a star plus b star whole star, or a star plus b star whole plus. This never stops basically. The focus is on how do you get all strings. The focus is on how do you get all strings. The cautious, and remember these things are very dangerous. A plus b plus whole star. The issue is here, single a you can't generate, single b you can't generate, even though you generate epsilon. So remember here a plus b plus never write. When you do that you are in trouble. So don't include this. This is not same, this can't generate everything. So don't include this expression, this kind of expression especially. Okay, don't include this. Okay, now the question is which one you want to understand, why that is equivalent to a plus b whole star. Because writing is, I know many things, I can write lot of things, but I don't want to waste the time to write so many things. Which one you are not able to understand, that is equivalent to a plus b whole star. That I'll explain the same way you focus on others. Anybody want that is equivalent to a plus b whole star that you are not able to understand? If you are all clear, then absolutely all right. Why all clear? Because epsilon I can generate, a I can generate, b I can generate, 2 length, 3 length, 4 length, that's enough to understand. Second column, first one. Oh, that's so simple, that is same as this one. Where is that? This one, just a power 0 you take, that's matching with this one, right? If you can understand this, that is already done. If this can do everything, that can do everything. By adding many things, you can't go more than a plus b whole star, right? If this you understood, oh, that you can't observe. Here put a power 0, you got the same one, then this is doing everything. Why do you want that? Right. First you focus this one. Yeah, ask the questions like somebody was asking, right? A star b whole star. Why this can't do everything, not equal to a plus b whole star? Because here how you generate single a. Forget about many strings. Epsilon you can, but single a how? If you try to go for a, b also comes. Single a can't come. But when you put a plus in between, you can go to a, you can get it. Is that clear? Single a you don't get from here. You can't think about this expression at all. Any other? Understood? Come on, nice. Can we write expressions quickly? But there are many answers. You can write on your own. So I'll just take one expression. Can you think about it? So I'm just writing something. Just think about it. Your focus is on, may I get A plus B whole star? Yes, Anjali, there are many such things, but you are missing something there. Can I say this is equal to A plus B whole star? So how you get that? So focus on, can I get A here? Yes. Can I get a B here? Yes. So somehow you logically think, sometimes very easy, logically think, can I get A here? You want A, go this side. You want B, go this side. And you can repeat any number of times. The focus on what do you need. That sometimes you get directly, sometimes you don't understand how to get. But observe the strings. When you don't understand this way, right? So observe. Oh, epsilon, yes. A, S, B, S, double A, S, A, B, S. So after some time you will conclude that, oh, I have some sequence to get every string. Got my point? Now I'm going to write one important such expression. You tell me how many I have written equivalent so far. So many, right? So many. Okay, I'm writing again. So now you look at. Don't ask me why I'm writing this, because I know I'm writing it. Just tell me, are they equivalent to A plus B whole star? Okay. The four expressions I am giving here, are they equivalent to A plus B whole star? My question is, these four expressions are very, very important also. Let's see who can conclude. How many are equivalent to regular expressions, A plus B whole star? How many are equivalent to A plus B whole star? A numerical type possible gate question. No one or only one? If you say not equivalent, you should tell me what string you are not able to generate. Then I'll show you how to generate. Very simple. When somebody concluding it is not equivalent, right? Tell me which string you are not able to generate. So how do you do? Just take strings in order, try to focus on them. Are you able to generate? If you are able to generate, what pattern you are able to observe? So after understanding this one, right, you will get what logic you are having inside. Everybody generating epsilon? Very nice. Everybody able to generate A? Yes. Everybody able to generate B? Yes. Everybody able to generate double A? That you should understand, but are you able to understand? That's my point. Some people can't understand how that is generating. I want them to ask the questions. If anybody not able to understand any string from here, then I'll help you how to generate. I'll tell you the internal meaning of this one. See, if I want to start with A, you take this one. If you want to start with B, put a power 0, go inside. Then every string, see epsilon anyhow power 0, right? Epsilon anyhow power zeros. Put all power zeros, you will get epsilon. But now, if you want to start with A, take this A and go forward, everything comes out. If you want to start with B, take power 0 and take from here directly, start with B, because that need to be epsilon. So start with A from here, start with B from here. So the string starting with A, I'll begin from here. The starts with B, I'll take from here. Are you able to understand? The same concept everywhere. Starting with B here, starting with A here. And ends with A, I need to stop here. Ends with B, I need to stop here. And ends with A, I need to stop here. Ends with B, I need to stop here. So understand, if it is ends with B, then this should be power 0. If it is ends with A, then this should be power 0. So you need whatever the string you have here. Everybody? So actually these four forms are covered from the other expressions. Everyone? So all are actually equivalent to A plus B whole star only. The thing is, this pattern you require, where did you get them? So I'll help them too. Okay, the four problems are done. Now let's go to the fifth one. So this is not the fifth I'm saying, I'm talking about the regular sequence. Fifth, starting with A. Remember this? Can you write an expression? You know the number of states also? Starting with A, okay, X belongs to double A, double B. So this question will not solve for DFA, but you can try later. Okay. In first for BB followed by B a power 0 2, then it's fine. A power 0 is epsilon. B epsilon is double B only, right? Anjali, that was right. You should write B a power 0, B a power 0 twice. That's a double B only, right? A power 0 epsilon, B epsilon is B only. Correct, that was correct, Anjali. Yeah, Anurag, I missed that question. How will you generate BA from the first option? Sorry, that was a miss, right? BA, how do you get here? Just I'm explaining here. How do you get BA? BA you want, right? So first to get a B, so focus on that. 4 times I go inside. 4 times you can go, less times also you can do. So I'll go twice also I can get it. See, A power 0 first. Then I'm going twice inside. The first time, because I can go twice here. First time I can take BA power 1, BA power 1, that's enough. 2 times I take BA power 1 only. Got it, right? BA, very easy. That was straightforward, BA. You could have asked different question. Okay. Yeah, you are right, Anjali. So now I'm going to write the expressions. After that you need to tell me the meaning. So then we will have the cross check. So this one is fine, you know, right? A plus B whole star. But is this only one way? No. You can also write A plus single A, multiple A's, but anyhow starts with A, remaining that you can mix with A plus B whole star. Okay. Still this is not having an issue. There is another important expression, A B star. This is only helped us to form previously. This is the one of the important form. You go inside, definitely starts with A. If you want A again, don't take a B. If you want a B, take B there itself. So you decide whether you want a B every time after A, right? If you want after A one more A, then come back, take A only by putting B power 0. So this is going to generate all the strings starts with A. So next, this double A or double B starts with double A or double B. So easy. I have many other answers, like this one you can replace with anybody else. So many answers are there. This one ends with A. So ends with A. There is another important pattern, that is A must end, but before B's may or may not be there. This can be repeated any number of times. Look at how did I write that. I must end with A, but before B's may or may not come, and this thing I'll repeat any number of times I want. If I want only A's, B power 0 I'll take A's. If I want end with A, but before that many B's are there, I can take B's here. Okay. So one of the important expression there. Similarly, you can write for starts with B, you can write for ends with B, just by switching symbols. This one ends only, right? So ends is very simple. Ends with double A or double B, that's fine. The containing double A. Containing double A before, after anything. This is containing double A or double B. See that, double A or double B. So containing either double A or double B. So before, after anything. So now onwards, I'll write an expression, you should tell me the answer. Are you ready? So this thing is, you are able to understand the form, right? Now I don't do that. I'll write expression, you should tell me the meaning of the expression. Are you ready? Because there's another way to ask the gate questions. You need to tell me the exact meaning, okay? In the short notes, you can remember, you can maintain this expressions, that would be sufficient, I guess. Okay. Focus on answering. Did I take the correct number? 19? Oh, sorry, it was 11. I'm very sorry. That would be sufficient to answer in the exam. Perfectly all right. So I change the number, so cross check accordingly. So this one starts and ends with A, right? You are able to look at that meaning, right? Starts and ends with A, the meaning. Set of all strings starts and ends with this A. Starting with A as well as ending with A. Yeah. Starting and ending with A. What is the next one? That is also starting and ending with A, but you can't say that word. But you need to add one more else. One more thing. What is that? It is also starting and ending, no doubt. No doubt. But minimum length is important, because by default this makes A is the minimum length. Now, but minimum length is 2. That you should mention. If you don't mention that, you are saying that A also there here, but A is not there. So this condition should be added, minimum length is 2. Here no need to say minimum length is 1, because by default that one length also comes when you say set of all strings. Okay, next one, starting with A and ending with B. That's very clear. Starting with A and ending with B. And this one, don't use that many sentences. Just say starting and ending with different symbols. Because if I start with A, then end with B, start with B, end with A. So starting and ending with different symbols. Different input symbols. The symbols are input here. Here starting and ending with same input symbol, because see that here A itself starts and ends, but here you take first symbol is A, last symbol is A, right? Here first is B, last is B. So starting and ending symbols are same. And I have a question for you. Starting and ending with same input symbol, then why can't epsilon is here? Anybody? Why can't epsilon is here? Epsilon, why it's not there? Any idea? Because epsilon is not a symbol to talk about I am starting with the same input symbol and ending with the same, right? So epsilon don't include here, because clearly mentioned same input symbol should be there, right? Beginning and end. Here epsilon is not having input symbol, so you don't include that. Epsilon is not a symbol. There you don't have a symbol, so you can't speak this sentence for epsilon. Okay? If anybody says include epsilon, then include it. Don't say don't include here. This is a very special case. Okay, 15. Are we ready for the next expressions? Okay, let me write in short form now. You got my point, right? So I am going to write the very short form. 16. A plus B whole square sigma star. 17. Sigma star A plus B whole square. 18. B star A B star A. 19. A star B A star B A star. 20. Okay, take only one for understanding. A plus epsilon B star. In the exam this kind of questions comes. They are very standard questions. You just revise them by looking at sigma star A sigma star A sigma star. A plus B plus epsilon whole square. A whole square is forget about whole 100. Nice. Just say one word, that would be fine. Just say one word. What did you understand from here? Just I'll write something like length of W greater than or equal to 2. What did you understand? Same. There is no difference. These two are same. Same language they are representing. This one is number of A's of W exactly 2, because you will never see the third A, and remaining places any number of B's may happen. Okay, exactly 2. And this one number of B's of W exactly 2. And here number of A's either 0 or 1. Here number of A's either 0 or 1. When you look at either no A or 1A or 2A, only maximum you will see 2 A's. So number of A's of W less than or equal to 2. It means 0, 1 or 2. 0 means both epsilon. 1 means keep one of them as A, other is epsilon. 2 A's means put both of them are A's. Right. This one is number of A's, 2 A's guaranteed, but third A you can get from anywhere. So number of A's at least 2. And this one A plus B plus epsilon means either 0 or 1 length string comes. Now if you repeat them, you will see 0 length you can get when you put epsilon everywhere. You can get 1 length, 2 length, 3 length, everyone. You will get length of the string is at most 100. Length of the string is at most 100. So very famous expression for that. Yeah, length is 0 to 100. That's correct. As if it was good question. So my strategy was something like giving mock test. That was a very important factor for revising all the subjects in single day. So my focus was every day I used to touch almost every subject, because mock test means what? So 3 hours you need to switch subject to subject, right? At the same time I used to have, let's say last 10 days I have, so every day I need to focus on 2 subjects, so 2 times I got a repetition in the last 10 days. And at the same time mock test I used to give regular, so that I need to connect with every subject. That was very simple, but taking time to attempt the test, and it was so tired to go for many things. It depends. Maybe you can go till Feb 1st or 2nd. And 3rd you don't give the test and try to keep for the revision 2nd and 3rd mainly. But it's okay. You should not, you attempted till let's say Feb 1st, and 2 days you have given the gap. So your body may not support to sit 3 hours continuously. So it's very important to have that habit. But don't ignore sleeping well and having proper food. That's very important in these last days, because if you don't get sleep properly, then it's again an issue in the exam. Okay. The strategy is yours, and exam is yours, and give your best. You know what is there in the exam and what to do in the exam. So what best you can do, that you should do and come out of the exam. Right. So it's true, right? It's not you. Everybody will get stress. Even we are stressed. We are having a lot of stress, right? We are coming to the platform and teaching continuously, right? We are having stress, but at the end of the day, we look at, yes, students are getting benefited, and that makes so happy at the end, right? Why we are coming to here and teaching this many hours? Because you should get a benefit from this. And those people want a revision, they were not able to do themselves, at least they come here and they do practice and they do revise, because you feel motivated when you are in front of the teacher, right? That makes somewhat preparation well. And if you are doing alone on yourself, you don't get that push. That push we are getting from this platform, that you can get benefited. Correct? Everybody, those people who are not able to see, when you plan it for 3 hours I want to prepare, but you can't, because there was no force from you. When you force yourself, then you don't need any help in the world. Is that correct? Yeah. Because as a faculty, we actually don't waste the time unnecessarily teaching one concept. We know when to stop, when to switch. But we are taking the doubts, because you should not have these silly doubts when you sit in the exam. There's only one thing. Yeah, good. Correct. So even I like the PW platform, that everybody working hard, even all the teachers that you see, right, they try to deliver every concept that is needed for the gate, and they don't ignore the students. First thing is, they consider whether you are asking the right doubt or wrong doubt. They keep on helping you to put in your right direction. Right. Many people, I saw the feedback from the students that compared to any other platform today, the PW is making the best, affordable, even a paid platform also. It was so cheap, like 4,000 to 5,000, and it's not cheap because the platform is designed for the students specially. Great. So where are we right now? Now come to the 20, many things happened, right? Let's go for some other important expressions. You understood, right, pattern? Sometimes the expression comes, sometimes the language comes, but you need to find out which is the right language, which is the right expression. So let's go for some other pattern, like A star, very important pattern. So you are aware of this, right? Doesn't matter A star, A plus, 1,000 times comes. You just look at what is important there. Suppose you have A plus, A plus, A plus, A star. Just look at what is important there again. When you have double A whole star, And another one, this is also one of the gate question. That's why I'm taking specially these expressions. Look at, this is also one another important one. Okay, let's see who will answer it. Can you simplify it fast? This one, first one. Great. See, that's true, right? Live sessions, so you can ask more doubt, you can interact. But अगर recorded में जाके आप खुद ही पढ़ोगे ना, maybe you can do fast forward, but you can't focus much. That is the true. That's why most of the people are coming to the live even till morning. The reason is you can do attention, you can give an attention to what you are learning. So A plus, correct. The next one, see, remaining all you put epsilon, but this one is compulsory, A, at least one A. So that makes you need A plus. And look at 3 times you need minimum A. So 3 A's compulsory. But later on, how many A's you want, you decide. That A star can help you. Of course, you can write many other ways. I'm just writing one way. I'm just writing. This can be written as double A plus, or it can be written as A plus A, or it can be written as A plus double A. But understand the minimum 3 A's. That minimum is important. Minimum 3 A's. Here minimum 1 A. That makes a trick here. Minimum is 1 A. Here epsilon 1A, 2A, 3A, 4A, 5A. Oh, when you do all of them, right, you can see every string is there in this form. So that side you have even A's like epsilon, 2 A's, 4 A's. That side you see infinite strings. This side you see odd length strings, 1A and 3 A's, 5 A's and so on. When you look at, oh, all strings are covered. Even length this side, odd length this side, you got A star. Of course, this is not expression, just to understand I am writing this form. And this one, oh, epsilon power 0. 1A, you go inside, take 1A and put power 0. You want 2 A's, repeat twice, but first time A this power 0, second time also A this power 0. That means you got double A also. Triple A, go once, get triple A, double A. So you have everything again. Perfect. So now the other important, like I have seen the confusion, contains double A double B expression, and second containing double A or double B. Third contains both. Can you write expressions for them? These 3 are very, very important in exam. Asked multiple times this kind of questions. Chanchal, what was that? Double A whole star can be ignored. A star generates old. Where do you want to ignore? Which question it was? If you want support, take it. In the union, if already generating, you don't need to take the same, right? Again, repetitive things you can ignore. Last one, previous slide. What was it? Oh, you can't ignore it. You put power 0 when you don't need it. When you don't need it, right? See, epsilon I want. You got a power 0 already. But 1A, how do you want? Power 1, A and power 0. When you don't want, put a power 0. Double A, how did you get? Go twice. Go twice. First time here A and put this power 0. A put this power 0. Double A doesn't matter which power 0 it is. you got double A. So whenever you want, consider, when you don't want, put a power 0. The star, always those people who don't know about the star, be careful. A star means A is not there or A is there. That is the meaning. When A is there, how many times that you decide? When you don't want it, put A power 0. You decide. When the star is there, be careful. It is either 0 or greater than or equal to 1. So that means A may not be there. When somebody writing star, that makes this can absent. But when somebody writing plus, so that means it must present at least once. So be careful. When something star is there, don't look at. If you don't want, don't look at it all. Put a power 0. Okay, keep this in mind. Power star is very, very important in the expressions. It may or may not be there. It could be absent. Okay. 1. Everybody answered? Containing double A, so easy, right? Sigma take A comma B. Don't take anything else. Double A, double B, before, after sigma star. Sigma star means A plus B whole star. Okay, that's perfect. And this one, double A or double B. So easy, right? You can write 2 individual expressions or you can take 1 expression, is your choice. Double A or double B. Sigma star, sigma star. Another way you can write, for double A separate expression plus double B separate expression. You can also do that, right? You can apply sigma star this side, this side. And this one, how you want to have both? That means double A may happen anywhere. See, one expression is double A might happen first. Other expression is double B might happen first. But in all the places remaining, anything could happen. Sigma star. There is a one expression when double A comes first, when double B comes first, then this is an expression. But both must be there in the expression. You can't ignore other one. And only the issue is sequence we don't know who comes first. That's why you need 2 expressions. But in the exam, they have asked this question, but they did not give this option. What did they do? This sigma star, they pulled left side, and this sigma star, they pulled right side. So sigma star, one sigma star here and other sigma star here. Then remaining portion they kept here. So this was one of the gate option, and many people were looking what was the right answer. So this was the option given in the exam. They asked the same question, but option was this one, not this one. But both are actually same. Just they took the common left and right sigma stars. I think most of the regular expressions which are important we have covered so far. Can we move to now identifying regular languages? If anything really you wanted which I am missing, you can ask me, I will cover it. Can we go for now identifying regular languages? Somebody wanted to convert from DFA to regular expression. Do you want before starting or after this one? Okay, let's look at after this then conversion. Okay, we are unnecessarily deviating the important topic. So how many of you know this? It's not an algorithm, it is just a concept, right? It's just a concept, it's not an algorithm. How you look at a language is important. How you look at a language. Language could be finite or infinite. If it is a finite, don't look at much, doesn't matter. If it is a finite, whatever the form is, doesn't matter. They may ask you a power n, b power n, a power n, n is less than 1000, 10 power 10 power 10. Is it finite or not? Because number of strings could be many, but that decision makes this language is finite. Is that clear? Once the language is finite, you should always believe you can write regular expression, but that might take what? One day to write all the strings or to write a form, or one day might to design a DFA, doesn't matter, right? It might take 100 days to design a DFA, but it is still finite language, that you should believe. Okay, This every finite language is what? Regular. Is this point clear? Every finite is regular. And another one, when the language is infinite, look at, is this having one symbol or more than one? If it is one, only one way you should think, that is forming AP or not. If you don't have one symbol, if you have A comma B, A comma B comma C, then you need to look at some other way. Okay. Now, when you have one symbol, is it forming AP or not? Like A star, double A star, is it forming AP or not? We may not write like that, but A power n greater than or equal to 0, or A power 2n where n greater than or equal to 0, anything, something like that. A power 3n plus 5. All these languages actually forming AP. Right? Yeah, thank you, man, Sadam. Is this clear? Any language which is having, some kind of arithmetic progression. Just now also we have seen, right, something like A power 3 comma A power 5 whole star, like 3a's plus 3 5's, 3 1's plus 3 5 1's whole star. Such languages forms arithmetic progression. But who is not going to form arithmetic progression? They are dangerous here. Not forming AP, like A power n factorial, A power 2 power n, something like that. We are going to look at these things. Okay, they don't form AP. Like, you should know that what is AP series, then you can understand the sequence. Non-AP series like prime series, factorial series, 2 power n power n square, n cube series, they don't form AP, if you are aware of them. Okay. Now this side, when it is having more than one symbol, there are two things will happen. Like, you have lot of sequence, right? A, B power n. Oh, this is obviously you don't need that other thing. Just let me write A, B power n. You have more symbols. Still it is regular language. Or you may have A star, B star. Or you may have something like, A power n, B power n, C star, where n is less than 100. Don't assume it is a finite language. It is infinite only, but more symbols are there. So this kind of languages are regular, where there is no dependency, or where there is no kind of this not forming AP concept here. Okay, if it also comes here, then that will be non-regular. You can see here, if I have something like A power n factorial, B star. Oh, B star is not giving an issue with the A power. So there it is not forming AP. There is no dependency here, but no forming AP. Now here A power n, B power n. So this is also not regular. Now you can see there are a lot of points that we need to cover in this session, right? So that kind of languages we are going to practice. When you look at here, it's okay, because I'm giving the language exactly what is language, right? Then you don't have a difference. You will assume, okay, they are non-regular, okay, non-regular. But when I ask the question, is it regular or non-regular? Then you need to put an effort where it goes exactly. Clear? It's not the shortcut, it is a concept. How do you approach the question? Understand the language. Once you understand where it lies. Oh, finite set means it. Oh, question, how many of you are aware that? See, language, coming to the basic, guys, finite language, that means finite set. Language, another name is what, yaar? Set only, right? Infinite set. Finite set, it means it is having finite number of finite strings only. Infinite set means it is having infinite number of finite strings. Every string should be finite only. We never take infinite string concept. Every string should be finite. If you are writing anything in the language, W1, W2 and so on, this W1 is always finite length. We will never take infinite length. Every string should be finite in a language. The language may be finite or infinite, but string never be infinite. Is that clear? Like ABA, this is a finite string. And what is the infinite string that we never take? Something like AB, that never ends. Oh, this string never comes in TOC. This string never never present in language. If it is present in language, then that is not computable in computation. Okay, anybody keeps this kind of string, just straight away say that we never compute that. Example, very simple. If I am speaking continuously infinite time, who will listen to me here? Right? I'll speak 8 hours, 10 hours or 24 hours. Whole day I am here in live, going on. Who will come in there? Right? It's impossible, right? So if you have a program, input never be infinite. Input should stop sometime so this program executes and gives some output. So that's what important. Whether it is finite set or infinite set, the string type is finite, but that string, how many are there? Finite number of or infinite number of? So remember that. So here in English we speak finite strings. It means finite number of strings. So that's not we are speaking here. Finite number of finite strings, infinite number of finite strings. So understand the concept. Each string type we are concatenating. This is the one word now. So here people don't misunderstand the statement. Where is that? Here. This is a single word here. So this is a single word. Finite string. It's a plural one word. Don't separate finite number of strings. That we are not talking about. This is a one word. Okay? Don't separate it. In actual sentence, infinite strings means infinite number of strings. That we are not talking. Infinite number of finite strings. Each string type is a finite in both of them, but such finite strings are finite, such finite strings are infinite. Okay? So that's why when we write A star, what do you have here? Language, epsilon A. See that every string is what? Finite or infinite? Our assumption is also in the infiniteness also every string going finitely only. Don't say that, sir, there is an infinite string. Oh, don't say that. It's not real number to talk about. This is just like natural numbers, you know, right? 1, 2, 3. There is no real number here. Real number, the number itself is infinite. But natural number is the fixed constant. Okay? So keep that mind. That's why natural number is computable. Real set is not computable. Because single number itself has a difficulty in the real numbers. Got it? So this is the finite length. This is the finite, this is the finite, this is the finite, everybody is the finite, but such strings are infinite here. Okay? That is also one of the gate type question. That's why I am repeating that. Those people who are not aware. Very good. Okay, let's start. Do you need small break before starting? Of course, I don't need these slides. You practice that slides later. Do we need a break? Small? Because it looks like, what is the time? 1:10. 5 minutes break before starting, because regular languages there are many. I can't stop writing at all. Five minutes? Perfect. So we'll meet 1:15 AM. Still we are running the first chapter, right? So 1:10 AM to 1:15 AM break. Yeah, 5 minutes will be enough. Later on we'll take more time when we switch the chapter. Bye. See you. I'll be back. Audio clear to everyone? ओके, दोज पीपल आर टेकिंग द ब्रेक, राइट? आप ब्रेक में कंटिन्यू करो, जो चाय पीना है, जो पीना है। तो मैं लैंग्वेजेस लिखूंगा, उसके बाद एक एक लैंग्वेज डिस्कस करेंगे। इस ऑफिस से ले रहा हूँ, आसिफ। Okay, you can continue in the break for a few minutes. Meanwhile, languages लिस्ट लिख देता हूँ फटाफट। शॉर्ट फॉर्म में लिखता हूँ, तो समझ में आया तो ठीक है, नहीं आया तो बता देना मुझे। बिल्कुल शॉर्ट फॉर्म में लिख रहा हूँ मैं, कोई भी डाउट है तो पूछ लेना मुझे। सिर्फ इंपॉर्टेंट लैंग्वेज की बात कर लेते हैं यहाँ पर, ठीक है? ठीक है, ए पावर की बात है, ठीक है? इसके बाद सीक्वेंस चेंज कर लेते हैं, ए पावर एंड बी पावर की फॉर्म। आइडेंटिफाइंग, वही तो है ना, कंटिन्यूएशन। हाउ टू आइडेंटिफाई रेगुलर लैंग्वेजेस। द एग्जाम में ओनली रेगुलर कभी कभी आता, कभी कभी CFL रेगुलर के साथ में आता क्वेश्चन। सो यू नीड टू आइडेंटिफाई। So regular, sometimes finite, sometimes CFL, sometimes CFL but not finite, sometimes DCFL. So very important topic. Okay, 9. So focus on this 9. Let me focus on other. So I'll try to make the big list here itself. So just tell me what language it is. Regular? What is regular? Is it finite or infinite? So 3 words, you use it: regular, finite and infinite. So whichever matches, just do it. So keep answering. Good. So also cross check together, guys. If anybody is answering wrong, please try to help them. You are wrong. But don't argue each other. So you have 5 minutes time, okay? Just take 5 minutes time. So I'll be waiting for your answers. Okay, I'll sit here. But I'll speak. The first one, yes, good. It depends on value of n. That's perfectly right. What about the second one? So everybody answered what is the first one? First one, there is a dependency, right? The both values should be same and n is unknown, so n greater than or equals 0. It depends on n value. Don't say, Bhavesh, the n is given. N is anything. When they don't mention it, n is anything. Everybody, don't say that n is not given. N is given already. It should be any value in the world. But you can start from only 0, minus you can't put. So it starts from 0. The second one, mn. Both are anything. So second is regular, A star, B star. Perfect. Yeah, that's good. Identify the regulars, like somebody answered like Ani, 2, 5, 6, something like you identify. 2, 5, 6, 12. You missed some languages too, okay? 12, then 13, 15, 16, good. But you missed some languages also. Ani, just cross check. Did you miss any language in the given list? How many of these languages are regular? Very good question, right? You can count them. Why chart is stopped? Are you answering it? Is there any finite language here? Okay, let me ask first question. Is there any finite language? Okay, answer to my question. Then I'll get to know how many of you got the right answer. Is there any finite language here? So with this, I conclude what you know. How many finite languages are there in this list? If there is a finite language, which language is the finite? Okay, do you need more time? Okay, I'll wait for 2 more minutes because so that you may think about the problems. Anjali, how 8 will be finite? So many mn values are there to get GCD is 1, right? If you are assuming prime numbers, how 2 prime numbers you take, always the GCD is 1, right? Co-prime. Infinite combinations are there for GCD is 1. But LCM is 1. In the world, only one string that is there, LCM is 1. Yeah, Ani, that's 9. So let's answer it. Okay, this one, either here n is not given, it means, remember my point, here n is anything, so that is going to start from 0 by default. So this is called as not regular. Just not only not regular, it is also infinite language. Why infinite? Because there are some infinite languages which are regular, there are some infinite languages they are not regular. So keep one point here. Keep one point here. Remember that infinite languages are 2 types. Some are regular, some are not regular. But remember, if it is not regular, right? If anybody says not regular, if L is not regular, then it has to be infinite over the sigma. It has to be L is infinite. But when somebody is saying L is infinite, then it can be regular or non-regular. Remember that in the exam, if they say L is infinite, possible regular or not regular. But if they say L is not regular, then it must be infinite over the given sigma. We are talking about set of strings, remember that. Clear this point? Okay, in the exam theoretically, non-regular is always infinite over the sigma. This one, again Mn is not given. It means Mn or anything. Anything means you can't take negative values here, right? You can take only from 0. So this will be A star, B star. Obviously it is infinite. Not only just infinite, it is also regular. Did you see now? Both are infinite, but that is non-regular and this is regular. Next, what is n to n? There is any dependency between A's and B's, right? If 100 A's comes, then 200 B's should come. So there is a dependency that goes till n value is larger, infinite. So this is dependency is there, and it is infinite language, no doubt, and it is also not regular. Okay. That comes in the last case, more than one symbol and there is a dependency. What is this? There are two symbols are there in the language. Before hash, if there are 1000 days, then after hash 1000 days, then how will you verify? So impossible, right? So it's again infinite and not regular. When we say regular, in case if you have different powers like a power k, b, a power n, then a star hash a star, that is regular. How dependency? Dependency in the sense that is not a word to use, but you see, if you have a power n, b power n, what do you mean by this basically? Right? Why we conclude there is a dependency? You understand, if there are 100 a's, then you will see definitely 100 b's. Then how will you count these two are exactly same? How do we remember? In what? Finite automata, let's say. Anyhow, you can't write regular expression. Let's look into finite automata. How do you remember in finite automata? It's possible a power 100 means you need 101 states and followed by 100 or 101 states. That makes, let's say, nearly 201 states. 2 not 2, wrong. 201 nearly you require to understand. To remember this, nearly 200 states needed. But I don't know exactly, is this maximum 100? No, it is a power 1000, b power 1000. Again you need nearly 2000. Nearly, I am saying not exactly. And if I say a power 1 lakh and b power 1 lakh, then what do you say? Or you keep on changing your machine. The same language, every string demands different number of states. And with few states, you can't design a DFA. You need the infinite number of states, but DFA never contain infinite number of states. Anybody trying to design epsilon accepted and 1A, 1B accepted. You see what happens. And 2A, 2B, you see how you should design. And 3A, you never stop increasing the states, and this machine never stops. That means, how should I design a DFA or NFA or any finite automata for this language? Impossible, because with a finite number of states, this language cannot be accepted. That's why, how do you understand this? Oh, there is a dependency between the symbols by analyzing, not just by looking this language. Remember that. Anybody only looking this languages, you don't get the answer. Maybe you will succeed in this slide, but not all the time. Got? Here directly AB is there, but when W is there, your identification should be A's and B's, not the W. W helping to form a string, but AB is visible. That's why you are able to understand very quickly dependency is there. Here there is no dependency. Sequence is important. A star, B star. How many A's, how many B's? We don't care. Right? There is no dependency between A's and B's. Here you see A's only depending on other A's. A is only depending on other A's, but before hash and after hash, there is a kind of dependency. But that dependency is not going till infinite. It's going till infinite. That is very important. The dependency going till infinite. That's why we are not able to understand. If it is coming up to 100 length, we can do it. Up to 1 lakh, you can do it. Up to 1000, you can do it. But n value is unknown, arbitrary. That's why you are not able to get regular property. Okay. So this one, now you don't say dependency. 100 days are there, 100 days should come. But this one, understand it is actually converting into a power 2n. That a power 2n means even number of a's. Even number of a's means you know how to write it, double a whole star. I have written an expression, you should believe it is regular. Whenever I write expression, right, don't look at what is the finite method, don't look at what is the grammar. You should directly say it is regular. Okay. This is infinite language, but also regular. Okay. And see here, n to n. N to n means what? 3n. 3n means what? Multiple of 3a's, that's right, multiple of 3. Number of a's is multiple of 3, or number of a's is divisible by 3. So it's definitely infinite language and regular. How many states? We know 3 states will take. Oh, here. Now see, A and B, two different symbols. If 100 A's comes, 100 B should come. This is exactly same as the first one. This is same as the first one. So let's say not equal. Equal already covered, right? Anyhow, it's not regular. Put equal or not equal. The answer is infinite language, but it is not regular. Why not regular? Because you can't compare A's and B's for infinite time, that you don't know what is the string length in the world. Every string you have to verify this. GCD, how many? See, now try to understand. Do you get every string in A star, B star? No, right? There is a particular pattern. If A power, let's say 1 is there, then B power should be 1. If A power 2 is there, then B power 3 is fine, 5 is fine, 7 is fine. So their GCD should be 1. There is a greatest common divisor. So 1 should only divide both of them. See, if you look at the every value of m, there are different values of n. When you try to observe, you never get any pattern, right? You can't assume A star, B star, and if 2 is there, then there is a fixed combination, 3, 5, 7, 11. So prime numbers, co-primes you need to find. Obviously, there is no logic with the states to find the co-prime. So here the language is infinite, and there is a dependency between number of A's and B's. If number of A's is 100, then B's you need to find which can give you GCD is a 1. Number of strings, very simple, right? Now we are coming to the basics. How will you say the language is finite or infinite? Guys, you tell me. If I am writing A power n, B power n, so how do I know it is infinite language? I have epsilon, I have AB, I have A square, B square. Now look at here, how long you write. How do I know it is infinite? By looking at the strings only, right? If I have a problem, A power n, B power n less than 100, now you see it, epsilon comes when you put 0, when you put 1 AB, and how long? Up to 99 only. By observing the language, what strings, how long, the value of n will tell you, the length of the string will tell you, right? When you look at the meaning, you will get to know, oh, language is infinite or finite. Got the point? It's very simple, right? This is the finite, this is infinite, because you don't know what is the last string at all. Last string, you look for the last string, then you will get the conclusion, right? If you know the last string, that is a finite. If you don't know who is the last string, that is infinite, obviously. Okay. Whenever I say finite language, definitely will know who is the last string. In this whole list, you have only one language, which is the C. Now you get to know how many combinations of m and n are there. Their LCM is 1. Here there are infinite combinations. Look at m is equal to every n prime you have. That means when m is equal to n can be any prime, that will give you GCD is 1. Infinite combinations are there only when I fix the number of a's is 2. But here the LCM you will get 1, m is 1, n is 1. Only one string, that is A power 1, B power 1. That's LCM is 1. That means instead of asking A, B, they are asking some new form. Now LCM happens 1, only m is 1, n is 1. Everybody agree? Yes or no? Is there any other combination that will give you LCM is 1. Impossible, right? Come on, quick. That's the only one string. This is the finite language. You can see that. This is the finite language. Every finite is what? Every finite is what? Regular. So understand the meaning. DFA never computes LCM. DFA never computes GCD. You pull the strings, look at the set of strings. Oh, is it regular property or not? Do you have any dependency or not? That's why we are able to conclude the final answer. Here, WW, don't look at that. Look at the meaning. What do you get from WW? Epsilon, AA, BB, WWA, AB, AB, BA, BA. That means whatever I get W, then later I should repeat. That I can't conclude it is equal to A plus B whole star, because only some strings from A plus B whole star are in this form. That means there is a creation of a dependency between these two positions, and that dependency too. All finites are regular. That's what, Anjali, I'm saying, right? That's what this concept is given to you, right? Before this, what is this concept? Every finite is regular. This is what I told you in the beginning. You need to remember this concept, at least the finite language you remember. Remaining we'll discuss. Okay, so this one, it creates a dependency between the two positions. Like, what do you mean by positions? When I am saying WW, it is not just WW. It is epsilon, epsilon gives epsilon, A gives you AA, and what? BB gives you double B. Something you understood, right? So this dependency is always having, like if I take a bigger string, then this same string is repeating here. I am not able to understand this form because there is always dependency created like this. You can see the dependency. What's happening here? This dependency cannot be ignored. I can't say this is equal to sigma star. If it is equal to sigma star, definitely I can assume it is also regular, but this is not giving regular. If I want to make a regular, I must say WW such that length of W less than 100, then this will become finite language. Then it will be regular. But no such thing is given. W is unknown length. A W can be 100 length, 1000 length, 1 lakh length, and other W should repeat the same. And my states cannot remember the W because my states are not having infinite number of states. So this is going to be infinite language and also not regular. Same problem, reverse of the string, palindrome, even length palindromes. So it is also same answer, infinite and not regular. Keep asking if you have any doubt. And let's look at the 12th. What is the difference between 10 and 12? I saw many people, the 10 they will think like a 12. That's why I took that. 10 and 12 both are different. Here 10, the same W repeats, but in 12, W1, W2 are two different strings. They could be any arbitrary. So somebody when conclude it is just nothing but W1, nothing but W2, nothing but A plus B whole star only. Because I can make absent of W2, I can do everything with the W1, because W2 I can put epsilon, or W1 I can put epsilon. It's my choice to get every string in the world. Yeah. Fine. Yes, CSL I will be explaining that in CFL concept, okay? Anybody got this point? So 12th we got answer regular, infinite and regular. Infinite as well as regular. What about this one? 13. Did you get the all even length strings? Do you know what is even length means? Length of W is divisible by 2. I'm writing an expression. This is length of W divisible by 2. It is also infinite and regular. How many of you got this answer? The 13th is also regular. How many of you are able to get it? Set of all even length strings. Because these two lengths must be same, not the strings. Strings I am not worried. Lengths only. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. When you observe 0, 0, 0 length, 1, 1 means total 2, 2, 2 means total 4, 3, 3, total 6. So total length is 0, 2, 4, 6, 8. So all even lengths will generate from this language. Everybody? So observation is important, but the 14 exactly same as the 10. The 10, another way you can say W1, W2 are same, that will convert to the 10. Okay? I'm not writing the answer, you got it. 15 and answered? Yeah, 10 and 14 exactly same. But 13, don't misunderstand. There is no dependency here. You need to observe the strings generated by the language. Okay? Yeah, how many of you got? Observe epsilon, epsilon. Okay? A square comes. W, A power 4 comes. When you observe, you see some form. That form is making the arithmetic progression, which is set of even length strings or even number of a's, which makes infinite, and obviously it is regular because over one symbol forming arithmetic progression is always regular. So WW, when you look at, you don't understand. When you look at the strings, you will get an idea, oh, they are forming arithmetic progression. Is that clear? Never say WW means not regular. That's over more than one symbol. This is a over one symbol. Clear? Yeah, even is or length of the string is even, that is also fine. Next one is exactly same as a 15. Only the difference is W power R and W. Why both are same? Because over one symbol, reverse of the string, no impact. Over one symbol, do you know? W is equal W power R. If W is over one symbol. Triple A, reverse, triple A. So over one symbol, you can't see the difference W and W power R. So both will generate same set of strings. 17, W hash W power R. So before hash, whatever it comes, after reverse order it should come, and length of the W is not finite to decide a finite language. It is infinite and dependency is there all the time, so it is not regular. In case if I do any mistake, let me know quickly, because sometimes I speak not regular and I write regular. So that mistakes happens once in a while. 18, so you see that before hash, after hash is exactly same as 4 only. 4 is what? Infinite and not regular. It's exactly 4 written in other form. Before hash, how many is? After hash also same number of is. That is a 4. Yeah. So anybody want the answers other than this? Do you want to know exactly know what is the meaning of the each language, whether it is DCFL or can we discuss there? So those languages which are not regular, you should know exactly are they DCFL or the CFL or the CSL, because definitely all these languages are CSL, no doubt, but some languages are DCFL, some languages are regular, some languages are CFL. Okay, otherwise we'll discuss later. Do you want to mix up that concept right now? Is this fine? Can we go to other list? Okay, perfect. So this is a very easy list. No need to worry much about it. It's a very, very easy list. Okay. So remember this slide. If this question comes in the exam, make it quickly. Of course, I am only writing few, but you can make hundreds of languages by looking at this. Yeah, now you can try. If you really wanted DCFL, CFL right now, you can try. Later on we can come and revise this. Because Rohit was discussing, so I thought, should I? Those people who are aware of it, just you can answer yourself. Later you cross check. We just take a 5 minutes break, 5 minutes or 4 minutes time. Let me cross check the answers. 25 to 30 all are regular. Excellent, Sakshi. And it says 24, 25, 27. Correct. What about 26, Ani? Rohit, why 22 is regular? I did not get. Okay, 24, 25, 6, 7, 9. What about 28? 28, is it regular? Okay, how many of you answered that? Let me check. Here not forming AP, this prime series, right? Prime n factorial 2 power n power n square is fine. But this m power n is actually AP series, because this makes all the sequence 1, 2, 3, 4, 5, everything comes here. This is actually equal to A star. But somebody trying to confuse you that m power n, actually what it makes is, you have m is equal to, you can put whatever you want, but n just put a 1. That makes you 1 power 1, 2 power 1, 3 power 1, 4 power 1, 5 power 1, 6 power 1. That makes all the possible numbers, right, in a sequence. But these are not forming AP, n square, n power n, 2 power n, n factorial prime. These are non-AP series. So these are definitely, all are infinite. There is no such thing here finite. Everybody is infinite, but these are not regular. From here to here, they do not form AP. When you observe the result, string only, you will understand are they forming AP or not. So here you need to put the strings in a sequence, then you will get to know everything is possible. So that's why they are not regular. Oh, great. It is, infinite and regular. Okay, here no need to write infinite because all are infinite only here. Now this one, by looking at you can't understand. A power prime is not regular, but when you repeat it, it could be anything possible, right? A power prime is not AP series, but when you keep whole star, in mathematics you don't have whole star, but here you will have. So here you look at epsilon possible, 1a, a power prime is not possible, 1a, a power 2 possible because you have a prime is 2, and a power 3 possible because prime is a 3. Sometimes prime is a 3. A power 4, how do you get? A power 2 you repeat twice, because here a power 2 whole star is there. Anybody is confusing with a power prime whole star? Just do practice. A power prime whole star. It means like a power 2, a power 3, a power 5, a power 7, a power 11, and so on, whole star. Now you just think about the strings. What is possibility? Epsilon, yes, power 0. A power 2 is there directly. A power 3 directly there. A power 4, this one you repeat twice. A power 4. A power 5 directly. A power 6, you get 2 3 times or 3 2 times, you decide. After that everything is there. So now the key is, oh, this is except a everything, that I can say a power n such that n not equal to 1. You already know this, right? Except a, you can write something like regular expression epsilon or 2 a's minimum followed by any number of a's. Very simple. Except a, everything possible. Oh, somebody want write, you can write the mathematical notation. From a star, try to delete a. But this is not regular expression, remember, because minus never comes in the expressions. Okay, if you want, you can include a special expression. Okay. So you got it? Why it is regular? Except 1a, you have everything else. And that you can write expression, that you can design a finite automata. So it is regular. It's forming AP. You can see from a power 2 it's forming AP. Same, put n is equal to 0 or put n is equal to 1. You can observe a star there already. One value of n only, you are able to get everything. Remaining n values are redundant. 2 power n, put n is equal to 0. Then everything comes out as a star. N is equal to 1, n is equal to already covered by this a star. Okay. Put here n is equal to 1. 1 power 1, a power 1 whole star. You can see that a star here itself, just one value of n, most of the problems will be decided. Here, this 3, just one value of n you are able to understand, but this one you can't, because you need to consider all the primes to understand this set. Okay, this one, put n is equal to 1, or 1 is fine, so it's a star. This m value is 1, n value is 1, that's a star. So all these are regular. Right, all of them are regular because they are forming arithmetic progression. Correct? Okay, last the series that we will see 31. So before that, just assume W WX belongs to already have written. Okay, 32. WXW 33, XWW 34, WW power R X 35. You know this all languages, right? Just for repetition and revision. So you should look at carefully, understand what do you know about them. So any confusion you can ask, I'll explain separately. While writing the answer, you can give a sequence like 31 to 34 is regular, 31 to 34 non-regular. You can put, if all are same answers in a sequence. With this, we can move to another concept after this. Then we will mix up these concepts again later in DCFLs and CFLs. There also we can repeat these questions if needed. There's other pattern is there, but that takes much time. That's why I'm not putting in the revision right now. Okay. We'll stop here with this. But there are many other patterns that you can see in the gate PYQs. We have discussed some of the patterns there. Okay. – 31 to 36 regular. Excellent. So I'll put that lines also. So if you see any observation there, you can try. This is a one pattern, and 1, 2, 3, 4, 5, 6. This is a one pattern. 1, 2, 3, 4, 5, 6. This is another pattern, and I just close this pattern here itself. And this many patterns I have given, different patterns. Yeah. Take time, 5 minutes. Then after 5 minutes, we'll start discussion. So what is the key here? Here, what is W? Because anyhow X is not repeating, right? So X is free completely. So you need to look at why W is coming again. Is that X can help or not? If possible, try to disappear the W by putting epsilon or by substituting with the minimum string. One key concept is there in all of them. If you put the W minimum string, can you get some unique form which can cover everything? So understand that line. Put a minimum W, get some answer. Is that covering every other W form or not? How many got in all of them? Here, just by putting the W with epsilon, these things can be deleted by putting just epsilon. You get everything is equal to simply A plus B whole star. That's equal to X comes out, and that's equal to A plus B whole star. No need to worry about the W, because whatever W is saying that X already covered it. If we put W is AB, whatever that X value, the whole thing is already covered in the A plus B whole star. So no need to worry about is the W repeating or not, because this is dominating. When you put W is epsilon, all other W's are covered in this form. Okay? Yeah, that's very easy. But here, when you say minimum 1, you can't put epsilon. So what you have to do, when you put the minimum W, that is AAX, BBX, which cannot cover everything. That's an issue. So here in all the forms except this form 41, except this 41, this is only regular, remaining all are not regular. This all forms you cannot see any regular concept. Only 41 is important, remaining all will become not regular. Then you may ask the question, sir, how to answer this? So I am just taking WWX, just look at how do I answer it. WWX such that W, length of W is at least 1. Of course, WX belongs to A comma B whole star. Indirectly what I am trying to say here, W belongs to A comma B whole plus, because minimum 1 I kept, and X belongs to A comma B whole star. Then what is an issue? Here when I put minimum W, let's say length of W is 1, what do you get? AAX or BBX. Now when I put length of W is equal to, then what do you get? A, this, then again AAX. Now this I put AB, then ABX. Then if I put BA, BAX. Then if I put double B, then double BX. What is the issue? This one length, is it able to cover the two length? That is a key point. When I put a minimum W, is that remaining all are covered here? This one is covered here, this one is not covered, and this one is not covered, this one is covered here. That means if the second length form is not covered, when I put second length W, it's not, the form, whole form is not able to cover in this form, then indirectly that you need to have the importance of this one, importance, you need to consider it, and length of W is equal to 3, again you will get different sequence, then this is going to have a dependency forever. So it's not possible to say it is regular, so that's why we have a dependency till infinite. But what is happening to this first few problems? These problems, when you put W is epsilon, minimum only I kept, then no need to take one length, two length, three length W's, because already there in this A plus B whole star everything, right? So this concept is very important. Here you put a minimum W, then only you can verify very easily. Then why 41 is regular? Just cross check. Why 41 is regular? When I put W x W power r, length of W is what? Greater than or equal 1. What's happening here? AXA or BXB. This is length of W is equal 1, minimum W. Now I put 2. Now no need to worry, because already covered here. Just I am trying to prove this one is dominating everything. You see, 2 WAX reverse is WA is already covered, and AB X BA reverse, this first year last year is already covered here. And if I start with BA, then reverse is AB, the start with B end with B is already covered here, and BB X reverse is BB, start with B end with B is already covered here. So take 3 length, 4 length, 5 length, whatever, then this is only the answer you get it from here, right? So that is AXA or BXB. X is A plus B whole star. So that is what the answer for this question. That's why yeah, 41 is what? Regular. Correct? Please answer everyone, right? Rohit is answering, that's fine, but what about others? Of course, to get these answers, initially I worked a lot to make this concept, very clear. So putting minimum W is not a formula, not a, any textbook concept. It is a concept created by me during, explanations. The students were struggling to understand these forms. So I created a lot of forms and, given the difference between them. So just put a minimum W that gives an answer. Why need to put a minimum W? Because W only repeating many times. If X is repeating, then focus on eliminating X. So we have a repeats, that is the target to eliminate. Okay, so any question? 38, why don't you try yourself 38? 38 also, when I put a minimum W, that is not covering any other W forms. The same concept put in. I just explained one of them, 37, and here regular. So 37, 41 explained, remaining you just try like 37. Okay. 43, oh, W is coming only for 10 length, 10 length, 10 length and excess, anything. So the WW will give you 20 length, fixed 20 length, and then followed by X. So that 20 length, do you know how to cover 20 length? I'll just write an expression for this. Length of W exactly 10, right? 10, 10, and that is repeated, right? Repeated that you need to, okay, expression directly not possible. Why? There is not a one W to write. The same W should come, but you have finite combinations only. It's 20 length, but 10 length, same 10 length comes, but you need to guarantee that's possible. It is regular because no dependency, that dependency coming up to 20 length only. Okay, up to 20 length only dependency, then after that no dependency at all. And exactly 10 length, that too. And here also, here W is actually saying that it's not there indirectly. So when you put W is epsilon, W is 1 length or 2 length, fixed length only you are keeping, indirectly all will become regular. All will become regular. From here to here, the W is actually coming only one time with the 10 length, so assume that W is not there at all. That's enough. If W is coming till infinite, you are in trouble, but in this 43 to 48, there is no issue with the W, because coming only for 10 length, that you can take care by writing expressions, very lengthy expressions. But if you want really the length of W, take 1 or 2, then I will show that, because here you may have a problem. But WX, just take very small concept 2. Then how do you write an expression? See that this is a WX, then W is AB, then ABX, BAX, BBX, over. X is A plus B whole star, khatam. Right, these are 4 expressions, put a plus in between, this is the answer. It is a regular expression also. But if it is 100, I can't write all of them, that's why I ignore it. If it is length 10, very time consuming. But it's very easy, put a small value to understand always. Fix a small value, because already it's fixed 10. Now what about this? Now X is at least 1. Anyway, W is 0 only, right? Why can't you eliminate it? You can eliminate in all of them. When X length is 1, minimum 1, same answer like A plus B whole plus now. This answer comes as A plus B whole plus, because minimum 1 length. So this, I did not write for all the 6 forms, but you just assume for remaining also regular. These 2 are regular. Now what about this? Now X is 10 length, means indirectly X is not there. When X is not there, WW all are not regular. Previously this was regular because of X was helping, not W helping, right? X is helping to get the strings, here X is not there indirectly. Now X you can't believe at all. Even if I put W is epsilon, X is 10 length only, but I have 100 length, infinite number of strings here. So all these are not regulars. What are they? These all are not regulars, because W always there. Oh, 43 to 48, they are not finite. W only finite, but X is infinite here. Oh, they are infinite languages. Oh, don't make the mistake. They are infinite, because X is coming as A plus B whole star. X is coming as A plus B whole star. If both are finite, then the language is finite here. W and X both are finite length, then the language is finite. Here it is not. Okay, I did not write that case, but you can assume that. If you really want both W and X limit to 10 or 100, then the language will become finite. Okay. So I hope with this, few important concepts are covered. Of course, most of the important, but some pattern questions I have not covered here. That's fine. So some of the questions we have, you can try later. Many questions are there in the slides. If anything is not covered in this revision, you can practice. Of course, most of them are covered here. So these things, right? Small questions are not covered, like M is equal to even, N is equal to odd, M is equal to N equal to even. So some tricky questions are there. Answer is already there. Just cross check. Can you do that? Can you do that? Yeah. Many languages are there. If I have not explained anything, so you can just have a look into it. Most of them are covered. Just I brought the slide to revise it. Okay, this form is also covered for you. This answer is also given. Good question, Geraint. That's what are you missing here? Let me help you. You need to put W by understanding, don't put blindly. The blind concept don't work. These are created, not textbook concept. 51 to 56. Why we don't put W is epsilon? Let's take 51. 51. So look at that explanation. 51. WWX. What is the length? Let's take smaller value, right? 2. Then why don't we put, is it W or X? I'm sorry. X, right? Just take smaller length. If we put W is equal to epsilon, Can we cover whole language? Let's say L. Can we cover all strings in L? That is my question. Look at the same question for the first question. What was that first question? I forgot. Take that 31. Take that 31. WWX. When, okay, that's it, right? Here, if we put W is equal to epsilon, can we cover whole L? Let's say this is L. Can we cover whole L? Whole L. So you answer it now. You get the meaning, right? Here, when I put W is equal to epsilon, this 2 deleted, X, oh, that X is helping to get everything. But here, is that X will help you? If you put W is equal to epsilon, what happens? X happens, but X is 2 length, that is AA or AB or BA, BB. Is it equal to L? Not equal to L. This was equal to L, because whatever you do, that will only be there in A plus B whole star, right? You got that point? Come on, quick. Everybody got why we can't put W is epsilon? Because X cannot help here. X is not going to help because X is limited. To get L. Here X was no restriction. X is almost right. X is everything. That's why we are depending on X. So that clarity should be there. Why we are able to say not regular, why we are able to say regular, because when I put some minimum W, I'm getting whole L. I'm not getting one form only. I'm getting one small form, but that is covering everything. So that's what the trick in whole language, right? Whole list. That was the trick. Okay? Any other doubts you have? Let me know. Okay. Good. Switch. Because some people are waking up now, I can see. Okay. Do you need any small break? Just have a relaxed 5 minutes, right? Taking 5 minutes break actually help you. If you are really tired and go to sleep, not tired, continue it. So that break will help you whether you should continue or not, because you can't force your brain to happen it. Good. Even I have it, chai banana. So let's meet at 2:30. Even no, not 8 p.m. here, a.m. Okay. We'll resume at 2:30 a.m. Okay. Because I am speaking continuously, sometimes I need relaxation too. Yeah, thank you so much. Welcome back. एक ही कमेंट दिख रहा है यार, सिलेबस कब कंप्लीट होगा? फर्स्ट चैप्टर में होगा, वो भी रूपेश कुमार से। एक कमेंट भी आंसर नहीं दिया, पहली बार आके पहले क्वेश्चन पूछा यार कब कंप्लीट खत्म होगा। राइट, क्लास में कंटिन्यू करो, पता चलता है यार कब कंप्लीट होगा। राइट, ब्रेक हो गया, अभी चल रहा है ब्रेक। Is there any buffering? I will wait. It's okay, Rupesh. I'll take care because I'm not going to teach every day, right? I'm just teaching now and tomorrow, maybe today. And then when will I meet you? Tell me. Right? Not having the classes every day, right? We are working only for one day for you, but you people are doing more hard work than us. Okay, that can be manageable, yeah. You have to work hard sometimes. Is that audio, video and clear? Because I can see in my computer there is a buffering issue, but do you have any buffering issue? I need to refresh, I guess. All clear? Okay. So if you do refresh, that buffering issue will go away, because for my computer the buffering issue is happening every time I start the session after the break. Okay. And now the idea is like how we complete the syllabus. Let me plan you, because those people are waiting for the last chapter, right? After this, there are 3 topics that I am not covering right now. One is NFA with epsilon moves, the Murray and Millie motion, and then pumping lemma, and along with the conversions if anybody want it. That I'll keep at the end. If anybody interested at the end, I'll bring them into practice, okay? Practicing questions only there. We have a lot of practicing questions there also. Is that clear? These 4 topics, conversion between any model to any model, like regular expression to finite beta or finite beta to expression, or even regular grammar will start after this. Clear? Yeah, thank you, Shinchan. Fine, let's begin the session. Closure properties. See, closure properties for regular languages, right? Do you have any list? Let me check. I have the list, but I don't want to go to any list. Okay. Yeah. Just cross check this questions and examples there, because I'm going to explain with my own list now. Okay, let's begin with the closure properties. Before going to the closure properties of regular languages, let me explain for finite languages what are the closure properties. First, have you understood what is closure property? That is, many of you are not aware that what is closure property. Closure property basically nothing but operation. If you take any operation, right, over the languages, this operation is not over the strings. Operation over the strings is different. Operation over the languages is different. This is operation over languages. Everybody? Oh, okay, Rupesh. I just got to know. Because you asked suddenly one question that you were not there at all, so I thought somebody spam. Okay, it's fine, no issue. Now, the closure property nothing but operation. Operation get 2 meanings. Either it will be closed or it will be not closed. So when you are going to apply operation, right, there are 2 things. One, there is a domain. This domain may have the strings, may have the languages, but it should be very clear. This closure properties for the languages, but closure properties can be also applied for the strings. Closure property can also apply for the languages. Closure properties can be applied for various things, like in mathematics can be applied for the numbers. Are you getting my point? So it depends on, can be applied for the programs, can be applied for the motions, can be applied for the grammars, but we are only looking for the closure properties for the languages. That means in this domain we have languages. What we have? languages like L1, L2, L3, L4, L5 and so on. So this domain is called as, let's say, set of languages. So each time our domain will change, like closure properties for finite languages, closure properties for infinite languages, closure properties for regular languages, similarly non-regular, similarly CFLs, DCFLs. So it's a huge topic. So if you can understand at one place, remaining just copy paste mostly the same concepts, same definitions, only language will change. But union definition, operation definition will not change. What result will change? Input will change. Is that clear? But operation definition will not change. Union means the meaning is same everywhere. Intersection, meaning is same everywhere. Clear? So operations we are going to see. First we will apply for finite languages, then we will apply for infinite, then we will apply for regulars. Now what is closure property? We have operation, we have domain. Is that clear? This domain name, let's say D, and operation name, let's say O. If we are saying D comma this operation is closed, it means, I'm talking about the domain is languages. I take any two languages, any means every here, any means every. I take any two languages, I apply this operation, the result, if it is in this domain, then we say this D comma operation is closed. Again I am saying, when we say closed, this operation we are applying on these languages. Assume this is a binary operation, because operation again many types, unary, binary, of course we only take unary, binary, but ternary, k-ary, many things are there. Now pick any two languages, maybe L1 you pick twice, or take L1, L2 or L1, L6, your choice. Take any two languages from here, apply the operation, the result is also inside this domain, in this domain, then we say closed. The definition is very simple. If and only if for all languages, let's say L1, L2 belongs to D, you apply such that the L1 binary operation I am taking, but unary operation you pick only one language, belongs to D. You pick two languages from this domain and the result is also in the domain, then we say D is closed under that operation. Is that clear? The definition is very, very important. For this you have only one concept called as algorithm. You need to write an algorithm to understand this concept. You can't take examples at all. Everybody, example, natural set addition. I am talking about mathematics, not TOC. Natural set addition. So you take any two natural numbers. After addition, is that result natural? Oh, then we say n comma plus is closed. Now natural set over the subtraction. Take any two natural numbers, do the subtraction. Will you get again natural number? No guarantee. In that case, we say not closed. Guaranteed inside the domain always, then it is closed. Not guaranteed, sometimes inside, sometimes outside, then it is not closed. Yeah, domain will change, right? Operations will change, right? Okay, you want to know the difference? The closure properties, we call them what is that? Group theory, right? Closure, these properties are similar everywhere, but domain changes, right? Set of numbers like natural numbers, natural set or real set, or what else? Set of complex numbers, so many are there, right? Set of numbers you will take, or set of matrices in linear algebra. You can also apply in discrete mathematics. Set of languages we are talking about now, set of strings. Domain keep on changing and operations keep on changing. Here you may apply addition, subtraction, multiplication, division, if anything else. Set of matrices, what you can apply? Addition, multiplication, inverse, something like that. Set of languages, what you can apply? Union, intersection, difference, complement, and so on. Set of strings, what you can apply? Concatenation. What else you have? Prefix, no, I don't know. Prefix you can take, prefix, suffix, something like that. So depends on the domain, operations are going to change. Once apply the operation, result is inside the domain, we can say that operation is closed. but you don't get always inside the domain, sometimes you are getting outside the domain, then we say not closed. So in mathematics, especially in discrete mathematics, you only work on this, and in TOS will work on, but special cases you can also look at this. Okay. So there is no restriction how these closure properties can be applied, where it can be applied. It can be applied in any subject basically, wherever you have the operations and the set. Okay. Definition will have kind of similarity, closed definition everywhere same. Yeah, definition is same. In definition, what do you say? There are two elements, any two elements belongs to D. Here you write element applied with other element, that is all. Element we say, but element may be number, element may be language, element may be string, element can be matrix, it depends on the domain. Clear? This definition is same everywhere, only element might change. Here domain has languages, but domain can have numbers, domain can have the strings, domain can have the matrices, that can change. Everybody clear? So I am clearly explaining about the languages, that is why I fixed L1, but actually you can take x1, x2, x3, x1 can be any element. Yeah, Sarfaraz. Yeah, concept remains same. If I want to say not closed, here let us go for the some examples here itself. Here n comma plus, is it closed? Yes. N comma minus, not closed. Closed only will take. Multiplication, closed. Why they are closed? Because take any two natural numbers, do the addition, you will get. Take any two natural numbers, do the multiply, you will get again natural. So that is why they are closed. But when it comes to examples for the languages, we will talk about that slowly. Now we are only talking about not closed and closed definitions. Okay. D comma circle operation is not closed. When we say that, anybody aware? You don't need to find every two, just find there exist, not for all, remember that. There exist L1 and L2 which are there inside the domain, but after applying the operation, L1 applied with L2, you will not see in the D. That is enough to say not closed. That is enough to say not closed. Not closed is so easy, just you need to find an example, take from the domain, but result is outside the domain. Then you got that is not closed. But finding that example is the challenging for you. For this you need an example. For the previous one you need algorithm to prove it. Why every two languages, like if I take two regulars, after applying the union, why the result is always regular again? Because you can prove with expressions, you can prove with the finite automata, you can prove with the grammars. There are many cases why that proof is valid. Here algorithm is needed to prove why every two languages in the domain, after applying the operation also in the domain, you need algorithm. Is that clear? But for this you need example. Example is sufficient. So proof by example, proof by algorithm. So there are two proofs, closed you need algorithm and not closed you need an example. Are we ready now? Are we ready for finite languages? You need to remember the definition before answering closed or not closed. Okay. And I will take as many as possible operations. If you want, even I can explain with the meaning also. Okay. Okay. Two domains I am taking parallelly, finite and infinite. Okay. If you want, you can also write the meaning, why it's closed, why it's not closed. It's not explicitly mentioned in the syllabus, but you should know, aware of this operations over the different domains. Then later on we will discuss clearly for regular languages. Don't know how many comes, just I am putting the lines. So we will see this many, but this will be expanded for regular languages very clearly. Okay, first one, union. just look at the domain when it is having finite languages. When you have the all finite languages, what is the result? Closed or not closed? Let us say infinite languages. Don't consider regular language at all right now. That is later. It's just like mathematical concept. Union, intersection. Anybody do not aware of any definition, please let me know. Complement of a language. Somebody asked complement proof using finite automata. That's very easy, right? We'll see that later. Difference. These are the very famous operations you should remember for all the different domains. Reversal, subset, Cleany star, Cleany plus, both almost same, there is no difference much. Okay, these 9 operations we'll look into it. In the exam, just they will ask closed or not closed. You see a lot of questions like that. Closed or not closed. If closed, just let me know why it is closed. And homomorphism and all these things you will learn in regular languages. If you want, you can write it. It will become very big list now. What is checking closed or not closed? If it is undesirable, why we are able to see it? It depends on the operation, right? If the operation is not possible to apply, the question completely makes it, Rupesh. Operation will tell you, can you decide it or not? You are able to answer it closed, not closed. You are not able to answer it closed or not closed, then it is undecidable question, right? You are able to say, right, if you have the meaning, then you are able to say closed, not closed. It means you have decided the answer, right? All are decidable questions only then. Completely out of box question it is. If it is undecidable, why we should have learned this concept, yeah? When the domain is unknown, operation is unknown, then we can't do anything. Operation is known, domain is known. Yeah, I want your answers, right? Oh, I know, Rupesh. That's why I'm able to convey that answer. Because most of the people don't know how the closed and decidable words should be used. So I predict that if they ask the questions from finite and infinite, mostly they should stand here. Otherwise, you apply the same definition for the other things. Regular language we will see a lot. So now the question is, union for finite languages, is it closed? Now you should apply. Finite language, union, finite language. Is it always finite? Yes. Yes or no? Yes. And finite intersection finite. Keep one domain first, so you will have a clarity. Finite intersection finite. Is it always finite? Yes. Everybody, finite union finite. Take any finite in the world, in the domain of finite languages, right? Here only finite languages are there. Take any two finite in the world, apply the union, you will get finite back. Apply intersection, you will get finite back. But complement of finite, no. It is infinite. Remember that? Here the complement of finite will become infinite. I'll prove it slowly. Difference, finite minus finite is always finite. Finite dot finite, always finite. Finite reversal, finite. Subset of a finite set is again finite. Cleany star of finite, could get even finite. Epsilon, if you do clinical star, you will get epsilon back, you don't get infinite. But if you take non-empty language, then you will get a different one. Clini plus, epsilon plus is again epsilon. So finite, clini plus may be finite or infinite. So look at this importance. How did I get conclusion? You can see the explanation. Okay. Should I write that answer? Okay. The conclusion is here. You see here, finite intersection finite is always, sorry, union, no? First one is union, right? Union, F means assume finite, is always finite. See one direction I am looking. Finite intersection finite is always finite, and finite complement you always get infinite. So why? Anybody aware of that? Why finite complement is infinite? Finite, forget about finite. L complement means over sigma, it is sigma star minus L. If you are doing finite complement, you will get sigma star minus finite. Do you know sigma star is infinite? When you do infinite minus finite is always infinite. It is not mathematical complement operation. It is the TOC over the sigma complement, remember that. Mathematically, finite complement may be finite, depends on, because universal set, their universal set is always finite, but our sigma star is infinite. In mathematics universal set could be finite, but in TOC sigma star is universal set which is always infinite. That is why infinite minus finite is always infinite. That is why we got here not closed, because finite complement is not finite at all, even single time also. But to prove closed, every time it should be finite. Finite minus finite. What is finite minus finite? Is again finite. Why is that? There are few concepts you should know. They are, you can see here. One thing, the finite intersection any language, you always get finite. The few important operations. Finite, you subtract with any language, forget about finite or infinite, right? Doesn't matter. Any language in the world you take, finite minus anything, you get always finite. Right? There are other concepts also. Infinite language, union, any language is again infinite. Right? These three properties are very, very important. In the exam, this was already asked one time in the gate. Okay? Now, concatenation, finite dot finite. See how many strings you get. Let us say 100 strings, let us say 1000 strings. 100 strings followed by 1000 strings. This concatenation only you do, right? So again you will get finite only. There is no concept of infinite. Reversal. एक finite language है, उसमें reversal करना है. Every string you take and do the reversal. Finite number of strings, and reversal also will get the same strings, same number of strings, but reversal. So now if you want to understand reversal, one more concept here. If you say any language, right? Let's say number of strings in L is n. If you do L power reverse, the number of strings is also n. But only the thing is, if AB is here, then reverse will be BA. So every string you will do the reverse, you will get the L power reversal. So remember this one, if L is a finite, definitely there are n number of strings, and reverse also will get the same n number of strings, only every string in the reverse form. Okay? So keep this point. If L is equal to n, if L has n strings, reversal of L will also have n strings. But if it is infinite number of strings, then you can't write this n. Okay? Both will get infinite. Subset. How many of you know subset of a language? If I take my language is finite, if I am trying to find the subsets, you get 2 power n subsets, right? And every subset definitely finite. Everybody knows this concept. Let's take my set is okay, having finite number of strings only. Is this finite set? Finite set. What are its subsets here? Subset could be empty, or subset could be what? Only A. Subset could be only BA, or subset could be X itself. Now every subset, is it finite or not? Because given subset is finite, then subset of that finite is always finite. So every subset that you got here, every subset of finite set is dash always finite. Correct? That's why you are getting back to the finite always. So that's why it's closed. Subset is closed for the finite language. And clean is star. This is one difficulty. Why this is not closed? Take one example. Take one example. If I take L is equal to epsilon, then try to do L star. Again epsilon only. Right, that is a finite. But what about if I take L is equal to A? One small example, look at that. Earlier I was talking about epsilon pi. Let me explain that. If L is equal to A, now L star, are you getting a finite back? No, right? This is the infinite. That means this is enough to prove why it is not closed. Right? Except epsilon and empty language, every clinic closure will get infinite, like a complement. Complement for every language. But this clinic closure, except empty language, except epsilon. Only epsilon is there or nobody is there, then only whole star will become finite language. But all other cases, all non-empty languages, the clinic closure is infinite. That means clinic star for finite languages, the result may be finite or may be infinite. The infinite example I have given. I took finite, but clinic closure got an infinite. That means not closed. Same clinic plus, same example, L plus will be A plus. So it is also not closed. Any doubt in the finite languages? Because I am going for infinite, here it is important. Any doubt for infinite finite languages? Then I will take up and then I will go for the infinite domain. Clear? Okay. Let us answer the infinite. Now what is your domain? Never take finite languages as an input, because our domain is fixed. Now I have Clini plus Prabhakar. Clini plus there only are L is equal to A. This is the finite. After applying L plus, Clini plus, is it getting finite? No, right? Infinite, that's enough. There exists L, after applying operation you are going outside the domain. This belongs to domain, and I took the belongs to domain. After applying the operation you are not getting belongs to domain, because our domain is having only finite languages. Now this infinite is outside the domain. That's enough, right? That's enough, right? Why Clini closure and this Clini plus both are not closed? That was already there. Answer is here, already there. Here only I said L plus A plus, that's all. The Clini star is having already explanation. Yeah? Fine. Infinite language. Union, closed. Intersection, no. Complement, no. Difference, no. Concatenation, yes. Reversal, subset, no. Clini star, yes. Clini plus, yes. How many of you got the correct answer for you? This list is given much time back, right? How many of you got the correct answers for this infinite languages? Not for all, but maximum 90%. Out of 9, how many of you did at least 7? Yeah, Amrit, happy Republic Day. Good. Okay, anybody need any explanation? Please let me know, so that we'll go for regular languages. Just give me a second. Okay. Are you able to see, right? I just hided the messages. Yeah. No, you are not able to see, right? Yeah. Complement and difference. Complement and difference, right? Okay. First one is clear. Infinite union infinite is always infinite set. No doubt about it. Intersection. Why? Just take A star, B star. Let me take small example to understand whenever not closed. This one, just A star is infinite. An intersection. B star is infinite. But result is finite. Oh. That means you don't get infinite always. I have two infinite languages. Their intersection not able to get always infinite, because I can show that one example you got a finite. Is that enough example? Why we have the not closed? Not closed means one example fine. I don't need every example in the world. Remaining example may get infinite, I don't care. But some example I have, the result is finite. The next one, what is the next one? Complement. See, I can show you one example. Complement of infinite. I'll show you one example that is a finite. That's enough, right? Take A plus B whole star, sigma star. Do the complement. You got empty. That's enough. Infinite complement may not get always infinite. Starts with A, complement maybe, you will get infinite. But sigma star, sigma plus complement, only epsilon. Are you able to understand? Infinite language complement, you don't get always infinite. That's enough. Counter example. Right? What is not closed? At least one language in our domain. Our domain is infinite languages. At least one language is complement. Going outside the domain are finite languages, that pi only epsilon. Correct? Now, any other example? Difference. Difference, right? Take the same language here, sigma star minus sigma star, what happens? Empty. Result is not infinite now. I took the sigma star, both the times I picked the same language, I did the difference, I am not in the domain. I went outside the domain, that means not closed. The pi is outside the domain, finite language, right? And subset, yeah, subset. Itself is fine, but pi is the subset of everybody in the world, right? Take any infinite, take L is equal to A star, and the subset of L, I can write empty language, I can write epsilon, I can write only A, I can write only double A. So many finite languages. Every subset of A star need not be infinite. I have the subset. I have some subsets. Subset of L I can have is only pi. Instead of writing this way, let me show you another way. See here. I have infinite language. I have what? Infinite language. This is an infinite set. Now, do you think every subset is what? Infinite? No, this is not infinite. This is a finite. Only epsilon, only A, or A power n such that n less than 10. These all are finite only, right? That's enough. Counter examples, one is enough. You don't need all. But A star itself is infinite. And inside also double A whole star is there. This is infinite. A power prime also there inside. This is infinite. See, some subsets are infinite, some subsets are finite. That's enough to say every subset is not infinite. Some subsets are finite, some subsets are infinite. That's enough to prove why it is not closed. When we say closed, every time you are in the domain, but are you able to prove? When I put a cross, every time you are not able to prove. That's why I put the cross there. Okay? Yeah. Right? Right. Are we ready to go to the regular language? That is the actual topic now. What we are looking for closure properties for regular languages, just to understand Without algorithms, this finite infinite domains I have worked on, right? Here I did not use any algorithms, but for this you should learn algorithms. Okay. Okay, I'll take the list one by one. Now it's actual heading also same regular languages. Okay. Union. You tell me it's closed or not. Okay. In one line, intersection. Do you really need big list? Time waste, I think. Yes. We have a shortcut to remember also. Okay. How many of you know all these are closed? Okay, in the exam, the union intersection so important, including complement, right? In the interviews, they will ask, prove it. Why are you saying the union of two regulars is regular? Can you prove it? Then you should know exactly algorithms. Oh, Shubhani, you are not following. Did I miss that cross mark? Cross means only two things. This means cross. Here only 2 points I have. Here tick means there is no word may not be closed. This means closed. Cross means not closed. There is no word may not be closed. Okay, remember that the people I have seen, a lot of people, right? Closed word is there, not closed word is there, but may not closed word is not there at all. In English, looks like the all words are correct. There is no meaning to this. Closed means all the time, for all x1, x2 belongs to domain such that x1, x2 some operation, x1, x2 you apply, x1 circle x2 is also belongs to domain. Not closed means there exists x1, x2 belongs to domain such that after applying the operation it's not inside the domain. That's all. There is no kind of need not be closed. Need not be. But result is different. Yours is good point because many people don't observe it. See here, where is it? Let me talk about that. Infinite, intersection, infinite. Don't ever say not infinite. What we say, need not be infinite, because sometimes infinite, sometimes not infinite. Because for that you can see example, A star intersection A star, oh you got A star. A star intersection B star, oh you got epsilon. So sometimes infinite, sometimes finite. That's why by observing this you got this answer. But because of this, infinite, let me write that too, set of infinite sets under the operation intersection is not closed. We say only one word, not closed. It means the result may be always outside the domain or maybe sometimes outside the domain. That we don't know. The operation will help us. Oh, sometimes inside the domain, sometimes outside the domain. Clear? Everybody clear? When do you say there is no word not need not be closed? Directly is closed or not closed? It means the infinite intersection infinite may be always infinite. Maybe means you should answer it. So infinite union infinite, always infinite. Infinite intersection infinite, sometimes infinite, sometimes not infinite. If there is no closed, not closed words we are using separately. Is not closed. There is no word need not, but need not be infinite is there. That's a different word. So understand clearly. Oh my God. Okay, the words itself need to have a clear when to use the word need not be, that will use for understanding the result of the language. But close, not close, together we speak. Domain, operation, when these two are together, is it closed or not closed? That's all. I did not give a definition for may not be closed, that word is not there. Okay. Everybody clear this point? May not close, the sentence is not there technically. Okay. Let me write the list of operations. Later I will explain the examples. Okay, which one is not closed? Any idea? Which one is not closed? We'll just work on examples after this. Anyone remember them? Okay, I am just making short, I don't want to discuss everything here. Can we fit here? Okay. So this big list you can remember just with the two words. Two words. In the world you have hundreds of operations. In the exam, predict that they may give you own operation. You should know how to explain or how to understand. So don't assume that they will ask only these questions, but 99% they are asking only these questions. But 1% they can make a new operation too. Finite substitution. So if you are not aware of the definitions of this, then just work on this. The infinite union, 27 infinite intersection, 28 infinite difference, 29 infinite concatenation, 30 just copy paste the same thing, infinite subset. What is the list that you have? I saw many classes students made the shortcut. What is the shortcut? Just remember two words here. One is a subset, other one is this infinite. So if you want to know the closure properties, closed or not closed, just remember shortcut, the subset, of course proper subset also you can answer it, and infinite followed by any operation like union, intersection, difference, concatenation, substitution and subset. Just remember two words, subset and infinite followed by anything. That's correct, Rupesh. But can you remember the two words? If you can remember the two words, 9th and 26 to 31. Numbers also don't remember because they keep on changing it. Depends on how many you include. So subset, and don't use finite subset word, that is closed here, finite subset. Okay. So 26 to 31, infinite followed by any operation name that you see, union, intersection, difference, concatenation, subset, substitution. This all are Quotient, the meaning, we'll see examples. Quotient, we'll see example, Anjali. Okay, so remember these two words right now. So I'll just take one example, work on each one just to understand. One example each one quickly. I am coming, Tanish, you asked, right? Each one I am going to take one by one very quickly. So please, if anything is missing, please ask me quickly. First one, union. We know it is closed. For whom? Don't ever say closed, but you should say whom, which domain? Closed for regulars. But it may not be closed for everybody, right, in the world. It is closed for regulars. It may not be closed or may be closed for others. But why? Why it is closed? Why people are saying that regular union regular is again regular? Why is that? Do you have any algorithm? So many algorithms are there. For this, you write one regular expression. For this, you write another regular expression. You can always write, because they are regular languages, put a plus. This will be another regular expression. This exactly generates what you want. Is that clear? A very simple proof here. Of course, in finite matter also we have a proof, composition. Union, everybody clear? Screenshot? Okay, screenshot lena hai, le lo. Remaining all, that means, I'll just put the tick marks. You don't need to worry about all this. We'll see the examples and proofs for some of them. They're all closed. Tick means closed, remember that. So now cross tick. This is not closed, and you can see the red mark. Green are closed and red mark are not closed. Just remember two words to get the shortcut. Done? Yeah, you can get the video forward and backward, right? So to get the answer. Okay, here what kind of questions are coming in the exam? First, you got a proof, right? There are many such proofs. Composition. I'll just write the words. There are many proofs. If you want to learn, right? There are many proofs. You can use regular expressions like this, or you can use finite automata like 1 cross finite automata 2, composition. Use NFA also, like design one NFA and put epsilon transitions for both initials. Use regular grammars. Oh, there are a lot of proofs. In the exam, in the interviews, you can use any of the proofs if you know. Okay. So now the question is, what is important for exam? Anybody knows? What is important for the exam? Say, look at, let or if L1 and L2 are regulars, regular languages. But I can't write for every operation, right? Only this operation I will help you. Okay. Then they will ask, what is L1 union L2 is dash. They did not mention which regular, right? They did not mention which regular. Is enough closure property is enough to answer this or not? Because in closure property, already we know this union is closed. This is only the closure property that we are talking about. Right? It is always regular. Is regular means, remember, when we don't mention always, it is always only. Is always regular, also written as is regular. Remember that sentence also. Second. Now question is different. If L1 union L2 is regular, then can you say anything about L1? Of course, in the exam they may ask you, and for L2 doesn't matter. Can you guarantee regular? No. Here answer comes as need not be regular. Now you have a doubt. So how is that possible? When these two languages are given, result is regular. But result is regular doesn't mean that L1 is regular. So now examples needed. Oh, you should know L1 union L2 is regular. This we should prove that L1 may be regular, may not be regular. So now we have to prove what could be L1. So we are trying to prove that. You see it. Now union you need a regular, right? This one I will take sigma star. Even I take this as a non-regular. Okay, let's take this one is non-regular. L1 is non-regular. L2 you take sigma star. What is the result? Is equal to sigma star only. We got L1 union L2 is regular. But did you prove that L1 is regular? No, right? It's non-regular. Now switch them. Sigma star union not anything. Any is fine. Is equal to sigma star. One example, right? That would be sufficient. This is regular. It's enough. L1 sometimes non-regular, sometimes regular. Sometimes non-regular, sometimes regular. That will give you L1 is need not be regular. The same way L2 is need not be regular. Everybody? This is a model gate question. When last year, I guess, last year it was the question. Last 3-4 years, it was asked twice. Closed or that's a different question, yeah. Decision properties, that is. The topic is not yet started, Aniket. Is L1, when L1 and L2 are both are regulars, then you can decide it. You have an algorithm for that. That's a different question, right? That's a decidable question. There we will understand, right? Subset check, the set containment problem. What you are asking is set containment problem. What I have to repeat, this is given and we need to find what is L1. L1 union L2 is regular. Now is that guaranteed that L1 is always regular? So L1 sometimes regular, sometimes not regular. That's what we are proving. If you can prove this, one example for regular, one example for non-regular, then I can answer need not be regular. Now that's what I have taken. This is a non-regular example, this is the regular example. See, result is always regular or not? I am just taking, don't look at this, L1 union L2 is sigma star I am taking. This is regular, right? That doesn't mean that L1 L2 is L1 is always regular. No, L1 is sometimes regular, sometimes non-regular. Understand theoretically. You could take infinite examples are there in the world. I am only taking this example. Non-regular you can take anything here. A power n, B power n. Any non-regular you take, you know, anything union sigma star is sigma star only here. Why I am taking sigma star? Easy to prove, easy to understand. Why I am not taking difficult examples? Because how do I think infinite examples are there? Which one to pick? This is very easy to pick, sigma star. Right? Sigma star very easy to pick. Empty language, sigma star, A star, B star. These are very easy to pick. Okay? Everyone? Just read the sentence carefully. What is given? What do you want to do? If L1, L2 given, then L1 union L2 always regular because I proved just now. Write a regular expression, put a plus in between, you always get a regular. Or you can use many proofs are there. You can use so many proofs are there. There is a proof 1, there is a 2, there is a 3, there is a 4. There are 4 proofs I have given here. But algorithms are different for each one. Okay? Done? So that's the problem, right? Each one it's a, if you want to more practice on this, you can just try like this. L1 is equal to A star, L2 is equal to B star. Can you find what is L1 union L2? which is A star plus B star, or in the exam you can see A plus B plus epsilon, or in the exam you can see A star plus B plus, or in the exam final conclusion is same set of strings should be there. You design, you write anything, all are same. Of course there are infinite answers. L1 is equal sigma star, and L2 you take any, then what is L1 union L2? Sigma star. L1 is equal pi and L2 is any, then L1 union L2 is always L2. Okay. Similarly, you just think about all possibilities. Okay, that is a union, right? So now can you think about intersection similarly? So now I don't want to explain that way, right? So now let's look at some of the examples and proofs if needed. L1 is regular, okay, that's a point, and L2 is regular. Can you answer then? This means then, assume that then L1 intersection L2 is dash, okay, is what? Second, if L1 intersection L2 is regular, then can you answer what is L1? L2 also you may ask similarly. 3, if L1 and L2 are non-regulars, then can you tell me what is L1 union L2? This theoretical gate questions completely, no example at all, right? You need to find out. You need to find out examples for them. Non-regulars, then L1 intersection L2. The proof is composition. You can do two finite meta composition, the intersection can be proved. Okay, complement I will explain after this. Okay, answer 1, 2, 3, 4. What will be the final answer? It's a given, clearly it's a given. You need to find out, is it always regular, is it always non-regular, or need not be regular? What is the answer? 3 options I am giving: regular, non-regular, need not be regular. Okay, you can choose the option. Okay, I am giving the options like A, regular, B, non-regular. Think about this only, don't think about anything else. Need not be regular, means may or may not. Choose A, B, C, any one option. First one is a closure property. Closure property, no need to worry. Every two regular languages intersection is closed, so the result is always regular, no doubt. If intersection is regular, then can you tell me what is L1? Here L1, L2 not mentioned. You need to find in the world. It's not the closure property question, right? It's not the closed, not closed question. The result is regular. Oh, result of two languages intersection. Now they are asking what is L1. So now you need to think about, when I take L1 is non-regular, is there any possibility of the result is regular? Right. When I take L1 is regular, we have the options already. Now you need to think about this. Don't say regular. The answer is need not be regular. This is what we fail many times, because you are not able to interpret properly. Here see, L2 I will take pi. I can take here A power n, B power n. Non-regular I took L1, still result is regular. Still result is regular. I take regular only, still his result is regular only. Can you see that? I am getting the result is regular even though L1 is not regular. That means when intersection is regular, no guarantee L1 is regular. So understand this point. 2 is actually L1 may or may not be regular. Still the result can be proved as a regular. Result I am talking about, but question is what is L1? Is it always regular or is it always not regular? We don't know, anything could happen. When L1, L2 are non-regulars, their union again need not be regular, need not be regular, non-regular, anything you can answer. May be regular, may not be regular. When both are non-regular, need not be. Non-regular also you can write, need not be non-regular, both are same. Okay, now anybody need any explanation for any question? Because this could be direct gate questions and predictable. Anybody do not not able to understand, please let me know. So I will explain the any statement here. Because late after this, we will just discuss important examples only. Are you able to understand? Two non-regulars union, this is non-regular, this is non-regular. Their union can be regular. Do you know that point? Can be regular, can be not regular. Right, A, C, 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 correct. Can we go further? Because this might be the important factor. How do you know that need not be regular? See here, A power n, B power n, non-regular. Its complement also not regular. When you do the union, you will get sigma star. When you take the same language again, then what do you get? Same will get. It means sometimes regular, sometimes not regular. Sigma star is regular and A power n, B power n not regular. So result may be regular, may not be regular. Example is here. Right. So those people who want an example, you have here. Intersection. Sometimes I will show you regular, sometimes see A power n, B power n, intersection B power n, A power n. That result is only epsilon. And I will take the same language again, then I will get non-regular back. Sometimes non-regular, sometimes regular. So answer is need not be regular. Everybody clear? One example for regular, one example for not regular. So non-regular languages union. I may get regular or I may get non-regular. Non-regular language intersection may be regular, may not be regular. So these examples might not click immediately, but just always depend on 2-3 things. Focus on sigma star, focus on empty language, focus on A power n, B power n, focus on epsilon, and focus on their complements. There you will have the logics completely. Everybody? Don't pick random languages. Pick always well-known languages in the world that can give you answer. But don't know which one to take, just randomly try well-known only. Not all the languages in the world. Okay. Somebody wanted complement, right? Just let's go for complement before going to any other. See, regular language, L is regular. Then why L complement is also regular? Not only this, if anybody gives L complement is regular, then also you can prove L is regular. This is a completely different statement. Because of this, you can write simply L is regular if and only if L complement is regular. You can do that. And not only this, L is non-regular if and only if L complement is non-regular. Of course, union you can't write if and only if. L1 and L2 are regular, then you can prove L1 union L2 is regular. But converse need not be true for union and intersection. okay, only for complement both side holds. So what could be the reason? Anybody? L complement. If any one is regular, other definitely regular. Why is that? Any guess? Suppose I am assuming L has a DFA. Do you know how to get the DFA for L complement? You can get complement DFA by interchanging finals and non-finals. You get DFA, and this DFA definitely accepts L complement. That means if L has a DFA, L complement will have a DFA. Same algorithm, L complement, if it is having a DFA, then interchange final non-final, you will get DFA for L. That's why the complement of a regular is irregular. Complement of a regular is always regular. Clear? Is this statements are clear? If any one of them has a DFA, other will have a DFA. But if any one of them is not having a DFA, other will not have a DFA. Clear this point? This is an algorithm for complement property. Now you ask me, any regular language in the world, its complement is also regular. But you need an example sometimes to understand. So let's take some examples. In the exam they ask a very different way. You don't believe that questions comes. Suppose L is pi. What is its L complement? Can you answer it? You know that, right? Of course, reverse I am not asking, you know that. If L is having epsilon, then what is L complement? 3. If L is starts with A, assume sigma is just A comma B, so that we can easily write the answers. Then what is L complement? Anybody? If L is equal to ends with A, then what is L complement? 5th, if L is equal to, what can we write? Very interesting, that is, sigma star A sigma star. What is L complement? Don't know how to interpret, but just check. So can you find out the complements? Predictable gate questions again. Let me have water. After this we will go for the grammars, regular grammars and context free grammars together will go. Then push down automata, then CFLs, DCFLs. So second and third chapters will have discussion on all concepts, but you don't spend much time like this. Yeah, what is that expression, yeah? Yeah, not starts with A, I know, but what will be the expression? The meaning you understood, right? Starts with A, not starts with A, but what will be the answer? Not ends with A. Good meaning. That is a good meaning, right? This one is sigma star. This one is sigma plus. What is this one? This one, either string starts with B or it will have epsilon. Is that clear? Because here epsilon is not there, so in the complement it should be there. And here ends with A. So string might end with B or it will be just epsilon. So only two kinds of strings. Containing A. Anybody written not containing A? If it is not containing A, anybody answer that? This is a contains A, right? Not containing A is simply B star. A is not there means what will be there here? Only B's, right? Only B's, that is a B star. Okay, not containing A means only B's can happen if A is not there. Okay, last one I am expecting. Let's see fifth one, we will answer it. If the string is not in A star B star form, then what will be that string? No, yaar, epsilon should never come in the complement because epsilon already A's, B's all are there, yaar. So I'll just wait for your answer because one of the important concept in regular languages, A star B star complement. In future, if they want to ask the complement, this is much predictable. And remember here, L union L complement must be sigma star. That means every string in the sigma star, one of them should contain. And L intersection L complement is always pi. There should be the no common string. Remember these points. If the string is already here, in the complement never happens. But when you do the union, never miss any string in the world. Every string should cover. So keep that concept clearly. Okay, what is the last question? I'll just wait for 1 or 2 minutes here because you may need a time. What sigma star? What is that? Where is AB? B is there, B star is not there here, na? Here A is must always, the containing A here, only B is not there here. Sigma star, it's not the sigma star plus A, it is sigma star dot, this is there, only B is not there here. What is interpretation? A always there, only B is not there here. If B is coming, A is also there. Only B never happens there. Come on, what kind of interaction? AB is different, B star is different. Both strings are different. Containing A. Don't say exactly 1A. Exactly 1A I didn't say. Containing A, before, after anything. It's not, question is wrong here. Don't assume it is exactly 1A because A plus B whole star is there. It is the containing A. Should I write that meaning here? It's a contains A. Don't say exactly 1A, wrong. Sigma star is having A's here. Right? You are assuming it's a 1A. 1A is wrong. How do you write 1A? B star A B star. This is exactly 1A. This is exactly 1A. This is not exactly 1A. It's a sigma star, not just B star. Okay? B star A B star. This is exactly 1A. Because remaining positions you will never get A if you have the B star. I think Prakar, ask your friends. They might got from Telegram or in the app. So if not downloaded, request the sir to upload so that you can download. Okay, in the app you may find it. Come on. Sixth, B power n A power n. Why B power n A power n? Yaar? So are you saying that A star B star union B power n A power n, is it sigma star? Wrong, right? Because here I can't cover B A B in N, both of them. How can I say that it's, oh no. Here, any string which is not in this form, they must follow BA. It must containing BA. So before, after anything. So it's one of the important concept. If any string contains BA, that never be in this form. So containing BA is the logic. If any string contains BA in the world, then it is never be in this form. One never say B plus A plus, wrong. That B plus A plus can't cover everything outside the L. Only you are looking for A power B power form. Who will look for B power A power, B power A power, B power A power? Can come in any sequence, any long, right? So this can cover everything in the world outside the L, right? Come on, come on, come on. What people are answering? It's not A plus B whole star here to say L complement is pi. So understand A star, B star, why you are getting complicated. I know that. That's why I am asking that language. A star, B star is this language. Now this is the sigma star. Now here what strings are there? Are this only B plus A plus? Is not there B plus A plus B plus? Is not there B plus A plus B plus A plus? Who will cover all of them? Yeah? Only this one? No. Here BA, sigma star, sigma star. If you can find BA anywhere, before after anything can happen. This is exactly outside what you see here. If you do the union of this two, you will get all, right? So you are only thinking about this, then who will think about this, who will think about this? There are so many instances where you can't think individually except this form. Okay? Okay, fine, fine. Got it? You know, there are some other ways to understand, but that way is constructing DFA. If you can understand DFA complement of complement of language, there you may understand sometimes. Okay? Got it, everyone? But not that easy. That's why I am trying to explain. Not that easy. Okay, try to consider DFA later on. Just cross check. Okay, any operation that you need, please let me know. So closure properties. So I just explained all of them, which are closed, which are not closed. Just cross check. If anything wrong, just correct it. Okay, I did not say it properly here, but check it. Table for finite sets, table for infinite sets. So which are closed, which are not closed. And what else? Regular languages, you know, all are closed here, right? You know all of them. But any of the operation do you need, let me know. So I'll explain them here before going to the next topic. Okay. Yeah, some of the examples are also there. Just follow them, which I have not explained. You can find out from here. So I'm not reading this. Okay. I think till this you have the closure properties. Got it? So now tell me which operation you wanted to. Let's say quotient. So some people are not aware of the quotient operation, right? What is the definition of quotient? Basically for the strings and for languages, both are different definition. Like for the strings, UV by V, the answer is U. This is for the strings. For languages, L1 slash L2 is nothing but the V such that UV belongs to, sorry, this is U, right? U such that UV should be there in the L1 and V should be there in the L2. Then only you can get that is U. U is the answer. Almost same when you are applying for two strings. When you are applying for two strings, example A, B, C slash B, C. So this is the V and this is U and this is V. So the result is A. And do not try to cancel like a mathematics division. It's not a mathematical division. So remember that it's not a mathematical division. Suppose you have ABC slash A, you get nothing because the same A should be here, but it is not matching. So V is not there in this at all at the end. Look at that. ABC slash epsilon, you will get whole ABC because you can assume after C epsilon is there. So this is a very important point. So ABC slash epsilon, you can write ABC epsilon by epsilon, you can assume ABC is the answer for this. Everybody got what is UV by V is equal to U concept? Yeah, the denominator, this is if you assume denominator, this should be there at the end of the numerator. So that looks like a suffix. If it is there at the end, then remaining portion will be in the answer. Like 23 by 333 cancel 2 like this. 123 by 23, then 23 is going to be 1. Something like this. Are you able to understand? ABC by ABC, then cancel it, here epsilon is there, you will get epsilon. Are you able to understand? But don't do mathematical division, it's not a mathematical division. So nobody was there to explain at that time when I was preparing. Many things were, I know, understood wrong way, and that is why today I am able to explain in the right way. The only thing is when you do the mistakes, you will do it correct way. Right? You are getting exactly what you need to learn, but at my time, nobody was there to explain correct way. So people used to say what is closed, not closed, that's all my concept. Right? Why it's closed, why not closed, nobody was there to explain. From the books, so many pages are there to understand. When we read the books, we don't get clarity because we don't have the patience to read the books. You know that, right? So it's very difficult to learn from the textbooks, because not a one textbook, 12 textbooks for the gate is not that easy. Of course, I read the textbooks, I read it, but not got much concepts from textbooks too. Yes, only the thing is you do the mistakes and learn it as best as possible. Right? That's why, in my classes I always ask you, request to ask the doubts. When you ask the wrong question, you will get to know what it is wrong. That way you should not ask. If you not at all ask, right, तो आपको पता नहीं होगा यार ये कैसे पूछना है क्वेश्चन. वैसे भी सीख सकते हैं आप. क्वेश्चन पूछो, गलत है सही है, बाद में सही करोगे. Okay, so this is what the quotient. Now examples. Just look at. Suppose somebody asked A star by epsilon. Can I say A star? Because epsilon is there at the end of every string. So how you do that? Right? You can just put A star dot epsilon slash epsilon, you can assume A star. Okay. Second, if you write A star by A, so don't ever say A plus directly. It's not that way. You should answer something like this: epsilon A square, A power 3, and with every string you need to do the coefficient, right? Every string you need to do the coefficient with A. So how do you do that? Epsilon by A by A square by A cube by A, and so on. So from here you get nothing, that's fine. But from here you get epsilon, from here you get 1A is there, and here you get A power 2. So what did you get? Epsilon A square, which is actually back to A star. So are you able to get? You got the answer A star. So A star by A is A star. You will get nothing. If the pi is there, you get nothing. When you have the string, right, you will, L by pi is the pi, you will get nothing. L by epsilon, you will get L. Suppose A by A star, in this only one thing matches, that is A by A. Oh, there is one more, epsilon is also there, I am sorry. Epsilon is there, A by A is there. From A by double A onwards, nothing will match, because double A is never be there. So here you get 1A, here you get epsilon. So answer is epsilon plus A. Everybody got the answer? So this is how you apply the quotient. This is how you apply the quotient. So understand, for the simple examples, when the lengthy question comes, you can easily apply. Any doubt in this? So only thing you require to remember, subset of regular language is dash, need not be regular. That example is very important. Just take A plus B whole star. Everybody knows it is regular. Everybody knows, right? It is regular. But its subset, see, pi, regular. A power n, B power n, it is also inside but not regular. A star, B star, it is inside, it is regular, and itself is regular. right? So many, b power n, a power n is also inside, that is also not regular. A star inside, that is regular. So some subsets, these are all subsets of this language, but some are regular, some are not regular. That is why this statement, the subset operation is not closed. Even proper subset also same answer. Yeah, Rishikesh. Subset, you are asking about 26, which union? Okay. Anybody else have the questions here before moving to anything? I will just explain infinite union. Just think similarly for all other infinite concepts. Infinite union, finite union. What is the difference? Practically, finite union is possible, but infinite union practically impossible to implement. Okay, impossible, because how can you do the infinite union except theoretical understanding? Okay, so how you understand now? Infinite union means for regulars you are applying, right? So you have a regular language 1 union, regular language 2 union, regular language 3 union. You apply infinitely, the result, what do you get? You are going to prove it need not be regular. What you are going to prove need not be regular. But when you apply the similar concept, regular 1 union, regular 2 union, regular 3, but how long? Only finite time, right? Let us say k. K is fixed, constant. It is a constant. Maybe 100 or maybe 1000, you will always get the result is regular. This one you do not need, because union of two regulars is regular, yes or no? This is regular, and regular union regular is regular, and keep doing the k minus 1 times, finally you will get regular only. The same proof, every regular language you write expression, put a plus in between, answer is over. But this one, why sometimes regular, why sometimes not regular? See, if I have only epsilon as R1, this is a regular language, right? Union, and R2, I just take one string. This is also regular, right? Finite language, in fact. Union, this I will take only a square, b square. Oh, this is also regular. If I keep on doing the similar kind of strings, the result will be a power n, b power n. But is it regular? No. And in fact, if you want to prove regular, very easy. Sigma star is regular, and you take any regular language, result is sigma star. So now you can conclude the infinite union, if you are going to apply for the regular languages, the result may be regular or may be not regular, but practically we cannot prove, because union is impossible to apply infinite time, right? This one is practically possible, and you can prove it is always regular. That is why finite union closed and infinite union not closed. Yes, that is correct. Finite subset of any language is finite. Any other? If you have any questions, write, because this is the right time to ask the doubts. Okay. Because some people will wake up and will join for the next chapter. Now we are still in the first chapter only. Yeah. So any doubt you have, you can ask in other chapters too. So let me move to slowly regular grammar and context free grammar. Okay. So everybody knows this definition. What is a regular grammar? Can we start the next topic quickly? And no, without CFLs, DCFLs, how can we go undesirability here? Any of this video is there, right? In case you are not able to continue because you are getting sleep, you can watch video later also, okay? Otherwise, you go to sleep meanwhile, wake up by putting alarm after 1 hour or 2 hours. I am there here, right? Anjali, in case you want undesirability, you can go for sleep sometime and then wake up later. Okay, those people really waiting for the last chapter, right? So get relaxed and come back. Are we ready for the next? Target is still 11 or 10, now 4, right? Next 6 hours, 5 hours will be there in my guess. Okay, after this first chapter, so with this regular grammars, we are going to begin the context free grammars also. Are we ready? In revision, get doubts. If you have the doubts, you can ask anytime. Okay, let's start. The regular grammar definition. What is the regular grammar? It should be either left linear grammar or right linear grammar. If the grammar is left linear grammar, the non-terminal left hand side exactly 1, even right linear grammar non-terminal LHS is exactly 1. But RHS side, the leftmost position only non-terminal in the LLG or no non-terminal at all. If you have non-terminal in the RLG, that must be at last. So what is the meaning of this VT star? VT star means the one non-terminal followed by any sequence of terminals. Here T star V means any sequence of terminals followed by one non-terminal. Example, something like this: S derives AAB. So this is the production for left linear grammar. For this, S derives, let's say, ABCS. So that is the first rule. There is another rule. You can also have epsilon. In the T star, you can write epsilon also. Here also I can write something like AB. So the T star, you can write 2 sequence of terminals. So your production should be in this form or this form. You can have 100 productions in this form or 1000 productions in this form. You can mix. But your grammar should follow LLG or RLG, then we say it is regular grammar. But don't take few productions from here, few productions from here will not be a regular grammar. Remember that. It must match this definition or this definition. If anybody writes something like this, AS or SB or C, say that this is not a regular grammar. Not regular grammar. I am not saying not regular language. Language might be regular, may not be regular. But this grammar, this rule following RLG, this rule following LLG, and this rule following both. This rule following both. Now we can't conclude it is regular grammar. Why? You can't say whole grammar is LLG. You can't say whole grammar is RLG. So we can't say it is regular grammar. Everybody clear? What is regular grammar? It must satisfy this definition or this one. You can't have this grammar at all. But when it comes to context free grammar, the LHS, RHS, in the LHS only one non-terminal. RHS no restriction, anything, any. So you can write something like this: V arrow V union T whole star. You know, right? Sigma star means everything. Here V union T whole star means anything, any sequence. So this is the rule. Just guarantee LHS is exactly one non-terminal. It is the context free grammar. Oh, what is grammar? You want me to repeat that? Okay. What is grammar? Grammar is set of 4 parameters. The V basically represents set of variables. Like finite automata, like regular expressions, we have the 4 parameters. Regular expression we have 4 operators. Finite automata we have 5 parameters, and grammar we have 4 parameters. So V represents set of variables, which is similar to like states in the machine. T is like your input alphabet, similar to that. Set of terminals. Terminals we represent with the lower case always. Variables, non-terminals, we represent with uppercase mostly. P is the set of productions, also called as set of rules. So grammar basically called as the collection of the rules. This is only the grammar definition. S is a start symbol. That's one of the symbol in the V, right? So now what is a grammar? Grammar is the collection of productions. What is a grammar? Collection of rules collectively used that generates a language, that generates a set of strings. That means grammar basically represents a language. Like finite automata represents regular language, regular expression represents regular language. Now regular grammar will represent regular language. Is that clear, Rishikesh? It is another model to represent a language. Like automata, we have another model to represent a language. Now come to the regular grammar. Is going to represent a regular language by using two kinds of restrictions. You follow LLG or RLG, then we say it is a regular grammar. Okay. Context free grammar is going to represent context free language. This CFG is going to help us next chapter, that is context free language. Okay, what is context free language? Means you should have a context free grammar or PDA, that we will discuss again. Okay, let us start. Are you able to understand? Of course, this you practice here. I can't help this. Okay. Similarly, I'll help you to practice. Okay, first one. Suppose somebody is writing the epsilon. What is the language? Can you think about it? What language it is? Always we start with what? To generate a string, we start with S. So whatever S produces, if I ask language, you just do what S does. That is language generated by grammar. It is just epsilon. So always we assume the first symbol is going to be start, and then your grammar will begin. So whatever S is going to produce, that is your language. If it can't produce, empty language. Empty language, look at that another one, second example. Suppose S is there and A is there, but capital A is not given to you. And you have written a program, main function is calling A function, but A function is not implemented. That means you got an error, right? You can't generate. So here language is what? Anyone? Here language is nothing but language generated by S, nothing but empty. You can't get even one string from here. Clear? Come on, quick. Okay, let me write quickly what you can understand from here. A or B, what is the language? A comma B or A plus B you can write. Fourth, suppose if I have epsilon or A derives B, then you need to collect properly. Epsilon you can directly, but capital A you need to find what is it? Small b. So always use this bottom up technique. Bottom up means first find out A. So you got a B, right? You got a B, right? Put that here. So BA comes here. So language is epsilon comma BA. So do bottom up approach in the grammar, you will get right answer. Correct? So here I am not explaining, a derivation of a string that you can study in compiler, right? So here I am not explaining that, just will do directly languages. Both, for both context free grammar and regular grammar. S derives, how many of you know this concept? Okay, directly we'll write the answer without analyzing much. We'll see as many as possible for both. Okay. Make it quick so that we can learn a lot of language grammars. we know regular languages, right? That regular languages you can also write a grammar now. So now regular language you can represent with the help of the grammar. So we know regular expressions, we know finite automata. Now we are coming to the grammars. These grammars are representing languages because they generate set of strings. That collection is called as regular language. If it is grammar is regular, then always regular language. If not regular, may or may not be. Okay, let's see, wait for the answer. What is the answer? Okay. So we have a simple concept to understand. So I'll just help you to make a formula here. If you see something like x alpha or beta, if you see this kind of form, right? So what is repeating here? This alpha term keep on repeating, like if you don't want alpha, beta comes out, or beta alpha comes out. If you repeat twice, alpha comes twice, beta will be substituted once only. So here alpha is going to be repeated. The option is like beta alpha star. This form is going to come out. Assume beta alpha is sequence of terminals. Assume that. Everyone? So beta comes here to stop the recursion and alpha keep on repeating. If you don't want, go directly, that's beta alpha power 0. If you want, then take one time alpha, put a beta before. So you should know this beta should I keep before alpha or after alpha. So if it is a left recursion, then beta should be before alpha. If it is a right recursion, beta should be after the alpha. So let's look at. Here see, who is repeating is important. That A is repeating. Then who comes to stop this S? Then epsilon comes. So epsilon A star. So the language is going to become A star. Okay. This one, A is repeating. And who comes to stop this S? Epsilon. So A star epsilon. So this is also A star. And here A is repeating because that S helps us to repeat A. So A stops the recursion. Then A star, that's going to be A plus. And here again A is repeating and this A comes to stop the S, A star A. So which will be A plus. Everyone? Yeah, thank you, Shekhar. Good. And are these regular languages? Yes. When you have a regular grammar, right? So now tell me, who is LLG and who is RLG? That's also important, right? This is LLG. And what is this? RLG. And what is this? LLG. This is leftmost, right? LLG. And what is this? RLG. Are you clear this point? And all these are regular grammars. Grammar may be LLG, grammar may be RLG. And look at the previous one. I forgot to mention there also, I'll mention there. Here, oh, this is LLG, RLG also. Why? Because this production T star is there in both of them. And this one is LLG because non-terminal is there leftmost. And who is this? T star is there in both of them. So it is LLG as well as RLG. Sometimes it happens both, but not because of non-terminals, because of only terminals. Okay, this one non-terminal is leftmost, so it is LLG. So everybody clear who is LLG, who is RLG here? It is also very important to understand all are regulars, but some are LLG, some are RLG, even some are both. But both means that T star is coming here to satisfy both. Okay, what about 9? Oh, a plus, how do you write that? No, this double A whole star, epsilon comes to stop, so L is equal to double A whole star. Okay, don't put that plus inside here. Double A repeating, not one A. You try to write the strings, epsilon, next double A, next you repeat twice, you get a 4 A's, but here S is there, put epsilon, then you will see 4 A's. Okay, 3 A's never happens here. What about the next one? This double A repeats and this A stops, means A followed by double A whole star. A because it stops S and double A whole star. And basically what I am trying to generate here, even number of A's grammar and odd number of A's grammar. In the exam they will ask which language it is generating. Oh, number of A's is odd or odd length string over the one symbol. Okay, this is an even length string over the one symbol, and this one is same as the 9th, but answer is A whole star, but epsilon is came from the right, but right or left doesn't matter, same language. This and this same language again. So this one we write double A whole star followed by A, but it is also same as A followed by double A whole star. So in the exam they will try to confuse you, but remember, even though double A is repeating and A is coming at the end, but if you don't see this option, you should choose this, because both are actually equivalent. Okay, any doubt here so far? Here we are not trying to generate individual strings, we are directly generating the language by observing the pattern of the grammar, which is very important for you in the exam, because they will give you 5 or 6 non-terminals, then you can't try to understand one by one string, it will take much time. Okay. Let's mix up. Let's go for some other pattern also. 13. S derives SA or SB or epsilon. Very simple. A different kind of recursion, different kinds of recursion. Using left linear, that is left recursion also. Now let's go for right recursion. Can somebody try run randomly 0 length, 1 length, 2 length, so get some strings and observe the pattern. Right. So when you have two recursions, two left recursion, right, this A and this B can happen any sequence. See, the B might end, A might end. So this is ending concept. So if you don't want end with anybody, just epsilon is fine. Or if you want only end with A, take this one, end with B, take this one. So anything can happen. So this A and B can repeat in any order, in any order. So this one is same as A plus B whole star, but before that S happens. But how do you stop that S? Because of this epsilon you put there. So it's going to be A plus B whole star. Put this epsilon here. You should stop that. If you don't have this, then language is empty, because of this only you are able to get the strings. Now similarly, here A and B we are able to repeat, but to stop the S, who is coming? A or B is coming. So S, the language is S followed by A plus B whole star. If you want to stop it, this one should substitute here. So that will become A plus B. A or B means A plus B followed by A plus B whole star. So you know that what is it? X star is X plus. Yes, correct. Now these are same as that one, but only the recursion is different, because here rather than left recursion you have a right recursion. So directly I am writing the language is a plus b whole star. Here I am directly writing the language is similar to this one, but only left and right recursion is the difference. So here the s is the right side, but answer is going to be same, like a plus b whole plus. Any doubt in this? Let me know. I will generate the strings if you really want it. Yes, the 13 and 15 are same, 14 and 16 are same. If anybody not able to understand anything, right, let me know, because this kind of the form is going to come in bigger grammars, then you should use directly, because there you can't try to understand only this form. That is in compiler now. For top down parser will cast, right? Do you have any parser? Are you implementing compiler here? No, right? It's just grammar. You are trying to understand it, right? What is the language represented, not what parser you are implementing. Okay, that's in compiler. Left recursion will cause some problem to the top down parsers, because they follow leftmost derivation, so they have an issue. Okay. Okay. I want the meaning of the language. What language is generated? Just like containing a or two length strings, or what is this problems, right? Representation of the language. So yeah, just let me know if I don't reply to any chat, because my mobile is battery is dead almost. सब सेम नहीं होता यार, सब सेम कैसे होता? See, understand, always focus on bottom to up. If you miss that, of course here there is only one, right? So no need to worry. Here in this two, focus on bottom to up. What is this? The first one is doing this one, bottom one. It's actually doing a plus b whole star. We just know, right? And take this and put here, so that you will get what is the language. Language, nothing but language generated by s, nothing but a dot a. So a, whatever it does, dot a. So what a does, a plus b whole star. And it is ends with a, or it ends with a. Similarly, if you look at this, right, it is a starts with a. You observe in the exam, oh, anything, everything, a followed by everything. That's all. The L is nothing but a followed by a plus b whole star. Very simple. Correct? This is ending with a, starting with a. And what is this? Oh, now you need to observe. This is a, this is b, this can be repeated, means a plus b whole star. So language is a plus b whole star, and s is there after. So now this a will be substituted here. So what do you get? A plus b whole star a. It is same as that ends with a. Why these two are same? This is using LLG, this is using RLG. And how do you implement ends with a with a different grammars? Of course, both are regular grammars, but this is the left linear grammar and it is the right linear grammar, but generating the same language. That's why if you know in the future, if you want to relate LLG and RLG, you should say both are equivalent. If you have LLG, you can convert to RLG using algorithm. If you have RLG, Using algorithm, you can convert to LLG. We have algorithms also. Now last one, that a plus b whole star, a should come before. So here L is equal to, for this, L is equal to, a comes before a plus b whole star. So starting with a. If you look at the answers, right, 18, 20, they are equivalent, and 17, 9, 19, they are equivalent again here. Everybody got? I'm just trying to implement the regular languages only, right? Regular grammars can do only regular languages. It can't do non-regular languages. Okay, focus on it. Okay, very interesting grammar. We just use the basic concept. Perfect. Rishikesh was right. Here language is A star, B star. Here language is how A star, B star. You need to find out one by one. Oh, this will give you B star. Put that B star here. Put that B star here. Now this will give you A star, and B star you need to put here. So A star, B star comes there. Similarly, this will give you A star, put A star here. So this will give you B star, and A star you put here. So this will be B star, A star. And look at this carefully. This is the B star. A comes here, but A means A star. So this one is A star, B star. So understand slowly to get the meaning of this one. So here again 21 and 23 are same, 22, 24 are same. Everybody, very, very important for the exam point of view. If you don't want to write regular grammar, still you can. The same languages, oh, you don't want regular grammar? Still you can write context-free grammar. Of course, these are also context-free grammar, no doubt. Everybody, these are also context-free grammar. But everybody got the point? Just look at what I did. In everywhere you do the same approach. Last one I am explaining. Look at again. If anybody missing the point. So what it does, B star. So put the B star here. Then this A star you repeat, and this capital A is a B star, right? You just put here. So B star, A star comes here. Now these languages, you don't need regular grammar. I'll write non-regular grammar. You see that? Very simple you write if you want non-regular grammar. 25. See, two non-terminals never happens in the regular grammar. So this is the non-regular context-free grammar. See that? Very, very simple. You decide how do you want to generate. What language it is? Now we are moving slightly different. I'm introducing, this is not a regular grammar. Why? Because two non-terminals never happens in LLG and RLG. So this is not regular grammar. But it is context-free grammar. Also remember, every regular grammar is context-free grammar. Or regular grammar might be LLG, might be RLG, or might be both sometimes. But context-free grammar need not be regular. This is not regular. So what is the language? Somebody is saying that, ho, Anjali, no, there is no equal here. Oh, what is equal? No, don't do that mistakes. This is the B star. This is generating A star. Put A star and B star properly here. A star and B star here. So the language is A star, B star only. Don't write A power and B power and right now. Both are having no relation. After any number of A's, you will get any number of B's. Correct? But see, the language is regular. Yes or no? But grammar is not regular. Are you able to understand? Powerful grammar. That's why it can do anything. It can generate regular, it can generate non-regular also. That means it should generate only CFL, but this grammar is not regular, but language is regular. Everybody clear? A non-regular grammar can generate a regular language. Everybody got the point? Regular grammar always generates a regular language, but non-regular grammar can also generate a regular language. Theoretical gate question possibility. Exactly. This is not in LLG, not in RLG, so you can't say regular grammar. If you want to say regular grammar, you must prove it is LLG or you must prove RLG. I can't prove LLG, I can't prove RLG, so it's not regular. No epsilon, I am very sorry. If I do that, I was wrong. If you have, did I do that? Where is epsilon? You have epsilon, right? S derives A derives epsilon. Oh, epsilon you have indirectly. How do you generate? S to A to epsilon. Oh, epsilon is there. Directly is not there, but indirectly is there. Okay, very, very important. Oh, don't misunderstand the concept. Epsilon is there everywhere, but capital A was giving epsilon that you are not able to see directly. Correct? Yeah, good morning, Imanshu. Don't misunderstand that epsilon. Slowly. Anyone? It's not a regular grammar, but what is the language? Can I say A plus B? That's happening 3 times, so power 3 means exactly 3 length strings. Correct? Finite language, obviously it is finite language. Exactly 3 length strings, exactly 3 length strings. Similarly, are you able to understand what I am going to explain here? 27, I want at most 3 length. What should I do? A. So A derives either A or B or epsilon. So what do you get? The language is epsilon or A or B. That's for one A, but 3 times is there, power 3. So at most 3 length, at most 3 length. If you want minimum 3 length, just put one more capital B here. Capital B can do everything. Okay, you decide how do you want to write the grammar. Of course, I am writing non-regular grammar. You can also write regular grammar for them. Okay, let's keep moving further. 28. So in the exam, if they ask this grammar, can you tell me what is the meaning of the language? Okay, this looks very big, But when you simplify bottom to up, you will see very simple answer. So can you answer it? I'll just wait for 1 minute. Yeah, it's fine. I'll be there when Prabhakar. Other people will also join, right? Those people who went to sleep, they will come back. Yes. That's fine. Tanish, you can do that. Such that n less than or equal 3. Simplify 28 1 by 1. What is C? Put in C and then take that and put in B and so on. You see something different answer. No. Where is ends with A? For C, A plus B whole star, right? It's just for C. For B, it is A plus B whole star A. But I am asking for S. That is, Aniket got the answer. What is the meaning of that, Aniket? Strength, I think you are doing little mistake. You are missing some point, strength. Not substituted properly. No, Anjali. No. If I tell you right, you will get answer clearly. Look at that. Third symbol from end. Third symbol from end is restricted. Can you observe that? How many of you, when you have the options right in the exam, you will easily get that logic. Now I am not giving the option, that's why you are taking the time. But in the exam, just cross check. Cross check. See, this will give you everything. Just sigma star. This will give you sigma star ends with A, right? So this is going to give you sigma star followed by A, and this is going to give you B followed by A plus B. That means sigma star A already there followed by A plus B. You take that B A or B B, take a B common. So it's A plus B, right? That A plus B I kept and B I substituted as it is. And then take A, later A plus B is there. So final answer is very simple, that is copy, right? This is A followed by A plus B. That is your language. That is your language. A is decided already here. That is sigma star A plus B. And A plus B is already there here. So what is the meaning of this? This is the last, second last, and third symbol from end is A. Very simple, right? If the options are there, you can easily identify. So third symbol from end is A. Now look at another question here itself. Now the question, they may not ask the language. This grammar is given. The question is, they may ask different one. Can you find how many states in minimum DFA? Then don't use any algorithm to convert this to DFA. When a whole 3 hours is not enough sometimes. Then understand, oh, third symbol from ending is A, oh, 2 power 3 is equal to 8 states. Everybody got? No algorithms, only the concept. You know this, right? Third symbol from end is A, 2 power 3, 8 states. But third symbol from beginning is the 3 plus 2, 5 states. Everybody got this concept? They may not ask the language. Sometimes take the above grammar, consider the above grammar to identify the number of states in Numerical type question they might be. So you should be ready for any kind of question. They may ask the language, they may ask the expression, they may ask them DFA, or they may ask another grammar, don't know. Okay, let's change the concept now. So this is not a regular grammar at all, because non-terminal is coming somewhere in the middle. Okay. Yes. How many of you got this is a power n, b power n? This one you can write a power n plus 1, b power n plus 1, or you can write a power n, b power n such that n greater than or equal to 1. Either you say 1, or if you say 0, then you can put plus 1. By default, if I am not writing anything, that means greater than or equal to 0 only. Are you able to do that? Yeah, most of you. If you are not able to, ask me, I will explain. This one, a comes in the middle. First, you know how to repeat this. Here, this a and this b, it is repeated equal number of times. It is repeated equal number of times. So, this one and this one repeated equal number of times. Okay, it repeats but equal, and both are different positions, not the same. So it repeats like this. It repeats, but both are equal. Now the epsilon comes in the middle, so only epsilon is possible, only AB possible, double A, double B, everything is possible. And here also same, a power n, b power n, and AB comes in the middle, so it becomes a power n plus 1, b power n plus 1. So here a power n, b power n, a comes in the middle, so a power n, b power n. That is the concept of this ASB. But if you want to stop, here S is there. To want to stop, a should come in the middle, so that a comes here. So this is repeated and this is repeated equal times, and the language is going to be a power n plus 1, b power n such that n greater than or equal to 0. And if b comes in the middle, the very simple a power n, b power n plus 1, where n is 0. Correct? Similarly, you have a lot of languages like this. If you are able to understand this form, the remaining also easy. So understand this form. These two will be repeated equal times, but A is this side, B is that side, and in between who will come, that is decided by, that is terminator. So these are terminators basically. Okay. (33). S derives, sometimes they may ask ASB, then how do you answer it? 34. Sometimes they ask ASBB, how do you answer it? 35. S. AB, A derives. AA or epsilon, B derives ABB or epsilon, something like that. Oh, which one? Understand, when you are saying 0, right, look at the strings. Epsilon, valid. AB, valid. Strings only look at, don't look at what I write. I write because of the strings are there. So look at B, this reason, here n greater than or equal 0, look at that language. Minimum is what? AB, epsilon is not there. Here minimum AB, here also minimum. When I put 0, 0 plus 1, 0 plus 1, AB should come, epsilon should not come. So you decide how you want to write. These are the different ways to write. These are the different ways to write. You want me to see a different answer for this? You can see A power n plus 1 is the right, plus 2 I will put, plus 2 also I will put, still I will get the right answer. A power n plus 2, B power n plus 2. Now n value is changing. Now what value should be n, so that it will start with 1. So n plus 2 should be 1. So n should be what? Minus 1. So n greater than or equal to minus 1. Then when I put n minus 1, minus 1 plus 2 will become what? Minus plus 1 will A power 1, B power 1. So what is that value of n begins? It doesn't matter. What minimum string is giving is going to be the final answer, right? Are you able to understand? I can write even n plus 2, I can write even n plus 100, but what is the n value where I begin? Then A power should be 1 that I can make by putting any value of the n here. Are you clear? So don't worry about this much, just look at what is the minimum string here. According to that you write as per your understanding. So what are the answers? Yeah. This one 2 times A, right? So it's just like L is equal to double A power n, B power n. So this can be written as A power 2n, B power n, such that n greater than or equal to 0. Just look at the strings carefully. Minimum epsilon, next minimum double AB, next minimum 4 A's, 2 B's. So understand, if 2 A's comes, 1 B should be there. If there are 100 B's, then 200 A's should be there. So what is the connection? That you just understand. And here, oh, both should be equal, but that equal is not odd, it should be even. Both should be equal, A power n, B power n, but n is even. Like let's start with 0. N is 0, epsilon. N is 2, next n should be 2. So A power 2, B power 2, that is what you get next. So understand here n is even, or you can write another way, somebody written already, A power 2n, B power 2n, that is also correct. Either you say A power n, B power n where n is even, or you can say A power 2n, B power 2n, both are exactly same. Yeah, n mod 2 equal to 0, that's also, there are many ways to represent, correct. So you know, right, different ways to represent, that's good. Now here, this one, we know A power n, B power n, and this one is A star. What you write? A star, A power n, B power n. A star, A power n, B power n. When you look at this number of A's will be greater or equal to B's. How do you write that? A power I, B power j, such that I value either equal when A power 0. It is not A power 0, it is greater. So greater or equal to j. Similarly, for B's also you can increase or decrease. Right. And last slide for the context-free grammars. Let's focus on this last slide, 36. ASA or epsilon. 37. ASA or BSB or epsilon. 38. ASA or BSB or ASH. 39. ASA or BSB or A or B. 40. Okay, we'll stop with this. That is context-free grammars. Then we'll move to the next topic. इसी में होगा ना, दूसरा क्लास तो नहीं होगा, राइट? We'll just take breaks, a few breaks for the next two topics, right? Because you need definitely a break for the Turing motion. Have a break first, and other people may also join. Five now. Don't know how long we take the class today. And compiler. $35, $36. Yeah, regular. That's good. Even though grammar is not regular, it's right. Correct. Rishikesh. 35 or 36 you are asking? 35. What is 35? Oh, it's not regular. Oh, there is a dependency, right? It's not regular, because how can you understand A is more than B is? Oh, that's not possible. 35 is not regular. Grammar is not regular, even language is not regular. Okay, any answer so far? There's a one question which was there in the exam that I am writing specially last. What is it here? 41. S derives AS or epsilon, and A is AAB or epsilon. So 41 was a gate BYQ type question. It was gate question. Any answers? Let me check your answers. 36. Okay, I'm not asking regular or not. I'm talking about answer, language. Regular or not, you can answer it later, no? Shreyank, what did you say? No. Oh, so you should know. What do you mean by? First one is simple, right? What is it? L is equal to, both same times repeats, you need epsilon, which makes A power 2n, which makes even number of A's. This has no issue. You can say that. But 37 is a new concept. When you see ASA or BSB and something is there here, whatever, doesn't matter, okay? Now, what is the meaning of this? The first symbol is A, the last is A, in between S is there. And if again this S, you replace with this or this. If you replace with this again, A comes. If you replace with this, B comes. And S is there. S might be any of these three. So if I go this, A comes. So what do you understand? This two should be same, this two should be same, and this two should be same. because that S is going to replace them all the time. So what are you trying to get? This is a W, then this must be reverse. And this epsilon comes to stop here. So what is this? W power R. It means even length palindromes. This concept is for everybody understood? Everybody understood? Here if you want to observe the strings, epsilon comes out from directly, double A comes from here, double B comes from here, and the next string is 4 length, that A. In between double A or double B comes. A. In between double B may come. So I took this one. You can take the first this one, B. In between double A, double B may come. Double A, double B. Are you able to understand? So it's going to get W power R form. So that makes you even length. What is it? Even length palindrome. W may be odd length, but odd length followed by odd length is going to be even length. So even length palindromes grammar it is. But for that you should represent. How do you represent? L is equal to W power R, such that W is anything. But the next one, hash comes to stop. Here epsilon is there, so W epsilon W power R. Here hash symbol is there. And this one, now in place of epsilon here you got A or B. So this will give you set of all odd length palindromes. In between them just you write X. X is either A or B. So it's set of all odd length palindromes over A comma B. This is all even length palindromes. Correct. This one, oh, epsilon is there, A is there, B is there, means even length epsilon will help you, A or B will help you for odd length. So this will give you all palindromes. So that you can write W such that W is anything, but that W when you reverse you will get the same. That W is every string which is the palindrome. So this is a palindrome definition, and every W in the world who is the palindrome. Correct? The last one, anybody? So I'll give the time for 1 minute. Can you write the last one? So it's a new concept. 37 to 40 is a new palindrome concept completely. I don't know, Prashant. Today it will be class, I guess. Oh, don't say odd length, but it is not every string. Ash is there, na? Shreyang? You can't say set of all odd lengths, because ash is an extra symbol. Ash is a special. Is also input symbol, but comes only once to separate W and W power R. Ash is another symbol. You can also take a C. C also you can take. Here you can write a C. Then you assume ABC is a sigma. If you are confusing with ash, ash is a special, appears only once in the input, not like A comma B. Only at the end you are substituting, right? You can't write 2 ash, 3 ash in the language. But it's not, you can't say it's all, you can't say odd length, because odd length is what? This is odd length ABA. Can you get it from here? No. This is odd length, that is not coming here. Okay? That's a different kind of palindrome. Yeah, so what is this? So you got this point, right? What is this first one? This will give you A power n, B power n. That's fine. But what is the meaning of this one? it will repeat this capital A as many times, and epsilon you substitute. So language is nothing but A star. But what is A star? Capital A star means what is capital A? One language, that language you should write something like this way. Or you may write simply A power n, B power n whole star. Now I have a problem. So many people do not know exactly how to use a set and parenthesis. So I am just talking about this. This bracket will have a completely different meaning. I don't know how many of you know. This is completely different from A power n, B power n whole star such that n greater than or equal to 0. These two are completely different. What is the meaning of this? Is n is decided inside. So this means, oh, you can write something A power n1, B power n1, A power n2, B power n2. You can repeat as many times, but every time you repeat, this two should be equal, this two should be equal, this two should be equal, and that can be done any nk times. Let's say A power nk, B power nk. So k is here, you decide k is what? K is greater than or equal to 1. Of course, you can also take 0, but I didn't take it. But what is the difference here? It's repeating, right? Here you can't write this way, you can't write this way. Here all are actually same. A power n, B power n, A power n, B power n, A power n, B power n. You decide that star we don't know. So this is how the string comes out. This is a k times, okay, that star, any number, I don't know how exactly. So greater than or equal to at least this, right? How many times? 1, 2, 3. So this can come 0 or more number of times, 0 or more times. Have you seen the difference? It's a very complicated notation. Here the n value is fixed outside. It might be 0, then everywhere 0. If it is 1, everywhere 1. If it is 2, everywhere 2. But it is not like that. If this n value is 1, that n value may be 100. This n3 might be 1000. So you, every time you go, n is decided inside. So everybody got that point? Here what string is possible? Let's say AB, triple A, triple B possible. Yes or no? But the same string, it is impossible. AB, triple A, triple B, you can't generate. Why? All of them should have the same power. What you can get? AB, 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 something like that. Or double A, double B, double A, double B. You decide how long you want it. You can get it, but this one you can't. Whatever you get here, that is possible here, but it is possible more. It is a superset of this language. Everyone? Difference, I am explaining, right? You try to understand the strings, don't look at the form. When you look at the form, lot of confusion, yeah. That's the form, that was the option there in the gate. Here, epsilon, yes. AB, yes. Of course, any string in A power n, B power n, yes. But if I want 2 times, repeating 2 times, what you have to write? AB, AB you can get, but AB, double A, double B you can get. Double A, double B, single AB you can get. Understand what's happening. Every time you come inside, the same n, no need to be a, right? Here these two are equal, here these two are equal. You can see that, right? Right. Every time you come inside, this A power 2, B power 2, here no need to be A power 2, B power 2. It could be A power 1, B power 1, A power 2, B power 2, A power 3, B power 3, any. But here you just look at epsilon is there, A power n, B power n is there. But after this, if I want the repetition, so here A power n, B power n, again you will get A power n, B power n. It means like AB, AB. Here it means A square, B square, A square, B square. You don't get A square, B square, A power n, B power n that you got here. Here if you see, observe carefully, if you want repeat, a power n1, b power n1, a power n2, b power n2. You can't write all the powers are same, but you should do here because n is fixed outside. Here I can write a power 1, b power 1, that's fine. I can write a power 1, b power 1, I can write a power 2, b power. That's impossible here. That's what the difference, right? If you can understand this one, if I want to repeat twice, here these two same, but all the 4 no need to be same. Here all the powers should be same. Got the point? Right? 41 is this one. This is your, actually it is not a CFL. Oh, you can't have a context free grammar for this. This is your context free language. You can't, because this many powers you don't have implementation in the context free languages. You can see here what I have written. It's already answer is there. That means when a comes, right, something epsilon is there, 1a is there, 2a is there, 3a is there. You can't relate the 3a's, what strings you have taken. This a you have taken a power n, b power n, this a you have taken another a power, b power. But this a, that a may not have a relation. Here 100 a's, 100 b's, there 1000 a, 1000 b might be there. So no relation between these two a's except the strings are in this language. Right. Right, which is really important question. See, 3 stars I kept because I know it would be very difficult to understand how the star is applied. It's not about regular expression, it is about some other language completely. So I think with this we have completed context free grammar. Okay, there are many, but we no need to worry about. Okay, so pumping lemma will discuss later. So these things you practice on your own. See, grammar is there, language is there, keep identifying them, and then yeah, you have a lot of questions there in the PPT itself. A pumping lemma we will see at the end. Right now we are not much interested, but definitions, everything is clear. Okay, equivalence classes, just let me explain. If you have the if you have the regular language, right, so keep this point. If you have the regular language, then L definitely will have finite number of equivalence classes, and that too the number of states in minimum DFA. If the DFA has 100 states, minimum DFA, that means you have 100 equivalence classes. Example, suppose L is equal to starts with A. How many states in minimum DFA? You have 3 states, right? 3 states. It means 3 equivalence classes. You really wanted to know them? Just simple example I am giving. You will design first, okay? On A, you will accept everything starting with A. Oh, starting with B, you will not accept anybody. Epsilon also. So there are 3 classes here. So this is the 1, this is the 2, this is the 3. 1 actually represent epsilon, 2 represent starts with A, and 3 represent starts with B. And when you do the union of all these 3, right, 1, 2, 3, you will get sigma star. If you try to do the intersection, right, you will get empty. So these are the 3 equivalence classes. Every state actually represent any string which halts at 1, that will be there in the 1 equivalence class. Any string which halts at 2, that will be there in the 2nd equivalence class. Any string which halts at 3, that will be there in the 3rd equivalence class. So every regular language you will have a DFA, minimum DFA, and number of states in minimum DFA is also same as number of equivalence classes for the regular language. Always it should be finite, because finite number of states means finite number of equivalence classes, and number of equivalence classes is same as number of states in minimum DFA. Everybody? Yes, Saul, is you are able to type and you are able to see the chart, right? It is the live class. It will be asked. It will be asked in future, but so far it was not introduced. Correct? So very simple question. How do you know the language is regular or not? This is the best one. But to identify finite number of equivalence classes, again you need to come to the DFA only. Okay, that's that relation, right? Equivalence class, this is over the particular set. This is similar to this one only, but that equivalence class have the similar relationship only. Yes, exactly. Correct, correct. But these are the languages where over the sigma they are the sets completely. The domains are different. Domains are different. Yeah, almost similar definitions. Equivalence means reflexive, symmetric, transitive. Here also will have the similar kind of good relationship. Okay, if L is not regular, then L will not have a DFA because you cannot design with a finite number of states. That's why it will have infinite equivalence classes. Example, A power n, B power n. A power n, B power n, you don't have the DFA. You don't have a finite automata at all. So you need infinite states. So that means infinite equivalence classes. Yeah, before going to the PDA, okay, any of context free grammar explained, right? How much time you need a break? Or do you want me to continue? Because PDA, you need at least you need a break to put an effort. Yeah. What's the time? 5:16, right? Yeah, take the break. 5:16 to, just take a little bit longer, 5:35, because I can't see the difference, right? I'm not getting 10 minutes, I'm looking at the chart and I'm not getting the time enough. So just take a little bit more. 15 minutes break, yeah, almost 15 to 20 minutes. Right. If you sleep, it's okay, but if I go to sleep, then nobody can wake up me right now. Okay. Anybody joined just now? Okay. It could be possible to go sleep. But I'll be active. No, actually, pumping lemma whole concept is not much important. You should learn if you really need it. You're worried about it, please you should learn. As far as my knowledge, it was not much important. Yeah, after that, one break before Turing motion. Then in 2 sessions we'll complete. Or it will take 3 sessions break. Okay, okay. Please, I will not listen any song also right now. Okay. See you back. Okay. Just give me time for the break. Morning, guys. Can you hear my voice? Are we ready to start? Yeah, good morning. So welcome back then. That's back. थोड़ा टाइम लगता है फिर वापस आने के लिए. सुबह सुबह है ना. Okay, let's begin. So in PDA, most important topics, right? Context-free grammar. We just covered, right? What is context-free grammar, how it looks like. And the PDA, we have the CFLs and DCFLs identifications. Then closure properties. Okay, closure properties, basic properties only. They may not ask very big list. The small list is enough to remember. Okay, here the most important is a CFL, identifying CFLs, and context-free grammar. The PDA is just important but not much. And closure properties always, as usual, it is very important in whole TOC. है ना? Right. Come on. Are we ready to go for the PDA? So push down automata. Push down automata में कितना parameters होगा? How many parameters will have? Like apart from this 5, you will be having, there is bottom of the stack. You can also represent as something like this, and then gamma, that is a stack alphabet. So this is a stack alphabet, gamma, tau, whatever you want to represent, but gamma is the well-known notation. And this is the bottom of this stack symbol, or initially top of the stack. When nobody is there, Z0 is there on the top of the stack. Right? So is that similar to the PDA is equivalent to, can I say, finite automata? This 5 parameters is nothing but finite automata only, right? Plus these 2 parameters are coming from where? These 2 parameters are coming from stack. If you want to design a PDA, right, the finite automata features whatever you have, additionally you just need a one stack. So this will work like equivalent to PDA. Okay? Of course, many things are there to understand configuration, but the power I'm talking about. When you look at logically, finite automata plus one stack will work equivalent. This one stack is unbounded, right? You always push finite number of operations only. You do finite number of operations on the stack, but the stack is you decide based on your input or based on your requirement. Okay. So configuration I'm just talking about. You have what? The input tape. That's obviously same as like a finite automata, and you have the head, and you have the control, finite control, like a finite automata. This is read or write head. Sorry, write you don't have here, right? Of course you have it, but normally for acceptance you don't need it. And additionally, this is a finite automata configuration, moves left to right, and you have some input here. Additionally, you have the one stack which is unbounded. So this will interact to perform either push operation or pop operation. If you don't want, you no need to do it. So only you can do push or pop. If you don't want, no need to do anything. And everybody knows stack has two operations, push or pop. And if you don't want, you can use no operation concept. Okay. Skip meaning is you are reading an input but you don't want to do anything, that's fine. But stack allows only two operations, push or pop, but this configuration they can decide whether it want to use a stack or not. Okay, fine. Now let's go to the directly details. How many types of PDA? Anybody knows? We have 2 points, right? DPDA is there, PDA is there. Both deltas are different. Like a PDA also called as NPDA, also called as NDPDA, non-deterministic. By default, the PDA called as NPDA. So remember this point, PDA, NPDA, no difference, right? It is just synonym. But in finite automata, you must mention it. Are you talking about DFA or NFA? Because their DFA and NFA are equivalent. By default, there is no such thing. Right here, by default, PDA is non-deterministic. Now, here delta definition is. Did you remember a DFA definition? Q cross sigma, right? That maps to Q. But additionally, you have a stack. So before changing the state, you should look at your stack and you should perform some operation. So there are two additional parameters are going to come. One to understand this stack before and after. So are you performing push or pop or no operation? So here there are three kinds of possible transitions. Either you may do push or pop or no operation. Everyone? And in NFA, what was your transition? Q cross sigma, and that maps to 2 power q, right? So additionally, what is new component? Gamma, right? Cross gamma, what is it? You can use a star if you want it. That you don't have in DPDA. That means you can look at two symbols at a time. Of course, you don't want, you can ignore it. And that gamma star goes up, non-deterministic gamma star. So basically, why we use this? To understand, let me do something. I'll just write a few things, focus on it. Q, comma, A, comma, X is equal to Q dash, comma, AX. What is the meaning of it? Just understand, tell me what do you know about this. You just look at, I'm just doing three things, very easy to understand in DPDA. You should know what you are doing here. Can anybody tell me what is 1, 2, 3? How can you understand? Now you have the stack, right? Those people who cannot understand these 5 parameters, please learn first, then go further how to consider the PDA, DPDA, right? पहले ये पता करना चाहिए, what are they? Come on guys. What is 1, 2, 3? Which operation you are performing? Just tell me operation, that's fine. No need to worry about remaining things. So here you need to have the focus. Come on, quick. Yes, that would be sufficient. How do you know what operation that you are doing? Just look at this place. Here X is there, here AX is there. It means additionally what did you do? You did push A. That's all. You just look at this to understand everything and what you are doing. Remaining you know already in finite automata, right? If you don't have this, just looks like finite automata. Very easy, just looks like DFA. And X is there, epsilon is there. What did you do? X is deleted, means you did the pop X. And what is here and what is here? Exactly same, means nothing happened. No operation performed on the stack. No change. Is that clear? What happened on the stack? Push, pop, no operation. But all the time you are reading A only. Your head is reading A, remember that, because deterministic it must read the symbol. See, don't worry about other things. Other things you know in finite automata. If I delete this 3, right, this 3 and this 3, it exactly DFA concept only. Q cross sigma to Q. Only additionally you need to look at what is there before and what is after. So before X was there on the top, now above X A is also coming like this. X was there on the top somewhere, and after that the above X A is there. So what you are looking at now, here X is there, here AX is there. So that change you are looking. X is converted to AX means above X somebody came. That is the meaning of this one. We are not talking about entire stack. We are talking about top of the stack only. Okay? Everybody got this? Everybody? If X is there and nobody is there at that place, means what has happened? What has happened? Somebody deleted. This X is deleted. Here nobody there means it's deleted. And X, again X is there. There is no change. In DPDA, it's so easy. You know, every DPDA is a PDA. How many of you know that? How many of you know every DPDA is a PDA? Every DPDA PDA is, right? So all these DPDA transitions you can write, but additionally you can use your own transitions based on this definition. Okay, you look at this. I am following this definition in the first column. In the second column, I am following this. When I look at this, every DPDA is a PDA. That means all these 3 transitions I can copy paste here. Okay, I am just doing that. 1, 2, 3. Just copy paste. Apart from this, what else you can do? I am just doing it. So I am not explaining the same thing. You know this. Okay. So now, what is this next concept? So now additionally, if you really want to push right, see this Q, A, without looking at the top of the stack, you can also push here. And between 1 and 4, 1 you are seeing the top of the stack, and other just throwing without looking. Assume that nobody is there. Of course, top of the stack nobody is there. Just push it, you will see the A. So nothing converted into A, something like this. You have nothing here. Of course, remaining you have it. Here nothing is there, and that you are pushing A, then A will come here. So nothing converted into A, it means A is pushed. This is another way. Only this is allowed in PDA, but not allowed in DPDA. DPDA you should see who is there on the top of the stack, but here without seeing, because gamma star means epsilon also can come there. Fifth one. So understand these points, that later on will be very easy. If you really want to pop, I know definitely you have to see it. You have to see it. But if you don't want to do any changes, see A comma epsilon, Q dash comma epsilon. See, this epsilon doesn't mean pop all the time. Many people don't know. Here epsilon is there. Here epsilon is there. Means no change. Means no operation. Even that I can represent many other ways. You see this? Sixth one. Delta Q comma A comma something. I don't know what is that. And the same thing here also. That means again no operation. So are you able to understand the operations here? So this is the push, this is the pop, and this is nothing, no operation. And this is again push, this is no operation, and the last one is also no operation. Really you want to speak clearly, okay, from state Q by reading input A. So you should know exactly the first one is a state, this one, and next one is the input. next one is the top of the stack, maybe one symbol or no symbol or many symbols, that is you decide. And this transition is maybe exactly 1 or maybe 0 or more. This will represent 0 or more. So, I have taken only one like this, but here you can have multiple. So, any doubt in this? Just to understand what is delta, then we can go for the construction. Are we ready to go for the construction? Okay, for exam point of view, you do not need to construct, right? Just I will give you PDA, you need to understand. For the exam model, what we do, they will give you PDA, you will understand. The same way we will practice today. Okay, I do not ask you to construct this and that, it will take a lot of time. Okay, exam model, what questions comes, we will practice that way. I will give you some machine, please focus on it. Okay. This is the exam model question. Of course, in the exam they will mention all the parameters. This is special. End of the input you have a dollar. Here you do not have any dollar. Like in DFA, NFA, we do not have any dollar at the end, right? But here we have it. That's fine. At the end of the input, you should halt at any cost. Let's see. How will you answer these questions? You take time. One by one, focus on epsilon, focus on 1a, focus on 2a's, focus on 3a's, only work on this sequence. Epsilon, what concept is needed? A, double E, but it's just not a state, you have two things, state as well as stack, both you need to track. What is the state and what is the stack content? Assume in all of them Z0 is there initially. Okay, I will wait for the all answers. One is A star, perfectly right, Jaiswal. Tanish, correct. It is the first one is A star, right? Good. Two is A star. Excellent. Yes, Tanish. Then how to understand this PDS? How do you know that is accepting A star? What was the logic? That's all? Only two people are answering. What about others? First problem, that's why you are not answering. Only the problem is how you track now. If you forgot the stack, you will not understand the language. Third one is also A star, Jaiswal, because dollar is at the end of the input here. If epsilon is there, dollar is your input. Okay, so the third motion is condition should be mentioned. The first one, see how you need to focus on. if your input is epsilon, that means without reading anything, what you can do, let me write the numbers also, write names also, A, AB, let's say AB. First focus on here, how do we know it is A star? It's just like our DFA, right? What is there initially on the stack? Z0. And now suppose I will give you 3 A's. How do I know it is accepting? So from A, we read A. So we read A and we don't do anything. This operation is called as no operation. It just read A, skip A, that's it. No operation, but read the A. So I read A, but I don't do anything. Again I will be in same state. I read A, but I will don't do anything. I'll read A comma Z0, I'll do nothing. And when I read A, then I am going to halt. But where I am halting? I am halting at the same state. You can see that I am halting there only. That means you are going to accept that. Correct? A, and that A, you are halting at A only. So this is the final state. The first one is very simple. It's just like a finite automata. Only the stack is there. You should look at what's happening. Nothing is happening. So you are reading, but nothing is happening because A comma Z0, Z0 only, A comma Z0, Z0 only. So we are not changing the stack, so no problem. It's just like A star. It's just like a star. And also remember, if you want to convert any finite automata to PDA, this is only the algorithm. If this is your machine, then just add one component, comma Z0 slash Z0 over. Every finite automata you can convert into PDA by using this concept. Go to every input symbol, just add comma Z0 slash Z0, comma Z0 slash Z0. Every finite automata will convert into PDA. Everybody clear? That means if you have constructed 100 finite automatas, that means you know 100 PDAs now. Every regular language you can also design a PDA. You can convert every finite automata to PDA. This is an algorithm. Everybody clear? In the exam they may ask you, do you have any algorithm to convert finite automata to PDA? Yes, this is an algorithm. Clear? Of course there are very many other algorithms, but we don't worry. One example is fine. Got it? So language is what now here? Language is A star. Okay, first one is fine. Second one. Any doubt, please ask me, I'll explain. How I accept epsilon? Here see, from A, when nothing is there, so Z0, don't do anything on the stack, go to final. So you are going to this path, and halting at final. So in PDAs, most of the textbooks they follow this notation, most of the textbooks, because they wanted to understand clearly end of the input. Here I don't understand, you need to look at when the end comes, right? But here this epsilon represent end. How do you know that? Because from here no transition, it means it has to be end, there is no other option for you. Arey yaar, in finite automata did not remember finite automata. Initial state is the final yaar. When you don't read anything, you will be there only now. You are halting at final only now. In DFA, did you remember? NFA, did you remember? Initial state is the final, you accept epsilon. The same thing is happening. If epsilon is there, you will halt at A only. Clear this point? This concept you should not forget. This concept you should not forget. Here, explicitly you are going to the final state, but implicitly already A is the final. Everyone? So these machines are different, these machines are different. Okay, most of the PDAs, DPDAs, we do this kind of configuration. We keep separate final, and to understand it is the last, here we always keep end like this. Epsilon means end happened, then I am coming to final. In between you should never come here, because from here there are no transitions. Clear everyone? Who was the doubt? Yeah, Rishikesh. Now how do I know here epsilon is accepted? Because this is the path. Here what is the path? A itself is the path. And here single A, can you accept? A, don't do anything, A only input. And after that, A means you take that A transition, that is A on A, you go to A, but on this stack you should remember what happened on the stack. You maintain it, Z0, no change, A comma Z0, Z0 only. And then, oh, after this, you read nothing, you go to B. So this is the final. that means single A accepted. How do I accept double A? Double A, you accept something like this. A on A, again A, but no change on the stack, because you told that don't do anything on the stack. And after that, epsilon. That means double A also I can go to final, and that's why language is what? A star here also. But here, these machines are completely different. Why? Because dollar is the end of the input. Here epsilon means not epsilon, here dollar. So epsilon means dollar. Now from A, when I read a dollar, you are going to B. Everybody? So that's why epsilon is accepted. That's why epsilon is accepted. How A is accepted? A means a dollar. So how do you do? From A, by reading A, you will be at A only. But after dollar, but you should know what is happening on the stack at the same time. Nothing happening, because this operations stack, we don't do anything on the stack. Now A on dollar, see, Z naught, dollar comma Z naught, you go to B. And double A, then dollar, triple A, then dollar. So what's the language? This is a very special machine. So this is a standard one, and this is a very easy one, and that's a very complicated, because you need to understand when the end comes. So here also A star. Everybody clear? In the exam, you don't know what kind of question comes, but this is a very popular gate question. 3 times only they asked so far. Can we go to the next? The fourth one. Let's say now. A comma Z naught, A Z naught. Okay, let's see. Not now. First know how to construct the PDA. You can't understand right now. You can't, because you should design first, right? If I give you, you can easily identify. If I give you, I'll give that too. You will easily identify. But while designing, you should know what should be the approach. Identifying DCFL, CFLs could be complicated, but identifying DPDA, PDA, if I give you, you can easily look at it. Like an FA, right? For the same combination, you should have multiple 0 transitions. Here DPDA, 0 is fine, but you should not have the 2, that we will see it. Just wait for some time. Keep asking the doubts. What is the answer? Okay, one by one, because multiple things takes much time. Come on, come on. Quick. Nobody is answering, I should teach myself then. What is it? This is the mistake, Jaiswal. So now you should try. So look at epsilon. Let's keep some name A. First, let me explain clearly. Initially, Z naught is there. Now we'll focus on in the input tape. Nobody is there. Nobody is there, right? Nobody is there. Epsilon means nobody is there. Now from A, when I don't have anything, I will hold there only, right? A from A, that means epsilon is accepted. Everybody clear? Why epsilon is accepted? Because from A, when I don't have anything, I stop there only, because I can't read anything. No, I can't read anything, right? See that? I can't read anything, right? Everyone? From A, when I don't have anything, I'll stop there. Epsilon comma Z naught, I no need to do anything, I'll stop there only. I no need to have a transition. Okay? Now, single A, when you have single A on A, A comma Z naught, what it does? It pushes A and goes there only, right? Goes there only. And it goes there only. A on A, it is going to A. Now it stops. Are you at final? Yes. Then single A also accepted. Everybody understood this point? Everybody understood this point? Single A accepted. Everybody understood? Now the key point is double A. Now the key point is double A. Now from A, by reading this small a, what should I do? I will push A. Everybody should know this is the push A. So you should do that now. A I push. But next time when I go to the same state, now this time here it was the combination A comma Z naught. So you did that A Z naught. Now A comma A, we don't have any transition, no transition. See that A comma A, we don't have anything. It means we don't have a path for AA, no path for AA. That's why double A is invalid. Clear this point? In deterministic PDA, we do this way because covering every combination takes much time. A comma A, I have to go dead state, I need to stay there, it takes much time. So in DPDA we will avoid, whenever the invalid string comes, ignore it, assume that we don't have a path, means it is going to dead state. Actually it should go dead state like A comma A, what you want to keep the same, keep it, it's a dead state, and there every sigma cross gamma, keep some gamma to do maintain there itself and stay there, right, because you don't want to do anything else after this, okay. But we don't do that ever because we want to save our time in designing. Triple A, yeah, second year only you don't have a transition, that means triple A also will follow that, right. So now the language is just epsilon comma A. Everybody got? It's very simple. Only the thing is, yeah, we have written a lot of programs, complicated sorting, and this is a very simple than sorting here. Just you need to look at what you are doing. It's not a finite automata. Exactly how you are tracking the every input, you need to start with the Z naught, and every symbol you should know what you are looking at and what you are doing. See that A comma Z naught, A Z naught. You should look at A means reading A, Z naught means you are looking at Z naught, A Z naught means A is pushed. So first A you pushed, but second A, top of the stack is A. That means A comma A should be there. But in finite automata, A, if you have this one, right, A star. But here A comma Z naught slash A Z naught means not A star. But if I write here Z naught, now it will become A star because every A I do nothing on the stack. That means every A it is a similar A comma Z naught, A comma Z naught, A comma Z naught. You can read any number of A's for this. But the difference between these two, you are pushing first time itself, then A comes here, later on this transition is useless. Second A, this transition is useless. That's why the double A is not accepting. Got it? That is what the problem with the PDA, right? Why everybody cannot understand? Because they only look at the state, they never track this, right? You know, write programs if you want to understand every variable data, if you have the stack data, if you have the recursion sequence, all things should be done, right? It's similar to that. You are actually executing from this function, you are doing some logic here, okay? Okay, let's look at another question. How you understand? This was similar to the gate P by Q. Purely non-deterministic. Purely non-deterministic. Okay, wait. Okay. Okay. So one of the model gate question. There are two final states, you need to focus on two things. What are the strings halts here? What are the strings halts here? So what A comes, what C comes, the A union C will be the answer. Okay, take time for 2 minutes. Let's see. So that's all over, right? For the GATE exam, this kind of questions you need to practice. You don't need to design a lot of PDAs. That never be asked. But to identify CFL, DCFLs, you should know that. Any answer you give, we'll discuss that. Whether it's right or wrong, doesn't matter. Just understand what you got it. Just try for every string. Don't look at, just understand, right? Epsilon, A, 2A, 3A, 4A, what's happening? Then epsilon, after that B, AB, BA, BB. So you'll understand the pattern easily. Yeah, correct, Rishikesh. Excellent. Look at Sriyank. Rishikesh answer. You already know, right? Oh, these transitions you did not see it. Okay. So first, what is the first step? First step is to understand what is each transition. What is this? It means it can push every A directly without looking at top of the stack. Now epsilon means you are not looking at, just you are throwing A onto the stack. So this can do, it can accept epsilon, it can accept 1A, it can accept double A, because after that it will halt at here only. So this will clearly tell that, oh, capital A is responsible for accepting any number of A's. It is not seeing the top of the stack. That's epsilon means not looking at, whatever is there, just you are throwing it. If you write A comma X, that means you are looking at. A comma epsilon means you are not looking at. Epsilon X means you are not looking at input, but you are looking at the stack. Oh, everybody has a meaning here. Epsilon comma X means you are not looking at the input, but you are looking at the stack. So understand, each is important. Epsilon comma epsilon means not looking at input, not looking at the stack. So these two things are very, very important. Where is the epsilon? What is the meaning? Okay. So based on that, later you will decide what operation. Clear? Now the capital A says that, oh, it accepts A star. Capital A can accept A star. Okay. Now capital C, what strings can come here? Anybody? You push every A without any doubt. But when B comes, B always demands A. So what is the meaning of this transition? This means pop A. For which input? B. And what is the meaning of this one? Pop A. For which input? B only. So for this two, you need to pop A, but how many A's are there? Let's say 100 A's. Then 100 B should come to see the Z0. If you are coming to this transition, means it is end of the input. What is it? End of input. Maybe dollar you can assume if you want. This should be, no A should be there. No A should be there. So when will it happen? If exactly B's should be equal to number of A's, then only you will see the Z0. Why? If 100 A's are pushed, then first B, then 99 B's should come to pop the 100 A's. Then you can come to this path. It makes that C is going to understand A power n, B power n, and at least one AB should be there. But if n greater than or equal 0 also you can write, because A union C, here epsilon is there, you can also keep epsilon, not an issue. So you can understand A star union A power n, B power n. Epsilon you can keep both the times, not a problem. Or you can write, n greater than or equal 1. It's your choice. Yes, that is a pop A for input B. For B. That is also important. This is a push A for A. Done? This is one of the gate model question. This is one of the gate model question. Are you able to understand? No transition for Z naught. Why do you want? That is a deterministic, right? The non-deterministic, you don't need a Z naught. Yeah. So this is a non-deterministic motion. This is not DPDA. Now somebody was asking, sir, I did not understand what is DPDA and PDA. This is not a DPDA. Language is DCFL. That's okay. Language is DCFL, but this is not a DPDA. It is just non-deterministic. It is the only PDA. How do you know it is not DPDA? Because this transition enough. DPDA never take the operations without looking. Always it looks at. So this transition is the issue. Only this transition is an issue. Okay, everybody got why this is not a DPDA? Because in DPDA you will always look at that gamma, Q cross, sigma cross, gamma. That gamma means definitely you should look at somebody, but here you are not looking at. But language, what language it is? This language can be implemented with some other DPDA, but it is DCFL only. We can design a DPDA for this if we want it. Everybody? It's the same problem. Here I can write Z, here I can write, see I can copy it, right? I can copy it, I'll just do it, wait. I'm copying it. Okay. Fine. See, same problem, small change. Okay. This, let's say, assume it is 6th. Here small change, but answer is same again. But this time is DPDA. Everything is same except you can see now A comma Z naught, A Z naught. Clearly you are telling how to push A comma A double E. Answer is same. It is DPDA now. Answer is same again. Clear this point? I did nothing except clearly telling now first A push, remaining A's also push, that's it. But whenever you want alt at final only, that means accepted. Any doubt in this? Previously it was non-deterministic PDA, now it is deterministic PDA. But end of the input, this is a special transition for all the motions, whether it's DPDA or NPDA, doesn't matter. This is a special transition, end of the input, because here you don't have a transition, it means you are talking about this end of the input. Good morning, log 2 base 2 is equal to 1. Correct? Are we ready to design now PDAs? I will focus on designing so that we can identify CFLs, DCFLs later. Can we move? So this is where we lack in understanding PDA. Even you design 20, 30 PDAs, doesn't matter, but understanding one PDA also takes an effort. Okay, this was the sixth question, right? Okay, few, one state only sometimes gets confused, right? Let me do that. Hey, let's see who will answer it. Assume final state concept, okay? Don't assume anything else. Okay, just answer it with one state only. You don't need many things. Here, How many of you know this is just epsilon? How many of you know this is pi? How many of you know this is A star? Anybody answer correctly? Anybody is having the doubt, please let me know. I'll just look at any doubts are there. Seven, 8, 9. Everybody has a clarity? We are using final state concept in all of them. The language final should be there to accept. The first one, single A is not having a path because A comma Z naught is missing. Initially Z naught is there. A comma Z naught, you don't have a transition. That means single A you can't understand. A comma A never happens. The second one, maybe you will push, but what is the use? There is no final state at all. The ninth one, any number of A's you are pushing and will alt finally, that's it. No doubt? So here you should ask more doubts because from here you need my support. Okay. Let's start. First problem, how you design A power n, B power n. Second, any machine you design, that's fine. Okay, anyhow I can't see, right? So I'll just help how to design. Okay. First you need to work on what to do, then you can do it very easily. So take one small input, let's say 3 A's, 3 B's. What is your agenda? Like this 3 A's, what you do? Push X for A, and what you do? Pop X for B. Oh, you may ask, sir, why you push X, why can't you push A? You decide, it's your logic, my logic is different, okay? Who is that? Z is by default, right? Unless they say initially stack is empty. So you should write clearly the data you should read. Rishikesh, if they say initially stack is empty, you should follow that. But we are assuming Z naught is there initially. Question will tell you whether Z naught is there or not. Yeah. Ninth one. What was the mistake in ninth one? What was issue in ninth? Oh, ninth. Already explained here. This is already covered. Did you remember this one? This one only, right? This much only given to you. Your A star already done, right? This is not given. Only this is given. Only this is given. Oh my God, what's happening? Just need to focus on what I was explained there. Here, epsilon. What is it? This is A. You will start at A and you will there only. Stack you don't touch. By default, Z naught is there. It is same. It will not touch. And A, you don't read anything, accepted. A is the final. Single A, how do? You will start with A, and when you read A, you will push A, it's done, and you will be going to A, it's a final. So this is accepted. Similarly, double A, accepted, you will push 2 A's onto the stack, then you will halt at final only. This is explained already, that's why language is A star. Okay. Yeah, just pushing and halt at final. Nobody asked to pop, right? Why do you want to pop unnecessarily? Yeah. What is the logic for this? Logic is important. Okay. Let's take 3 A's. And how many B's should be there? 6 B's. Then how you do it? So do it simple way. There are many techniques. Just one technique is fine for me. So what technique we will follow? Every A you can push 2 A's. Here what you do? Push 2 A's or 2x is your choice. 2 X's for every single A. Then what you do? Here pop 1 X only for every B. What you are trying to do? Here 3 A's are there, 6x you push and 6x, 6B will match. That will be very easy technique. But there is another way. Push as these 3 A's, but every 2 B's you can pop 1 A. That's another technique, right? Every problem can have any number of logics, right? This one, take one small number or small string, 6 or 4 A's, 2 B's. That is also fine. So how do you do now? Here, instead of popping 2 A's for B, what you do is here every 2 A's, every 2 A's push 1 A. How to do that? Every 2 A's push 1x. Then here pop 1x for each B, for every B. So that here 4 A's you push 2x and 2x to B will match. Got it? A simple logics I am talking about. There are many other logics. Okay, one logic would be sufficient to understand. So how you do it? Just check. I am designing the motion. Initial state. What do you do? Every A, you only told that you need to push x. So I am putting here A comma z0 slash x z0. I don't push A here, I push x. Of course, in exam they may push A, they may push B, follow accordingly. If I push a B, I need to pop a B. Remember that. If I push Z, I need to pop the Z. So decide what you are pushing and what you are popping. Now this is only first A, right? Remaining A's you will see A comma x. That you will write double x. Got it? The first A you push x. The remaining A's you will see x only on the top of the stack. So you are going to put 2x, means 1x you see, you write one more x above. That is 2x you have to represent. That is every A push 1x. This is the meaning of every A push 1x. Now here, every B pop 1x. How do you do that? Don't stay there unnecessarily. You will get after B is also S. B comma x pop. How long? As many B's coming, that many x should be there. But how long? If 100 A's comes, then 100 B's should come to pop. Then from Q1, end of the input occur. So specially you design epsilon z0 means when end of the input occurs, then top of the stack should be z0 means all the x are deleted. Then you do whatever, I don't care, I am going to final. So this is the final state. And epsilon you want to accept the special path from here to here, that is epsilon z0. Do whatever. So this path will accept epsilon, this path will accept every string which is having equal number of A's and B's. The string is in the form of A power n, B power n, right? And takes time, no doubt takes time. But this is how you design a DPDA. This is actually DPDA. But you can also design a PDA. You know, these two transitions you can take one to understand this two. So in place of this, what you can put? A comma epsilon slash A. It can do both the jobs. Whether it's first A or second A, third A, doesn't matter. You can do with the one transition also. Okay, PDAs are designed in a simple manner basically. It can be very quick if you want to PDA. Now this one, push 2x for every A. How you do that? If A comes, I need to push 2x. So if z0 is there, how do I push 2x? X, x, z0. That means 2x is done. Now next time A comma x will be there on the top of the stack. Now 2x, already one x is there. Now 2x you need to put above, right? Understand the stack is like this. X, 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 like this. You are designing like this. This x is there. Now you need to represent 3x so that 2x is pushed. Now this will take care of every A, it will push 2x, then the job is same. Every B pop 1, B comma x epsilon. Every B pop 1x. How long? Till the end of the input comes. When the end of the input, this epsilon basically, end of the input comes, then top of the stack should be z0 because all the x's are deleted. The do whatever you want, delete Z naught, keep Z naught is your choice. So you are going to final. Everyone got this point? And here, how do you do that? Every 2A's you push 1x. So that is very interesting. 1A don't do anything, other A you do something, push. So how you represent? Initially A comma Z naught. Keep the Z naught means nothing happened. Skip A, but this A you need to push. But first time you are pushing, that's why A comma Z naught. Next time you don't see A Z naught. Next time you will see here A comma A. So don't do anything means A comma A only. Skip. But push means A comma A double A. What's happened? What's happened? Every 2A's you need to push 1x. Okay, I'm pushing A, right? I'm pushing 1, right? I'll just edit it, okay? I'll just edit it because I told here x. I'm doing A, that's fine. You can change it. What is that? First A, Z naught. What do you do? Keep Z naught only. And here first every 2A's, then second A comma Z naught, push 1x. And next time you will see A comma x, keep the x, don't do anything. But here you see x, then push one more x. So every 2A's you push 1x. How? Skip, push, skip, push. So first you skip, then push, skip, push. So we will be here after every 2A's. Anyhow, it's the even number of A's only, you will come here only. From here, every B you need to pop 1x. That's it. Then exactly half of the B's comes because you have taken care of that what? Every 2A's 1x. Now you go to final when you see end of the input. When you see end of the input, Z naught should only there because all the x's should be popped. Go to final. If you want to accept epsilon from initial state, you should have this transition. What is that? Epsilon comma Z naught. Do whatever. So this is A power 2n, B power n. So are you going to design a PDA? No, right? You are going to understand. So now we will work on how to identify CFL and DCFL. Is that clear? Of course, you keep on designing. This is a never ending process. You know that. This is a never ending process. Anybody want to design more DPDAs and PDAs? Let me know. I don't want to design anything. Main topic is not this one. Main topic is identifying CFLs and DCFLs. Anybody want to design more DPDAs? Because in the exam, either they will give DPDA, you need to understand, or they will give PDA, you need to understand, or they will ask languages CFL or DCFL. Okay? If you have any specific language, you may ask to design. I'll do it. Okay. Let's move to identify, you know, right? Regular, finite, infinite, DCFL, now CFL. So how can you come up with this many, answers? There are so many other but we will come to up to CFL. Language is given. If it is regular, no issue. You already know what is regular. Every regular is what? DCFL. And every DCFL is what? CFL. But what is this? We will understand clearly. And if it is not regular, here is an issue. Not regular, maybe DCFL or maybe not DCFL. If it DCFL, no issue, it is always CFL. If it is not DCFL, we have an issue. It may be CFL, it may be not CFL. Right? So this many things we are going to learn. One example I will give each place. Regulars, right? Regular, a star, b star, a plus b whole star, many things. Here a power n, b power n, which is deterministic context free language, because how it is deep, you have a DPDA, every a push one a, every b you pop one a. There is no confusion on a, no confusion on b, you are able to understand one way. But sometimes it happens, when b comes you don't know push or pop, then you are in trouble. Even it is a push, but you don't know how many push you want to perform, one push or two push. So there is a lot of confusion on a symbol, then you have a problem. Like here the CFL example, a power m, b power n, suppose m is equal to 2n or n is equal to m, now you are in trouble. Here 3 a's comes, let's say 4 a's comes, push it, but 1b, what do you assume? B's are off or B's are twice? Now you will be having confusion. So single first B, you are not able to understand what to do. This logic and this logic both will say different. So same B, you should take two different transitions. So this makes non-deterministic PDA. You don't have deterministic. Yeah. Many logic, Tanish. That's what I'm saying, right? If you want to design a PDS, right? Many kinds of logics are there. If your logic works, you can design. Not CFL. So in case if you have something like a power n, b power n, a power n. So here the one stack will never help you to understand that problem. That's a power 100, b power 100, a power 100. One stack can compare only two symbols. You need to compare three symbols that to parallel. Like if you compare a and b, that a's, you will miss how many a's should come here. You lost the connection between the three positions. Okay, so for this language you don't have a PDE. Are you able to understand how many types of languages we are going to discuss now? Okay, so some more new concepts are going to come, obviously. There's one more concept comes here, not CFL, a power prime. This a power prime over one symbol not forming AP directly comes this side. Why? If you are not able to design a DFA, you can't design a PDA also, because over one symbol stack is L plus. Not DCFL and CFL, this case, right? For that you need example, understanding, right? So look at a power n, b power 2n, union a power, this is where you need to focus on. Now this is the one language, right? This is only I am saying it is a CFL, it is not a DCFL. We will practice, right? Why it is CFL, why not DCFL? See, I have a string. Now this 4 A's, let's say I am pushing as it is, because all the strings I should have the deterministic logic. Now this B, what should I do? Should I, for this one, for this B, should I pop 1A? For this B, should I pop 2A? See here 2 B's are there, 2 B's I need to pop 1A. If I am getting more B's, right? So one logic says that every 2 B's pop 1A. Here 1B you pop 2A. What to do? Should I look at this logic or should I look at this logic? On B comma A only, B comma A only, I was not able to understand deterministically, but non-deterministically you can do. How? So first what you do is, every A you push, that's a common. But now look at the same B comma A, you will have two different paths. This side you try to understand a power n, b power 2n. This side you try to understand a power 2n, b power n logic. But you know how to design this side separately, but from the same state you need to take the two different transitions on the same combination. See that? Sigma cross gamma, same combination. So both the sides you are going, this is called as, is exactly like NFA, on X, you are going to take two different transitions. This is a non-deterministic motion, right? But this X is so big here because two combinations you have to look at. Okay, In NFA only input, but here input and top of the stack. Is that clear? This makes a non-determinism. So this is not a DPDA, and DPDA impossible for this. DPDA impossible for this. Clear? See, this is combination, right? You understood the 2 power q cross gamma star, why we have? Because of this. But DPDA you have only q cross gamma star. Exactly one side you will go, that is a deterministic. But when you are going 2 sides or 3 transitions or 4 transitions, they are purely non-deterministic. That, see, by looking at this you can't. By looking at the string only you will understand. Oh, 4 years I push, but for this B what to do? If I implement this logic, this string might be this one. If I implement this logic, this string might be this one, because this is there only in this language. There is only one language only, not 2 languages. Okay? Just I separated 2 forms, but it's actually one language only. But if I write that, you don't understand. That's why I didn't write it. Epsilon, A double B, double A B. This way I can write, but you don't understand. That's why I didn't write it. Okay? Any doubt? Are we ready? Can we start? Okay. Let's start with A power n, B power n again. So these 3 problems we know, but exactly what meaning it is. Is it infinite or finite, regular or not regular? Everything you answer it. Okay. If you really want it, I'll just make the many things here. Okay. Let me make a table also. Okay. So what I am going to write here, finite or not, infinite or not, regular or not. Of course, finite that you can get conclusion, right? Infinite no need to write. Finite tick mark will help you. Regular or not, DCFL or not, CFL or not, and finally CSL, context sensitive language. Okay. If anything that I miss CFL, that definitely CSL. Okay, let's focus. So you tick the marks, whatever it is. Previous one. Similar to that. Yeah. So those people who have studied TOC, for them it will become easy. But first time you are studying this, I don't recommend. it all, because you know how complicated without knowing DPDA and PDA. So if you have already constructed them, it will become so easy for you to explain what language it is. The shortcut is only one shortcut, how you perform the operations on the stack. That is only the shortcut. Let's look at one by one. So what is the answer? It is infinite, so you can't choose. It is not regular, so you can't choose it. DCFL, so CFL, so CSL. Okay. Just now we have constructed DPDA for this, and this is also right, same. In the exam multiple MSQ, then you should choose these three. If they ask DCFL but not regular, that's a perfect answer, right? So by looking at this, you can say that that is a DCFL but not regular. That means you answer remaining all and this one also. Not regular means not finite also. DCFL means CFL, CSL also. So exact name is DCFL, which is not regular. Okay, exact name. And this one, same. But logic is slightly different from above. Right, here you might be having every 2 B's you pop 1 A, or every A you push 2 A's. So understand different logics are there. So this one is not finite, not regular, even it is not a DCFL. So here is an issue. Here every A you push it, but B, is it equal to A? Or if you see here, the B is half of the A's, that you need to understand. So this one is again, it is not a DCFL. Why? You can't design DPDA, that means B, you cannot have one transition. You should have two transitions to understand two different strings. So you create a non-determinism. Here you know that PDA is more powerful than DPDA. That's why DPDA you don't have for this. Next, not equal to n is fine. Either less than or greater. Less than is different, greater than is different. So understand, here you may have less than or greater than, but both will have a different combination. Here it is not regular, but it is DCFL only. So remember, it is the DCFL only. Even in fact, from here all these three are DCFL only. Those languages which are not DCFL, definitely will understand some non-deterministic transitions are there. Okay, anybody answered wrong? The fifth one, anybody answered as a not DCFL? You know, this is very important. People may keep a cross mark. Why? Because they assume here not equal means less than and greater than, both are there. Oh, many are answering. You seventh, oh, don't do that. Do you want a designing? Fifth and seventh, both are DCFLs only. Sixth, you want to explain? Sixth is so easy. Okay, let me explain that. So all of them, just let's conclude a different way. Yeah, then I'm designing a DFA means, you know, A power M, B power N. So there are many logics. M equal to N, M less than N, M greater than N, M not equal to N, M less than or equal to N, M greater than or equal to N. If you know the logic for these three, right, they are depending on these three only. Okay, understand. M equal to N means what happens? Let's say take small string, triple A, triple B. You know what to do? This you push as it is, and for this you need to pop one by one. So when end of the string comes, epsilon comes, then here it has to look at only Z naught on the stack. So then you will go to final. That's it, right? Epsilon comma Z naught, you will go to final. This is the combination that you are looking for, because all the A's that you push, that B should pop the A's. Then when the end of the input comes, stack should left with only Z naught. This is the logic for m equal to n. And what is m less than n? Just take one example. M less than n means what? 2A, let's say many B's, 5 B's. Okay. So what you should do now, 2 A's you may push, let's say Z naught. Push, but this B you pop 1A, this B you pop 1A. Now this B comma Z naught, here you will understand more B's are coming now, but you can't conclude. Why? Because this must be valid input, here A might be there. So what you do is, you just skip B comma Z naught, skip all the B's, and when epsilon comes, epsilon comma Z naught, go to final. Just accept it. Are you able to understand? The logic is important, how you design. Of course, if you want me, I'll design it. If you want any of them, ask me, I'll design it. Now m greater than n, how you do it? Now take this is easy. Let's take more A's, less B's. Now initially Z naught is there. What do you do? Push all the A's from the initial state. Done. This B you pop A. When the end of the input comes, A should be there on the stack. It means more A's happened. Here more B's with this B happened, and here more A's, this will decide. End of the input, A is there on the stack. It means go to final. Epsilon comma A should happen, not epsilon comma Z naught. For this epsilon comma Z naught. Array, that 5th and 7th only, every answer is there here, right? So now look at m not equal to n. Here only every answer is there, right? 5th, 7th, I am explaining more than that. M not equal to n. What is the 5th? M not equal to n only? Sorry. I am explaining for that only, right? 5th, 6th, 7th, all of them, the answers are here, right? Now m not equal to n. Where is here? Sorry. 5th and 7th, even more than that I am explaining here. Now m not equal to n. What do you mean by that? Either this will happen or this will happen. See that? Here B comma Z naught comes, you skip the B's. Otherwise epsilon comma A comes, you will go to final. So both are different combination, B comma Z naught, epsilon comma A. So no confusion. If both are happening B comma Z naught, you are in trouble. If both are happening B comma A, you are in trouble. But one is B comma Z naught, other one is epsilon comma A. There you have a different decision. B comma Z naught comes, B is more. Epsilon comma A comes, A is more. So you have a different combination, so no confusion. And that is m not equal and means either this or this. Less than or equal means equal or less than. Equal or less than. Greater than or equal means greater or equal. So I'll design m not equal and then you conclude it. M not equal and I'm designing. Understand what is this here? M not equal and means m less than n or m greater than n. You should have a logic clearly. What you are going to do, m less than n means A's less than B's. A's less than B's, what was your logic? If you don't have a logic, then you will never do this. A's are less than B's. What is your key point? You push, you pop, this B is the key point. This B will look at Z naught because number of B's, number of A's matches before B comma Z naught comes. Here B comma Z naught is a combination. Here B comma A is a combination. B comma A because the stack has A's. Here A comma A is the combination. Here A comma Z naught is the combination. The stack what it has, right? Stack is having Z naught and A's you push, and this B you will look at this A, this B you will look at this A, and this B will look at this Z naught. This Z naught you will look at. You see that how I'm doing it. Now this B onwards you will take this Z naught only because you don't pop now. You will just skip them. You will just skip them and then go to final. So here I am going to do this A comma Z naught, copy paste, so many motions we did, push all the A's blindly. So when B comes, pop A. This is common for all the problems. Now the logic starts. More B's or more A's. If more B's, this path you take B comma Z naught, but keep the Z naught and skip every B because so many B's might be there. B comma Z naught. Then here end of the input Z naught should be there. Do whatever, go final. And epsilon you want to accept, impossible because not equal. So here you will never have epsilon. This is for more B's. More A's, more A's. How do you accept more A's? Only B's. There are so many combinations. There are so many combinations. First, let's try for more A's. More A's means what? From here, B's are not able to pop all the A's because only less B's are there. Then more A's means here end of the input is happening. Here end of the input epsilon happened, but top of the stack is A. Then go to final. But two kinds of strings are missing. Only A's, only B's should be accepted. So any number of A's are coming from here, end of the input happened, accept, because A is more, then only A's might happen. Only B's, then from here should go here. When only B's are coming directly B comma Z naught, then keep the Z naught and skip every B and then go final. Look at this motion is deterministic. Is there any state the same combination you have a two transitions B comma Z naught only one, epsilon comma A only one, and from this B comma A only one, from this A comma Z naught, A comma A, epsilon comma A, B comma A. Every combination is unique. That's why this is the DPDA and this is the DCFL. Okay. Anyhow, that takes much time here. In the exam, you never do that. Anything you want to do, you practice now. In the exam, if you don't understand, you can't answer it. Very simple. If you don't have a good practice on construction, ignore the question. You don't have a clarity, ignore it. You can't answer every question in the GATE exam. Clear? If you have practiced DFA, so DPDA, NPDA construction, then you can answer clearly. That's what I am helping, right? What is DPDA, what is PDA, how to construct, why they are, what is relation. These languages, if you are able to answer these questions 8, that means you can answer most of the questions too. Okay, let's go to the next list. I'll keep increasing the complexity. We'll see some interesting languages, then we'll conclude later. Okay. Okay, so you keep answering. So this is a very famous language for us. Tenth. 11. Right. The ninth one is the DCFL, correct. Anybody want the logic for anyone, any problem here? Please ask me so that I may explain for 1 or 2 minutes to get the conclusion. Because if I don't explain it all, then you don't get the logic properly. Whichever the problem you are able to do it, answer it. Remaining, you can just look at explanation. Yeah, I'm waiting for the answers, right? So take 2 minutes time to understand. First column is very simple, right? Is there anybody find it that you can choose? Yeah, 10th is very important here, 10th. Because that is a well-known CFL which is not a DCFL. 10th problem. You have seen multiple times in the GATE exam, right? The 9th, 10th difference is the symbol. For 9th you can design a DPDA, but 10th you can't design deterministic PDA. Yeah, 12th is the finite language, correct. 12th is the finite language. Okay, let me write the answers. Which color is better? Okay, if I look at, there is only the one finite, remaining or not finite, okay, not restricted anybody, correct. If I look at them regular, so anybody regular here that I can see? Nobody is regular except this one. Every finite means everybody satisfies, so ignore that. Ignore the 12th. Language is finite, so definitely it is going to be everyone. So 12th is done. And focus on remaining one. Let's start with the first one. 9. W as W power R. How you do it? W, we don't know what is it. First thing is W could be anything in the world. But whatever it comes, push as it is. And the last symbol of W will match with the first symbol of W power R. But ash is the indicator when you need to start popping. So this is deterministically you can do it. It's not regular, but deterministically you can do it using the stack. So 9th one is a very well known DCFL. Do you know that clearly why it is DCFL? Everyone, if anybody do not know, please let me know. I'll give an example to understand. 13. Here ash is not there. So you will not know when the reverse will begin. So you have some non-deterministic choices to do that. So from CFL it will satisfy. So you can design it PDA, but you can't design. You can't design DPDA. This one PDA is so easy. If you want W power R, right, where W belongs to A comma B whole star, see that how you can design. Randomly you push everything, don't know how long, but you push randomly everything as it is. But you change your brain or logic, so you jump here Oh, if the W is over, you come here and start popping exactly in the reverse manner, A comma A or B comma B, that's it. Then if really these two are matching properly, then at the end of the input Z0 you will see go to final. So only the palindrome, even length palindrome only can take this path, nobody else. That also W will push here and you will change here without reading anything, without changing the stack, and pop everything match, because if my string is ABB, then its reverse is like B is here, B is here, A is here. So what do you do? ABB I'll push here and this BBA I'll pop here by matching exactly the same combination. So that makes this is belongs to L, right? Clear? Oh, example for 9. 9 is very simple. Here CFL, this is not a DCFL because you need to go non-deterministically. This is never be DPDA transition. So only PDA possible. If you have W hash W power R, that's so easy. I can design whole machine if you want it. W hash W power R. Oh, clearly we can design how. This one push as it is. Here skip, don't do anything. But this one pop by match. Pop with match. So how? Let's see. Initial state. Push everything. How? What do you mean by everything? It might be A comma Z0. It might be A comma A. It might be B comma Z0. It might be B comma A. It might be A comma B. It might be B comma B. All combinations. Don't miss anything. So just push means A Z0, double A, B Z0, B A, B A B, B B. So push exactly what you need. So when do you change or when do you start popping? When the hash comes. Oh, below anybody may be there, may not be there. W can be epsilon. So it could be Z0, keep the same. If it is A, keep the same. If it is a B, keep the same. Now go to some state, there you start popping. How do you pop it? A comes, then definitely A should come here, pop. If B comes as an input, top of the stack should be B, so then only reverse will happen. Then end of the input, when epsilon comes, only Z0 should left, then go to the final. So now what's happening here? This is just W and this is looking, this is hash, this is looking for W power R. That's it. W hash W power R concept. Is that clear? This is the 9th machine. Machine I am talking about. This is the DPDA. Anyway, we don't need it if you understood the logic. In the exam, never construct the machines. It takes much time. This one same, right? Like A power n, B power n. Push all the A's, skip, then pop all the A's. Okay? So that's a DCFL. And this one W W. And there is no X to understand it as a regular, right? And W W. Can stack help you? Impossible. W W power R is stack form, but W W is a queue form. So we don't have a queue. We have only one stack. So we can't do even CFL, but CSL you can. Context sensitive language, just to understand, everybody is a context sensitive from here. Okay, in the exam, if you are able to understand it is not CFL, blindly you can go to CSL for this kind of languages. No confusion at all. And this one, even though hash is there, but how will you understand this W again here? The first symbol is there, bottom of the stack. That first symbol only you wanted first. So impossible. First in, first out, impossible. Last one, yeah. 2 symbols only we had taken much time, and here stack is empty. How the W can be guaranteed that this is same as this one? Right? All the 3 symbols are depending on each other, 3 positions. 2 positions we can cross check non-deterministically, but 3 positions we can't. So this is going to be even not CFL. Not CFL. This one is also not CFL at all. 3 positions we can't do with the one stack. Right. Anybody want any explanation for any question? Please let me know. I'll wait. How 13th is not CFL? WW. What do you mean by WW? It is not a finite language, right? It is infinite language. Suppose you have A, B, B, the same thing should come. Same thing should come. Now, this A, B, B, if you push onto the stack, to remember you will push onto the stack. This A is actually looking for the bottom, But how can I match it? Can I go there? Is it possible go there? This is only top. And A, you can't compare with the B. And if I delete this, I will lose it. So stack is not going to be helpful. This B should look here. But if I go here, these two B's need to be deleted. So stack, you can only look at the top. You can't look at in the bottom or middle. So that's why it's not CFL. You may ask, sir, other languages, why they are CFL, like, WWX. There we don't look at WW, we look at A plus B whole star. We give me any string that is there in the language, right? You know that. Why we made it is A plus B whole star. This actually, do look at this language. Don't look at WW, it's not there. This language you look at, that's a representation only. I'm not looking at WW also, I'm looking at this one. This combination I'm looking at. Okay? Any doubt? Anything else? Quick. Any doubt? Okay, let me write directly the important languages. Okay. A power n, B power n, C power n, and 18. Its complement, that 17th complement. 19. There is a language called as WW. We know that it is not a CFL, and its complement. 20. WW power R. Each might be taking at least 10 to 20 minutes. So better to avoid the questions for these languages. A power n, B power n, its complement. Power n, B power n, C power n. I explained in P by Q also this kind of questions, right? Just answer directly what is the first one which matches. Okay, no need to answer everything. Just first one which matches in the row. Is it DCFL? Is it CFL? What is the answer? If you are not asking any doubt, that I assume that you know the meaning or you know the answer properly. Anything you don't understand the exact answer, please ask the question at least at the end. 17 is a very well known context sensitive language, very well known, but 18 is what? Perfect. 18 is a CFL. Ritik is right. Yeah, there you will have the doubts because there are very special languages. There you may assume master level questions from 18, 19, 20. That's 3 questions are MTech level questions, but could be asked in, could be possible in the GATE exam also. I have seen some questions. So I'll just take the first one, which is matching, right? First one. That means remaining or not correct. The first one CSL. That means these are not matching. Okay, I'm just ignoring. Okay, I'm just ignoring because they are not satisfying. Okay, got it my point, right? Next one. This is going to be CFL. So CSL, and the next one is also next one also. And last one, the DCFL complement is DCFL. So DCFL, DPDA, you can also do the complement like a DFA, interchanging final non-final also works here. And the last one is only context sensitive. And the last one CSL, last one CSL. So any doubt, please, of course, doubts cannot be resolved for every question here. 21, 22, 23, yeah, one of them I think. 18th I can explain why it is CFL. Already explained in PYQ session, I guess. Yeah. So those people who are not aware, please let's know that 18, 19, 20 are actually context free languages. Even though their complements are not CFL, but these are CFL. Okay. See, 17 is not CFL, but its complement is CFL. Not for all, only for DPDA. Shreyank. Only for DCFL. 21, you can use the DCFL, DPDA concept. But PDA you can't do that. Oh, see, if that complement works right, that is also going to be CFL, right? That will not work here. This was a DCFL, complement of every DCFL is a DCFL. So you can use this property because in the DPDA you can do interchanging final non-final, but you cannot do that in the PDA. In the DPDA you can design pure deterministic push down automata, then you can interchange final non-final. Okay, so this is a different from other 3. Here they are having only PDA, they don't have a DPDA. This 3 no DPDA exists. For this 3 PDA only exists. For this 3 PDA exists. Context free grammar you can write. Okay, and this one is DPDA exists, so interchange final non-final. Yes, exactly, for DPDA that works. Okay, do you want any explanation for any question? Please let me know. If it is needed, I'll take it. Question number 18 I will explain. Yeah, 22 is very clear, right? 4 symbols are depending. How can we do with the one stack? So definitely we'll go for context sensitive. So let's go for question number 18. Question number 18. Question number 18. A power n, B power n, C power n. It means what? A power m, B power n, C power k, such that m equal to n equal to k, right? This is some language. Let's take its complement. A power n, B power n, C power n, its complement means A plus B plus C whole star. From this you need to eliminate A power n, B power n, C power n. But how? How do you do that? See here. If any string which is not in this language, right, not in this, then definitely you might be seeing a power m, b power n, c power k. Maybe this two is not matching because here everybody is matching, right? M may be not equal to n, or you can write even or if you want it. M might be not equal to k, or n might be not equal to k. This might happen, or if the string is not here in the same sequence is their string, then this might be one reason. But string may not be in this sequence. In my string, BA might be there. Here, a lot of strings are there, right? So union the BA, sigma star, sigma star. If BA comes in my string, it has never been this form. Or union, it might be CA, containing CA, or it might be CB. CB is not covered, right? Yeah. And look at this is the CFL because this is DCFL and DCFL, DCFL, but union is here CFL. You can design a PDA for this. You can design DFA, means you can design a PDA, PDA, PDA. So 4 possible PDA transitions. All 4 PDAs you can combine by taking the epsilon transitions also. So this is the trick why it is a CFL. Why it is a CFL. Everyone? नींद आएगा in different situations यार. एक situation, if I am the student, I am not getting, definitely I get a sleep. Second situation, I am not getting interest in teaching, then I will get boring. But either of them I am not, right? I am not a student, I don't get boring while teaching, that's why another reason. Oh Manjit, that's good, right? I can see many people are joined again. Why it is CFL? This is the reason. CFL, 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 CFL. In the CFLs, it works. You can do the union easily. Design a 4 PDAs and put epsilon transitions, make a new PDA. Okay, that's why here it works. Okay. (25) a power n factorial. 26. I am not writing remaining, just one example, fine. A power m, b power n, c power k, such that m plus n is equal to k. 27. B power m, c power n, d power n. 28. So this is different. What you are asking previously, all powers are same, but here all powers are not same. You compare this language with the previous one. Somebody was asking doubt, right? Just focus on this 30, which could help you for the exam point of view, revision. Let's conclude the answers. I'll sleep for 2 minutes. गुड मॉर्निंग अवनीश। हमको तो थोड़ी देर के बाद गुड नाइट हो जाएगा यार, आप लोग गुड मॉर्निंग बोल रहे हैं। Yeah, Putin I can see, but there from the beginning. Well, many here. Today is not my day, right? I cannot sleep more, but usually I sleep 5 to 7, 5 to 8 hours, depends on the time. Yeah, any answer? And this list is also very important list. Okay, by that time we'll try to complete this chapter, right? Then we can have the fresh before the last chapter. Yes, Rishikesh. या कितने लोग हैं वो यार 12 घंटे से पढ़ रहे हैं आप लोग, right? Great to see your dedication, not me but you. Rishikesh, Shreyank, Putin. Okay. तो आंसर क्या होगा? फर्स्ट वन, व्हाट विल बी द आंसर? 25th. That is having only one symbol. We know it is not regular, so it cannot be CFL, only it is CSL. It cannot be anybody. Why? The single stack. See, if you have at least two symbols, right? One you can push, other you can pop. See, only A's are there. Which A you will push, which A you will pop. If you can't do with the states, you can't do with the stack also. So here there is a property. 25th, we have a very important concept. If the language is over one symbol, remember this point. Finite automata and PDA, no difference. Either both will exist or both will not exist. That means L is both regular and CFL, or L will not be neither regular not CFL. So L over one symbol, that finite automata and PDA will work same, because over one symbol L will be either two cases will happen. L is regular as well as CFL, or L is not regular as well as not CFL. There is neither regular not CFL, that is the meaning. Only these two things will happen. That means finite automata PDA, there is no difference over one symbol, because stack, basically here the problem is the stack. Stack is useless. Why useless? If you have everything is A, so which A you will push, which A you will pop. If I have at least A's are there, B's are there, A's I will push, B's I will pop. So I can understand, or at least some hash is there, then then before hash I will push, after hash I will pop. But here only A's are there, only one symbol is there, you can't use the stack. That means finite automata and PDA, there is no difference. The power is the equivalent. Got that answer? This one. Oh, A's you push, B's you push, C's you pop the B's, then you pop the A's. So deterministically you can do. So definitely these three. This. And here you can compare A's with the B's, C's with the D's. Push A, pop A. Push C, pop C. So understand what you are reading, what you are popping. A's you are reading push A. B's you are reading pop A. C's you are reading push C. D's you are reading pop C. So there is a comparison always. And this comparison also deterministic. So it is a DCFL. And next one, A's you push, B's you push, and C's you pop with the B's, D's you pop with the A's. So here also it is DCFL. And this one, oh, you need to compare A's with the C's, B's with the D's. So it's not a stack order. When C comes, you are looking bottom of the stack symbols. B's might be top, then you can't go to the below B's. So it is not going to be CFL at all. So only CSL. And this one, A's, B's push, same symbol. A's push X, B's push X only. C's pop X, D's pop X. If end of the string comes, or end of the input string comes, then you should have the Z0. So that is deterministically possible. Okay. Any language that you want to explain, then ask me, I'll try to do that. (26) again. Oh, 26 what you do basically. Let me take one example. A power m, b power. Take an example to work out. It's not that easy when I explain, right? You can't catch sometimes. So take an example how you do it. Let's take double E, triple B. So here should be 5 C's, correct? Then what you do? A, just I'm doing it here, right? Z0. A, push X only. A, push X only. B, push X. So you will get total. Here also push X. Here also push X. And B's comes, you do that push X, push X, push X. Now what you do? For this, pop it. For this, pop it. See, sum only, right? This whole sum only you need to match. That's possible now. Possible when end of the input comes, Z0 should be there if this C is equal to sum of A's and B's. So go to final. Clear? Just take one small example to understand, it will work out. When you're not coming out with a concept or logic, then you don't know why it is DCFL, why it is CFL. Okay? Done? Got it? Similarly, there are many languages, but I hope if you can understand these 30 languages, other languages, it will not be difficult for you. Okay, that's my intention. Are we ready to go to the next topic? Are we ready to go to the next topic? The list is there, but I don't want to show that list. Okay, I want empty slide. Yeah, it's here. Ready? So after this we can take a break, then we can start the Turing motion. So first let's understand what you can remember for regulars, what you can remember for DCFLs and CFLs. First, have you remembered the closure properties list? Very important. Closure properties list, did you remember? The short form now. 1 union, 2 intersection, 3 difference, or complement is also there, right? Complement, 4 difference, minus 5th what? Concatenation, 6th reverse. Short form I am writing. I think I have another short form also, okay. Just let me write another way, because these words you are understanding, right? Just want to say like this, L1 union L2. So we'll know is it unary or binary. L complement, L1 minus L2. What else you have? Concatenation, reversal, Kleene closure of L. L is depends on domain, okay. The subset of L, and 10. What else we have? The order doesn't matter, but keep having all this list. Prefix of L, 11, suffix of L, 12, the substring of or subword of L. Okay, there is another one called as quotient, right? 14. So important only I am writing. F of L means substitution of L, homomorphism of L. 16. H inverse of L. There is another one which I have not written. If you want, you can write epsilon free H of L, means you don't substitute with the empty string. 18. You can use a finite union, finite intersection. 20. Finite difference. Okay, let me write the word. Sometimes which doesn't look good, right? Finite subset, finite substitution. I may not be writing all, but I am just writing the important list which can help you to remember the shortcut. 23. 23, 4, 5, 6, 7. 23 to 27. We have something like infinite followed by union, intersection, difference, subset, substitution. Okay. Subset, substitution. Okay. This is infinite followed by. So 23 to 27. So now here, how do we remember for different classes? Okay. Now I am just making a shortcut. When you look at this list, you should have this shortcut with you. When you look at this list, you should have a, I am not writing half of L, 1/3 of L, they are very special. For regulars they are closed, but remaining you just take care of it, not. Now I will just make, okay, first we will work on, do you want even finite languages? I can make it, but I am just ignoring finite. Let us start with the regulars. Regulars languages, for regular languages, what you need to remember? Only two things. You remember subset and infinite. Infinite followed by union, intersection, difference, subset and substitution. Okay, infinite followed by anything. So 6 plus 1, you just remember 7 operations. What are they? The 9 and 23 to 27. This is a 9, 23 to 27. So these are not closed. What is it? Not closed list. It means remaining all are closed. It means remaining all are closed. Not closed list only you will remember. Okay. For deterministic CFLs, so now we are getting the new list. Deterministic CFLs, we have very few closed. So here you remember closed rather than not closed. What are they? Anybody? Complement and see, all are almost one prefix, and nobody is closed at all, nobody, and anything else? Here also nobody closed. Finite subset, oh, that is for everybody. Very special that finite subset is. I think that's all. Can you see that? LPF. Anything else? Let me check one more time, because sometimes you will have more. No. So just remember the shortcut also. CPF, that is also fine. Inverse homomorphism, I forgot that. That's what I'm looking for. Inverse homomorphism. H inverse. H inverse. H inverse of L. So only 4 operations. So I'm just making a shortcut now. What is the shortcut? C means complement. P. I just want a different color. Why it's not coming? C means complement. P means prefix. And inverse homomorphism. F means finite subset. CPIF. That's enough to remember the close shortcut. CPIF means complement, prefix, inverse homomorphism, and finite subset. So that which F also you should remember, not just F. F means so many finites are there. So finite subset, that you should understand. Okay. For regular languages, just SI. S means subset, I means infinite followed by anything. Okay, don't assume that I is inverse homomorphism, wrong. This I is infinite operations. Okay, there's a not closed shortcut, and CFLs next. For CFLs, what do you remember? You remember again different, like regular languages, not closed. Why not closed? Because this not closed list is very small. Not closed list is very small. Okay. What are they not closed? Here first, here intersection. What else? Complement and difference. Once you know these two, any one of them is not closed, then definitely minus is not closed. And this 3, then subset anyhow that is there, and quotient, and now intersection. So finite intersection. Okay, let me write in short form. Finite intersection and finite difference. And infinite followed by anything is definitely they are not closed, right? Infinite followed by anything, union, intersection, difference, substitution, subset, do be here. So these are not closed. So how do you remember this? Not all. So you make a list. How do you make the list? You can see, if you remember intersection, complement, difference comes, and subset is not closed for entire this domain also, and quotient. So remember important one, intersection, complement, so difference, quotient, and finite anyhow that you can conclude from this, intersection, finite intersection, difference, finite difference, and infinite everybody. So important one I am making shortcut. I means intersection, complement, then difference if you want you can add it, but I will add it later if I needed. Q means quotient, and I am not writing anything. So ICQ you remember, because of C who comes? Because of IC, because of IC D comes, and the subset is there for everybody, and infinite, that SI is there for everyone, right? That SI is there for when here also there, and finite intersection, finite difference, because of what? I, and difference you have F square. F square means finite intersection and finite difference. I think that's all you can remember. ICQD is fine. ICQD is fine. So F square can come from the intersection and difference. SI is there for everybody. So if you really want to make a shortcut, ICQD F square SI. SI you already know it, and this you can just write ICQD F square, that would be sufficient. Is that really anybody want to make a shortcut? That will be easy. Okay, from this list. Of course, if you add any more new operations, that will change the formula. right? And few important points here. What are they? The finite subset is closed for everybody, and inverse homomorphism closed for all these domains, and the subset is not closed for all these domains, and infinite. These 4 you need to remember at any cost, because the subset is not closed for all, and the infinite operations not closed for all, but inverse homomorphism closed for all here, and finite subset is closed for all. But we are remembering very few. For regular language, we only remember S and I, remaining all are closed. DCFLs, only these are closed, remaining all are not closed. CFLs, these are not closed, remaining all are closed. Okay? Yeah. So this is about closure properties. Now we are going to look at so many interesting points. Okay, anybody want to make a shortcut? I hope you got the point, but that may not be asked in the exam as it is. The actual questions are like this. 1. CFL union regular is what? CFL intersection regular is what? These are the most happening questions in the exam. CFL minus regular is what? Okay. Similarly for DCFLs. DCFL did not ask, but may be possible in future. Regular, assume that is regular. Okay. DCFL minus regular. Anybody? 2 things I did not write, they are I am writing specially. Regular minus CFL, this is a different one completely. Regular minus DCFL. Very simple, the answers are also very easy, because of they have the proofs. All these answers are CFL and all these answers are DCFL, but only here regular minus CFL you get actually CSL here, and this one you get DCFL. The 2 are very special. You don't apply the Chomsky hierarchy. It is not a Chomsky hierarchy. This is not a class of CFLs. It is the one CFL, one regular. Yeah, you know that one here. If you look at one regular intersection another regular, you will get regular. But this is one DCFL and another regular. When you do the union, you may say DCFL, but here intersection you may say regular. That's wrong. Just take one example. A power n, B power n, and A plus B whole star. Result will be A power n, B power n. That's not regular, right? So here you will do the mistake. So you may have the choice of doing the mistake here. People need to realize, just take one example, A power n, B power n, intersection sigma star, you will get A power n, B power n. You don't get sigma star. It is just regular. REL I did not start the chapter yet. These are called as regular closures. What they are called as? Regular closures. A special topic. Regular closures means one of the language is regular. They are called as regular closures because you see one language is regular here. Union is commutative, so I no need to write to the 2 sides. Okay. So this two you can convert into this form. So if you anybody want to understand, look at CFL minus regular. What you can write? L1 minus L2, is same as L1 intersection L2 complement. So what you can write? CFL intersection regular complement. Regular complement is what? Again regular. So CFL intersection regular. So it's converted into this second problem CFL. Similarly, you can understand, right? Okay. Let's take this one separately. Second, DCFL minus regular. You can prove similarly it is also DCFL using the same principle. Third one, the problem is when you write regular is the first, then CFL is the next. What happens? Regular intersection CFL complement. How many of you know CFL complement is the context sensitive language? It may or may not be CFL, but always CSL. The result will be converted to CSL. So may or may not be regular, may or may not be CFL, but always CSL, always CFL. Fourth one, regular minus DCFL. Why did you get a DCFL? Because you see regular intersection DCFL complement, because you can convert this to intersection and complement. DCFL complement is DCFL. So regular intersection DCFL. What do you get? It's a in the DCFL that I think total list is fifth problem, I guess. It is you get a DCFL back. If you see this DCFL intersection regular intersection DCFL, you will get DCFL in the previous list here, right? Yeah, people are joining back. I think they woke up just now. So these are the interesting result. These are the interesting result in this list. Okay, some examples where it might help you in the exam. Okay, let's look at first question. First question. A power n, B power n, C star intersection A star, B power n, C power n. Just write the answer whatever you understand. Okay. Second, A B power n, C star intersection A power n, B power n, C power n. Third, A B star intersection A star B. What is the result? Fourth, A B power n C power n intersection A power n, B power n, C. Fifth, A star B C star intersection A power n double B C power n. Okay. What is the answer, man? 8. So after this closure properties, what we do, we'll take little bit lengthy break like 40 minutes, 1 hour. It depends on you, half an hour to 1 hour in between. I just want to see the answers here. second one A, B, C. Perfect. Is it correct? Just cross check. Shreyank, are you doing any mistake? Second, Ritik said A power A, B power N. Yeah, Ritik is right. Ritik is right. Satya, A, B, third one. Yeah, excellent. That's A, B, correct. I want the result. I don't want is it CSL or CFL. I want the result. Tanish, what exactly the language is? Of course, you got the point. CSL. Yeah, third is AB. Correct. What about the fourth one? Fourth, fifth, no one answered it. A common, okay, B power N. If I take it, how is that possible here? Fourth one not able to answer it properly. No, fourth one no one answered it properly. No, not answered it. Fourth, I am looking for the right answer. Yeah, everything is in front of you, right? You are not actually looking at the strings, you are looking at only power. That's very dangerous. You need to know what is restricted. No Tanish, no Tanish, no yaar. No one answered the fourth one properly. No one. H. Look at what is must. That will help you what need to be taken as an output. What is must? If you have one C, yeah, Sritam, you are right. A, B, C. Only one C should be there in both of them. Only one A should be there in both of them. This will demand one B only there in both of them. It's very interesting and important. Okay, fifth one. At least come for the fifth one correctly. Yeah, if you take 2B, 2C must, but I don't have 2C there in both of them. The last one, fifth one. If anybody answers, then I'll start answering all. Good. Sritam is very quick here. Look at where do you need to focus on. Here AB should be equal, here BC should be equal. To satisfy both of them, all the three should be equal. Here this 2 and this 2, right? This 2, you need to be equal, satisfy all of them should be equal. Now focus on this one. 1A is there, so you must write 1A. And here you look at, when you write 1A, look at that.